Hi guys, my name is Bappy and you are welcome to my course. In this course, you will try to master the complete Agentic AI with the help of LangGraph. If you have seen over the internet and everywhere, nowadays people are moving towards Agentic AI system. Previously, we used to work on the LLM based application, RAG based application, but right now, agent is getting very much important and crucial for the application development. Nowadays, AI agents are becoming very much powerful because of its automated workflows. So right now, you only need to provide a prompt, and from your prompt itself, your agents can understand your goals. And these goals would be divided into multiple tasks, and all of the tasks could be completed by using some kinds of tools. Your AI agents can decide which tool to use to perform what kinds of tasks. So these kinds of automated workflows your AI agents is having, and with the help of that, it can perform any kinds of tasks you will be providing to your AI agents. So that's why this is far better than our traditional Gen AI application development, because right now with the help of agents, we can automate the workflows. So in this course, guys, I'm going to teach you each and everything you need to master the Agentic AI with the help of LangGraph. But before that, first of all, we'll try to understand my course plan. This course I have divided into multiple phases. So as you can see, this is my entire plan for this course, Agentic AI using LangGraph. So first of all, in the phase one, we'll try to complete the introduction to Agentic AI. First of all, we'll try to understand what is Agentic AI, okay, how AI agent works. We'll try to see the difference between LLM apps and AI agents application. We'll try to see the agentic behaviors like reasoning, planning, memory tool, okay, decision making. Then we'll try to see some real world use case of Agentic AI, traditional AI versus generative AI versus agentic AI system. Okay, then we'll try to see the evaluation from chatbots to automated agents. Okay, we'll try to see each and everything. Then some other stuff we'll try to cover, as you can see, like limitations, why agents need memory tools, workflows, control logic, then agent architecture, prompt and system instruction, tools, memory, planning, reflection, environment interaction, and human feedback. Okay. Then in phase two, I'll try to start with asynchronous programming and Pydantic, because if you are already working with AI agents, I think you know that you need these kinds of asynchronous programming, because all of the agents are using, especially all of the agents framework are using these kinds of asynchronous programming in the backend. Okay, so in this course, I'm going to focus on the LangGraph. So LangGraph internally uses asynchronous programming. That means you can run your agents in parallel. Okay, we'll try to understand this asynchronous programming. Okay, why it is required for AI agents, how we can code inside Python. Okay, then we'll also try to see about the Pydantic. So Pydantic is a Python library, and we use this Pydantic for the data validation, okay, model validation, and these things you need whenever you are implementing the AI agents. Okay, I'm going to tell you why it is required and why you have to learn this Pydantic as well. Okay, so each and everything we'll try to cover in the phase two. Then in phase three, guys, I will start with our first orchestration framework, which is LangChain. Now you can ask me why we'll be learning the LangChain here, because if you know, LangGraph is a product of LangChain. Okay, LangChain team has developed LangGraph, right? So that's why to master this LangGraph, we need some knowledge on LangChain. First of all, we have to understand whenever we didn't have these kinds of LangGraph framework, so how people used to create the agents with the help of LangChain. So that's why we'll try to use LangChain to build these kinds of agents and multi-agents workflows. Okay, and still, if you are using LangGraph, you need to use LangChain, because from the LangChain, you will be loading the large language model, you will be loading the prompt templates. Okay, all of the utility related code you will be writing with the help of LangChain, and LangGraph you'll be using for building your agent workflows. Okay, that's why LangChain understanding is a little bit required. That's why I'm going to complete this LangChain inside this particular course. Then we'll start with the phase 4, which is LangGraph. So here we'll try to understand each and every component of LangGraph. As you can see, what is LangGraph, why LangGraph is required, LangChain versus LangGraph, then graph-based agent workflows, state management, node and edges, okay, state, nodes, edges, then conditional edges, okay, start and end nodes, graph compilation, state graph, check pointer, message state, sequential workflows, parallel workflows, conditional workflows, iterative workflows. Okay, then we'll try to see basic chatbot architecture, message handling, state management, user input, and we'll try to see how we can implement agentic chatbot with the help of LangGraph. So after that, we'll start with phase 5. So here we'll try to learn about the memory planning, monitoring, and autonomous system. So here we'll just try to learn what is persistence memory, why it is required, agent memory, short-term memory, chat history, how we can stream the responses, okay, chat threading, conversation management, permanent chat persistence memory with database, okay, tool integration in LangGraph, okay, inside the Agentic AI application. Then we'll try to see different tools, okay. Then we'll also try to learn like how we can integrate RAG, that means RAG features inside our AI agents. Then vector database integration, okay. Then we'll be learning another important concept, which is human in the loop. That means HITL. This is required nowadays. All the agentic application are having this kinds of human in the loop integration. Then we'll try to see the monitoring, our agent monitoring, agent tracing with the help of LangSmith. Then we'll also see how we can debug the agent behavior. Then phase 6, guys, we'll try to start with the deployment and production grade engineering. So here we'll try to dockerize the entire agents, okay. Then we'll try to add the fast API backend, database setup, GitHub Action CI/CD, AWS deployment, render deployment, okay, environment variable, then production folder structure, logging, monitoring, each and everything we'll try to cover. Then the final phase, phase 7, we'll try to start with some end-to-end real-world AI agents project implementation. So we'll be implementing basically 3 major projects here in this course. The first project, I'll be implementing one end-to-end agentic chatbot with the help of LangGraph, database, LangSmith, tools, RAG, HITL, AWS, and render. And second project, we'll be implementing our own ChatGPT agent with the help of LLM, LangGraph, Fast API, LangSmith, ChromaDB, SQL Alchemy, database, and AWS. And third project will be implementing called TripMate AI. This would be an end-to-end multi-agent table planner agent with Grok, LangGraph, PostgreSQL, and Fast API. Okay, so these are the 3 major projects we'll be implementing in this course. Then you can ask me what would be the course requirement to start this course. What are the things I need to know? I'm expecting you are familiar with advanced Python programming, because all of the coding I'll be coding in advanced Python. Then basics of generative AI knowledge is required if you're understanding about AI agents especially. So you need some understanding about generative AI, at least about the large language model. Okay, these are the things. Then software requirement wise, you should have Anaconda installed in your system, VS Code, Git, and GitHub, and Docker Desktop, and Postman. Okay, so these are the tools. If you have, you can start with this course. But don't worry, I will take care each and everything. If you are not familiar with this concept, I'll take care. I'll try to teach in such a way so that you will be getting all of the concept in a clear way. Okay, so yes, guys, this is the entire plan, and throughout the entire course, we'll be completing all of this concept. And trust me, the way I'm going to complete all of the concept, you will be loving a lot, and after this you won't be having any kinds of doubt. Okay, so if you're already familiar with Agentic AI, I will still tell you, just try to go through the entire course. I think you will be learning some new concept here, so some new implementation here. Okay, so definitely you will be enjoying the entire course. Okay, so yes, guys, this is the entire plan. Now let's start with the course concept. First of all, I'll give you the idea about the evolution of Agentic AI, how Agentic AI came, okay, from the traditional large language model. Then we'll try to start with the other concept as well. So in this video, first of all, we'll try to understand and see the complete evolution of this Agentic AI, like how Agentic AI came, and what we used to do in our traditional generative AI application. First of all, I will give you the entire understanding how Agentic AI came, what are the things they have introduced. Then I'm going to discuss about the detailed understanding of Agentic AI, the characteristic of Agentic AI, different component of Agentic AI. We'll try to understand with a good example. So guys, you can see on my screen here, I have already written the definition, like what is Agentic AI. So if you see here, Agentic AI is nothing but it's a type of artificial intelligence that can take up a task or goal from a user and then work towards completing it on its own with minimal human guidance. Okay, and it plans, takes actions, adapts to change, and seeks help only when necessary. So by this definition itself, I think you are getting little bit of understanding what I'm trying to say. Those who are already familiar with ChatGPT or any other agentic AI system, if you have already used VS Code, then Anti-Gravity, Cursor AI, Cloud Desktop, right? So these kinds of application if you have already used, so there you will see that whenever user gives any kinds of prompt, right? Based on the prompt, that application decides what to do. Let's say if you are asking a very simple questions, let's say we're asking, tell me about Python. So most of the large language model have been trained with lots of data, okay? Especially whatever data we are having on the internet, so they have used those data and they have trained those are the model. And every model is having a knowledge cutoff, okay? Every model is having a knowledge cutoff. Knowledge cutoff means a specific date till they have trained the model. Let's say if I'm talking about ChatGPT, or let's say GPT 3.5 turbo, or let's say GPT-4, you will see that those model probably they have trained on the year 2022 or 2023 around, okay? Till the date they have taken all of the data from the internet and they have trained those are the model. So whenever I'm asking about the Python, so definitely in 2022 or 2023 this information was available on the internet, and definitely our large language having these kinds of knowledge, right? So it will be able to give you the answer in short or directly. But whenever I'm asking anything which is latest, let's say I'm asking a latest information, I'm asking like, tell me about the latest news of Iran and USA, okay, were in 2026. So that time, definitely, if you are using a single large language model, okay, these kinds of large language model won't be able to give you the response, okay? It will tell, I don't have enough context, okay, after 2022 or 2003, so I can't answer your questions, okay? These kinds of, I think you will get the answer. If you have used the older ChatGPT, I think you are getting what I'm trying to say. So, but if I'm talking about nowadays, whatever application we are using, like Cloud Desktop, then Anti-Gravity, Cursor ID, if I'm giving any kinds of prompt, let's say I'm telling, just try to implement a application for me. Let's say implement a Python game for me. So what it will do, it will try to take that prompt as a command, and it will automatically, let's say, plan for a task like what to do, okay, how it can implement the entire game for you. So to implement a game, first of all, it has to create the environment, it has to add the requirements, it has to create the user interface, it has to make the character, okay? So one by one, all of the plan would be sorted. Then once all the plan is ready, okay, it will execute the plan one by one and it will complete the entire system. And definitely in between, it will try to test that particular, let's say, application, okay? If it doesn't get any kinds of bugs, it will continue and it will complete that particular work for you, okay? So that means everything is happening automatically. And sometimes you will see that in between it will ask a human interaction, it will ask for a human input. Let's say whenever it will try to implement a game, that time it might ask you what kinds of color you want for this particular environment, how many character you want in this particular game, what would be the, let's say, car color, what would be the car speed, okay? So sometimes it will ask some kinds of questions to the human, okay, for the guidance. And once we'll try to provide the feedback, or let's say our input, it will take that input again, it will try to continue the workflow, okay? So that's why here you can see it is telling with minimal human guidance, okay? Not complete human guidance, we give like very minimal human guidance here. And it try to plans, takes action, okay, adapt to changes. Let's say it has to it has to do one particular changes in the environment, or let's say color, or let's say any character, it will automatically do that, okay? And it seeks help only when necessary. So guys, before I give you the entire discussion on this agentic AI, first of all, I want to walk you through the fundamental concept of generative AI application. Like so far, whatever application we usually create, okay, and how this agentic AI, or let's say AI agents, came in the market. Then we'll try to understand this agentic AI concept. So for this guys, I'm going to take you on my whiteboard and there we'll try to discuss each and everything. So guys, I'm inside my board. So here I'm going to write down each and everything. So see, whenever I'm talking about uh, AI agents, right? AI agent. So this is the application of generative AI. Okay, this falls into generative AI domain. And those who are already working with generative AI, so I am having a dedicated course on my channel, the complete generative AI course. So there I have already discussed the foundation of generative AI. So in that course, I have already taught you all the concept regarding generative AI, large language model, okay, retrieval augmented generations. So each and everything I have already covered there. So if you are not familiar with generative AI, first of all, try to complete that particular course. Then it would be easy for you to understand. Okay. So in generative AI, the main component we usually work with large language model. Okay, large language model. So there are different large language model nowadays. I think you know, there are some organization, there are some company, they have launched different models. If I'm talking about Meta, okay, Meta AI, so they have launched something called Llama. Okay, Llama. Then if I'm talking about OpenAI, they have launched GPT. Okay, then we are having Mistral, we are having Gemini. Okay, this is from Google. So that's how we are having different large language model nowadays we usually use. So previously, whenever we started generative AI, that time we used to only use a fine tune based, or let's say pre-trained based large language model. Let's say here I'm having a large language model. So we used to provide a prompt. Okay, prompt, and it used to give a response. Okay, response. So basically we used to use this large language model for text generation. Okay, for very good quality text generation, or for some other task also we used to use, like for language translation. Okay, then for text summarization, then definitely for chat operation. We used to ask different kinds of question and we used to get the response. Then definitely for like some other NLP task like NER and so on. Okay. So initially, those who have already used this chat GPT, I think you are trying to relate the concept what I'm trying to say. It was like a very basic application, okay, we used to use for this kinds of text generation task. But slowly what they did, they actually introduced also image generation. Okay, image generation. So image generation happens whenever they introduce something called multi-model system. So in the multi-model, you not only generate the text, there you can also generate the image. Okay. But what was the problem with this kinds of application? As I already told you, let's say if I'm talking about any kinds of large language model, it is having a knowledge cutoff. Okay. This is having a knowledge cutoff. So what is knowledge cutoff? Let's try to understand. So for this, let's go to the Google. And here, if I'm searching for any kinds of model, let's say I'm searching for OpenAI models. Let's open up the models. Now let's pick any kinds of model from this OpenAI. So let's say if I'm talking about the GPT for 5.4 mini, or let's say if I'm taking any older model. Yeah, so I think here some models are available. Let's say if I'm talking about this the view all. Let's say if I'm talking about the GPT 4.1. So if I click on this model, you will see that this model is having a configuration. Configuration means the context window, like how much context it can take, then maximum output tokens, how much token it can generate, and there is a section called knowledge cutoff. Okay, so here the knowledge cutoff you can see January 1, 2024. That means this model has been trained till January 1, 2024 internet data. Okay, so if you're asking anything after that, let's say if you're asking February 1, 2024, definitely this model is not going to give you the response, because this model doesn't have the knowledge after January 1, 2024. Okay, whatever, let's say recent update we are having on the internet, this model doesn't know about that. So the main problem I think you can understand, let's say if my prompt is before this particular knowledge cutoff, the information I am looking for on from my large language model, definitely this model can give you the response. But if it is after the knowledge cutoff, that time it will not able to give you the response. Okay, it will tell I don't have the context, I don't have the informations, okay, after this particular knowledge cutoff. So I'm extremely sorry for that. So that is the things actually happened whenever ChatGPT came, okay, initially in the market. And I think you remember, okay, ChatGPT used to give this kinds of response. Then what they have introduced a concept called RAG. Okay, why they have introduced the concept called RAG? Because now let's say if I want to add some other information, let's say this is 2026, so now I want to add some more informations, okay, inside my large language model. So what I have to do, I have to fine tune this model, right? I have to fine tune this model. And fine tuning means we are taking the pre-trained model, okay, and on top of that we are adding some new data, adding new latest data, and we are training few parameters here. Okay, and whenever I'm talking about the LLM parameters, it will count like from million, right? Million to billion. Okay, this is the issue. So fine tuning is not an easy task. For this you need a good resources, then good budget, okay, then you should have also time. If you're having these kinds of things, then you can easily fine tune one large language model. Okay, there is no issue with that. So for the company, this fine tuning task was easy because they are having a good resources, they're having like very heavy investment, okay, they're having lots of time, so they can do that. But what about for the developers? Let's say if I'm creating an application, okay, for my client, and if any new data is coming and I want my application to be ever on top of this new data, so for me as a developer, this is going to be like very hectic task, right, for fine tuning a model, because I don't have this kinds of supercomputer with me, I don't have this much of budget, okay, so that I can purchase a good cloud for the training. I don't have that much of time so that my client will wait for me, because they has to also do the business, right? If I'm running my business also, this should be continuously running, and I should have handled all of the client with latest informations and everything. Okay, so that time researcher introduced something called RAG concept. Okay, this is called retrieval, okay, retrieval augmented generation, okay, RAG component. In the RAG component concept, what we used to do, let's say we are having a large language model, this is completely fine. Let's say we are having a large language model, okay, so it will be connected to a knowledge base. So knowledge base is basically a database, okay, it's a vector database. So this is called knowledge base. So it is having all the latest information, latest data I can say. Okay, so this data you have to store in the knowledge base and you have to connect with your large language model. Okay, and for this connection we use the orchestration framework, some orchestration framework I think you know inside Generative AI. we are having LangChain, we are having Llama Index. Okay, so this is called orchestration framework. So we use these kinds of orchestration framework to make the connection with our LLM. Okay, now if user is asking anything, okay, let's say user is giving input. Okay, first of all, this input would be verified in the pre-trained model. That means the large language model itself. First of all, it will try to check whether this information he's asking, what kinds of question they're asking, it is available in the LLM itself or not. It is available in this knowledge cutoff or not. If it is having, okay, in this knowledge cutoff, this will give you the response. Directly, this will give you the response. Okay, this will give you the response directly. But what about this information is not available? That time it will go to the knowledge base. It will go to the knowledge base. Okay, it will do something called semantic search, similarity search. This will get the relevant result about the questions user is asking. Then this particular relevant answer, again, your large language model will take. It will try to analyze. It will try to clean up. It will try to rearrange the response. Then it will try to send it to the user again. Okay, that's how the entire RAG system works. Okay, RAG system works. So basically, the major component we have added is knowledge base, and adding data in the knowledge base, it is super easy because only you just need to fetch the latest informations and add in the knowledge base. And your LLM is already connected to the knowledge base. So anytime if you're asking any kinds of question, it will bring that particular latest informations, and it will do the refining operation. Then it will pass to the human. Okay, so this will work like that. Okay, and this was the very famous technique that time. Even nowadays also use the same technique. We create the RAG application, and this actually helps us from this fine tuning operation, because here we are not doing the fine tuning, okay, on our LLM. Only we're just working on the knowledge base. We are adding the data in our vector database. This is the things, right? But there are some problem with this vector database or this RAG system. What is the problem? Whenever I'm talking about the real-time data means the data is continuously changing. Let's say if I'm talking about weather informations, if I'm talking about temperature, if I'm talking about the latest news, okay, it is continuously changing. That time it is not possible for me to sit down whole day and take all of the latest informations and like add in my knowledge base. Okay, that kinds of things we can't ever do that. So that is why this RAG system fails. Let's say if we're asking questions to the RAG system, let's say tell me about latest news, okay, right now in the morning. So definitely this information is not available in the knowledge base. Okay, let's say morning news you have added, but what about the afternoon news? What about after 1 hour news? Okay, so these kinds of things you don't have. Okay, so that time your application won't be able to give you the response. So what you have to do that time, you have to think about a different approach. So that's why researchers thought, why not we can create an agent? Okay, why not we can create an agent? So that agent will be connected with some tool. Okay, tool means we can use different tool here. Let's say we can use any kinds of search tool, we can use any kinds of storage tool, we can use any kinds of calendar tool, Google Drive tool, whatever we can use, but there should be some kinds of tool. So with the help of that particular tool, my AI agents will try to fetch the informations and it will give to the user. Okay, so what they introduce that time, they introduce a agent system. Let's say this is your agent. Okay, agent. Internally it is using a large language model only. Okay, whenever user is giving any kinds of input, it is connected with some kinds of tool. Okay, so let's say if I'm asking for any latest informations, that time it is connected with a search tool. Okay, internet search tool. So mostly this will search on the Google, and Google is continuously updating, okay, with latest informations. So if you're asking any real-time question, first of all, what it will do, it will use this search tool. It will search over the internet. It will get the informations, okay, latest informations, and your agent LLM is trying to refining that, and it is giving you the response again. Okay, and why I'm calling this particular system as an agent, because your application is smart enough to understand when it needs to call this tool when it doesn't need to call this tool. Okay, this kinds of reasoning capacity your application will be having. Okay, that's why we call it as a agentic system. Okay, here we are not deciding when to call this particular tool. You just give the prompt, okay, to the application will decide whether I have to call this tool to get give the response, or I have this information with me so I can give you the response. Okay, so this kinds of capacity it was having. So this was the first agent they have introduced with some real-time tool. So if I take you to the chat GPT, so let me give you the example. So I'll open the chat GPT, and here let's say I'm asking a question. Let's say I'm asking, tell me about, okay, Python. Now see what will happen. This is directly giving you the answer. Okay, it is not referring any kinds of tool, search tool. It is not searching on the internet. Okay, instead of that, what it is doing, it is giving you the direct answer. Okay, because this information is already available in the knowledge base itself. Okay, knowledge LLM knowledge itself. Okay, because it is already having before the knowledge cutoff. Get it? But whenever I'm searching for any other question, let's say I'm telling, tell me the latest news, latest news of India election. Now if I search that, now see, it is searching for web. Okay, it is searching for web. It is using an internal search tool, and with the help of that, it is searching over the internet, and it is referring some trusted, let's say, sources like Al Jazeera, ABC News. Okay, that's how it is searching on different website. Okay, now if I open this website, you can see that this is a website, this is another website. Okay, and this website has already this kinds of latest news. It is bringing that particular informations, it is passing it to the LLM. LLM is trying to refining, LLM is trying to summarizing all of this, let's say all of this content of these kinds of sources, and this is refining and giving you the answer. Okay, refined version of answer. Okay, so this is called actually agent system. Okay, it is utilizing some kinds of tools in the backend, and this application is automatically deciding when it needs to call that tool, when it doesn't need to call that tool. Okay, not only that, this is a simple example I have shown. If you have already used anti-gravity, let's say if I open up my anti-gravity, so this is my anti-gravity. So here I can give the prompt to the agent. So let's say here I am telling create a car racing game using Python. Okay, Python. Now here you can select different model, because internally I told you agent uses a large language model. Okay, because this is the brain. Okay, it is having the reasoning power, and it decides actually when to use the tool, when it doesn't need to use the tool. Okay, so here you can select different model. So anti-gravity supports, these are the model, you can select any of them. Now if you give this prompt, you will see that automatically, first of all, it will try to make the plan. Okay, what to do. Now see, it is telling generating. Let's wait. Now see, it is thinking. Okay, it is thinking. Now it is trying to making the entire plan for you. Okay, how it is going to create that particular racing game with the help of Python. What are the resources it needs? What are the tools it needs? It will try to make the entire plan. See, this is the plan. You can see this is the plan. Okay, proposed plan. Now what it will do in the plan, first of all, it will do the initialization, set up the Pygram display, front and clock, then player car, obstacle, collision detection, score system, give over screen. Okay, then what are the requirement it needs, verification plan, So this is the agent plan, guys. That's how one agent works. First of all, it has to make a plan, and based on the plan, it will start working on that. Okay, now I told you in the definition itself, it will seek for help when it necessary. That means little bit of human interaction is also needed. Now this plan is proposed to me. Now I can review the plan. Okay, I can make some changes. Okay, so let's say if you want to change anything, let's say you don't need this particular step, you can change anything. Okay, you can change anything, you can edit anything. Okay, then you can review it, you can like tell, okay, this plan is completely fine for me, you can continue. Now let's say if I do the plan is fine, go ahead. Okay, now if I give the prompt, I think prompt you can't see because this is just beside my image, but I think you can see. Okay, the prompt I have given. Now see, now it has started working on the plan. Okay, one by one it will work on all of the plan. Okay, and it will try to implement the entire game for you. Okay, so this is called AI agents nowadays. So AI agents is like this is not restricted to the tools only. Okay, now it can automate the workflow. This is called automation, right? Here I'm not writing the code. See, my agent is writing all of the code and it is asking for the approved. Okay, if I show you, if I let's say show you, so here you can see it is telling, do you want to run this pip install command? So it is asking for human interaction. Now if I give the human interaction, if I tell yes, just do it. If I tell okay, I accept the code, now the rest of the task it will automatically do that for me. Okay, so this is called AI agents. Now I think you have understood this particular definition. Now let me show you the definition once more time. So this is the definition, guys. Okay, so here you can see agentic AI is a type of AI that can take up a task or goal from a user. So here the task and goal I have given, just create a car racing game with the help of Python. So then what it will do, it will work towards completing this particular task is own with minimal human guidance. First of all, it will try to plan. Okay, then it will take action, adapt the changes. Okay, let's say whenever it requires any kinds of changes, it will automatically do that and seek help when it necessary. That means it will ask for my help. Okay, if I want to change anything, so it will ask for that particular help for me. It will ask for for my feedback. Okay, if I give the feedback, it will start working on that. Okay, so I think guys you have understood the entire evaluation of this agentic AI, how this agentic AI came, okay, right now in the market. Now in the next video, guys, what I'm going to do, I'm going to discuss this agentic AI in detail. Okay, the application working mechanism. Okay, I'm going to show you an example like how one agentic AI application works whenever we give any kinds of command. Okay, we give any kinds of prompt. I think you have seen all the anti-gravity, we given a prompt and it creates the plan. After creating the plan, what it will do, okay, each and everything I'm going to give you. I'm going to tell you the characteristic of this agentic AI, what are the characteristic it follows, what are the component it is having. Okay, so with a good example, we'll try to understand the entire concept in the next video. So yeah, this was only the understanding about this agentic AI evaluation, like how this agentic AI came in the market and whatever traditional application we used to create in the GenAI. Nowadays, people are people are moving to the agentic protocol. People are moving to the workflow automation instead of creating the simple actually text generation based application. Because right now everything can be automated, all the workflow can be automated. Okay, instead of working on manually, we can create agents, and that agents will try to complete that particular task for me. That's how you can also scale up your business. You can actually create some agents for your business, so it will run automatically. Let's say customer support agents you can create, okay, automatically. Email sender agents you can create. So that's how you can minimize the employee in your company, and you can save your budgets. Okay, but let's say if you don't have this kinds of agentic AI system, that time what you have to do, you have to hire someone to do that particular task. Okay, that's why companies are adapting these AI agents in their application development, in their workflow automations. Okay, they're replacing some low level employee which they feel like, okay, I don't need this kinds of employee and I can do this kinds of work automated way. Okay, people are thinking in that way. Okay, you have to also be smarter. Now people ask like whether we'll have the job or not. Okay, definitely we'll have the job, but you have to learn these kinds of technology. If you know these kinds of technology, then tell me who will replace you. But if you don't know this technology, let's say still you do the excel let's say data collection data collection, let's say strategy. Now tell me, I can easily create a agents and I can do the excel data collection. Okay, I can easily handle the customer automation. I don't need someone to handle my customer. Let's say whatever customer are coming to my website. Okay, I don't need to like hire someone to sit and reply for that. So what I will do, I'll just create a agents. I will give all of the informations about my website, all of my services. My agents will take care of everything. Okay, this is the things nowadays people are moving. Okay, so yeah, trust me guys, this particular skill is having high demand in the market. So if you can master this one, definitely you can get lots of opportunity. Okay, and I will try to complete this agentic AI in a such a way so that after completing it, you can create any kinds of agentic AI applications. So in this video, I'm going to discuss about the detailed discussion about agentic AI, how one AI agent works, how one agentic AI application works. We'll try to understand each and everything with a good example. Apart from that, I'm going to also discuss about the key characteristics and key component of agentic AI system. So this is going to be one amazing discussion, guys. Make sure you watch till the end. And if you have any kinds of doubt, feel free to comments in the comment section. So instead of talking too much, guys, let's start with our discussion. So guys, on my screen, I think you have seen the definition of agentic AI. So this definition is already familiar with you. In my previous video, I have already given you the walkthrough. Let me again give you the walkthrough of the definition. As you can see, agentic AI is a type of AI that can take up a task or goal from a user and then work towards completing it on its own with minimal human guidance. It plans, takes action, adapt to changes, and seeks help when necessary. So in my previous video, guys, I have given you the demo of a AI agents application. I think I showed you the anti-gravity example. So there what happens, let's say whenever I used to give a prompt, there I given a prompt like just create a game for me, car racing game for me with the help of Python. So what it was doing, it was creating a complete plan. Okay, I think you remember it was creating a complete plan like what to do, what are the environment it should use, what are the package it should use. Okay, then what should be the color, what should be the let's say environment. So it has each and everything. It was like making the plan. Okay, after making the plan, guys, what it started, it was looking for my confirmation whether if everything is fine or not. So it was looking for a minimal human interaction. Okay, minimal human guidance. So whenever I approved everything, it started taking the actions. That means one by one, all of the plan, it was starting executing, right? And it was creating that particular games for me. Okay, so that's why this definition is, I think, pretty clear, like how one agentic system works. But if I'm talking about a simple chatbot, okay, so in simple chatbot, what happens? You just try to do some question answer. Okay, it will give you the answer with respect to that, but it doesn't have any kinds of, let's say, tool integration. It doesn't have any kinds of, let's say, reasoning capacity so that it can automatically think like, okay, now I have to use the tool and now I don't have to use the tool. Okay, but in agentic AI application, it has the capabilities for selecting any kinds of tools it's required. Okay, let's say you are doing some automatic coding, or let's say you are creating a game, right? That time what kinds of tools it is required, it will automatically call that tool and it will start creating that particular application for you. So let me give you one example, guys, how this agentic system works. So as you can see, guys, this is the example I have taken. So let's say this is our agentic system. Okay, this is a agentic AI application. So let's say DSwithBappy wants to hire some backend engineer, or let's say some other kinds of engineer. So what I have done, I have created this agentic AI system, okay, for my platform. Now let's say if I'm not using this kinds of platform, so what I have to do, maybe I have to hire someone, okay, so he will try to, or she will try to prepare everything, okay, for this particular job role. That means the job description. Then once the job description is ready, he or she will be posting over different job platform. Then they will continuously monitoring that how many applications are coming. Once application are getting submitted, again they will try to review that. If application is coming very less, again they will try to update that particular job description with a different job role, again try to upload that. Okay, that's how they will be continuously monitoring. And once application got submitted, we'll try to review that. And once reviewed, everything is fine. Okay, let's say we got some amazing candidate, we'll start scheduling the interview. We'll take the interview. After taking the interview, what I have to do, I have to actually prepare a offer letter for him. Then we'll be sending the offer letter, and once the offer letter is approved, then we'll try to do the onboarding operation. So this is a like very long and time taking process, and here I have to definitely pay for that particular work, right? Let's say the person I'm hiring for this one, so definitely I have to pay for that, right? But let's say I don't want to pay, because nowadays people are using agentic AI system. So what I'm going to do, let's say I have created this agent for me. So what this agent does, so this agent is already connected with my platform DSwithBappy. So it is having all the data, okay, about my let's say platform. And I have already told this particular agents like what kinds of candidate I want, what kinds of job requirement they are having, what is the salary, okay, each and everything I have given to this particular agent. Now here what I'm going to do, I'm going to simply give a prompt. I want to hire a backend engineer, and they should have 2 to 4 years of experience. Okay, let's say this is my prompt. So first of all, I think you remember what a agent will do, right? A agent will first of all try to make a plan. Okay, a agent will try to make a plan. But how it is going to make the plan? First of all, the command, the prompt you are giving, this command and prompt would be taken as a goal. So as you can see, my agent goal is hire a remote backend engineer. Okay, their experience should be 2 to 4 years of experience, and this is the plan actually it has automatically created. Now just try to see the plan. Okay, the way actually a manual human will do that, it has done the same thing, okay, but with a revised version. Now you can see it is giving me a plan. First of all, it will try to make a draft job description and post on best platform. Okay, let's say LinkedIn it can post, Naukri it can post, okay. Then some other job platforms are also available, okay. So there it will try to post that particular job description. So once posted, it will continuously monitor the pipeline. Okay, monitor the pipeline means, let's say I have posted a job description. It doesn't mean that I will just try to disappear, right? Automatically application will come. It's not like that. You have to continuously monitor that particular job description, like how many applications are coming, what are the candidates are applying for, is there any issue or not, right? We have to continuously monitor that particular pipeline. So what we are going to do, guys, we'll be continuously monitoring that pipeline. So agent is also telling we'll monitor the pipeline and adjust strategy if needed. Okay, so it will automatically adjust, okay, this particular strategy if needed. Let's say you are getting very less application. Let's say your expectation is, let's say 50 application, but you are receiving 4 to 5 application. That time definitely this is not meets your expectation, right? Definitely there should be some problem with the job description. That's why candidate are not preferring that preferring your job description. So what agent will do, maybe agent will try to change the job description. Let's say instead of backend engineer, maybe it will tell like full stack engineer, or let's say full stack AI engineer, okay, or let's say web developer. These kinds of job role, again it will try to set, and again it will prepare the job description, again it will post on the platform. Okay, then again it will continuously monitor that particular pipeline. Then let's say now this particular pipeline is working fine, so people are applying for that particular job role, we are getting lots of candidate. So from the all of the candidate guys, we'll try to filter out like what would be the best fit for this job, for this particular job role. We'll try to select that particular candidate. So agent will try to select that candidate, and maybe let's say it will take 2 to 3 candidate, and it will schedule interviews for them, right? So once interviews is scheduled, then it will be taking the interview. Then after that, let's say we selected a candidate, agent will try to draft the offer letter. So offer letter would be created and it will be sending to the candidate. Once candidate is approved, then it will start the onboarding process. Okay, so this is the entire plan it has proposed. Okay, it is the entire plan it is proposed. Okay, now after preparing this particular plan, I think you remember, it will first of all ask me, should I continue with that? So definitely you have to give a permission, yes, continue. Okay, then what it will do, it will first of all see what is the first plan. First plan is drafting the job description. Okay, so it will tell, now I will first start with the drafting the job description, taking help from the company documents. Like let's say I have already given my platform access. Okay, DSwithBappy platform access, so it is having all the documents, all the data. Okay, what are the things I am having the requirement, it will try to take all of the data and it will try to prepare a job description for that. And now it is telling, do you want me to make some changes? I'll try to review the entire, let's say job description. If completely fine with me, so I'll just try to tell, no, this is absolutely fine, you can continue with that. Now let's say my agent has prepared one job description for the backend engineer. Let's say we are looking for a remote backend engineer with 2 to 4 years of experience in backend development, blah blah blah. Okay, so once this particular job description is ready, now the second plan was posting the job description in a different platform. Okay, now it will tell, all right, shall I go ahead and post this job description on the following platforms like LinkedIn, Naukri, etc. So I will try to review again, and again I'll tell to the yes, you can do that. Then what it will do, it will try to post that particular job description. Then it will tell, I will continuously monitor the application and keep you posted. And for posting this particular job description on a different platform, we have to connect with the API of the platform. Okay, so this particular API, we can call it as a tool. Okay, so LinkedIn having a tool, Naukri is having a tool. Okay, that's how there are thousands of like job posting platform, they're having the tool. So you just need to give the tool access to the agent. So agents will try to decide when to call what kinds of tool. Okay, maybe you can't see now, I think it is visible. So just right hand side you can see it is calling the API, okay, as a tool, and it is trying to access over the LinkedIn and Naukri, and it is posting that particular job description in that particular platform. Okay, so that's how this kinds of agent works. Now what should be the next plan? Let me show you what should be the next plan. Next plan would be revising the job description. Okay, let's say it was continuously monitoring. Okay, it was continuously monitoring the pipeline. Then it just received, you can see the job posting has received only 2 applications so far, much below our expectation. Let's say my expectation was 20 applications, but I'm getting only 2 applications. So definitely there would be some problem with my job description. So my agent has suggested me some kinds of feedback. Okay, you can see it is suggested some action. So it is telling broaden job description to include full stack. That means instead of giving the backend engineer, maybe we can make it to full stack engineer, because full stack engineer might have demand in the market and people are looking for this kinds of job. And promote job on LinkedIn or let's say Naukri. Okay, so what it is trying to say, it is trying to say like why not we can promote that particular job on the LinkedIn by doing the advertisement. Okay, maybe by doing the advertisement it will go to that particular candidate and he or she might be interested and they can apply. Now it is telling, shall I proceed with that? So if I'm fine with this particular suggestion, I'll do yes please. Okay, you just continue. So this is called actually what? I think you can see the definition. Let me show you. See, adapt to changes. Okay, adapt to changes and seeks help when necessary. Okay, my agent itself is trying to planning, taking action, and it is doing the changes if it's required, and it is also seeking the help when it's necessary. It is trying to wait for my confirmation, and it is doing all of the work for me. Okay, now what it will do, again it will try to change that particular job description. Revised version of job description would be posted, and also promotion marketing would be activated. Then again it will start monitoring the entire process. Okay, so yeah, now what it will do, guys, it will try to continuously monitor. Now let's say here we are getting our expectation right now. Let's say uh, revised job description posted, promotion activated, and it is continuously monitoring. Now let's say 8 application received. Okay, this is completely fine. So what I can do, I can screen them using our checklist: strong candidate, partial matches, and weak matches. Okay, that means it will try to divide all of the candidate in 3 category. The first category would be strong candidate. Let's say from 8 application, 2 are strong, 3 are partial matches, and 3 weak matches. Okay, so what it will do, it will try to only select the strong candidate, okay, with respect to my let's say company's requirement. Now it is telling, shall I schedule the interviews with the top 2? So if everything is goes fine, I'll tell okay, you can continue with that. Okay, so what it will do, it will try to schedule the interview. But before scheduling, what it will tell, it will first of all try to check my availability. So for the availability, what I can do, maybe I can give my calendar access to my agent. Okay, I think you know that we can integrate any kinds of tool, okay, any kinds of applications to the agents nowadays. You can connect your Slack, you can connect your calendar, you can connect your Google Drive, anything you can give the access. Even if you have used already Cloud Desktop, you will see that Cloud Desktop, you can also provide your computer access, entire computer access, okay, and you can control your entire computer. This is also possible, right? So what I will do, I will give my calendar access. So my agent will try to check my availability. Okay, now it is telling, let's say, sure, let me check your availability for this week. You are free on Friday. Let's say I'm free on Friday. Do you want me to schedule the interview on Friday? So here I will tell, yes, go ahead. Okay, I don't have any kinds of issue. I'm completely free on Friday. Now what it will do, it will try to draft an invitation email for the candidate. Let's say this is the email it has prepared. Hi candidate, we would like to schedule a 45 minutes of interview for the backend engineer role. Please share your availability. Okay, so this email would be sent it. Now 6th step, it will try to do the interview process. Okay, so 5th step, it was doing the scheduling. Then 4th step, it was doing the shortlisting. Okay, and 3rd step, I think you know, it is doing the revision of the job description. Step by step, it is running the plan. Okay, not randomly. Now once, let's say, candidate accepted the invitation of this interview scheduling, so what will happen, it will try to remind me. So it will tell, quick reminder, you have 2 interviews lined up for Friday. So I'll tell, okay, thanks for reminding. Now it will tell, I have mailed you a documents containing a list of interview questions asked in previous interview for the same role. Now it is not only schedule the interview for me, it is also preparing the interview questions, okay, for that particular job role, and it is giving to me. Okay, so I'll tell, okay, I'll check that. Now let's say these are my interview question it has prepared. Okay, now what I'm going to do, I'm going to take the interview of the candidate. Okay, manually I'm going to take the interview for the candidate. Let's say 30 to 35 minutes. I'll take the interview. I will ask all of the question my agent has suggested, and if he or she is completely fine with that questions, he is able to give me all of the answer, so definitely I'm going to select, okay, one of the candidate. Now let's say I told, I have finalized one candidate, can you draft an offer letter? My agent will tell, sure, here is the offer letter, please review. I will tell, okay, yes, it works. Then offer letter would be sent it and tracking the acceptance. Okay, that means this is my offer letter. Okay, my agent has prepared, it will send to the candidate. Okay, let's say we are pleased to offer you the position of backend engineer, please let us know. Please let us know if you accept. Okay, so once the candidate has accepted, now what it will do, it will do the onboarding process. Okay, after sending the offer letter, it will do the onboarding process. So here, candidate has accepted the offer, I have initiated the onboarding, welcome email sent, IT access requested submitted, laptop has been provisioned. Okay, shall I schedule an introduction meeting with him? I'll tell yes. So the introduction meeting would be scheduled. Okay. So that's how guys our agent system works with a very minimal human interaction here. So you just only give to, you just only need to give a task. You just only need to give a prompt. Let's say I want that, or you have to do that particular work. It will automatically make the plan, take the actions, and it will ask for the help when it necessary. Okay. So this is not possible with a simple chatbot or the simple RAG based application, whatever we used to create previously. This is only possible in the Agentic AI system. Okay. And this is called actually AI agents, and every AI agents works in that way. Okay. First of all, it will try to make a plan, and step by step, all of the plan would be executed. This is called take actions. Then adapt the changes. That means whenever it necessary, it will do the changes. And whenever, let's say, it feels like, okay, it needs to ask to the human for the confirmation, it will do that, because I can't give full access to my agents to do everything, because definitely there should be some manual human observation. Okay. Otherwise, some other things might be happen, right? So that's why some minimal human interaction is required. If you take any kinds of Agentic AI application, whether it's Claude Desktop, whether it's your anti-gravity, Cursor AI, it works in that way. Okay, I think I showed you the example of anti-gravity. There I was doing the automatic coding, right? I was implementing a game. So there I gave the prompt. It was taking that particular prompt as a goal. After that, it was creating the plan. Okay. In the plan itself, step by step, all of the things it has suggested me. Then I approved everything. It was creating step by step. It was also executing in between. If any change is required, it was doing that, and it is asking for my confirmation. And once I confirm, it is doing each and everything for me. Okay. So I think now the agentic system is clear. What this agentic system is, how it works. Okay. Now we'll try to understand the key characteristic of a agentic AI application. So for this, let's go to the next actually diagram. As you can see, these are some key characteristic of a AI agents or agentic AI applications. So the first characteristic, you can see it should be autonomous. So definitely the example I have showed you, this is completely autonomous agent. So there I only told I need to hire a backend engineer with 2 to 4 years of experience. So what it started, it was started creating the plan, taking the actions. Okay. Everything was automatically doing there, right? It was posting the job description. It was continuously monitoring that. It was asking the help to me. If I confirm that, it will again recontinue the work. So it was completely autonomous. Okay. Then it should be goal oriented. So definitely the task you are giving, it should be taking that particular task as a goal. Okay. Without goal, how it will achieve that particular work, right? So in our life also, whenever we get any kinds of work, whenever we get any kinds of task, definitely we have to take it as a goal. Okay. If we take it as a goal, then we can complete that particular goal by planning something, right? We'll do that different planning. We'll execute those plan, and we'll try to achieve that particular goal. Okay. That's why the next characteristics, the planning. So to achieve this goal, we have to make the plan. That means for this particular example, you saw that it was creating the plan. Like first of all, job description would be created, posting in the different platform, continuously monitoring. After that, it will change if it is required. Then scheduling the interview, sending the offer letter. It was complete plan, right? Then reasoning. So this is the most important characteristic of an AI agent, the reasoning. And here your LLM comes, right? Because LLM is the only brain your agentic AI system is having. With the help of this particular LLM, it performs the reasoning operation, and it automatically decides whether it needs to call any kinds of tool or not. Because your agents will have connected with different tools, right? Different application sources, and it will automatically decide when it needs to call what kinds of tool. Let's say whenever it was posting the job description, it needs to call the LinkedIn or Naukri API, right? This is the tool. Definitely it will not call the calendar API, right? So it is automatically thinking in that way. This is called reasoning, right? Then adaptability. Okay, adaptability, it should have it will automatically decide when to change something. Okay, what should be the suggestion for that? Okay, then the context awareness. Context awareness means it should remember the previous context. Let's say I given, let's say I want to hire a backend engineer. Let's say today I have given this particular prompt, and for some reason, I went out. Okay, let's say for 2 days I went out. Then again I came to my agents and I told, just tell me the progress about the backend engineer. Now it is, if it is doesn't have the context awareness, that means the memory integration, that time your agent will tell what kinds of backend engineering you are telling me, right? What is the task you are telling me? I don't know about that. But if it is having the context awareness, that means the memory, it can tell, okay, so this is the progress. I have already posted the job description, continuously monitoring, and let's say 8 to 9 application I got so far. So this is called context awareness, and every Agentic AI application should have this particular context awareness. Okay. So guys, now let's try to see the detailed discussion of each and every characteristic. So here I have already listed down each and everything. So first of all, let's try to understand this autonomy. Okay, this autonomy means the autonomous, the first characteristic. So as you can see, autonomy refers to the AI system's ability to make decisions and take actions on its own to achieve a given goal without needing step-by-step human interaction. That means if you have already seen the example of our AI recruiter, so there it was kinds of autonomous. Okay, it was autonomous agent, and it doesn't need any kinds of step-by-step human interaction. So there I was not giving step-by-step human interaction. I was not giving step-by-step prompt what to do, right? So the things is that I have only given my requirement, my goal. So it took that particular prompt as a goal. It was creating the plan. It was executing step by step. That's why you can see it is proactive. That means continuously it is working on that particular goal. Then autonomy in multiple facts like execution. It was executing the plan step by step. It was doing the decision making. Okay. By the decision itself, it was thinking like what to do, when it needs to post it on different platform, when it needs to make the changes. Then tool uses. Okay, let's say when to use what kinds of tool. Let's say whenever I want to post the job description, what kinds of tool I need to call. Definitely you need to call the LinkedIn and Naukri, right? So this kinds of ability my autonomous agents will be having. That's why the first characteristic, the autonomy, we can also call it as a autonomous, right? Now the thing is that autonomy can be controlled. Permission scopes, that means you can limit what tools or actions the agents can perform independently, can screen candidate but needs approval before rejecting anyone. Okay, that means it's not like that I am given the full autonomous permission to my agents. So definitely you can set the limit, you can set the permission. So let's say once one interviewer having the screening round, so before approval or rejecting, so definitely I have to see that manually, then I will approve that, then my agents will do that for me. Then human in loop, we can also call it as a HITL. So insert checkpoints where human input is required before continuing. That means in this case, let's say my agent was telling, can I post this particular job description or not? Okay, this is called human in loop, and every agents are having this kinds of functionality. Okay, going forward we'll be implementing the agents, right, with different framework. So there also you are having this kinds of functionality. With the help of that, you can actually create this kinds of system. Whenever your agent is needed your human approval, it will ask for that, then you can continue and it will start working on that. Then override controls allow users to stop, pause, or change the agent's behavior at any time. Pause screening command to halt resume process. Okay, so what happens, let's say in my agents, okay, whatever I'm doing, it's completely fine, but it should have my control. Okay, my control means, let's say I can stop this particular agents anytime, I can pause anytime. Let's say my screening round is going on. In between, if I feel like, okay, I have to stop the screening round, if I give the command, it should stop that. Okay, it should stop the process that time. Okay, so this is called actually override controls. Then guardrails and policies. So definitely your agent should have guardrails and policies. Nowadays you will see that agent integrates different guardrails. Okay, and for this one framework came in the market called Guardrails AI. With the help of that, you can define hard rules or ethical boundaries to the agent must follow. That means, let's say if I give you an example, it will tell never schedule interview on weekends. Let's say weekends I'm completely occupied, I'm not available. So I can give the restriction, I can give the rules, never schedule interviews on weekends. So my agent will never do that. And if you see, nowadays all the agentic AI application is having these kinds of guardrails and policies. Let's say if you're asking any kinds of violating content, if you're asking any kinds of sexual content, if you're asking any kinds of, let's say, adult content, definitely it will not give you the response with respect to that, because it has a guardrails and policies restriction in the agent itself. Okay, and for this we are having some library, we're having some framework, definitely will also see in our playlist itself. Okay, then autonomy can be dangerous. The application autonomously sends out job offers with incorrect salaries or terms. So if you completely make it automated, so what we'll do, there is a possibility your agents will send a job letter with incorrect salaries. Let's say your budget is 1 lakh, but your agent is sending the expected salary 10 lakhs, right? So definitely this is going to be an issue. So that time the applications shortlisted candidate by age or nationality, violating anti-discrimination laws. Okay, this is another terms. Then the application spending extra on LinkedIn ads. Let's say sometimes what will happen if it is running autonomously, although you are getting a good let's say application from your job description, but still your agent will feel like, okay, I need more, and it is spending more money on LinkedIn ads. Okay, so these kinds of things definitely you have to overcome, okay, by actually doing the human in loop HITL, okay, functionality inside your agent. Now the next things we're having, which is this goal oriented. Okay, goal oriented. Now you can see what is goal oriented. Being a goal oriented means that the AI system operates with a persistent objective in mind and continuously directs its actions to achieve that object rather than just responding to the isolated prompts. Okay, that means if you read here, you will see that goal acts as a compass for a autonomy. Okay, so to make your agent autonomous, definitely there should be a goal. In this case, our goal was hire a backend engineer. Okay, this was the goal, and will act as a compass for the autonomy. That means your autonomous agent should follow this particular goal, and to achieve this goal, it needs to execute different plan. Okay, now goal can comes with constraint. Definitely you can set some constraint. In this case, let's say my constraint was 2 to 4 years of experience candidate I only want. Okay, then goals are stored in the core memory. That means goal should be stored in the core memory. That means in the context awareness memory. Otherwise your agent will forget that what to do, right? Let's say if I give you a basic actually template, the common template for all the agents, it stores the data in the memory. So this is a JSON format. Let's say you can store any kinds of database here. Internally, agent uses a specific database or storage services, and it stores these kinds of metadata so that it can remember. So in this case, let's say the goal was hire a backend engineer. The constraint was 2 to 4 years of experience. Remote is true. Stack, Python, Django, cloud. Okay, these are the skills I'm looking for. Status is active. My agent is always active. When I posted the job description, this particular date would be also saved. Progress, job description is created. True. If not created, it should be false. Okay. Posted on different platform like LinkedIn and Angel List or Naukri. Yeah, it has posted, and this is the list. How many applications received so far? Only 8 applications. Interview schedules with 2 applications. Okay, so this is the storing strategy for every agents. So let's say each and every framework is having different way they stores the data, but this is the common. If I tell one common, let's say, structure, so this is the common structure. That's how the goal should be stored in the core memory. Okay, all the running instance metadata would be saved in the core memory. That's how it usually saves, and it will take that particular data from the memory itself to continue the plan, to continue the goal. Okay, that's how one agent remembers each and everything. Now I think you are getting. Now goals can be altered as well. Let's say once you have set one goal, you can also change that particular goal to another one. This is also possible here. Okay. Now the next characteristic, it is the planning. Okay, planning. So you can see planning is the agent's ability to break down a high level goal into structured sequence of actions or sub goals and decide the best path to achieve the desired outcome. Okay, that means let's say I have given a prompt, I have to hire a backend engineer. Now to achieve this particular goal, what this agent has to do, agent has to create a different okay, agent has to create a different plan. I think you saw that what was the plan. So for that particular example, it was preparing the job description, posting on different platform. Okay, then it was continuously monitoring that. This was the plan. Now whenever it is planning, you'll see that generating multiple candidate plans, it will only not, let's say, proposed one plan, it might give you multiple plan. Okay, let's say plan A, post the job description on LinkedIn, GitHub, jobs, or angel list. Okay, plan B is that use internal referrals, okay, and hiring agencies. So it has suggested you two plans. Now it is asking for your feedback. Okay, now based on your choice, you can select which plan you want to go ahead with. So whenever your agents are working, it has the reasoning capacity. That means it should also minimize my cost, right? And if it is suggesting me two plan, so definitely if I'm taking the plan A, so there I will let's say spend less amount, because here I'll directly post on LinkedIn, GitHub jobs and handle list. Okay, but if I'm taking the plan B, if I'm taking some hiring agency, so definitely I have to take their subscription plan, right? So there I have to pay more money. So get it? So that's why it is giving you different plan. Okay, then evaluate each plan. As I already told you, agents will itself evaluate the plan. Let's say plan A is perfect or plan B is perfect for this particular work. Based on that, it will give you the suggestion. Then the efficiency, which is faster. So if I'm going with plan A or plan B, which is faster, so definitely plan A is a little bit faster, because I can directly post the jobs on the platform itself and get the applications. Okay, then which one is having less cost? Definitely plan A is having less cost. Then risk, will it fail if we get no applications? Okay, then alignment with constraints, remote jobs only, budget. Okay, so these are my steps inside the plan. So based on this particular evaluation steps, it will select the plan. Okay, now third step, select the best plan with the help of human in loop. That means it will definitely ask to the human for the best plan, which one you would like to go ahead. So which of this option do you prefer? A pre-programming policy, favor low cost, channel fast. Okay, so definitely whenever I will take any kinds of plan, I'll try to check this particular low cost, okay, option in my mind. So yes, this was the I mean characteristic, which is planning. Now the next characteristic, the reasoning. Now let's try to understand this reasoning, guys. So what is reasoning? First of all, let's try to understand. As you can see, reasoning is the cognitive process through which an agentic AI system interprets information, draws conclusion, and makes decisions, both while planning ahead and while executing the actions in real time. Reasoning during planning, goals decompositions break down abstract goals into concrete steps. Tool selection, decide which tool will be needed for which step. Resource estimation, estimated time, dependencies, and risk. Okay, as I already told you, whenever a agentic system is working, it will be working with respect to the reasoning, because behind the reasoning one LLM works, right? And LLM has the actually intelligence capacity, so that it can understand and it can automatically make the decision. It can automatically, let's say, break down the goals. Okay, it can automatically tell you what kinds of tools should be selected. You can also like work on the resources estimations, like estimated time, dependencies, and risk. Okay, so with the help of this reasoning, guys, these agents would be more powerful, more efficient. Why? Because I told you, if one agent doesn't have the reasoning capacity, that means this should be the simple chatbot only. Okay, this should be the simple chatbot only. Why a chatbot is different from a AI agent? Okay, why AI agent is powerful? Because of this reasoning. Okay, let's say if I'm having a agent, if I'm giving any kinds of input, and it is connected with different tools, right? Some kinds of tools it is connected. Now whenever I'm giving an input, now this will perform this reasoning operation. It will decide the question human is asking, whether I have to directly give the answer, I have to refer the tool for that. Okay, so this is called actually reasoning. So reasoning is super important here. Okay, now here you can see reasoning, duration, execution, decision making, choosing between option, 3 candidate matches, schedule for two best candidate, and reject one. So this kinds of decision making is taking your agent, okay, with the help of this reasoning, with the help of this LLM. Now HITL handling, knowing when to pause and ask for help, unsure about the salary range. Okay, for an example, let's say if with the help of this reasoning, it is automatically decide when it should ask for the help to the human, when it needs to ask for the confirmation from the human. Okay, in this case, let's say my recruiter agent is asking what should be the salary range, just try to tell me. Then error handling, interpreting tools API failure and recovering. Okay, let's say sometimes some of the tool might be down, right? That time how this particular agent will handle that particular error. Let's say if my tool A is not working, so definitely it will try to move to tool B. Okay, so this kinds of ability this reasoning will be having. Now the next one, adaptability. So what is adaptability? You can see adaptability is the agent's ability to modify its plan, strategies, or action responses to unexpected conditions, all while staying aligned with the goal. Okay, so that means I told you, let's say in that particular case, I think you remember, we got very less application, right? And my agent was automatically give you the suggestion, and it was telling like I need to change the job description to backend engineering to full stack engineer. So this is called adaptability. Your agent is automatically modifying the plans, modifying the strategy, then again it is working with respect to that. Okay, you can see failures in then external feedbacks and changing the goals. Okay, now what is the next characteristic is the context awareness. I already told you what is context awareness. Context awareness is the agent's ability to understand, retain, and utilize relevant information from the ongoing task, past interaction, user preferences, and environmental cues to make better decisions through the multiple steps. Okay, and if I'm talking about context awareness, this is nothing but it's a memory. Okay, you can see context awareness is implemented through memory. Here we create two kinds of memory. One is short memory, one is long-term memory. Short-term memory and long-term memory. So as you can see, if my agent doesn't have the context of my previous, let's say, goals or plan, so then how it will progress the current one? So definitely to run the current progress, it should have the previous context, right? So let's say in this case, I have given I want to hire a backend engineer with 2 to 4 years of experience. So it should have these kinds of information in the context memory. Based on that, it will make the decision. Okay, this is what actually it is explaining. And what are the tool responses it is getting? Definitely it will also try to store that particular responses to the context memory so that it can give you the better response with respect to that. Now at the end, this context awareness implemented through memory. So here we create short-term memory and long-term memory. Short-term memory we create for the current state. Let's say if one current state is running, if it is creating some metadata, we will be storing in the short-term memory. And long-term memory means the whole conversation, the whole user interaction it is doing, it should have the present in the long-term memory. Okay, so this is the idea. So yes guys, these are some characteristic we usually have inside any kinds of AI agents, and how you will understand this particular application is a AI agents application or agentic AI application. If this application is having this kinds of characteristic, definitely you can think about this is a agentic AI application. Okay, definitely in the architecture itself, these kinds of characteristics should be mentioned. So guys, now we'll try to see the components of agentic AI application, what are the component one AI agent is having. You can see the first component is the brain. Okay, whenever I'm talking about the brain, so here LLM would be utilized. You can use any kinds of LLM here. So LLM has the reasoning capacity. With the help of that, it will make the decisions. It will try to do the HITL operation. It will do the tool selections. Okay, all the operation will be happening with respect to this particular brain. And the second is the orchestrator. So what is orchestrator? To build our entire agentic AI system, okay, we need some orchestrator. Orchestrator means this is the framework. Okay, framework. Let's say it will do the connection with the LLM, that means brain. It will make the connection with tool. Then whenever it is required for the tool calling, it will perform the tool calling operation. Whenever it is required, let's say it will call the HITL, that means human in loop, right? It will ask for the approval from the human. So these kinds of things, if I want to create a complete agentic AI application, I need to use some framework. I can't create with the help of simple Python, or I can't create with the help of simple TensorFlow, right? Or LangChain. This is not possible. So I have to use some end-to-end framework for that. Okay. So in the market, there are some famous framework, like we are having Crew AI. Okay. We are having LangGraph. We are having AutoGen. Some no-code platform is also available, like N8N. Okay. So apart from that, some other like framework are also available, but these are framework actually very common and very popular and very powerful in the market nowadays, and people use that, developer use that to create agentic AI applications. Okay, so throughout the entire this course, guys, we'll try to master. These are the framework. We'll see the entire Crew AI framework. We'll try to develop AI agents with the help of Crew AI. Okay, end-to-end multi-agent system we'll try to create. Then LangGraph we'll try to explore. We'll try to create end-to-end application with LangGraph. We'll try to see the AutoGen. We'll try to understand the entire AutoGen component. We'll create the AI agents with AutoGen. We'll try to see some no-code platform as well, like N8N. We'll see how we can create the AI agents without writing any kinds of code, by doing some drag and drop operation. Each and everything we'll be learning. Okay, so that's why orchestrator is also required, and this is one other component of a AI agent. And orchestrator means a AI agent building framework. Okay, always remember. LangChain can be also utilized. With the help of LangChain also you can create some of the simple agents, but later on LangChain published actually LangGraph, so people are moving to the LangGraph for building these kinds of AI agents. Okay, now the next one is the tool. So definitely tool should be available as a component. Here we can utilize any kinds of tool, whether it's any kinds of search tool, whether it is any kinds of calendar tool, or any kinds of application tool. Okay, if you just open the internet and if you search like agentic AI tool list, okay, you will see that there are thousands of tool listers available. Okay, whether it is search, whether it is any kinds of application with your Google Drive, with your calendar. So let me show you some of the list. So guys, as you can see, there is a GitHub called AI Agent Tools catalog, and there is some other website as well you will be getting over the internet. So if you open this up, so this is having all kinds of tools and toolkit, as you can see. So we are having archive, so tools to read archive papers. So I think, you know, if we read any kinds of research paper, we go to the archive website. Okay, archive.org. So this is also a tool. This tool is available in the framework itself. You can use this tool for reading any kinds of research paper. You can connect your AI agents with the research paper actually world. Okay, then Baidu search is there, Bing search is there, Brave search is there. These are my search tool. Okay, then code doc search is there, CSV search is there. That's how you can see Google search is there. We are having different tool. Okay, so this is for the code interpreter. Okay, these are the code interpreter. If you want to interpret any kinds of code, these tools you can use. If you want to do the productivity, these tools you can use. Okay, you can connect with your calendar, email, Zoom. Okay, this is for regular automation. Now this is for web browsing. If you want to browse the web, this tool you can use. If you want to connect with the database, these are the database tools are available. If you want to do the file operation, these are the tools are available. Okay, so that's how whatever tool you want, everything is available. Okay, in the orchestrator framework, in the AI agents, you can connect with anyone. Okay. Now next we are having the memory. Memory is another component. So I told you context awareness is required. So here we use something called memory. Okay, so memory should be also integrated, and for memory development, we use orchestrator framework. In the orchestrator framework itself, we are having different memory function. Either you can also use different database for the memory. You can do anything here. Then the supervisor. So this is the HITL, that means human in loop. Okay, human in the loop. So with the help of the supervisor, what it does, it's try to interact with the human when any help is required. It will try to ask for the help. It will ask for the human guidance or feedback, and it will continue the agents. Okay, so these six actually components, five components are available in any kinds of AI agents, and this is the high level actually diagram I have shown you. Some other component might be available as low level, but this is the main one. Okay, so if you find these are the components are available inside the AI agents, yeah, you can select that particular application as an Agentic AI application, and whenever you are creating, you have to take care these are the component, okay, inside your application. Now let me show you the component explanation. As I already told you, the brain wise, here what we do, we use a large language model. And what is the use of large language model? The goal interpretation, planning, reasoning, tool selections. Okay, everything is everything we do with the help of this particular brain or large language model. The orchestrator is a framework, AI agents implementation framework. With the help of we can do task sequencing, conditional routing, retry logic, looping iterations, and delegations. Okay, then tools we are having. So tools, with the help of tools, we can connect our AI agents with external sources. Okay, and to knowledge base as well. Let's see, if you're creating a RAG based agents, that time our knowledge base should be external sources. Okay, this would be perform as a tool that time. Now the next component I told you, the memory. So what memory does? So memory actually basically stores all of the context of the conversation, and we create actually two kinds of memory: short-term memory and long-term memory, and it will do the state tracking. Okay, state tracking is required. I already showed you previously, right? It was storing the data in a JSON format, so this is also required. Then the supervisor, so approval requested for HITL, that means human in the loop. Then guardrails enforcement, then edge case escalation. Okay, so let's say if you want to block some unsafe or non compliant behavior, you can use the guardrails evaluation. I'll also show you how to perform the guardrails evaluation. And edge case escalation, that means alert human when uncertainty conflict arises. Okay, and you already understood about this HTIL. Okay, human in the loop format. So yes guys, these are some components are available of AI agents, and whenever we are developing our own AI agents, we have to take care these are the part, and every AI agents are having these kinds of component nowadays. Okay, so apart from that, I think there is nothing inside our AI agents. If you feel like, okay, if there is any new things, you can just let me know in the comment section. Definitely I'll try to cover that as well. Okay, but so far my understanding, I think these are some we have to follow whenever we are creating or whenever we are working on agentic AI system. So yes guys, this is all about from this video. I hope you have understood and this was helpful for you. I think I already told you in my previous video, like there are some components are available, especially whenever I'm talking about the agentic AI. One of the component is the orchestrator, right? Orchestrator means there we use some kinds of framework. Okay, with the help of these are the framework we implement the AI agents, whether it's a single agents, whether it's a multi AI agent system. We try to create these kinds of things, right? So there is a concept, guys, you have to understand before I start with this kinds of orchestrator framework. The concept name is asynchronous programming. Okay, so why this asynchronous programming is required? Because if you see, going forward we'll be creating the multi-agent system, and to create the multi-agent system, guys, we'll be using this kinds of orchestrator framework. And internally this orchestrator framework uses asynchronous programming. Okay, that means it will run your agents in parallel. Let's say you have created 20 agents. So what it will do, instead of running agents as a sequentially, it will run all of the agents in parallel, so that your execution would be more fast. So this concept I'm going to discuss in detail, guys, no need to worry. First of all, let me show you one thing actually I have just figured out. Let's say if I go to the Google, so here if I search like is LangGraph uses asynchronous in the backend for multi-agents. So I think you know LangGraph is one of the orchestrator framework. With the help of LangGraph, we create agentic AI applications, right? And we'll be also mastering this LangGraph inside our codes. So as you can see, the response was yes, LangGraph is designed with first class asynchronous supports in the backend for multi-agent system. That means it is utilizing the asynchronous concept in the backend. Okay. Now, if I just go below, let's say I have asked for about the autogen, because autogen also will be covering inside our course. So as you can see, autogen also utilizes asynchronous programming at its core, but it is architecture fundamentally different from the LangGraph's state machine approach, but internally it is uses asynchronous programming concept. Now again I asked like what about Crew AI? Okay, so you can see Crew AI also supports asynchronous execution, but it approaches orchestration differently than LangGraph and autogen. While LangGraph uses a state machine and autogen uses a actor model, Crew AI is built around role-based collaboration and process-driven execution model. Okay, but the main funda is that all of the orchestrator framework we are using for developing these kinds of multi-agents application, internally it is uses asynchronous, okay, asynchronous programming. Now before I start with these are the orchestrator framework, first of all I want to clarify what is asynchronous programming, why it is required, how asynchronous works, okay, what is parallelism, what is let's say sequential execution, each and everything I'm going to clarify. Then we'll start with the orchestrator framework understanding. But after that, there is one more topic we have to cover, which is nothing but Pydantic validation. This is also important because you will see that whatever large language model we are having, it will generate the unstructured output. And to make it structured, even whenever we are giving any kinds of prompt, to make our prompt more structured, we use this Pydantic validation. Okay. So this Pydantic validation will be understanding in the next video, but in this video, I will only focus on the asynchronous understanding. Okay. So here I'm going to give you the detailed understanding of asynchronous with a theoretical understanding as well as the practical understanding as well. So let me show you guys what is this asynchronous. After that, your understanding would be more clear and you can easily understand these are the framework whenever you will be doing the coding. So let me give you the definition of the asynchronous programming. So here is the definition. Here is the simple definition. You can see asynchronous programming in Python. Okay, you can see asynchronous programming in Python is a programming paradigm that allows code to handle multiple tasks concurrently without blocking the program's execution. It is primarily used to IO bound tasks, example network request, file input and output operation, database queries, okay, allowing the program to perform other operations while waiting for slow external events to complete. That means this asynchronous programming will help you, okay, asynchronous programming will help you, okay, asynchronous programming will help you to run your task in parallel. Okay, so you are not supposed to wait for the execution. Let's say we know that we use synchronous programming so far. Yes or no, guys? We use synchronous programming so far. In synchronous programming, what happens? Let's say if I execute a code block, first of all, it will complete that. Okay. After the execution is complete, okay, then it will execute the second part of that particular code. Okay. But in between, let's say if you are waiting for the execution, okay, if you are using asynchronous programming, it can run another task in parallel. Okay, so these are the like say functionality we'll be getting here. Now you can ask me why this is required. Okay, why this asynchronous programming is required inside AI agents implementation. Agentic AI, you can create two kinds of agent. One is the simple agent. Okay, one is the simple agent. So basically simple agents you create only one block. Okay, it can only handle one particular task. Okay, but whenever, let's say you have complex problem, you have to divide the task in smaller chunks, and what you will do, you will be creating multiple agents. Okay, multiple agents you will be creating. Let's say this is agent 1, this is agent 2, this is agent 3. Okay, and what will happen, you will assign the task for all the agents, and these agents will be executing either independently or dependently. Okay, dependently. So it's your design philosophy. If you are making it as a independently, that time it will run as an independently. If you are making it to dependent, okay, it will run as a dependently. So basically what happens, let's say if you run, these are the agents, okay, these are the agents in a synchronous programming. Okay, in a synchronous programming, what will happen, first of all, these agents need to be completed, this agent's execution need to be completed. Once this agent when these agents will be executed, then it will move to the next agents. Okay, next code block, then these agents will be executed. Okay, once it is completed, then it will go to this particular agents. Okay, then it will try to run this particular agent. So let's say this agents is taking 3 minutes to run. Sorry, let's say here I can just tell you, let's say this agent is taking 1 minute to run, this agent is also taking, let's say, 1.5 minute to run. Okay, this agent is also taking, let's say, 1 minute to run. So what is happening, you have to wait for 1 minute, again you have to wait for 1.5 minute, again you have to wait for 1 minute. Okay, so if you like add all of the time, you will see that at the end you are having, okay, 3.5 minutes. 3.5 minutes you have to wait for the execution. But if you run this task in parallel, okay, if you run this task in parallel, let's say this particular agents will do the online search operation. So basically if you are doing the online search operation, you will be hitting some URL, right, Rive URL, and to get the response, this will take some time. Let's say sometimes this web server might be slow, that time it will be giving you slow response. So instead of waiting for that, you can execute your other agents. So let's say these agents will try to collect the images, these agents will try to collect the, let's say, any other file, okay, from the internet. So don't wait to execute any other agents, just try to run them in a asynchronous way, okay, in a parallel way. So each of the agents will be running in a parallel way. So let's say this, if this agent is also taking 1 minute, okay, so simultaneously you are running something, okay, in the backend. So you are not supposed to wait for 3.5 minutes. Get it? So that is the things I just wanted to tell you. So let's say whenever you are creating multi-agent system, and whenever you are creating, let's say, independent connection, okay, independent, let's say, policy, that time you should use this asynchronous programming inside let's say Python, or let's say whatever programming you're using, you have to follow that. And if you see any kinds of agents code, you will be seeing people are using this async, okay, async, this particular syntax, people are using that. Okay, so what is this async? Async means asynchronous, okay, asynchronous functionality. So in Python there is a library called async.io. So we'll be following that particular library to implement this particular code. Okay, so let me give you one example of asynchronous and synchronous programming. So let's say here I can write synchronous programming. And this side we have asynchronous programming. So in synchronous programming, what happens? Let's say what I can do, I can give you one example. Let's say here, let's say you are having a gas stove, okay, gas stove. In this gas stove, you only have one fire section, okay, one fire section. So let's say you are having 3 dishes, okay, you are having 3 dishes to cook. So what you will do, first of all, you will take the first dish and you will cook that. Once first dish is complete, then you will take the second dish, then you have to complete, then you will be taking the third dish, then you will be completing. Okay, that's how you can see it is taking T1, it is taking T2, it is taking T3 time. Okay, So basically you have to wait for the previous execution, or let's say previous task to be completed, then you can start the remaining task. But in asynchronous programming, what happens? Let's say you are having same gas stove, but here you are having, let's say, 3 fire section. You are having 3 fire section and you are having 3 dishes. Okay, let's say dish 1, dish 2 and dish 3. So what you have to do, you just need to run all of them simultaneously. Basically you are giving 3 dish to the 3 fire section. Okay, now at the T1 time, okay, all of the dishes should be completed. So you are not supposed to wait for the T1, T2 and T3 to be completed. Okay, so this is the difference between synchronous programming and asynchronous programming. I hope you get it, guys. So in Python, we usually follow this synchronous programming. That means if you're running a function, first of all, that function would be completed, then the remaining code would be executed. Now in programming, we call it as a subroutine. Let me just write here, subroutine, and we also call it as coroutine. I'll be discussing about what is this. Okay, coroutine. So what is subroutine? So let me write a program to explain. Let's say here I can write a function. So I'll just write a function. Let's say def. Okay, def. So let's say I'll give the function name fetch. Okay, fetch, let's say, data. This is the function name. So it is having some code inside that. Okay, now here I'm creating another function. Let's say def main. Okay, now what I'm doing, I'm calling this particular function. Okay, this function inside this particular main function, fetch data. Okay, I'm calling inside that. I'm calling inside that. Sorry. Yeah. Now, after calling, let's say in this main function also there are some code line. So what is happening here? Let's say if you're using subroutine, so that time, whenever you are executing your code, first of all, your code will come here. Okay, your code will come here and it will see you are calling a function inside that. Which function? You are calling this particular function. Okay, now what will happen? First of all, it will go to this function and it will execute all of the code. It will execute all of the code. Now let's say you are running fetch data. That means, let's say you are trying to fetch some kinds of data from the internet. You are using some kinds of API, some kinds of URL. Okay, and whenever it is hitting that particular API or URL, it is taking some kinds of time, right? So you have to wait for this particular time. So see, once this time is over, that means this execution is over, then you will be able to execute your remaining code. Okay, till then you have to wait for this execution. Okay, so this is the idea of subroutine. That means you are waiting for a task to be completed, then your remaining code would be executed. Although you are waiting here, you don't have any kinds of other task. You just need to wait for the execution. Okay, and once execution is completed, then you will be able to execute. You'll be able to see the other execution of the program. But in coroutine, what happens? So let's say here I'm having a function. And we use something called asynchronous. Okay, asynchronous syntax. So for this we use something called async. Okay, this is the keyword async. So we'll write the function as def, let's say, fetch data. This is the function. Let's say inside that you are having some kinds of code. Okay, now again you are having a main function here. So I'll just write def main. So what you are doing, you are calling this particular function def, fetch. Okay, fetch data. You are calling that, and inside main you are having some other code. Okay, you are having some other code as well. Now what is happening, just try to see whenever your Python will come here, it will see that you are executing a function. Which function? This function you are executing. And it will see this particular keyword called async. Okay. That time Python will automatically understand that this code you have written, it will run in a asynchronous way. That means, let's say here you are doing a API call and it is taking some time t1. Okay. Instead of waiting for this particular time, again it will come here. Okay, and execute the remaining code you have, okay, after this function. That means at the t time itself, this code would be executed and this code would be also executed. So you are not supposed to wait for the previous execution. So this is called coroutine. And if you're using this async, these are the things. So it internally uses this concept. And now we'll go for the practical. We'll try to see like practically everything, how it works. Then I think your understanding would be more clear. Okay. First of all, I'm going to explain the synchronous programming. Okay. Now here, I'm going to write two functions. Let's say for the first function, I'm going to write fetch, tc fetch weather. Okay, fetch weather. And the second function I'm going to create def fetch news. Fetch news, okay. Now what I'm going to do, I'm going to import the time module as well, just to see the execution time. So import time, okay. Now inside that, as of now, I'm not going to write any logic. Simply I'm going to write just a print statement. I'm going to give, let's say, fetching weather data. Then here I'm going to just mention a time. Let's say to fetch the weather data, you have to wait for some time. Okay, so this time I'm going to assign with the help of this time module. So here I'm going to give, let's say, I will be waiting for 4 seconds. Okay, 4 seconds. So it is for the simulate a network delay. Let's say if you are hitting any kinds of API, so definitely to get the response you have to wait for some time. So let's say this time I have set 4 seconds here. Okay, now once we stop for 4 seconds, now simply I'm going to just print, let's say, weather data fetched. Okay, so this message I'm going to write. Now similar wise here also I'm going to write facing news data, and again I will give some time. Let's say here I have given 2 seconds, and once my data news fetching is done, so I'll tell news data fetched. Okay, so as of now, just try to consider this is a function. This will fetch the weather information and this will fetch the news. Okay, now if you see, this function and this function doesn't have any dependency. These two functions are independent. Okay, these two functions are independent. That means if you want to fetch the weather, you don't need the news. If you want to fetch the news, you don't need the weather. So these are independent function. Okay, but once I will execute this code, okay, let's say if I write another function here, I'll just write another function def main. Okay, in the main function I'm going to call this two function. See, first of all, I'm starting the time just to see the time, like how much time it takes to execute the two function. So that's why I'm taking the start time. Then I'm calling these two function together, fetch weather and fetch news. You can see fetch weather and fetch news I'm calling. Then I'm taking the end time. Then I'm doing the subtract operation from end time to start time, and this will be my execution time of my program. But if you see here, these two functions are independent. These two functions is not dependent. Although it's independent, okay, it's not dependent. So whenever you will call the function, you have to wait for the previous function to be completed to run the next function. This is the issue. Okay, so I can see these two functions are completely independent. But whenever I'm calling this function, first of all, this function will execute. So let's say whenever you will execute the program, so your interpreter will come here. Okay, your interpreter will come here. Then it will go inside this particular function. Then it will execute all of the code, and here it will wait for the 4 seconds. Okay, 4 seconds it will try to wait. But see, in the 4 seconds, it doesn't have any work to do, so it will be waiting. Then once 4 seconds is over, this code would be executed, then your program will come here. Okay, then it will be executed. That means, first of all, the previous function would be executed, then the next function would be executed. So you can also check. So let's say if I want to show you, so I'll call this particular main function here. Okay, I'll call this main function. Now if I execute, see, fetching weather, it is waiting for 4 seconds. Now weather fetch. Now see, fetching news. Now it wait for 2 seconds, then news fetch, and total time taken, you can see 6 point something seconds. Okay. Now you can also take this code in one of the amazing website called Python Tutor, pythontutor.com. Here also you can visualize this code. Let me open the Python Tutor. Now I'll select the Python programming. I'll paste my code here. Visualize the execution. Okay. Now it has started. Okay, it has started. Now simply time is not defined. So, okay, so the basically I need to import the time here, right? So let's edit the code. So here I'll import the time module for time. Now I'll visualize the execution. Import time. It is giving you an error. Time found not found or supported. Only these modules can be imported. Okay, because this is a like a website, okay, Python tutor website. So here you can't import any. Let's say these are the library you can import, but some other library you can't import. So for this, what I can do, I can remove the time as of now. I just wanted to only just let you know that how it is executing. Let's say I will also remove the time part. Here also I will remove the time part. Here also, and here also. Let's say this is my message. Okay, so this is my simple message. Let's say executed. Now simply do the visualization. Okay, now see, here I have the control. So first of all, Python interpreter will come here. It has seen like here I am having a function called fetch weather. Then it will go to the next line, that is next function. Then it will go to the next function, which is main. And in the main function, you can see I'm calling here this particular main function. So it will go into the main function, and it will see like I'm calling fetch weather function. Okay, so it will go inside fetch weather, and it will do all of the operation. Okay, see, it is doing all of the operation. Now let's say this function is taking some time, so it will wait. Okay, it will wait for 2 minutes, 1 minute. Okay, how much time it is taking, it will try to wait for that. So once execution is completed, then again it will come here. Okay, then you can see it will execute another function, which is fetch news. Now again it will go inside fetch news, and it will do all of the execution and try to come here. That means you have to wait. Okay, you have to wait for the previous execution to be complete, then you will be able to run the new code. Okay, that's how you have to wait. Okay, you have to wait for the previous execution, and definitely it is taking lots of time. And now just try to consider if you are running a multiple agents together, and if it is running synchronously. So first of all, first agent would be completed, second agent would be completed. So execution time, it will take more. That time we run it is an asynchronous way, so that we are not need to open. We don't need to open for. We don't need to wait for the previous execution. Okay, the time it is taking, it's completely fine. I will simultaneously run for all of the function, and it will be executing together. Okay, so now we'll try to see that particular example as well, how it will work. Now we'll see the synchronous programming. Sorry, asynchronous programming. Asynchronous programming. Now here to uh, implement the asynchronous function, you need to import one library called import. Okay, async.io. Okay, async.io, this particular library, and I'm going to also import time library. Let's import all of them. Then here I'm going to again write the same function. I will copy the code and simply I'm going to mention here. Now instead of giving simply this definition, I'm going to write async keyword, okay, before that. Now once I have written async keyword, okay, async keyword at the first of this particular function, now Python will automatically understand I need to run this function in asynchronous mode. And here it is taking the time, so maybe I can use another keyword here called await. Okay, await. So simply I'm going to give it here. Okay, even you can also return something if you want. Okay, you can also return like uh, what is the return this function will be returning for you. Now similar wise I will also do it for this particular function. So async. Okay, now simply here I'm going to write await. Okay, await. So why you are writing await here? Because here it is taking the time. Okay, here it is taking the time, and whenever here it is taking the time, your Python interpreter will come here, and whenever it will see the await, so it will tell like you don't need to wait for this particular execution, so you can execute your other code, okay, whatever you have. So this code would be executing, and at the same time you can also execute your other code. Okay, I'll tell you okay how it will execute. Then simply in the main function also I'm going to make it as async. Okay, async, and here instead of calling like that I'm going to simply call it as await async io dot gather. Okay, there is a function, and inside that you have to give the fetch weather function and fetch news function. Both you have to provide. Okay, then you can calculate the end time, and simply you can print the time taken of this particular function. Now if you want to execute, what you can do, you can simply call this main function. How? You can use the await keyword main. Now see, if I execute, see what will happen. Okay, there is an error. Oh, sorry. Whenever you are using this await, right, you don't need to use the time that time. You can use async io dot sleep. Okay, so you are not supposed to use time that time. Okay, you have to use async io dot sleep. Okay, now same things I will be giving it here. Same things I'll give it here. Now I think it is fine. Now let's execute. Now see guys, it has taken only 3 seconds, and if I show my previous code, it has taken 6 seconds. Okay, so the time reduced by half. Okay, the time reduced by half. Just try to consider. Now just think like this is a big program. Okay, this is a big program, this is a big agents, and it is running so many stuff. Now if you run it in a asynchronous programming, now just try to consider how much time it should take. Okay, but if you are using asynchronous programming, see, it will be reducing the time half. Okay, because it is running everything in parallel. It is running everything in parallel. Okay, so you are not supposed to wait for the previous execution to be complete. Okay, so all of the executions are doing simultaneously. Okay, so that's why this asynchronous programming, okay, this async IO is required whenever you are implementing any kinds of AI agents with any kinds of framework, whether you are using AutoGen, you are using LangGraph, you are using Crew AI. Try to use this particular things in your development. Okay, this is good practice. There are two concepts you will be getting, which is the first is parallelism. Okay, and the second thing you will be getting concurrency. So what is parallelism? Running multiple tasks simultaneously using multiple threads, okay, or process. And what is concurrency? So let me write it here. Simply here I can write concurrency. Concurrency means managing multiple tasks that can start, run, and okay, finish with overlapping times. Okay, so let me show you a graph. I think by seeing the graph you will be able to understand what is the exact meaning. So this is the graph. So this is the concurrency. You can see task is running, okay, context switching to the task 2, then again task 1 is running, again it is doing the context switching, okay. But in parallelism you can see it is utilizing, okay, it is utilizing multi core, okay. Let's say uh, in the first CPU core it is running task 1, and in the second CPU core it is running task 2, but here it is only utilizing the same core only, but um, doing this concurrency operation, okay. So guys, I think you have seen this asynchronous concept. The main thing is that right now all of the orchestrator framework uses this kinds of asynchronous functionality in their backend. So we don't need to manually use the asynchronous inside our development, inside our code. But if you want, you can also use, if you want, you can also design your own pipeline, design your own agents. That time you can write the code from scratch. But whatever, let's say, uh, orchestrator framework will be using like LangGraph, then AutoGen, Crew AI, right? So everything already having these kinds of things are integrated, okay, in the backend. So I don't need to take care of this part. But in future, whenever I will do some coding, maybe these are the terminology will come. That time, I want you to don't actually confuse with the syntax. Okay, that's why I have clarified each and everything before I go ahead with the AI agents implementation. So in this video, I'm going to discuss another very important topic, especially whenever you are creating any kinds of AI agents application. The terms is Pydantic. Okay. So first of all, I will give you the idea why this Pydantic is required, and without Pydantic, what would be the problem. Then we'll try to understand the entire Pydantic concept. So this is my promise of if you complete the entire video, guys, I think you should not be having any kinds of doubt related Pydantic, whether you are working in AI agents, whether you are working with any other, let's say, AI application development, because everywhere nowadays we use this particular Pydantic concept, okay, for the data validation. So I think you already know that in Python, all of the variable is dynamic variable. Basically, we use the dynamic concept here. That means here we don't mention any data type, okay, of a variable. Let's say if I'm creating a variable named a, and inside that if I'm storing, let's say, one integer value, which is 4, you can actually remove that 4, and you can also store any other data type, let's say string, float, or boolean, any kinds of data type in the same variable itself, okay, without actually mentioning the data type, okay. So that's how Python works. It works actually dynamically, everything. In short, any other programming language, we use the static approach. So there we uh, first of all mention the data type, then we create the variable and we stores the data. But in Python, actually everything works as a dynamically. So here you don't need to mention the data types or any kinds of, let's say, hints related that, right? So guys, to make you understand what I'm going to do, I'm going to open my computer screen and there I'm going to discuss each and everything related to this Pydantic. So guys, here you can see I'm inside my computer screen. So first of all, I have mentioned the Pydantic definition, like what exactly the Pydantic is. So as you can see, Pydantic is the most widely used data validation and settings management library for Python, utilizing type hints to ensure data structure integrity. As you can see, it validates parts data at runtime to match specified types, making it essential for building robust APIs and handling external data with its core logic written in Rust for high performance. So this is the definition of Pydantic. Basically, we use this Pydantic for the data validation. I'm going to tell you about more about this data validation. What is data validation? Why it is required, and I mean how it actually solves one amazing problem. Actually, whenever we try to create any kinds of end-to-end application, especially whenever you are working inside AI domain, if you're working in machine learning, deep learning, generative AI, agentic AI, anywhere, whenever you are developing the application, you have to use this Pydantic. Okay. Now here I have listed down some key features and benefit of the Pydantic. As you can see, here are some key features and benefit. So for data validation and parsing, we use this Pydantic. So here you can see it defines how data should be structured using standard Python types, automatically enforcing these rules. Basically, see inside Agentic AI, why it is required, because here we'll be working with the large language model, and you know that large language model always will give you the output in an unstructured manner. And if I want to get a structured output, if I want to get the relevant response only, that time this Pydantic data validation is required. And whenever we are also passing any kinds of input prompt, okay, we have to also make it structured so that I can get the efficient response from my large language model, okay, instead of giving some unstructured data as an input. Then for the type hint and integration, so uses Python type annotations to define schemas, reducing the needs for verbose validation code. Then definitely for the fast performance, we will be using that. Basically, it is written in Rust actually language, that's why it is extremely fast. Then strict and lax mode is available inside this Pydantic. Okay, basically here you can do the enforcing strict type, and you can also perform the you can also performing this lax mode, okay, for converting, let's say, any other data type to another data type. Okay, this is also possible here. Then clear error handling, okay, provides detailed errors when the data validation fails. And JSON schema generation, Pydantic models can easily generate JSON schema for documentations or validation is in other languages. Okay, now it is telling Pydantic models. What is this Pydantic model? I'm going to tell you. So this is nothing but a class. Okay, we create a class and we inherit with this Pydantic actually base model. Okay, so that's why we call it as a Pydantic models. So whenever I'm going to show the practical, that time it would be more clear. Okay, so first of all, let's try to understand the problem. Okay, problem without this Pydantic. If I'm not using Pydantic, so what will happen and what would be the issue actually we'll be having. Okay, then I'll try to use the Pydantic, and I'm going to show you the benefit itself. So for this, I'm going to turn off my camera window, guys, so that you can see the entire screen. You don't miss any kinds of code snippet. Okay, whatever I'm going to write, I think that would be good for you. So guys, whenever we are working with any kinds of application, whether it's related ML, DL or Agentic AI, it doesn't matter. We will be working with the data for sure, right? So let's say here I'm going to take one example. I'm going to, let's say, create a function. I'm going to name it as let's say add, or let's say add patient data. Okay, so this is my function. So basically this will take the name of the patient and age of the patient. Okay, now what I'm going to do, let's say this function add these informations to the database. That means the hospital database. But as of now, I'm giving you the demo. So here I don't have any kinds of database. So simply what I'm going to do, I'm going to print those variable here. Okay, so let's say I'm going to print the name, and I'm also going to print the age. Okay, so once it is done, maybe I can give you a message called data added successfully. Okay, so let's say this is my message. Okay, once let's say I will call this function, it will add these informations to the database, and here I will get a message. Let's say database data added successfully to the database. Okay, let's say this is my message. Now let's say if I execute this code, let me take some cell. So if I want to, let's say, insert the data, first of all I have to call this function add patient data. So inside that, let's say I'm going to give the patient name. Let's say I'm going to give Bappy, and age is 25. Okay, now let's say if I just execute the code, you will see that Bappy and the age has successfully added to the database. That means it's working fine. Okay, now let's say this code is written by the senior programmer, and he has given this code to the junior programmer. He told like, okay, this is the function, and this function you can use for adding any kinds of let's say patient informations to the hospital database. Okay, now what junior programmer will do, definitely he will see the like function definition. So you can see this function definition is that this function takes two argument. One is the name and another is the age, and the data type is any. That means you can pass any kinds of data type here, because here I haven't strictly mentioned you have to pass string or you have to pass integer, float. Okay, this kinds of let's say type hinting I haven't done. So what he will do, he will try to add any kinds of data here. Okay, maybe let's say he has given Bappy here, patient let's say name. Now he can also give the age like that. Let's say instead of 25 like that, he will write like that 25. Okay, 25 in string. Now if I execute this code, still see my data is added to the database. But whenever let's say senior programmer is trying to fetch this data, okay, let's say there is another function, that function fetch the data. So whenever let's say he's fetching the data, let's say he wants to filter out those patient, the patient age is above 25. Okay, so what he will do, he will let's say write a condition. If patient, okay, if patient age is let's say greater than 25, okay, 25, then he will try to let's say call those patient. Okay, he is trying to call those patient. Now just try to see here, my junior programmer has added the patient information like that in a string format 25, but again senior program is trying to filter out the patient informations by the integer data type. Okay, definitely these kinds of I mean filter I can't ever perform on my database. If you're using SQL, I think you know that you can't do that, because here it is a string type, here you are giving the integer type. So definitely this patient will be missed that time. Okay, not only this patient, I mean similar kinds of, if you're doing the same thing, instead of giving the integer, if you're giving the string type, that time patient will definitely missed out. Okay, for the filter operation. So this is the like problem. Now you can tell, okay, then I can easily solve this problem. So what I can do, maybe instead of giving it like that, so what I will do, let's say I will try to maybe add a condition here. So simply here I'll add a condition. So if type, first of all I'll check the type. If type of name is equal, okay, equal string str, and type of age is integer, okay, then I'm going to then I'm going to insert the informations to the database. Okay, otherwise in the else condition I'm going to give a error message. Okay, so I'm going to raise an exception, raise let's say type error, type error. So here I'm going to tell invalid data type for the name and age. Name should be string and age should be in the integer format. Okay, now let's say if I execute this code, now let's say if I am trying to add right now these kinds of things. Okay, so what will happen? Okay, one more thing I have to add, which is the hinting, type hinting. So name variable should be string and age variable should be integer. Now if I execute, now see if junior programmer comes here and he if he sees see the let's say function definition, he will be able to see that okay, this function takes two argument. One is name should be string and age should be integer. Okay, so let's see if I give integer data right now, let's say 25, it will work perfectly. Okay, there should not be any kinds of error. But if he's trying to give like that, let's say again 25, so definitely that time one error would be coming here. Okay, now it is working completely fine. It's not like that you won't be able to do that, you will be able to do that. Now your senior programmer will be able to fetch the information very easily because you are following the same data type. Okay, whatever data type your senior programmer expected. Okay, so this is the thing. But the problem is that, let's say whenever you will be creating a big application, it's not like that you will be creating a single function, there would be lots of function. Okay, so let's say you want to create another function. Let's say the function name is update information. Okay, update patient information. Instead of add patients, maybe I can add update patient data. Okay, that time again it will take the name and age of the patient. Again you have to check this condition. Okay, you have to check this condition whether name is a string and age type is integer, then you will allow to update. Okay, let's say here I can tell update let me accept this data updated successfully in the database. Otherwise what I will do, I'll just try to raise the invalid let's say error. But whenever we will be creating the real application, it's not like that. We'll be working with 2 to 3 input data. There would be lots of data, and for all the data I have to write this particular condition. Okay, so again this is a manual task we have to do. And how many function you will be creating, in every function you have to definitely check that. Okay, you have to definitely check that. Let's say another condition comes up. The condition is let's say yeah, definitely, let's say you have given your data type, it should be name should be string and it should be integer. It's completely fine. But let's say your junior programmer insert the data like that. Let's say instead of giving positive 25, he will be giving negative 25. Now age cannot be never negative, right? Age cannot I mean it should not be negative. But if I, let's say, add this negative number, again it will be adding this particular number successfully. Okay, but this is another issue, definitely, right? Now you can tell me, okay, then what I can do, maybe I can add another condition here. So what I will do, let's say here maybe I will add another condition inside this in add patient data. So here I'm going to check another condition. If the age is if age is greater than, okay, age is greater than equal 0, that time I will allow this condition. Okay, I'll allow this condition, otherwise I will raise another exception, age cannot be negative. Okay, and this already I'm checking this information whether it is a string or integer. Okay, so this is the else block for this particular if, and this is the else block for this particular if. Okay, now here I have written the multi conditional statement. So here also you have to do the same thing. Okay, here also you have to do the same thing. Okay, so I'll remove this part. Okay, here also you have to add the same thing. Now if I execute this code, now see, now it will check that and it will raise the value value error. That means age cannot be negative. But if I'm passing the positive, that time it will be working. There should not be any kinds of problem. Okay, but every time whenever the condition is changing, okay, because it is true, right? Whenever you are creating an application, your application should handle this kinds of scenario, because as a user I can pass anything, right? I can pass anything. I can pass negative number, I can pass string number, anything I can pass in your application. But your application should handle this kinds of scenario. Your application should validate the data I'm passing, whether it is validate or not. Okay, so either you can do this validation by writing these kinds of manual conditional statement, either you can use the Pydantic one. Okay, Pydantic data validator. So how to use Pydantic I'm going to tell you, but I was just showing you the problem, what would be the problem if you're using this like traditional approach, traditional conditional approach. So here you have to write this kinds of condition manually every time. Okay, and again if you're creating any other function, again you have to rewrite the code and your code size would be very big that time. Okay, so this is the problem. Now let's try to see how to use this Pydantic to solve this problem. Now here I have already written how to use the Pydantic. So in Pydantic, first of all, we'll define a Pydantic model that represents the ideal schema of a data. Now what is model? Okay, model means this is a class. Okay, here we'll try to define a class of Pydantic. Basically we'll try to inherit with the Pydantic based model. Okay, after that we'll try to define the schema here. Okay, we'll try to define the schema. Now what is schema? I'll tell you. Then the second thing, instantiate model with raw input, usually a dictionary or JSON like structure. So once my let's say Pydantic class is ready, I will prepare my data. Okay, I will prepare my input data in a dictionary. It should be definitely in a dictionary or JSON like format. Then we'll try to pass the validated model object to the functions. Okay, here I missed one thing. See here, basically what we'll do, Pydantic will automatically validate the data, whether it is correct format or not, the data we are passing. If does not meets the model requirement, Pydantic raises the validation error. Okay, then once let's say my data validation meets, it is let's say validated successfully, that time it will try to I will try to pass the validated model objects to the function we have created. Okay, for any kinds of logic, let's say for a database insertion or update database insertion, we can pass to that particular function and our code will be working. Okay, now this thing we'll try to see in a practical manner. So for this, first of all, you have to install the Pydantic inside your environment. So how to install Pydantic? Maybe in the requirement.txt you can mention the Pydantic package, and definitely you just try to take Pydantic like more than one. That means it should be Pydantic 2 version, because in 2 version there are lots of update came, but don't use one version, because one version that was older and there you will be getting lots of issue. Okay, I'll try to suggest you use this Pydantic 2 or more than 2. Okay, you can use this one. Now once you have added in the requirement, so simply you can open up your terminal and just write this command, pip install -r requirement.txt. So it will be installing this Pydantic inside your environment. Okay, so for me it is already satisfied because initially I already installed this Pydantic in my environment. So once it is done, this is the notebook, guys. I'm also going to share you all of the source code in the description section. From there you can download and you can try in your system. Now here you definitely select the kernel, the environment you are creating, just try to select that. So for me, I have created this LLM demo. I'll try to select this. Now here I'll be doing the coding example. Now, first of all, here you have to import this Pydantic based model from Pydantic. So you have to import like that from Pydantic. So I'm getting the code suggestion because here I'm using this Microsoft Copilot. Yeah, so maybe I'll take the suggestion. So from Pydantic import, I'm going to import the base model first of all. Okay, so first of all, I'm going to show you the simple example. Then I'm going to show you the advanced example of Pydantic as well. Okay, first of all, let's start with the simple example. Now, once it is imported, now what I'm going to do, guys, I'm going to simply write a Pydantic class. Okay, so let's say the class name is patient. Okay, patient data. So let's say this is my class, and definitely you have to inherit this particular class with base model. Okay, so this is called actually Pydantic model. So this becomes actually Pydantic model right now. Now inside that you have to define the schema. So schema means like how many data you will be using. Okay, so here I'll be using 2 data. One is the name, another is the age, because I'm replicating the same example previously I have given. So here I was considering name and age. Okay, these 2 information only. And here I have mentioned the name should be in string and age should be in integer. Okay, now what I'm going to do, I'm going to again maybe copy the same function I created, or let's write that So def add patient data. Okay, add patient data. So this was the function previously I written. Okay, but there I passed this name and age directly, but here you don't need to give like that. So here what you have to do, you have to give the Pydantic object. Okay, but before that, let me show you what to do. So as of now, let's just pass it. And now the second step, we have to uh, in instantiate the model with the raw input. So we have to prepare our raw input. So input should be in a dictionary or JSON like structure. So let's try to prepare the input. So input is basically my patient information. So patient data is equal to it should be a dictionary. First of all, I will add the name. Okay, name and age. Okay, so this is a dictionary format. Now what I will do, I'll just try to pass this particular data to my Pydantic object. So here, what is the Pydantic object? Pydantic object is nothing but my patient data. Okay, so what I'm going to do, I'm going to pass it to the patient data. So here, let's try to create object of patient. Okay, patient. Let's say this is the this is patient is equal to patient data, and we'll be passing the data. And here I have given 2 star because this is a dictionary and we have to unpack the value, right? Key and value. So that's why we have given this 2 star here. 2 star means you are unpacking the data. Okay. Now this will become a Pydantic object. Okay. Now we have created a Pydantic object. Okay. Now this particular object will be passing to the function. All of the function will be creating here. Whether it's a add patient data, update patient data, will be like passing those informations inside the function. Now, right now, this function can't take the name and age separately. Instead of that, it will take what? It will take the patient. Okay, patient object. That means the Pydantic object. So that means here I can make this particular input name is at patient, and the type of the patient should be patient data. That means this particular class, and this is your Pydantic model, right? This is your Pydantic class. Now why I have given patient data? Because inside that I have prepared the schema. That means this add patient data function takes the data. Okay, take the data, and that what is the data format? Data format should be definitely there would be a variable called name, and name should be string, and there should be another variable called age. Age should be integer type. Okay, so that's how we are giving the type. But initially we are giving the data like that. We are giving the name, and we are mentioning, okay, this should be the string. Then we are giving the age. This should be the integer. Okay, but here we are doing the manual stuff. But here right now we just created a Pydantic class, and we are passing this particular class object, and it will automatically understand, okay, what to do, what should be the format inside that, what should be the structure inside that. This is called actually schema. Okay, schema means the data and the data type of the data. Okay, this is called actually schema. Now once it is done, now simply here I can add the patient information. So simply I can print the information. So right now, see, I can't actually directly print the name, right? I can't directly print the name here because we are not taking the name as a name variable. We are taking as a patient, right? So we can call like that patient.name, because inside this particular patient data object will be having the variable name. Okay, now we'll do for the same. We'll do for the age also. So print patient.age. Okay, now once it is done, I'll tell data inserted successfully to the database. So similar wise, I will create for the update. So let's make it as update. Okay, now it will again take the same patient data object, that means the Pydantic object. And once it is done, we'll try to tell data updated successfully in the database. Okay, and everything will remain same. Now let's try to see whether it is working or not. Now simply what I will do, first of all, let's say I will add the patient data. Okay, add the patient data. So inside this add patient, you have to pass this patient information. Okay, patient, because this is my Pydantic object we already created with the help of this Pydantic class. Now we'll try to pass it there. Now see, Bappy 25 data added successfully to the database. Now let's say I want to update the data. Simply I'll call the update patient data. Inside that I will again pass the patient object. Now see, the patient information is already updated. Now let's say in updated, okay, so what I can do, instead of patient, I can give patient 1. Let's say you can create multiple patient, that time you can do that. Okay, patient 1, patient 2, like that you can do. So let's say this is the patient 1 information. Okay, this is patient 1 information. This is updated. Okay, so whenever you are doing the update operation, so make sure you are giving any other name. So simply what I can do, see, before giving to the update function, first of all you have to validate with the help of Pydantic. So let's say now name is equal to Alex. Let's say this is patient 2. We are giving this particular raw data to the Pydantic, okay, Pydantic object, because here I already told you instantiate the model with the raw input data. So we are initiating the model, okay, the Pydantic model with the raw data we are passing here. Okay, raw data we are passing here, and this is doing the validation. If everything is fine, it will tell okay you can continue. Then we are giving to the function. Now see, this function is working fine. Okay, it should be patient 2, not patient 1, it should be patient 2. Now see, now it's become Alex. Okay, now the things I want to show you, the benefit actually using this Pydantic, which is that, let's say by mistake you have given let's say string 25. Okay, you have given string 25 instead of giving 25. So now what we'll do, let's say if I execute the code, see, Pydantic will not give you any kinds of exception. Instead of that, what it will do, it will try to convert this string 25 to integer. Okay, so you don't need to do it manually. So by default, actually internally this Pydantic will handle this kinds of scenario. So this will try to convert to the integer type. Okay, you don't need to manually do that. So here also you can do the same thing. Let's say if I give string 25, your data should be updated successfully. Okay, now let's say in future you want to add any other information, so you don't need to update these at the code that time, okay, manually. So here let's say you want to add the weight for the patient. Okay, so let's say weight, usually I can mention with the help of float data type, because weight should be float. Now simply what I can do, I can also print the weight here. Okay, now here also I can do the same thing. I can update the weight, and here you can give the weight informations right down. Let's say weight is 70.5 kg. Now if I add the information, see, still it will be working. Okay, I am getting one error because whenever I am updating the information here, I haven't passed the weight. I have to pass the weight here. Now see, it will work successfully. Okay, so there should not be any kinds of problem. Okay, but in our previous example, you will see that every time I have to handle this kinds of scenario manually. But in Pydantic, we don't need to handle that. Okay, we'll try to just prepare a Pydantic class, and in this particular class, we'll try to handle each and everything for me. Okay, but you have to make sure whenever you are giving your raw data, try to first of all validate. Okay, try to first of all validate with your Pydantic, then try to pass to the main function. Now I think this particular concept will be clear enough. The strict and lax mode. So basically what it do, it attempts to queries the data. Example, converting this string 1 to integer 1. That means automatically it will try to convert for you. Okay, but if you want to raise the exception, you can also do that. Okay, everything is possible here. And one more thing I want to show you. Now let's say if you want to add any other type data, let's say instead of giving this let's say this is a number. Okay, now let's say you are not giving the number, you are giving like that 70. Okay, say 70. Okay, 70. Now see, if I execute, it will throw you the error. Okay, it will tell input should be a valid number, unable to parse the string to a number, because we can't convert this text to the number, right? This is not a number. This is a other text. This is a like kinds of word we are passing. Okay, but it should be a number, whether you are giving as a string or integer, doesn't matter, but it should be as a number. So if you are giving as a number, that time it will be able to convert it to the integer. Okay, but if you are giving completely text type, it will not allow that time. Okay, so yeah, that's how the things work. But this is a very basic type example I have given. Now we'll try to move to the advance of this Pydantic. I will try to see like more depth validation, how it can be done. We can add so many parameters, so many stuff here. We can add so many, let's say, verification, and we can make it like more powerful. So guys, so far we have seen a very easy example of the Pydantic. Now we'll try to make it slight complex. Okay. So what I'm going to do, maybe I can copy the same class. So this is the class. I'll copy this, or I can copy the entire code and I will paste it here. Okay. Now see here, what I'm going to do, instead of taking name, age, and weight, maybe I will take some more extra variable. Let's say here I will take another data called married. Okay, whether this patient is married or not. Married. So this should be a Boolean data type, because either patient should be married. If married, it should be yes, either no. So if yes and no comes into picture, so we can consider in Boolean type data type. Then I can take another data, which is allergies. Okay, whether patient is having allergies or not. Okay, if he or she is having allergies, so what kinds of allergies he or she is having? See, allergies is it's not a single, let's say, type. Okay, there should be multiple types. Someone got allergies from, let's say, dust. Someone will be getting allergies from any kinds of food, right? It should be different, let's say, type. So that's why we'll be taking as a list. Now you can ask me why I'm taking this particular things as a list. Okay, because it should be list of allergies. Okay, let's say one patient will have might have multiple allergies. Okay, type, or let's say one patient will have only single type. Okay, so instead of taking a single type, maybe we can take a list of the type, I mean list type, so that if one patient is having multiple allergies, so I can easily store them, right? But if you're taking list, so you don't need to directly I mean write this list. Okay, if you are I mean writing in that way, it won't be working. So for this, what you have to do, you have to import this list from the typing module. So you just need to import list from typing module. So there is a module called typing, and in this typing we'll be having all kinds of typing, okay, inside Python. So we are importing the list. Okay, we are telling we need a list. Now it should be a list. Okay, so here we'll be telling this should be a list type. Okay, now I can't actually write list like that, because see what will happen if I open up my blackboard. See, patient is having allergies. Okay, allergies is nothing but it's a list. Okay, it's a list. Now the thing is that inside that we have to write the allergies type. Let's say this is dust type. And what is dust? Dust is a string, right? Now let's say food. Okay, food is also a string. Okay, so type cannot be any kinds of number. Okay, it should be a definitely string type. That's why I'm telling the list we are creating of the allergies, inside the list will be storing string type data. Okay, because allergies type should be always a string. So that's how whenever we are creating any application, we have to think about the data type. What should be the data type? Okay, the data we are getting, what should be the type? Okay, you have to think about in that way. So allergies should be list, and inside list the data will be storing, it should be string. Okay, that's why we can write this particular syntax, and this is called schema. Okay, we are creating the schema right now, and we are extending this particular Pydantic model. I think you get it, right? Now I'll add another, let's say, data, which is contact. Okay, contact information. So contact information, let's say I want to keep it as a dictionary. let's say someone will pass, let's say contact information like that. Let's say he or she will be writing in that way. Let me tell you. So contact, we want to take it in that way. Let's say contact info is equal to, it should be a dictionary. So inside that, first of all, user will pass the email address. Okay. So let's say this is the email address. Okay. And this is my phone number. Okay. Phone number. Let's say this is my phone number, like that. Okay. I think you are getting, and this should be also string type data. Okay. So that's why I'll be taking this contact info as a dictionary. Now inside this dictionary, I'm going to mention, okay, I'm going to mention what kinds of data I want to take. Dictionary should be string type. Okay, key should be also string, value should be also string. Okay, that's why we're mentioning the data type. And this is a dict, and again I can't use the Python default dictionary function. I have to import from this typing. So simply I'm going to import this dict, and now I'll mention it here. Okay, that's it. Now let's try to execute, but before executing, I think you have to know we have to prepare the raw data. Now let's try to prepare the raw data. So we are already getting the suggestion, we'll accept that. So here you can see we have added this one, married. Yeah, married. So this is, we have added, this is true. You can also give it as a string, you can also give it as a boolean, it doesn't matter, it will work. Then you can see we are giving the allergies. So allergies we are giving as a list. As you can see, we are having an allergies from peanuts and shellfish. Okay, then we are giving the contact info. Let's say this is my email address and this is the phone number. Okay, now let's try to execute whether it is able to work or not. See, I'm not going to update, these are the function. You can, if you want, you can also update with all of these variable, you can print all of them, but let's do it quickly. So here I'm going to simply execute. Okay, now see, information is added successfully. That means it's working fine right now. But in some case, let's say if I am giving, instead of, let's say these allergies, instead of giving this string, if I'm giving any kinds of integer number, let's say 23, okay, it will give you the error. Okay, it will tell one validation error from this patient data, that means the Pydantic model. So allergies, it is coming from the allergies. Okay, allergies field, input should be a valid string, not the integer. Okay, so that's how you can specify this one. So I'll come here again, I'll change it, execute. See, it will work perfectly. Okay, so that's how any kinds of type you can mention inside your Pydantic model. Okay, any kinds of schema you can mention inside your Pydantic model. Everything is possible here. Okay, so guys, we have seen another example. Now I'm going to talk about this required and optional fields. Okay, what is this required and optional fields? Let's try to understand. See, whenever we are creating this schema, right, we are creating this Pydantic model. That time, whatever data we are taking, right, whatever data we are, whatever schema we are writing, we have to give all of this field, right? We have to give all of this field whenever we are preparing the raw data. So if you skip any of them, okay, so if you skip any of them, what will happen? So let me show you the example. I'll copy this code, I'll add it here. Let's say these are my schema, right? Let's say I will, let's say not provide these allergies. So what will happen? So if I remove the allergies from here, let's say I will completely delete this allergy field. Okay, I will delete this. Now if I execute, it will throw you an error. Okay, it will tell one validation error from patient data, allergies field required. Okay, but you haven't given this particular data. So this is the issue. Okay, now let's say I want to make it as optional. Let's say if user is not also giving this allergy, it's completely fine. It should be completely optional. That means my code will still execute. So for this, what I can do, I can make it optional. So to make it optional, simply you have to import optional from typing. Okay, optional from typing, and you have to pass this data type inside the optional. Okay, inside the optional. And one more thing you have to define, which is one default value, which is none. Okay, so I'm getting one error. Let me check. Okay, the error I'm getting, it should not be parenthesis, it should be this square bracket. That's why that error was coming. Now it's fine. Okay, now this allergies field should be optional. If you are also not giving, it's completely fine. uh, I mean, it will still work. And by default, this allergies field will get one value, which is none. I can show you by printing that. So what I can do, I can print it. So just for simplicity, let's remove this function. Okay, I'll only keep one function. So here I'll just try to print patient dot allergies. Okay, now if I show you my data there, there I already removed this allergies field. Now if I still execute, it will work, and you can see this allergies parameter is getting none. Okay, this is getting none because the default value I have set as none. Okay, and it is completely optional. If you give also, it will work. Okay, if you skip it, it will also work. Now let's say if I give this value, so after married, I think, or I'll copy from my previous example this patient data, and I will pass it here. Okay, now here I have given this allergies field. Now if I execute, still it will work, but now it will take the value because we have given the value itself. Okay, but if you don't give it, still it will work, but it will take as a none. Okay, now one more thing I told you about the default value. See, you can also set the default value to any kinds of field. Let's say in the married one, I can set any kinds of default value. Okay, let's say if user is not giving any kinds of value, still it will take the default value. Let's say married is equal to, by default, I will be make it as false. Now if I, let's say, remove this married field as well, still it will work. So that particular, okay, I can print and show you. Here I will print it, patient.married. Now see, by default it is coming as a false. Okay, that means you can also pass any default value if you want. Okay, and you can also make any kinds of field as optional. Okay, this is also possible here. So guys, we have seen the optional and required field. Now I'm going to show you another example, which is related data validation. So in Pydantic, I told you we can also perform the data validation if you want. Data validation means, let's say the data you are giving, you can also validate whether it is in same format or same, let's say it follows the same same structure or not. Okay, so for an example, I'm going to let's say take one example. I'll copy the same code. So this is like becoming big line. So what I can do, maybe I can just press an enter just to make it as a little bit shorter. Okay, so what I'm going to do, I'm going to take another variable called email. Okay, as of now, let's try to consider I'm also taking one information from the patient, that means his email, and here I'm going to remove the email. Okay, so in contact information, let's only I'm going to take his phone number. Okay, this is fine for us. So email, I'm going to take it as separately. So what I can do, you can tell me, okay, I can make it maybe string, because email usually would be any kinds of string type data, yes or no, right? But if I'm taking as a string type data, so what will happen, let me show you. So let's say I'm taking as a string type data email, and now after name I have to pass the email. So let's say email, email should be email, so this should be okay. So let's say bappy@example.com, or let's say bappy@gmail.com. Okay, let's say this is my email. It's completely fine. Okay, now let's see if I execute, it will work. See, it is working fine. There is no error. Okay, but let's say if I not giving this @ sign, now if I still let's execute my code, it will be working. Okay, although this email format is not good. Okay, although this email format is not correct, but still my code is working. Okay, then what is the use of that? So here actually data validation comes into picture. So basically, see, if I am doing manually with the help of Python, so you can tell me, okay, I can use regular expression library and I can validate whether this email it is correct or not. Okay, I think with the help of regular expression also we can handle this scenario, but we are using the Pydantic. Okay, and definitely we are using it for my benefit, right? So in Pydantic, instead of giving this email as a string, you can also give this particular format um, to the email format. Okay, so inside this Pydantic, we're having another function called email string, email str. Okay, so what this email str does, it does the data validation. That means it will automatically check whether you are what kinds of email you are giving, it is in correct format or not. If it is not correct format, that time it will throw you the error. Okay, now instead of giving this string, maybe I can give this email str. Now what will happen? Now see, if I execute this code, if I execute this code, it will throw you error. The error should be this email. Okay, value is not valid email address. Now unless and until I'm not giving the valid email address, let's say if I give this @ sign right now it will work perfectly. Okay, there should not be any kinds of issue. So that's how you can perform the data validation. Before giving the data, you can validate whether the data we are passing it is in correct format or not, it is validated or not. Okay, I think you get it. Now similar things you can do with another, let's say, data validator. The name of the data validator is like any URL. Okay, any URL actually validates any kinds of let's say web URL, the web URL you are passing, whether it is in correct format or not. So let's say I'm also giving the patient LinkedIn information. Okay, so let's say this is a IT patient hospital. We are only taking the IT patients, okay, IT background related patients, and we are also taking their LinkedIn profile, okay, to our database. So what I'm going to do, maybe I can create another field here. I'm going to name it as LinkedIn. LinkedIn. Okay, LinkedIn URL. Yeah, and the type should be an URL, because this should be a URL format, right? An URL. Now here what I'm going to do, I'm going to pass a URL, LinkedIn URL. So I'm already getting a suggestion. So maybe I can hit another enter. Okay, so here we are taking the URL, as you can see, https /www dot or let's say I will copy my LinkedIn profile. So this is my LinkedIn profile. I will add it here. Okay, now see, if I execute this thing will work fine. Okay, there should not be any error. But let's say if I'm not giving this https, okay, if I'm only giving this www, or let's say I'm also removing this www. Okay, now if I execute, see, it will give you the error. It is telling input should be a valid URL. Okay, otherwise it should not be working. So this is the work of data validator. Okay, that's how in Pydantic there are some default validator are present. You can simply see the documentation and you can do the validation. Okay, if you want, this is possible here. Now one more thing I will show you, which is let's say here we used some of the already available data validator, validator like email string, then any URL. Okay, but let's, in some cases there should be some of the data, and for those data these kinds of validator won't be available. Okay, that time how you can actually validate those data? Let's say here what I can do, I can show you one example. Let's say here the name we are passing, I want to make a restriction, and the maximum length of a name should not be more than 50 character. Okay, that time how I'm going to do this kinds of validation. Okay, so for this we can use the custom validator, and we can write this custom validator with the help of when I'm using actually function called field. So what you can do, you can simply import this field from Pydantic. So you have to import this field from Pydantic. Just a minute. Yeah, you have to import this field from Pydantic. Now here, simply you just need to define this. Okay, let's say name, that should be string, and here I'm going to write the field. Okay, field. Inside the field, I'm going to tell the maximum length of a name should be only 50 character. Okay, it should not be above 50 character. Okay, now let's say if I execute my code, it will work fine completely, because right now the name I'm using, it is less than 50 character. But if you increase it, let's say I will add something big. Okay, now if I execute, you will see that it will throw an error. The string should be have most 50 character. Okay, so that's how you can do the data validation in your custom data if you want. So like that, I can also, let's say, set to any another field. Let's say I want to restrict the age field here. I want whatever age user is passing, it should be greater than 0 and lesser than, actually, let's say 100. Okay, so for this, what I can do, I can add another field here. I'm going to write is equal to field. So there is a parameter called GT. Okay, GT means greater than 0, and there is another parameter called LT. Okay, LT means lesser than. So here I'm going to tell, let's say 100. Okay, now if let's say user is giving the age, let's say minus 25, so this is definitely lesser than 0. So that time it will give you the error, because input should be greater than 0, but we are giving lesser than 0. Okay, now if you are giving the correct information, it is working fine. Okay, like that we can also, let's say, add these kinds of validator inside our allergies. Okay, let's say this is the list of the allergies we are taking, and all of the value should be string. Now we can also define the field here. So I'm going to write the field. Okay, field. So here, let's say the allergies we are taking from the user. So only user can pass, actually, let's say maximum five allergies. Okay, 5 allergy list. So that time I can define the max length should be 5. Okay, now let's say if user is giving more than that, okay, allergies, I make it as an optional. So what I can do, I can maybe add the data here. So previously I had the allergies, maybe I can copy. So from here I can copy. Okay, so here I can add it. After married, I can add the allergies. Married also I removed, right, previously. Okay, because this was optional. So here I can add the allergies. It should be a comma. Now if you're giving more value here, okay, that time it will throw you error. Okay, because it should be 5 item, but we are giving more than 5. Okay, so this is another issue. So let me, yeah, now it's working fine. Okay, so that's how, guys, we can set our custom data validator. Okay, we can set with the help of this field. Now this field you can also use for another purpose, to add some other metadata. Okay, to add some other informations about the schema, about the Pydantic model. Okay, I'm going to show you. So guys, now let's try to understand, apart from this data validation, like custom data validation, okay, why we can use this field. Okay, so see, field we can also use for the metadata information. Let's say whenever we are creating the schema, you can also pass any kinds of metadata here. Okay, other informations like description. Okay, some other example you can provide here, so that whenever this code is using any other programmer or let's say other person, they can easily understand what this field does. Okay, they can easily understand. Now see, the way we have written right now, this is completely fine, but it doesn't have any kinds of information about the name, let's say what name does. But if I add some other metadata like description and all, by reading the description, I think other person will easily understand what to do, right? So for this, here I have given another demo. I have already written this particular demo. So see here, if you want to write any kinds of metadata inside your schema, that time you can use this particular field function, but with that you have to use another function called annotated. Okay, so you have to import this annotated from typing. So now you have to write the syntax like that. Okay, previously I was writing like that. Okay, I was directly giving the string field and all, but right now if you want to write the metadata, first of all you have to give the annotated object, then inside that you have to define the data type. Okay, the type int, let's say this is a string, then you will be giving the field. So here my field was like maximum length 50. Now here I can pass some other metadata like name or like the title. Okay, so name of the patient. So that means this particular name field is nothing but it's a name of the patient. And you can also give the description. Okay, what this does, this give the name of the patient in less than 50 character. Then you can also provide some example. Okay, so that by seeing this particular example, your programmer can understand, okay, this actually works like that. So here I've given example like Bappy and Alex. So this is less than 50 characters. Okay, so similar wise you can use this for all the field you are having. Let's say I have given some other example. I have added this inside the weight. Okay, the same. See here we mentioned like this is float. Here we have given the field. Okay, right now I'm going to remove this stick parameter. I'm going to tell you why this is required. Now here you can also provide the description. Okay, description and all, everything can be done. Okay, so this should be mentioned inside field variable. So here you can mention like description. Okay, weight of the patient in kg. Then married also I have given the same thing, annotated. Then this is boolean type field. I have given the default value. So see, if you want to give the default value, so previously how I was giving like that. Let's say I was just giving an equal sign and giving the value, but right now you're using this field. So inside field itself, you can give the default value. Let's say in default is equal to none. So by default, it will take as a none. Let's say if you're giving any other, let's say true, false, it will take as true, false. Okay. Now here I have given the description. Okay. Now for allergies also, you can do the same thing. You can mention like, okay, this is optional because previously this allergies was optional and the data type is list, and inside that we are taking the string type data. Field is default value you are setting as a none. You can also give the default value if you want, and maximum length should be 5. Okay, so for contact details also you can do the same thing, but I left this part. Okay, now see if I execute, this is giving you an error. There is field required contact details. Okay, so the error is that here I have written contact details, but here I have given contact information. So here you have to give the same name. Now if I execute, it will be working fine. Okay, now one more thing I wanted to show you, which is this streak parameter. Let's say I told you in my previous demo, I think you remember, whenever let's say we are giving, let's say weight is equal to a string number. Okay, but here what is the type I have mentioned? Weight is equal to, it should be a float number. So by default my Pydantic is converting this particular string to a float because this is the number. Okay, but always it is not necessary to convert it. Okay, automatically convert it. Let's say you are creating an application there, you only want to take this kinds of, let's say, number as a string. That time you should not be convert to the float data type. That time you can write one parameter. So here you can write a parameter. The parameter name is streak. Okay, streak. So you have to make it as true. Okay, so if you make it as true, so what will happen? You have given float type, but if you are trying to give this string type, it will throw you error. See, it is throwing you error. It is telling weight should be input. It should be a valid number, float type number, but we are giving string type. Okay, that's why it's not working. So now if I make it as float, okay, see, it will be working right now. So if you're giving integer also, again it will throw an error because here I make it as a strict. Okay, strict parameter. So that's how you have all kinds of customization, customizable option inside Pydantic. Whatever you want, you can do everything here. Okay, this is possible. So guys, we have seen some data validation actually strategy, how we can do that. Now I'm going to discuss about this validator in an advanced level. We call it as a field validator. Okay, so see, so far the validation we have done, this was like the simple validation. So we used some of the predefined validator, and we also like given some of the like custom constraint there. Okay, but let's say you have some complex scenario there, you have to do a complete field verification. Okay, so for an example, uh, let me tell you like the problem statement. The problem statement is that, let's say the application we have created, let's say this is a hospital application. So basically this stores the patient information. Okay, then it performs the diagnosis to the patients. Okay, now just try to consider this hospital has also connection with some of the bank. Let's say some of the bank, it has the connection. Let's say HDFC bank, it has the connection. ICICI bank, it has the connection. Okay, now what happens if it is having the connection with the banks? Let's say whatever patients are coming from, these are the banks, so they will be getting 50% discount. Okay, they will be getting 50% discount from this particular hospital. And if the patient is not from these are the banks, so they have to pay 100% about the money. So this kinds of, let's say, validation I want to add inside this application. Now how to do that? So definitely this is a little bit complicated. So for this I have already created the code. As you can see, I just copy pasted the same code, but what I have done, I just reduced the some extra coded, so that you can understand easily. See what I have done. The previous validation I showed you with the help of annotated, I removed each and everything. I just taken my previous example. Okay, previous this clean example. So here you can see this is the cleaned example. Okay, I have taken the name, email, age, weight, married, allergies, contract. Okay, these are the things I have taken. Now let's say I want to check the email here. Okay, I want to check the email here because only I will understand whether this patient he's from any bank or not. How I'm going to understand? Because patient will give their email address, right? So if I'm a like a very common person, so I'll give my common email address like @gmail.com and all, right? But if anyone is working in the bank, so definitely they will be having their bank domain email address. Okay, let's say hdafc.com or icici.com. Okay, like that. So email is the best field I can do this kinds of validator. So for this, what you have to do, you have to write a custom function. Okay, so the function name is, I have given email validator. Okay, you can give any name, but I have given email validator. And whenever you are creating this function, make sure you have to give two decorator. One is the field validator. So field validator you have to import from Pydantic. So you can see I have imported from Pydantic field validator, and inside that you have to mention which field you want to validate. So here I will tell I want to validate this email. Make sure the spelling should be same. Okay, email field should be validated. And another decorator you have to get called class method, because this is the method of this particular class. That's why this class method. Now this is my function. So this function takes two argument. One is the class object itself. Okay, and this is the value. Value means let's say user is giving the email, right? Email address, let's say abcd@gmail.com or sdfc.com. Okay, so this is called actually value. So this particular value will come, and I have to validate this particular value. Okay, so for this, what I have done, I created a list. I named it as valid domains. So here I just listed all of the bank, let's say a domain, let's say sdfc.com, icici.com. You can also give any other bank domain if you want. Then what I'm doing, first of all, the value I'm getting from the user, let's say whatever email user is passing. Okay, I'm just trying to extract this last part. Okay, as you can see, let's say if this is the email address, I'm extracting this particular part. So this code is doing that. So I'm splitting with the help of this @, then I'm taking the last value. That means this particular part. Then what I'm checking, if domain name not in our valid domain, that means if particular this domain name is not available inside our valid domains, that means this is not a patient from the bank. Okay, this is a common people. Okay, so that time I'm raising an exception, not a valid domain. Okay, otherwise we are returning the value. Simple. Now let's try whether it's working or not. See, here I have given simple email address bappy@gmail.com. So definitely it will throw error because I'm not from the bank. Okay, still it is working. Okay, the issue is that this should be patient data object. Okay, not patient. This should be patient data object, patient data class. Now if I execute, now see it is giving you error. It's telling value error, not a valid domain. Okay, that means this particular person, it is not from the bank. Now see if I give the bank domain, let's say I'll give sdfc.com. Okay, now it should be working. Still some error. Field required merit. Okay, so here I haven't passed the merit, right? So let's give the merit as well. Merit is equal to true. Now if I execute, see it's working fine. Okay, because this particular person, he's from the bank itself. Okay, so that's how you can do advanced level validation. Okay, this is called field validator. Now you can also do some transformation with the validation as well. Now let's say I will be working on another example. So one more thing you can do with the help of this field validator, you can definitely validate, but if you want, you can also do the transformation. Let's say the name you are getting from the user, you want to store this particular name in a uppercase format always. Okay, if user is also not giving, it's completely fine, but you want to make it uppercase and you want to save inside the database. So for this, again, you can write another validator, field validator. So see, this is the function I have created called transform name. And I told you, you have to use two decorator. One is field validator. Now you have to specify which field. I'll tell name field and the class method decorator. Now it will take class, object, and the value. Now whatever value user is giving, that means the name, I'm just doing the upper operation. Okay, and I'm returning it. Now see, here I'm giving, let's say, lowercase bappy. But if I execute this code, still you will see that in the database, all of the character would be in uppercase. Okay, so this is called transformation with the help of this field validator. That is also we can do here. So guys, now we'll understand one another important concept, which is model validator. So previously I told you about this field validator. So in field validator, what I was performing. So let's say if I want to do a single field validation, that time I was using this field validator. Okay, but let's say there is a condition, you have to verify multiple field. Okay, multiple field means, let's say the system you have created, you want to add another functionality, which is, let's say if patient age is greater than 60, okay, that time in the contact details there should be a emergency number. So this kinds of validation I want to do. Okay, so that time with the help of only field validator I can't do that, because I can't actually mention two fields together in the field validator. Okay, only one field can be mentioned. So we solve this particular problem with the help of this model validator. So for this is a very simple concept. So let me show you how to add this. So here you have to add this code. So here I will just try to define the indentation, and you have to import this model validator from Pydantic. Okay, there is another validator called model validator you have to import, and inside that you have to give this parameter as after, mode is equal to after, and here you will be creating the function. The function name is validate emergency contract. This will take the class, okay, and this will take the model. Model means the entire schema. Okay, so if you give the model, that means you can access all of the schema, okay, from inside this particular function. So here you can see, here I'm checking if model.age, that means I'm extracting the age. If it is greater than 60 and emergency not in model.contract, okay, that means if emergency phone number is not available, that time we are raising one exception, value error, patient older than 60 must have an emergency contact. Okay, then we're returning the model. Now let's try to check this whether it's working or not. So let's say right now my age is 25. That means this kinds of this condition will not match, so it will work fine. So if I execute, see it is working fine, there is no error. But if I, let's say, make my age to more than 60, let's say 70, now this will throw you error. It is telling value error, patient or older than 60 must have emergency contact number. Now here I have to add the emergency contact number. So maybe after the phone number, I can add a emergency number. Now if I execute, so it's working fine. Okay, so this is called actually model validator. So that means if you have multiple field verification, that time you can use this model validator, okay, inside your application. Now let's try to understand another concept, which is computed fields. Now with the help of computed fields, what we can do, let's try to understand. Let's say in the same example, I want to do another thing. Let's say here I have added another informations, another data called height. Okay. Now see what computed field does. It does a computation itself. Okay. Let's say if user is giving any kinds of information and it has to recreate or let's say generate a completely new information by utilizing the same information, that time we'll be using computed fields. Let's say in this case, my patient has given me weight and height, but I want to calculate inside my Pydantic the BMI. Okay, BMI of the patient. I'm not taking the BMI from the patient itself. Instead of that, what I want, with the help of weight and height, I want to calculate the BMI. So that time I'll be using this computed field. So you have to first of all import this computed field from Pydantic. We have already imported. Now you have to again use this as a decorator, and you have to write a function here. So my function name is BMI, and again you have to use another decorator, which is property. Okay, you have to use this property. So the property, I think this is already available. This property is already available inside Python. This is default one, so you don't need to import from anywhere. Then this is the function we are writing BMI, and we are giving the self parameter, and this returns the float value. Okay, because BMI should be float, and here we are calculating the BMI. You can see here we are taking the weight. Okay, then we are dividing with the help of this height, and we are squaring it. Okay, then we are taking the BMI. Okay, we are calculating this BMI, we are taking the result, and with this result we are trying to returning. Now if I want to print this, so I have to just simply write patient.bmi right now. See, BMI I haven't written here, okay, inside my schema. Instead of that, I'm calculating it and I'm returning it. So that's why I have to call with the help of this particular function. Let's see, if this function name is BMI test, you have to also give BMI test here. Okay, this is required. Now simply let me show you whether it works or not. So here I've already given the height. Height, let's say I'm considering in meter, and weight I'm considering in kg. Okay, now if I execute, now see, it is also giving you the BMI. Okay, so this is called actually computed field. So if you want to compute anything with the existing schema you are having, in the existing data you are having, you can use this computed field at time. So guys, now we'll discuss about another important concept inside Pydantic, which is nested model. So sometimes what happens whenever we create the fields, so field might be complex field as well. So let me give you one example. Let's say here I have this particular Pydantic model, that means the class patient data. So here I'm having the patient information like name, gender, age, and another information I have, which is address. Okay, now address field might be complex field, because address I can't write in a single let's say word. So inside an address there should be three kinds of entity. One is city, pin, and state. Okay, now here I'm not going to write these kinds of syntax, okay, because this is not possible here. So instead of that, what we can do, we can create another actually Pydantic class, okay, Pydantic model, and we can make it as a nested. Okay, so how it can be done? So let's say here I've created my patient data. This is my model, and here I've created another model, which is address. Okay, and again I inherited with the help of this base model. Okay, now here I've given three entities: city, state, and pin. Now first of all, I've created the address. As you can see, address dict. So city is equal to, I have given Gurgaon, state is equal to Haryana, pin is equal to, this is the pin. Okay, now this particular address you have to pass where? To this address model. Okay, so we are passing it to the address model. We are unpacking that. Okay, now this will return me one Pydantic object. Okay, now I'm going to create my patient information right now. So you can see name, gender, age, and now right now address is equal to, see what I have done, I have given this particular object, this class. Okay, address should be this class, so I'm passing this particular object right now. Okay, address is equal to this address. Then this patient information I'm passing inside my patient model. Okay, now this is giving you the patient information. Now inside this patient information, you are having all of the information, whether it is related patient data, whether it is related address. Now let me show you. So here I'm importing first of all of the patient, you can see data. So inside patient, I am having name, age, okay, and the address. Okay, address object is also available. Now if I want to let's say access the name, I can do that. If I want to access the address, I can also do that. Now let's see if I want to only access the patient city. So you just need to write patient address dot city. So this will give you the city. Okay, so that's how you can write these nested models. This is also possible inside Pydantic. Okay, I hope you get it. So guys, one more last thing I'm going to discuss about this Pydantic, which is serialization. That means you can also export your Pydantic object as a dictionary or as a JSON. For this we use serialization. So I have taken the same example. So only the last part of what I have done. So here you can see, let's say this is my final object of my nested model. So what I'm doing, I'm just doing model.dump. If you do model.dump, so what will happen? It will return you as a dictionary. See, you are exporting your object as a dictionary. Okay, you can see this is a Python dictionary. Okay, but if you're using this JSON dump, okay, this should be string. That means it's a JSON format. Now you can use JSON library to export. I mean, you can also export it, you can also dump it, and you can also load it, let's say later on. Okay, this is required, let's say whenever, let's say you have created a Pydantic object. Okay, you have done some data validation and all, and you want to take it as a let's say file, and let's say you want to load it later on, you can do this kinds of serialization. Okay, this is also possible. It's like a in machine learning we train model, right? After training the model, we save the model, right? We serialize the model. So it's kinds of that. Okay, now guys, with that our discussion has been end, and we have understood all of the concept related Pydantic. Okay, and I think now you are pretty much comfortable with Pydantic. You should not be having any kinds of issue with the Pydantic, whether you are working in Agentic AI, whether you are working in machine learning, deep learning, anywhere, you will see these kinds of concept will be available. Okay, now one thing I want to show you. So if I go to Google and if I search like why Pydantic is important for AI agent, as you can see, Pydantic is crucial for AI agent because it brings the structure reliability and type safety for software engineering to be traditionally unstructured and unpredictable world of large language models. Okay, by leveraging the Python type hints and runtime data validation, Pydantic ensures that AI agents interact reliably with external docs, APIs, and databases. Okay, so here some of the you can see concept they have given. You can go through that. You will see that at the end, this particular concept is very much required whenever we're working with Agentic AI application. Okay, so yes guys, I think you have understood all of the concept. If you have liked it, please try to subscribe to my channel and share this video with your friends and family. So in this video, I'm going to show you how you can implement AI agents with the help of this LangChain. Okay, but if you're completely new to the LangChain, if you don't know about anything about the LangChain, so definitely there would be a prerequisite for this session, which is the LangChain. And this LangChain video is already available on my YouTube channel. As you can see, I am having a complete LangChain crash course on my YouTube channel. The video name is Ultimate LangChain Crash Course for Developers. Okay, so I'm going to add this video link in the description. If you're completely new to the LangChain, guys, first of all, go ahead with this particular video. Then you will be able to understand each and everything about the LangChain. Then it would be easy for you to understand this LangChain agents creation. Okay, but if you're already familiar with this LangChain, you don't need to go through this recording. It's completely fine. You can continue with this particular lecture. But those who are completely new, I'm telling you guys, please try to complete the LangChain. Then you can start with the phase 3. So in this video, I'm going to implement a single agent system application with the help of LangChain. There I'm going to teach you like what are the things you need to implement these kinds of single agents, let's say workflow, and how you can utilize LangChain, okay, for this particular task. So guys, in this video, we are not only going to implement our AI agents. After implementing it, I will also show you how we can deploy these kinds of agents over the cloud platform. So this is going to be very interesting video, and this is going to be our first agent. Okay, the first agent application will be creating with the help of LangChain. So this is going to be a single agent system, guys. Don't worry, I'm also going to show you the multi-agent system as well in the next video. So each and everything I'm going to clarify. So make sure you watch this video till the end. So guys, before implementing this AI agents, first of all, let me give you the idea about AI agents. Although I have given you the detailed introduction of AI agents, but let's do some quick revision. As you can see, an AI agent is an intelligent system that receives a high level goal from a user and autonomously plans, decides, and execute a sequence of action by using external tools, APIs, or knowledge sources, all while maintaining the context reasoning over multiple steps, adapting to new informations and optimizing for the intended outcome. Okay, that means agentic AI application or AI agents is having a kinds of power. Basically, it has lots of connection with external like tools, APIs, or knowledges. So whenever we are giving any kinds of prompt, okay, it is taking it as a goal, okay, and with respect to the goal, it is planning all of the let's say task one by one, okay, and once all of the, let's say, task is ready, it will try to execute those tasks, okay, as sequence, and whenever it required any kinds of external tools or APIs, it will try to use that. Okay, that means if I give you a brief idea about the traditional LLM and the current AI agents, what would be the difference between them? So let's say, I think you know, previously we use only large language model, right? Large language model, and here we pass a prompt, okay, prompt. So what will happen, this large language model will take that prompt and it will give you a kinds of answer or response, okay, but this large language model doesn't have any external connection with any kinds of tool, APIs, or knowledge sources, okay. So whenever you are asking something, it should be available in the knowledge base itself of the LLM. That means this information should be available when they train this particular LLM, okay. But the difference of this AI agent is that whenever you are giving a prompt to the AI agents, so definitely internally AI agents is utilizing the large language model as a brain, right? It is utilizing large language model as a brain so that it can perform the reasoning operation, okay, reasoning operation. And I think you know why reasoning is required, because with the help of this reasoning, it will decide when to utilize what kinds of tool or what kinds of external sources, APIs, or knowledge sources, whatever, right? So whenever we are giving a prompt to the AI agents, so basically what it is doing, it is trying to utilize the large language model, it is performing the reasoning operation, okay, and when it is required any kinds of external tools for getting the informations, it will try to use that particular tools or any kinds of API, any kinds of, let's say, external knowledge sources, it will try to utilize, then this will give you the response, okay, with respect to the prompt you were asking, okay. But whenever it is doing this kinds of operation, so basically it is running some of the plan, right? Internally it is running some of the plan, it is making the decision, okay, then it is executing. These are the workflow one by one, okay. So this is called actually AI agents. I think you already know that. And to make this particular agent, okay, to utilize these LLM tools and everything, we need a orchestration framework, okay, we need a orchestration framework. So with the help of that particular framework, we can integrate like large language model, we can integrate like external tools, APIs, knowledge base, okay, then we'll try to integrate the reasoning ability. So it happens with the help of one orchestration framework. So in this video, we'll be using LangChain orchestration framework, okay. Apart from LangChain, actually other orchestration frameworks are also available, which is only designed for AI agents like LangGraph, Crew AI, AutoGen, okay. We'll try to discuss definitely, but I want you to first of all show you the first orchestration framework actually LangChain developed, okay, for the AI agents. So we not only use LangChain for generative AI application development, still you can use LangChain to implement these kinds of AI agents. But LangChain is having some like limitation. I'll tell you about the limitation in the next video. What is the limitation we are having? Why we have to use LangGraph, Crew AI? Okay, these are the things definitely I'm going to tell you each and everything. So now let's try to see how we can implement these kinds of AI agents with the help of this LangChain. So for this, I'm going to open up my local actually directory, and there I'm going to launch my VS Code, and all of the setup we'll be doing, and we'll start the development. So guys, I'm inside my local directory. So here what I'm going to do, I'm going to open up my Visual Code Studio here. So let's open up my Visual Studio Code. So this is my Visual Studio Code. Let me zoom. And I also need to open up my terminal here. So I'll open up my terminal. Okay. So the first step here will be creating a virtual environment, and we'll do the requirement installation for this agent. So let's try to create a file here. I'm going to name it as readme.md. And inside that, I'm going to mention all of the command you need to execute. So to create an environment, you have to execute this command. So conduct create -n. I'll name it as lang agent. That means LangChain agent. You can give any name, it's up to you. Then you can specify the Python version. So Python is equal to, I'll be taking 3.11 and -y. That means I want to give the yes permission. Once it is done, you have to activate the environment, and you have to install the requirements. Okay. Now you can copy this command one by one, and you can execute inside your terminal. So for me, this environment is already available. So what I'm going to do, I'm going to activate directly. But if you don't have, guys, first of all, try to execute the first command, then execute the second command. So see guys, this Lang agent is already available. This environment is already available. Now I'm going to add the requirements. So let's create another file here. I'm going to name it as requirement.txt. Inside that, you have to mention all of the requirements for this particular agent. So I have already listed down all of the requirements you need, guys. So these are the requirements you need. So I need LangChain, I need LangChain community, I need LangChain core, I need LangChain OpenAI, I need these things I don't need. I need request, then tably Python and python.env. Okay, I'm going to tell you why this thing are required. Actually, let me tell you. See, LangChain, I think you know this is the main framework. This is the main orchestration framework. And to run this LangChain, you need some other dependency package like LangChain community and LangChain core. And here we'll be using a large language model, because I think you saw internally agent uses a large language model for the reasoning, and this is the main brain. So for this large language model, I'm going to use this OpenAI. Okay, OpenAI provider. So from OpenAI, I'm going to use a particular model. And here you can change with any kinds of model if you want. Let's say you can also use any free provider like Open Router. You can also use Grok API. Okay, you can also use Gemini API. You can use anything. But I have the OpenAI. That's why I'm going to use the OpenAI. But whenever you are using this kinds of free model, so there are some limitation definitely. So you won't be getting any kinds of good response from this kinds of free model. That's why I'm using my OpenAI model, so that I can show you the best response I'll be getting from my agent itself. Okay, but this course is this model is changeable, guys. This provider is changeable. Anytime you can change with any model, any provider. So simply you just need to copy that model initialization code, and if you give to the chat GPT, and if you ask, like, let's say I want to use Open Router, this free model, so definitely will be getting that. So let me first of all write the code, then I think you will be able to understand. Then request, I need let's say if I want to hit some of the URL, external URL or external website, external API, that time I need this request module. I'll tell you why this request module I'll be using here. Then tably Python. So tably is a tool, okay, search tool. So with the help of tably, what you can do, you can perform the internet search operation. Okay, so the agents will be implementing, will try to add this tool so that my agents will be able to search any kinds of content over the internet. And python.env I need for the environment management. I'll be using OpenAI API key. I need tably API key. All of the API key I'm going to mention inside my .env. Okay, so let me create a file called .env. So inside that, I'm going to mention all of the API key. But first of all, you have to install this requirement.txt. So let's copy this command. open up the terminal and simply execute that. So for me, it is already installed. It will tell like requirement is already satisfied, but for you, it will take some time. Okay, so see, it has executed. Okay, I think everything is fine. Okay, so here another package you need, which is LangChain. LangChain Hub. Okay, LangChain Hub is also required. I'll tell you why LangChain Hub is required. So let me install again. Done. Okay, LangChain. Okay, spelling is not correct. So let's copy the spelling. Now I think, yeah, everything is fine. So for me, it is already satisfied. For you, it might take some time. So once installation is completed, guys, what I can do, I can simply create a folder. I can, let's say, give the folder name as research. And inside that, I'm going to create a Jupyter notebook file. I'm going to name it as agent demo.ipynb. Okay. Yeah. Perfect. So one more thing I have to do, which is this .env file. I will copy this one and I'll paste it inside research as well. Okay, because if I want to execute this notebook file, definitely I need this .env. So that's why I have done that. Yeah. Now, guys, what I'm going to do, I'm going to first of all import some necessary library. But before that, let's select our environment. So Python environment, which is Lang agent. Okay, I'm going to select that. So simply I'm going to import some required library. So I need operating system, then I need certify. Okay, why I need certify, I will tell you. Then I need request, import request, then I need .env. So let me copy all of the import I need here. Yeah, so I need .env. So I will import load env, because with the help of this load env, we'll try to load the environment variable, and whatever key we are having inside that, we can load. Then from LangChain OpenAI, we are importing chat OpenAI. So this is the class we can use to load any kinds of large language model from OpenAI provider. Then we are also importing these tools. Okay, why this tool is required, I'll tell you. But as of now, let me delete this option and also delete this library, because these two things I want to show you later on. First of all, let's create a simple agents. Then I'm going to show you how we can improve this particular agent. Okay. Then from LangChain community, I'm importing this Tably search result. Okay, that means this Tably search tool. As I already told you, we are also installing this Tably Python. So Tably is one of the search tool. With the help of that, you can perform the internet search operation. So we can import this Tably from the tool, and it is available in LangChain community. Okay, that's why you are also install LangChain community. We are importing tools, Tably search and Tably search result. Okay, so once it is done, so simply I'm going to okay, another package I need, which is LangChain Hub. Okay, so from LangChain import Hub. So now let me import all of them. So it is asking, it will install some required ipykernel package. So let's install. So if you're doing it for the first time, let's say in VS Code, first time means in a like if you are creating a fast Jupyter notebook file and if you're executing, so initially it will install some dependency IPy related package. Okay, so it is installing. Let's wait. Once this installation is complete, then we can execute again. Okay, it has executed successfully. There is no issue. Okay, now here guys, what I'm going to do, simply I'm going to import some agent related functionality from LangChain. So first of all, I need two things. So from LangChain dot agent, okay, it is available inside agent module. I'm going to import create create React agent. Okay, so there is a function we are having called create React agent. Okay, so this thing, I'm going to tell you what is this create React agent. The full form of this React agent is reasoning, reasoning and action. Okay, so the full form of this React is reasoning and action. Okay, we can call it as a React agent. I'll tell you how this React agent works, what is the mechanism behind it. But as of now, just try to think. This is the agent we mostly use from the LangChain. Apart from that, some other, let's say, agent function we are having in the LangChain. But this is the most popular one people uses. Okay, reasoning and action agent. Now, once it is done, I'm going to import another functionality, which is agent executor. Okay, I'm also going to tell you why this agent executor is required and how this works with the React agent. Okay, so these two library I need. Now let's try to import them. Yeah, so once we have imported, now simply what we have to do, guys, we have to load the environment variable. Okay, we have to load the environment variable because in the environment variable itself we'll be mentioning all of our API key. So first of all, I need my OpenAI API key, because I already told you for the large language model we'll be using OpenAI, right? So let's try to mention the OpenAI API key. So how we can get the OpenAI API key, guys? I think you know, simply you just need to go to OpenAI API provider. So here you can go to the API platform, and left hand side you will see the option called API key. Okay, simply create a API key here, and you just need to copy the API key. Okay, so for me, I already have the API key. Let me show you. I'll just copy this API key. So this is my API key, guys. Don't use my API key. I'm going to remove after this recording. Just try to create your own API key. And you don't need to necessarily use this OpenAI API key. If you want, you can also use any other like LLM provider. Okay, it's completely fine. Now with that, I also need another API key, which is the Tabili. Okay, Tabili API key, because what happens, let's say whenever I will be initializing the search tool. Okay, search tool of the Tabili. So to use this Tabili, I need a API key. So how to get the Tabili API key? So for this, you have to visit tabili.com. Okay, or you can search like Tabili API key. So instead of Tabili, there are some other like search tools are available, like SARP API, DuckDuckGo search, and other tools are also available. But I'm going to use this Tabili one. So simply click on Tabili API key. So you have to create an account if you don't have an account. So I already have the account, guys. I created with the help of my Gmail. So once you are inside the dashboard, you will be seeing this kinds of interface. So from here, you can create an API key. Okay. So for me, I already have created some API key, but let me show you how to create the API key. So let's say here, I'm going to create an API key called my key. Okay. Once it is done, just create the API key. Okay. Your key is created. And initially, whenever you are creating an account, you will be getting 1000 free credit. I think this is enough for learning. But if you want to use it for the production, that time you have to take their premium plan. Okay. Now let's copy this key. And what I'm going to do, I'm going to open up my .env. Inside that, I'm going to mention my Tabili API key. So let me copy. So this is my Tabili API key. Okay, Tabili API key. Done. Now let's initialize this thing, but I have to load the environment first of all. Load environment variable. Let's load. Yeah. So here we are loading the environment variable, but before loading it, so here you can see I'm setting this SSL certify file. Okay. So from this certify library, you can see we have already imported, and here we are calling var. Because what happens if you're using Windows operating system, so sometimes it might give you some path related issue. Okay, because what happens, Windows by default open some older path. Okay, and that's why this issue usually raises. So what this code does, actually, it will tell your Windows that it will always try to use the trusted certificate authority so that whenever it is initializing the path, it will load the updated one, okay, instead of loading the old one. Okay, you can also search over the internet. You can read about this SSL certify file. Okay, I think you will be able to understand. But if you're using any other operating system like macOS or Linux, I think that time it is not required. But if you're getting the path related issue, that time you can add this code, guys. Okay, this is optional. For me, actually, I was having this issue. That's why I have added. But for you, if you don't have issue, you don't need to add it. Okay, it's completely fine. So once it is done, now we are getting our OpenAI API key, and we are loading it here in this particular variable, and we are also loading our Tably API key. Okay, once it is done, let's try to load them. Now we'll be initializing the Tably search result object. So I can name it as a search tool. Search tool is equal to Tably search result, and inside that there is a parameter you can mention like max result. Okay, max result means how many result you want after doing the internet search operation. Let's say we're searching for a topic. Let's say we're searching, give me some latest news. So how many search result you want, how many reference website you want. So if it is, let's say 2, this will give me 2 relevant let's say result. Okay, if it is 5, it will give me 5 reference. That's how it works. Okay, now let me show you how this thing will work. So simply what I will do, I'll just try to initialize it. Now let's try to test it. Search tool dot invoke. Inside that, I'm going to, let's say, give what is the capital of French. Okay, or let's say I'll tell okay, search spelling is not correct. Now fine. Now here I can tell, give me the latest news on AI. Now I will store it in a variable called result. Now simply I'm going to show this result. Search tool is not defined. I have to execute this. Now re-execute this. Okay, now see, it is real time searching over the internet, and it is referring some of the website. You can see this is the URL. So this is the first website it is referring for the latest news on AI. Let me show you this website. This is referring this blog google.com. So here is the latest AI news announced in March 2026. And there is another reference you will get, see this one. This is another website. From here also it is getting the informations. That means now my maximum result is 2. I'm getting 2 actually internet search reference. If you make it as 3, 4, you'll be getting 4 reference. Okay, like that. Okay, that's how you can use this Tably search for real time internet search operation, and this is called actually search tool. And you can use this tool with your agent, because agent should be always connected with this kinds of external tool, like this kinds of real-time tool. Whenever it needs any kinds of latest information, it will be using this tool to get this informations. Okay, with you. And again, I'm telling you, I'm creating a single agent system here. I'm not creating multi-agent system. I'm also going to show you how we can create the multi-agent system as well. Okay, each and everything I'm going to cover, but in this video we'll be only focusing on the single agent system. Okay, fine. Now our search tool is ready. Now simply what I'm going to do, I'm going to initialize my large language model. So let's initialize our large language model. So this is the large language model, guys. So from chat OpenAI, we are taking this GPT 3.5 turbo model. You can also use GPT 4.5, it's up to you. Temperature, this is the creativity parameter. I just kept it with 0. And here you need to pass the OpenAI API key. Now let's initialize the LLM. So once it is initialized, let me also test whether my LLM is working or not. I'll just do the invoke operation, LLM.invoke. Now here I'm telling, let's say, what is the year is it, and the result we'll be getting again will store response. See, this is it currently 2022? Okay, why it is giving you it is currently 2022? Because this GPT 3.5 turbo has been trained till 2022. Okay, it doesn't have any latest information after that. Okay, that's why this agent is required. I told you right in my introduction session why we don't use the large language model only, why agent is required. Okay, why real-time tool is required, each and everything I've already clarified. Now let me ask another question. Let's say, tell me a joke about AI. Now see, it is giving you a joke. Okay, that means it's working fine, perfectly. Now I need a prompt, guys. Okay, to implement the agent I need a prompt, and here we are using this create react agent function, and for this create react agent function I need a relevant prompt. So this prompt either you can write manually, either you can download from LangChain hub. So that's why we have already installed this LangChain hub, I think you remember. So what is LangChain hub? In the LangChain hub itself there are like so many prompt like predefined prompt are already available. So there are lots of let's say developer, they have already published their prompt. So you can use the pre-existing prompt and you can use it inside your application development. But if you want, you can also manually write this prompt. Okay, but why we are taking the predefined prompt? Because we are using this create react agent functionality. Okay, and for this create react agent functionality, this prompt is like very good, and this is recommended prompt to use that. Okay, now let me show you this prompt. You can copy the name, and if you go to Google, you can search it. You can search it here. Let's say now you can open the first website. Okay, so you'll see this particular prompt, guys. Here, see, this is already available in the hub, and you can see the prompt, guys. Answer the following questions as best as you can. You have access to the following tools, blah blah blah. Okay, I'm going to explain this prompt later on, but first of all let me create the agents and then let me explain, okay, what it does. Now my prompt is ready. Now what I have to do, guys, I have to prepare my tools. So I only created one tools, which is my Tabili search tool. So what I will do, I'll just try to add this tool. So let me create a list. Okay, inside that list I'm going to mention my search tool. Let's say if you're using multiple tool, you can add inside this particular list. Okay, I'm going to tell you how we can add also. Now my tool is also ready. Okay, I have to also execute the prompt. Now see, it has get this particular prompt from that LangChain hub itself. Now let me show you the prompt. Now see, guys, this is the prompt. Okay, this is the prompt. It has already got this particular prompt. Great. Now you have to create the agent. Okay, you have to create the agent. We have already got the prompt. We have already got the tool. Let me comment here. Okay, tool is there. Now we'll be creating the agent. Yeah, so to create the agent, guys, we'll be using this function create react agent, and this create react agent takes actually three things. The first thing is the large language model. Like this is the brain of that particular agent, and we are passing our large language model. The second is that tool. Okay, the tool it will be using for actually external search operation or external reference. And the third thing, it needs the prompt. Okay, that means you are telling your agent how it should interact, okay, how it should perform the jobs. Each and everything, each and every instruction is given inside the prompt. Okay, so whenever you are creating this react agent, that time you have to pass these three things. Okay, and this will return you one agent object. Okay, now let me execute. So I got the agent object right now. Now what I have to do, I have to run this agent, okay, with the help of the agent executor we have already imported. So as you can see, we have already imported this agent executor. So let's use this agent executor to run this agent. And don't worry, I'm going to explain you why this I mean how this create react agent works, how this agent executor works, okay, why it is required, each and everything I'm going to clarify. So now let me define the executor. So this is our executor. So as you can see, we are calling this agent executor, and agent executor takes another 3 argument. The first one is the agent we have created. Let's say here we have created only one agent, okay, which is this one. We are passing it. Then we are giving the tool, okay, the tool we have initialized. Then there's another parameter called verbose. So verbose, if you make it as true, that means whatever agent will execute, let's say whatever plan step it will execute, you'll be able to see that in the terminal. And if you make it as false, you won't be able to see the logs. Okay, so basically if you want to see the logs of your agent, you can make it as true, otherwise you can make it as false. Okay, so this will give you the agent executor object. So once you got the agent executor object, now you are ready to run this agent. So to run this agent, guys, we'll be using this agent executor, and we'll simply do the invoke operation. And here we are giving a input. So the input wise, we are giving find the capital of India, and then the find its current weather. Okay, so this thing I'm not going to pass it right now because I want to show you another things. Okay, now simply I'm going to tell find the capital of India. Now it will give you the response, and this response I'm going to print it. Okay, this response. So from the response itself, I will print the output. Now let me execute. Now see, agent is executing. So it is telling entering new agent executor chain. So I should use the search engine to find the answer. So it is using the search tool, that means the Tably search tool, and it is finding, see, it is action is Tably search tool, it is utilizing. Then it refers a website. Okay, from the website itself, it found that the capital of India is New Delhi. And once it got the result, okay, now you can see the final result, which is New Delhi. Okay, so let me give another input here. So I'm going to just write, tell me the latest news about Iran and USA war. Okay, now let's execute. So it is, you can see it is using this Tably search tool. Okay, so as you can see, my execution is done. So it is using this Tably search tool, and it is using different online sources, and it is extracting the latest information. And now let me show you the final output. So this is the final output. The latest news on Iran and USA war includes Iran warning of consequences if the US launches new attacks. Okay, blah blah blah. That means it is able to give you the real time, okay, the latest informations. Although we are using the GPT 3.5 turbo, okay, which is trained till 2022, but it is able to give you the latest actually informations about 2026. Okay, now let me show you. Let's say if I'm not passing any kinds of tool to the agent, so what will happen? So here, let's say what I'm going to do. So let's say here I'm going to create a empty tool. Okay, so I'm not going to pass anything in this tool. Now let's execute. Now again I will create the React agent. Again I will execute the agent executor. Then I will ask this question. Now see, it is continuously looking for the tool, but it is not getting, right? So it is not getting. So execution is done. Now if I print it, the final response, you'll see that agent stopped due to the iteration limit or time limit. Okay, what happens? Because whenever you are not providing any kinds of external tools, okay, what it is happening? It is not able to get any kinds of tool which it can use for searching these kinds of latest informations, and it is continuously running this tool, a loop. Okay, so there are actually limitation of this particular loop. So once, let's say, it is not able to get it, so this loop would be finished and you are getting this agent is stopped due to the iteration limit or time limit. Okay, but if we provide this tool, okay, if we provide this tool, that time, see, my agent is working perfectly fine. Okay, see, it's working perfectly fine. Now it is able to get the tool and it is able to search the content on the internet and it is giving you the answer. Okay, I hope you get it. That means what is happening, let's say this is our agent, this is our agent. Okay, and here we are giving a prompt or input, and what it is doing, first of all, this input is coming to the agent and it is utilizing LLM, okay, as a brain for the reasoning operation, and LLM is deciding, let's say, the input we are giving, whether it needs any kinds of tool or not. So the question we have given, so definitely it needs a tool, because here we are using very old LLM, right, which is GPT 3.5 Turbo. Okay, it doesn't have the informations about Iran and USA war, right, because this happens actually this year, that means the current year. Now LLM will tell, okay, I don't have the information, so what we have to do, we have to use an external tool. Okay, what we have to do, we have to use an external tool. So right now, let's say I have connected with Tabili Search API. So what it is doing, it is going to Tabili, it is executing this tool. This tool is giving you the response, like it is referring to website, because there is a parameter called search result. That parameter I have like set it to, so it will get two relevant, let's say, informations about the Iran and USA war. So this is returning to the agent, and now agent is getting that information and it is giving you the final output. Okay, it is giving you the final output. That's how things are working. And whenever you are not giving this tool, right, that time what is happening, agent is continuously looking for the tool, but it is not able to get it any kinds of response from the tool. That's how it is breaking the loop, it is breaking the iteration, and it is giving you, I didn't got the answer. Okay, the loop is executed, sorry, the loop is stopped. Okay, I think you saw this final message here. Here is the final message. Okay, I already like replaced it. I think you saw the message, right? This loop is already closed. We are not able to execute that. Okay, so that's how things are working. Now let me explain about these two things, which is create React agent and another is agent executor. Okay, how this create React agent works, why we call it as a reasoning action agent, and why agent executor is required to run this particular create React agents. Okay, I'll try to discuss this part right now. So guys, as you can see, first of all, let's try to understand this React agent, how React agent works. So as you can see, React is a design pattern used in AI agents that stands for reasoning and acting. Okay, it allows a language model LLM to interleave internal reasoning thought with external actions like tool use in a structured multiple process. Okay, that means I told you, if I want to execute an agent, so I need some external tools, right? And to select that particular external tool, definitely you need a reasoning, and that reasoning you are doing with the help of LLM, some kinds of large language model. Large language model is deciding, okay, now I have to use this particular tool, and you are using that tool to get the response, and you are actually sending that particular tool response to the agent, and agent is giving you the structured output. Okay, so the whole system is working like that. Okay, now we are using this React agent, okay, from the LangChain. So the React agent is implemented in that way. Okay, because internally they have written all kinds of code related this kinds of orchestration. That means it has the connection with LLM, it has the connection with lots of tool. Okay, so once we are giving any kinds of prompt, it is automatically deciding with the help of LLM like what tool to use, okay, for the actions. So let's say once I executed the tool, then what will happen, this tool will give you some kinds of response, and you will be structuring this particular output, and you will show to the human. Okay, so this is a multi-step process. Okay, this is a multi-step process. That means this is a kinds of loop. Okay, so you can see instead of generating an answer in one go, the model thinks step by step, deciding what it needs to do next, and optionally calling tools, APIs, calculator, web search, etc. to help it. Okay, that means uh, not only like tably search tool. Okay, you can use any kinds of tool here. Either you can use any kinds of API, either you can use any kind of calculator, web search, and anything. Okay, now see, this React actually works in 3 steps. So I have already given an example. As you can see, the first step is nothing but the thought. Okay, thought. Then the second step, you can see action. Okay, and the third step is nothing but observation. Observation. Okay, now see, here is the example. So what is thought? First of all, let's try to understand. Whenever we are giving any kinds of prompt, let's say we are giving a prompt, let's say we are giving a prompt, what is the capital of France, and tell me the population, tell me the population for capital of France. Okay, let's say this is my prompt. So first of all, what will happen? We are using, let's say, this React agent. So this prompt will go to the React agent, and React agent will try to make a thought first of all. So what would be the first thought? First thought is nothing but, let's say, I need to find the capital of France. Okay, so first of all, this would be the thought. Now for this particular thought, it will perform a kinds of action. Okay, so in this action, it will utilize an external tool. So in this case, it will utilize the search tool. Okay, and with the help of search tool, what it will do, it will try to perform some action. Okay, so let's say it has done the searching operation, the capital of France on the internet, and it got some observation like, okay, the capital of France is nothing but Paris. Okay, so once it got the observation, you can see the first loop is complete. Okay, the first loop is complete, and in the first loop, it has performed 3 things: thought, action, and observation. Now it will come to the second loop. Now you can see in the second loop, again the thought will apply. Now let's say it has already got the Paris, okay, the capital of France. Now it will tell, now I need to find the population of Paris. Okay, what it will do, again it will perform an action. Again it will maybe utilize a search tool or any other tool it is having. With the help of this particular tool, it will perform the action. Okay, so now it will try to figure out the population of Paris. Now let's say observation is 2.1 million. It is the population of Paris. Okay, now you can see this is the second loop. Okay, second loop is complete. Now it will perform the third loop. Okay, now you can see once it got the final result. Okay, once it got the final result, that time this loop would be stopped. Okay, now how it will understand this loop should be stopped? Because there we in the prompt itself, we try to set whenever we get the final answer. Now let's say the third iteration, you'll see that now I know the final answer. Okay, so once it knows the final answer, okay, that time this particular iteration should be stopped. Now you can see it will return with the final answer. That time the Paris is capital of France and has a population around 2.1 million. Okay, that means the prompt, I think you remember I showed you one prompt. Okay, we are using from LangChain hub. In the prompt also, these kinds of steps are available. Okay, and there we strictly mentioned that once you got the final answer, okay, once you know the final answer, just try to stop this particular iteration. Now let me show you this prompt again. I think now it would be clear to you. So guys, as you can see, this was the prompt. Now you can see the prompt: answer the following questions as best you can. You have access to the following tools. So I think you remember in our agents, we have already provided the tool access. Okay, all the tool access we are having. Now we are telling use the following format: question. Okay, question should be the input questions you must answer. Okay, the user input questions. Now you can have 3 things, 3 steps. First of all, thought. You should always think about what to do. Okay, and this thought, how it will think with the help of LLM. Okay, now with respect to the thought, it should perform some action. Okay, the action to take should be one of the tool. Okay, that means this action should be taken with the help of one of the tool. So once, let's say, we have selected the tool, now what should be the action input? We have to provide the action input. Now this will perform the action, and whenever it will get the response from the tool. So this is called actually observation, the result of the action. Okay, once you got the observation, now this particular step should be running continuously. You can see this thought, action, action input, observation can repeat n times unless and until thought is I know the final answer. Okay, I know the final answer. This particular let's say iteration should be continuously running. Okay, once you know the final answer, that time just try to provide the final answer. Let's say this is the final answer of the original questions, and what will happen, it will try to end that particular agent. Okay, so every agent works like that, guys. Okay, I think you got it, because the main funda is behind the agent is to run some of these steps. Okay, and continuously this will run these steps unless and until it found the final answer. Okay, once it found the final answer, then this particular loop would be break and you will be getting the final output. Okay, now you can see the question, as a like say human, we have to give the question, our question, and agent internally will try to take the agent scratch pad. Okay, what is agent scratch pad? Agent scratch pad is nothing but that three things. Okay, this thought, action, and observation, because continuously it has to take that. Okay, continuously it has to take that to understand the previous question, action, and observation. Okay, so these kinds of things will be continuously happening unless and until we are not getting the final answer. Okay, now I think you got it. So that's why I told you we'll be using this predefined React prompt for this React agent. You can also write your own prompt, but if you're writing, so you may miss down, these are the option, and whenever you miss down, these are the, let's say, context, so definitely your agent might not give you the correct response. So that's why prompting is always important whenever you're creating your own agent system, guys. Okay, so guys, now I think you have understood what is this create React agent. Okay, how it works. Now we'll try to understand what is this executor is, agent executor. Okay, why we need this agent executor to run this React agent. Let's try to understand about this. One more thing I want to tell you, which is that, let's say, after using this create React agent, it takes 3 parameter, LLM, tools, and prompt. We get the agent object. Okay, this is our final agent object, and to run this agent we need this agent executor. Okay, now let me show you another diagram. So guys, as you can see, this is the diagram of agent and agent executor. Now we'll try to understand how this works. Okay, why this agent executor is required. So let's say we have created a React agent object, which is nothing but our agent. Okay, in the code itself I already told you. Now to run this agent I need an agent executor. Okay, so why I need this agent executor? See, to run this agent, okay, I think you know internally agent runs actually 3 steps. One is the first thing is like the this one, which is let me show you. Yeah, the first thing is the thought. Okay, thought. Then second thing is action, and the third thing is observation. Okay, so to run this 3 step, guys, we need this agent executor. Okay, to run this 3 step we need this agent executor. So without agent executor we can't actually run these 3 steps. Okay, so that's why whenever we have created our agent, to execute this agent we need an agent executor, and internally agent executor handles this 3 scenario. So what will happen in the first iteration? Let's say you can see this is the steps of agent executor, orchestrate the entire loop. So first of all, sends the input and previous message to the agent. Okay, so what will happen? This agent executor will try to send the input. What is the input? Input nothing but the user input. Okay, user input. Let's say user has asked, let's say I think I can give you the same example, the previous example. What is the capital of France? And I need the population of capital of France. Let's say this is the input. So first of all, this agent executor will try to send this input to the agent, and it will also send the previous message to the agent. Previous message means these 3 things: thought, action, and observation. So initially for the first time, whenever you are executing the agent, definitely this three actually block would be completely empty. Okay, this three block it should be completely empty. That means whatever thought, action and observation you are sending, it should be completely empty. So your agent will only receive the user input that time. Okay, now once it got the user input, now your agent will decide, okay, whether it has to use any kinds of tools or not. Okay, now you can see gets the next action from the agent. Okay, so you can see um, yeah, so sends the input and previous message to the agent. Once it is done, now agent will try to let's say perform the reasoning operation. With the help of reasoning, it will decide the question we are getting, whether I need to use any kinds of tools or not, because agent is already connected with the tools. I think I showed you, right? It has already connected with tools. Okay, it has connected with tools. Now agent will decide whether it has to use any tools or not. Let's say it has to use a tool. What tool? The tably search tool. Then again agent will try to tell agent executor that like I have to use the tably search tool to give the answer. Okay, now what agent executor will do? It will go to the tool. What tool? The tably tool. Okay, tably tool, and it will hit the tably tool with the question user is asking. Let's say the first question was, what is the capital of France? Now tably will refer some internet website and it will give you the answer. Again agent will give this answer to the agent. Okay, now agent got the answer. Let's say the capital of France is Paris. Okay, now what will happen? This is the observation. You can see execute the tool with provided input, adds the tool observation back into the history. Now what will happen? Again it will try to add inside this thought, action and observation, because it is already getting this thought, then action and observation. Now these are the parameter would be filled up. Now what is the thought? Thought should be let's say it already got the capital of France, which is Paris. Action, it has already taken, it has used the tably tool. Okay, and the input was what is the capital of France, and thought should be it already got the capital of France. Okay, and action should be it has, let's say, already executed the tably tool, and observation should be the Paris. Okay, it already got the Paris. Now it will run the second loop. Okay, it will run the second loop because it didn't get the final answer yet. Okay, it didn't get the final answer yet. Now again what it will do, again agent executor will run. Okay, now agent executor will run the thought. What is the thought? Now next thought should be this one. Next thought should be this one. Now I need to find the population of Paris. Okay, this should be the next thought. Again it go to the agents. Again agent will decide whether it has to use a tool or not. So again it will tell, okay, I need to use the tably search tool. Agent executor will go to tably search tool. It will hit the tably search, again get the real-time information, pass it to the agent. Now agent will again fill up this information with thought, action and observation. You can see thought, action and observation. Okay, let's see, it got 2.1 million. Okay, now it got the final answer. Okay, now this agent will tell, now I have the final answer. Now once agent executor got this one, let's say now I have the final answer, that time this agent executor will stop. That means this is running the entire loop. Okay, that means this is running the entire loop. So once you are getting the final answer, this particular loop would be executed, exited, and your application will stop and you will be able to see the final answer. Okay, so that's how things are working, guys. That's how the LangChain agent and agent executor we are creating, it is working internally like that. Okay, so whenever you are using this React agent, so definitely you have to use this agent executor. This is very much required. Now I think, guys, you are pretty much clear about the LangChain create agent. Okay, how it works. Sorry, LangChain React agent, how it works, why we need this agent executor along with that. Okay, now let me show you as a code. So you can see the code, guys. In the code itself, we have already written this create React agent. It takes LLM, tool and prompt. Okay, with the help of prompt, it performs all the instruction how this React agent works. I think I already showed you the prompt. And to run this agent, I need the agent executor. That's why we are giving this agent. Tool we are also giving because I think you know that agent executor will invoke this tool. Okay, that's why tool access also I need to give to the agent executor. And there's another one, verbose. Okay, verbose is all the execution is happening right internally. See, you can see the logs. But if you make it as false, let's say I will make it as false. So what will happens, you won't be able to see any kinds of execution. Let me again create the React agent executor. Now if I run the agent, see, you won't be able to see any kinds of logs. See, it executed, but you can't see any kinds of log, but still you will be able to see the output. Okay, output is there. But whenever you make it as true, right, so you will be able to see the log. So for this, again, I have to execute the agent. Now see, this particular log, you will be able to see whatever decision, whatever thought, actions, and observation your agent is performing, you are able to see that, okay, in live. So that's why we make it as this parameter as true. Okay, now I think you are clear enough, guys. Okay, so yes, guys, so that's how we can use this LangChain to develop these kinds of single actually agent system. And this is our first agent, guys. This is like very simple agents we have created. So don't worry, in the next video I'm going to also show you how we can create the multi-agent system. So here only one agent is working, right? But if you want, we can also create multiple agent and that will be working together. Okay, this is also possible. Now what I'm going to show you, guys, I'm going to show you how we can convert it this particular notebook in a application file, that means app.py, and we can run that particular app.py. Okay, because I have showed you the research right now, that means the experiment right now, but in production definitely you will not create the Jupyter notebook file. Instead of that, you have to create a Python file. So let's say I'm going to name it as app.py. Okay, so simply what you can do, you can copy whatever code you have written in the notebook in this app.py. See, I just copy pasted the same code. Copies the same code. But before that, let me show you how we can improve this agent. If you want to improve it, if you want to add some more tool, so how it can be done. Let's say here I want to add another tool, and that particular tool will real-time search the weather informations. Okay, weather informations given any kinds of location. Because right now I'm using the Tably search tool, it is completely fine, but I want my custom tool. Let's say I have created a custom function, and that custom function I want to use as a tool. Okay, how it can be done, let's try to see that. So for this, what I'm going to do, I'm going to, let's say, import this LangChain dot tool. Okay, import, there is a function called tool, you have to import that, and I will import another library called request. Okay, this tool library I'll import. Once it is done, now simply here I'm going to create a function. So after this search tool, maybe I can create my custom function. So this custom function will get the weather information. Okay, so I've already written a function. So let me show you this function, how it works. So maybe I can show you test.ip, or let's say here itself I'm going to show you how this function works. Yeah, so this is my function, guys. So what this function does, this function takes a city name, okay, or given any kinds of location, and it fetches the current weather informations of that particular city. So for this, we are using this weather stack API. Okay, weather stack API, I think you know, this is our website, weatherstack.com. So let me show you. This is a website. weatherstack.com. Okay, so this is the website, guys. So here, first of all, you have to create an account. Just sign up with free. Okay, so once you sign up, you will be able to see your dashboard. Okay, so if you go to the dashboard, so here you will be see these kinds of interface. Okay, and we are using the free plan. So in free plan only we can search the real-time weather information. But if you're using the paid subscription of this weather stack, that time you can perform location search, astronomy data, hour by hour, okay, full historical data. So that means so many things you can perform here. But I only need for the weather information. That means my free plan is completely fine. So here you have the API key. You just need to copy this API key. Okay. So don't use my API key. I'm going to remove it after the recording. So here you have to pass this weather API key. Now what I can do, maybe in the .env itself, I can mention my API key. So here is the .env. So I already collected this API key, guys. Let me show you. So this is the API key, weather stack API key, and this is the API key I have copy pasted from the dashboard. Okay. Now simply here itself, you have to load this API key as well. So let's load it. Weather stack API key, wes.get weather stack API key. So you're also loading this. Okay. Once it is done, now see this API key would be given here. Now how these things will work, let me show you. I will copy this and I will paste it here. Now is f string, I'm going to just remove it because this is I have given only for static variable. F string I don't need. Now if you give any city here, let's say I'll give Mumbai. Hit enter. Okay, you have to pass the API key, right? So let's copy the API key. Now if I hit enter, see, you will be getting a response like that. Okay, so this is having the informations about the Mumbai, the current weather information, as you can see. Okay, the current weather information it is having. Okay, now I have to extract the data from this particular JSON itself. So what I have done, I have written a function here, as you can see. So this function hit this URL with this API key, and you can give any kinds of city name. I'm hitting with the help of this request library I have already imported here, as you can see, request. So once we get the response, so what we are doing, we are just converting to the JSON. Now we are telling if current not in data. So I'll tell could not find the fetch weather data because current parameter should be there. Because in the current one, we are having the current weather information. Okay, this temperature weather code it is having. Okay, so we are getting this current key. Now, once we get the current key, I'm taking the city name, temperature, weather, and humidity. Okay, these are the information I'm taking. If you want, you can also take any other information. It's completely up to you. So this is a function, custom function. Now, if I want to use this custom function as a tool, so what I have to do, I have to write a decorator at the rate the tool I have imported. Okay, so this tool I have imported, I have to just give this particular tool. Now what happens, this particular function becomes a custom tool. That means this tably search result, this is a predefined tool. This is already developed by some other organization or other company or other developer. But right now this get weather data function we have created, this is our tool, our custom tool. Okay, that's how we can create our custom tool and we can use it inside our agent. Okay, this is also possible. Now let me execute. Now simply what you have to do, here itself, in the tool itself, where I have mentioned the tool, in the tool, you just need to give the tool name, which is get weather data. Okay, that's it. Get weather data name. Yeah, now let's execute. I mean, I will execute from the beginning. Okay, now initialize the LLM. Now we are also involving the LLM for some response. Now fetching the prompt. This is the prompt. Now we're initializing our tools. Okay, now see, you can pass list of the tools. You can pass 100 of tools. Okay, it's up to you. Now we are creating the agent and we are passing the list of the tools right now. Now my agent is having multiple tools. Okay, one is the search tool and this is the get weather tool. Now I'll again execute. Now my executor is ready. Now I can give a prompt. So now I'll give this particular prompt. Let's say this is the prompt. Find the capital of India and then find its current weather. Now see, if I execute, you can real time see. I should first search the capital of India, uses the weather data tool, find the current weather. See, first of all, it has used the tably search tool to get the capital of India. So it is referring some website, Indian website, and it is getting the capital of India, which is New Delhi. Okay, so we got the New Delhi. Now once it got the New Delhi, now what it is doing, guys, it is utilizing my get data tool. Okay, my get data tool, and it is fetching the weather informations. Okay, so that's how things are working, guys. I think you got it. Okay, that means now it is having multiple tools. So tably search it is utilizing for the search operation, okay, for finding the capital of India, and my get weather data tool it is utilizing to get the weather informations. And how it is deciding? With the help of this React agent, okay, because it is internally using LLM, and LLM is doing the reasoning, okay, and it is deciding what tool to call. And this kinds of tool calling and everything is happening with the help of this agent executor, because it is running that 3-step. That means I think I showed you 3-step means first of all thought, actions, and observation. Okay, that's how things are working. Okay, I hope you get it. Now if I want to convert everything in the app.py, guys, so this is the final code. So let me select my environment, which is Lang agent. So this is the final code. I just copy pasted the same code, okay, from my notebook. As you can see, the same code, nothing changed. Okay, now I can run the app.py. Let me show you. So I will open up my terminal, and if I execute my app.py, so Python app.py. Okay, so it is telling tably. Okay, because I'm running the app.py, and now app.py will refer this .env, because previously I created inside resource folder. So what I can do, I can copy all of the key and mention inside this particular variable. Okay, now let's execute the terminal. Clear. Now again execute app.py. Now see, agent is executing. Now see, first of all, it is getting the capital of India. Now once it's got that, it is utilizing my custom tool get weather data, and it is giving you the temperature. Okay, now this is the final temperature. As you can see, the capital of India is New Delhi, and the current weather is 37 degrees Celsius with haze. Okay, perfect. That means we have implemented our first agent, guys. Congratulations, with the help of LangChain. Okay, and don't worry, I'm also going to show you how we can create the multi-agent system in the next video. Now let's see, if you want to convert this app to a user interface, this is also possible. Maybe we can add Streamlit user interface. So what I have done, guys, I have just designed a Streamlit user interface with the help of ChatGPT. You can also do that. Okay, it's like very easy. You just go to the ChatGPT and tell I need a user interface for this code, so it will generate for you. Okay, so what I have done, guys, I have already generated a. So what I can do, let's say I'll rename this file. Maybe I can name it as main.py. Now I'll create another file here. I'm going to name it as app.py. Okay, inside that I'm going to paste my updated code. So this code is having the Streamlit user interface. Okay guys, so this is the code. So nothing else, I just added the Streamlit. I think Streamlit is a Python package with the help of we can create the user interface without writing any kinds of HTML and CSS code. So first of all, we have to install this Streamlit. So I will add this in my requirement, Streamlit. So let's install pip install -r requirement.txt. Okay, installation is complete. Now if I go to my app.py, now this error will disappear. Yeah, now see, only change it has done, it has set a Streamlit page configuration. So there you can see it has done a page configuration. Page title is Agentic AI Assistant. Page icon, this is centered layout, this is the title, and we have given a markdown search and weather AI agents using LangChain, and everything is same. The only thing is that at the last it has added the user query section. So there would be a input box. So there I can give the query, and there would be a button. If I run this button, so my agent will be executing. Okay, so this is a simple user interface code my ChatGPT added. Okay, inside my this main.py. Now let's execute and see how this looks like. I will clear and run streamlit run app.py. I'll give the permission. Now I'll show you this agent. Okay, so here I'm getting an error. So let me see the error. Okay, so this error I'm getting because I told you you have to add this line. Otherwise this error might come because I'm using Windows. I will add in the app.py. Here itself I will add that. I have to import certify. Okay, done. Now if I re-execute, it should work. See, it's working. Now Agentic AI assistant, you can see this is the user interface. Now here I can give my query. So maybe I can pass find the capital of, let's say, French, and the current weather. Okay. Now if I run my agent, you can see agent is thinking. So every agent actually thinks. Okay, if you use any kinds of agent, guys, you will see that this thinking option is there because internally it is executing that tools and everything. All of these I mean 3 steps are executing, like thought, then action and observation. That's why it's taking some time. Okay, if you open any kinds of agent, let's say if you open VS Code agent, if you open Cloud Desktop, if you open Gemini, you will see that this process would be there. Okay, now see, response generated. The final response is the capital of France is Paris, and the current weather there is 11 degrees Celsius with rain and thunderstorm. Okay, that means our agent is perfectly working fine. Okay, amazing. Now what we can do, if we want, we can also deploy this over the cloud, because right now it is running on local host and people can't access my agent. So I can, if I want, I can also I mean host this. So if you want to host this, so what I can do, you can use different cloud provider. You can use AWS, GCP, Azure, but let me show you one amazing cloud provider. There you can deploy this agent as free. So the cloud name is Render Cloud. Okay, render.com. So if I open render.com, so you have to first of all create an account if you don't have an account. So I already have the account. I'll just try to click on the dashboard. I'll log in with my Gmail. Okay, now simply what you have to do here, first of all, you have to I mean upload this code to the GitHub. Okay, so what I will do, guys, I'll simply upload, but before uploading, I don't need to upload this .env, because if I upload my .env, my API key will be exposed. So here I will add another file called .git ignore. Okay, inside that I will mention .env should be ignored, and in research .env should be ignored. Okay, now let's create a GitHub repo. I'll open my GitHub. I'll go to the repository. I'll click on new. I can give a name. So let's say I'll give this name. Search and weather AI agents using LangChain. I'll add a README file. Then simply create the repository. And make sure you keep it as public. Okay, you can also make it as private. It's up to you. Now I'll click on code, copy this link address, I'll open up my local folder and clone this repo here. So git clone, done. Now what I will do, I'll just copy this .git and paste it here. Okay. And this folder, I'm going to remove it because I only need this .git. Okay. Now from my VS Code itself, I can commit the changes issue. Now if I show you, see, this .env is ignored. Now simply I'll commit the changes. Now I'll just write git add space dot. Now git commit -m. I'll give updated. Now git push origin main. Okay, now if I go to my GitHub, refresh, see, all of the code are available. Okay, now let's try to deploy. So I'll go to my render. And here, what I'm going to do, guys, I'm going to just create a new web service. Okay, now here I will click on public git repository. Now I'll copy the link and paste it here. Now let's connect. Done. Now you can give a other name also if you want. It has automatically taken my repository name. Now everything, just keep it as same. Only here you just need to give a command. Okay, see, it will also install the requirement, this requirement we are having. Okay, now let's give the command of running Streamlit app. So this is the command. So basically this command will run the Streamlit server. Now here I will take the free, okay, free instance, and here you'll be, by default you'll be getting 512 MB RAM and 0.1 CPU, which is a little bit slow, but it is fine for the learning. If you want to, let's say, professionally deploy it, then you can take their plan. Okay, but I think this is fine. Now here I'll try to add my environment variable. So here I'm having OpenAI API key. Let's add it. I have to give the value. Now copy this. Then I will add the environment variable, another one, Tably API key. I will add it here. Then add another one, which is weather stack API key, and add the value. Done. Now simply okay, now simply I'll just do the deployment, deploy web service. So this is the free instance. It may take some time, guys. We'll wait. Once this particular option is live, okay, now it is building the entire instance. Okay, internally it will set up everything. Once this is live, we'll be able to test that. Now see, it's running. Now see, it is installing the requirements one by one. Let's wait. So I will pause the video. Once this installation, everything is complete, I'll come back. So guys, as you can see, our application is live right now. Everything is fine. There is no error. Now there is a link you can copy and you can open in your browser. So there you will be able to see your agent. So guys, you can see this is our application. This is completely live. If you're using free instance, it may take some time. Now we can test it. So here I will just tell find the capital uh, of Nepal and tell me the weather of that. Now I'll run the agent. Now see, agent is working internally. So guys, here is the final response. The capital of Nepal is Kathmandu and current weather 20 degrees Celsius with drizzle and 94% humidity. Okay, amazing. Now you can share this URL with anyone. They will be able to use your agent. So yes, guys, I hope you understood. I hope you have seen how we can utilize this LangChain to develop these kinds of AI agents. But here we have created the single agents, okay, single agents pipeline. In the next video, I'm going to show you how we can create the multi-agent system, okay? So everything would be covered. So guys, we'll be continuing with our complete agentic AI course. And I think you remember in our previous video, I have already shown you how we can implement a single AI agents with the help of LangChain. So this was our first AI agents implementation with LangChain. Then I told you, I'm also going to show you how we can create multi-agent system with the help of LangChain. So in this video, I'm going to show you the entire implementation, how we can utilize LangChain orchestration framework for implementing these kinds of multi-agent AI system. Okay. So make sure you watch this video till the end. You don't miss anything. If you complete this video, you will be able to implement multi-agents AI system with the help of LangChain. And in this video, I'm not only going to implement these AI agents, even after implementation, I'm also going to show you how we can add the user interface and how we can deploy this kinds of multi-agent system on the cloud platform. I implemented weather AI agents with the help of LangChain. So there I created a single agent that has some tool connection, like I given Tably search tool and I created one of the custom tool. Okay, that particular tool can access any kinds of real-time weather informations given any kinds of city or location, whatever. Okay, that means if I show you the architecture diagram, so yeah, if I show the architecture diagram, so there, let's say I created a single agent. Let's say this is our agent. Okay, so this agent having some connection with tool. Let's say it is having connection with Tably. Okay, and it is having connection with weather API. Okay, so whenever I was giving any kinds of prompt or let's say input, so first of all, this will and definitely it was connected with a LLM. Okay, because LLM was the brain, and with the LLM actually it will perform the reasoning operation. And whenever I was giving any kinds of input, then LLM was deciding whether I need to use a tool or not. So with respect to the question, let's say if I'm giving a prompt, just tell me the capital of India and give me the weather informations of that, right? So what it will do, it will first of all go to the agents and it will search with the help of Tably, like what is the capital of India. Then it will get, let's say the capital of India is Delhi. Now what it will do, again it will tell, okay, now you just need to fetch the weather information of the Delhi. So with the help of this weather API, it will real time get these informations, and your agent will try to refine the output and it will show you the final output. Okay, so that's how the things were working, and the whole system actually we have orchestrated with the help of LangChain. So there we used actually create a React agent, right? This functionality we used from the LangChain, and to execute this create React agent, we used agent executor, and the full form of React is reasoning and action or acting, whatever you can say. So with the help of that, we created the agent. Okay, so this was the previous architecture. Now, first of all, let me give you the multi-agent will be implementing for this video. First of all, I'm going to give you the idea what is the system we're going to develop. Then I'm also going to show you the architecture diagram, okay, like what would be the flow and how we can create the AI agents, how we can make the connection with different tools. That means the entire overview I'm going to give. Then we'll start with the development. So for this, this is the actually content I have prepared. So as you can see, multi-agent system with the help of LangChain will be developing in this video. So a multi-agent research assistant is a fully autonomous AI system that thinks, searches, reads and writes on its own. Okay, that means here we'll be creating a multi-agent research assistant. Okay, basically this will perform the research. So I think you have seen in ChatGPT or Gemini, there is a research option is available. If you open that, let's say application, so if you perform the research, so what it will do, it will take some time and it will perform the research operation on the internet in a given topic, right? So that's how we'll be also implementing a research assistant. So that research assistant will be having some kinds of, let's say, tool access, and with the help of tool, it will perform the real-time research operation. Okay, and here we are not going to create a single agent. Instead of that, we'll be creating the multi-agent system here. So as you can see, multi-agent research assistant, a fully autonomous AI system that thinks, searches, reads and writes its own. Okay, instead of a single AI answering your question from tools, here we'll be developing a team of specialized intelligence agents. Okay, a team of intelligence agents will be developing here that collaborates together to produce a professional research report on a topic you give them. That means if you are giving a topic, okay, so what it will do, it will use all of the like specialized intelligence agents. Okay, it will work together and it will try to give you a professional, okay, research report on that particular topic. So it will not only research, okay, it will also write the report for you. Okay, and you can see the search agent goes. So the first agent should be the search agent. So with the help of search agents, will be doing the real-time, let's say, research operation over the internet. The search agent goes out on the live internet and finds the most relevant recent sources. Okay, so it will perform the research operation of all of the internet sources it is having. Then the reader agent then dives deep into those sources and scrap and extracting meaningful content. That means here I'm going to create another agent. The agent name would be reader agent. So that reader agent, what it will do, it will try to scrap and extract, okay, all of the content from that sources. Let's say the first agent will return you the recent relevant sources. That means some URL. Okay, now what I will do, we'll just try to pass this URL to the reader agent. So reader agent will take those URL and it will open that URL, and whatever content it is having, it will extract, scrap, then it will gather those content. Okay, then here we'll be creating another actually agent, the writer agent. Writer agents takes all that generated intelligence and craft a well-structured detailed report. That means there would be another agent called writer. So this will take all of the content and it will prepare a draft. Okay, prepare a draft report, and after preparing this draft report, we'll be sending this draft report to another agent called critic agent. You can see, and finally the critic agent reviews the entire reports, scores it and gives feedback just like a senior researcher reviewing a junior's work. Okay, that means at the last we'll be creating another agent. This agent will try to review, okay, whatever, let's say your writer agent has written, it will review, it will give you the feedback. Okay, it will do some marking. Okay, just like let's say you are a senior researcher, whenever your junior is giving any kinds of task, you are reviewing that and you're giving the feedback. So every single agent is powered by a large language model, okay, connected through LangChain's modern LCEL pipeline and orchestrated through a shared memory system that makes them works as one unified brain. Okay, so here we'll be utilizing the modern LangChain, guys. So previous agent I created with the help of the old LangChain, but in this development I'm going to utilize the modern LangChain as well, which is LCEL, LangChain expression language. So for this, definitely you need the understanding about the fundamentals of LangChain. So that's why I told you LangChain prerequisite, I mean, definitely should be there if you're working with this kinds of agent. So for this LangChain on my YouTube channel, I already have one dedicated video, guys, Ultimate LangChain Crash Course for Developers. So it's around more than 7 hours of course, 7 hours of recording. So there I already covered this LCL and everything. If you go to the timestamp section, you can see here I have already covered this LCEL, okay, LCL. Okay, the modern LangChain, which is LangChain expression language. Okay, so definitely you should have understanding on these other topic. If you don't know, please try to go ahead with my LangChain lecture. I will add the link in the description. From there you can check it out. Okay, so the main funda is in this development we'll be using the modern LangChain instead of using the old LangChain. I wanted to show you both of the LangChain version because still people uses old LangChain. Okay, and people also use like modern LangChain. Both I'm going to show you. You can use any of them. Okay, it's completely fine, but I will recommend you to use the modern LangChain because in modern LangChain, the updated LangChain, so many functionality came and people are moving to that. Okay, so instead of relying on old LangChain, maybe you can use that one. Okay, so each and everything I'm going to clarify. Now I think, guys, the project introduction part is clear what to do. Now let me show you the architecture, how we'll be building these kinds of system. So guys, this is the architecture. I think you can see. Let me show you the architecture. Yeah, so this is the architecture. So in this architecture, guys, as you can see, here we'll be implementing multiple agents. So that means, let's say this is the first agent we'll be developing, and here we'll be passing given a research topic. Let's say if I want to do a research, I will give the research topic, so it will go to the first agent. Okay, so this agent will have some kinds of tool access. So here I'm going to give Tably API, that means Tably search tool access to this agent. So whatever research you are giving to this agent, so what it will do, it will use this Tably API and it will do the real-time search over, operation over the internet, and it will get the relevant sources. Okay, it will get the relevant website for that particular topic to this agent. Okay, now what I will do here, this particular response I'm going to save in a state memory. Okay, so here I will try to create a state memory. So state memory will try to save this particular response so that and your next agent can refer this particular response. Okay, your second agent can refer this kinds of response. Okay, so that's why we are using this shared memory concept. You can also improve this particular memory by utilizing some other techniques. So this part I'm going to also discuss in my future lecture. So I think you saw my entire plan there. I told you we'll be discussing this particular memory part in detail, but as of now just try to consider we are using a state memory. You can also replace the state memory with any other, let's say like memory database. You can use that. Okay, it's completely up to you, but here I'm going to use a state memory in Python. Okay, I'll show you how we can implement that. So now we'll be creating a second agent, guys. So this second agent name is reader agent. So this reader agent will also have some kinds of tool access. So here I'm going to use a beautiful soup scrapper tool. So what this beautiful soup scrapper tool will do, basically whatever URL you are getting from the first agent, okay, given topic, so this will take all of the URL, and with the help of beautiful soup, it will extract the content from the URL. I think you know, with the help of beautiful soup, we can perform the web scraping. We can scrap the content from any kinds of given website, right? So that's why the first agent is returning the web URL, web sources, and with the help of second agent, we are extracting the content from the URL with the help of beautiful soup. Then what we'll do, guys, we'll try to pass this content to another state, let's say memory called, let's say, scrapped content. Okay, maybe I can create another actually, let's say object here called scrap content. Inside that I can save those informations. Okay, now here we'll be creating another two actually agent. You can also call it as chain inside modern LangChain. Instead of creating this kinds of like agent in LangChain, what you can do, you can create a chain, because at the end you got your final important content. Okay, if you got the final important content, now it would be easy for you to generate that particular report, and it would be easy for you to review that particular report. Okay, but the main thing is in that section. So basically here we are performing the real-time search operation on a given topic. After getting that, we're extracting the content. Then if we have the final content, guys, we'll be creating a writer chain. Okay, in LangChain we call it as a chain. Okay, you can also consider it's a agent. Okay, it's a agent, it's a writer agent. So what this writer chain will do, it will take that particular content, okay, your beautiful soup extracted, and it will write a draft. Okay, it will write a draft report on top of that particular content. Okay, because at the end it has also connection with a LLM. Okay, it has also connection with a LLM. It is also having connection with LLM. Okay, so with the help of LLM, with the help of this content you got, it will prepare a draft. So once it has prepared a draft, what it will do, guys, it will send this draft to the critic chain. Now what this critic chain will do, it will try to review this particular draft, whether is there any mistake or not, is there any let's say improvement section or not. It will try to review that. Once the review is complete, okay, once the feedback is complete, then it will show you the final output. Okay, it will show you the final output. So you will be able to see the final output. Even you will also see the feedback, the ratings, okay, each and everything you will be able to see from this critic chain. That means the critic agent. Okay, because it is also having a connection with a large language model. All right, so yeah, this is the entire actually architecture of this particular multi-agent system. So this is going to be very interesting project, guys. So make sure you watch till the end. So I think each and everything would be clear in your mind. Okay, now here is the step, guys, we'll be following to develop the entire agent. So first of all, at the first step, guys, we'll be setting up the environment. Then second step, we'll be creating the tools. Okay, all of the tools will be creating one by one. Then third step, we'll be creating all of the agents one by one. Then fourth step, we'll be creating a pipeline. That means why pipeline is required. Let's say after creating n tools, you have to combine them. Okay, you have to add them together to work, right? So we can do it in the pipeline section. So once our entire agent pipeline is ready, then we can run and test our agent. Okay, so this is the entire step we'll be following for developing this kinds of system. So guys, now I'm going to give you the idea why we have to create mostly multi-agents AI application. What is the problem with the single agent? So I think you know that this is like very I mean easy things you can understand. Let's say if there is a company, okay, if there is a company, let's say company, what they does, let's say they takes a project. Okay, they takes a project. Okay, after taking this project, so what they do, they just try to assign this project to a team, right? Team of employee. So in this team, what we have multiple employee. Let's say employee 1, employee 2, employee 3, and so on. Okay, so what they do actually, just try to assign these kinds of project as a task to the team, and definitely in the team itself they will try to divide the task to different employee. Let's say here some of let's say employee 1 is very good at with front-end development. Okay, front-end development. Employee 2, he's like really good with, let's say, AI development. Okay, and employee 3 is good at with back-end development. Okay, back-end development. So what they will do, so the project they are having, so for the front-end development for this project, they will assign the task to the employee 1. For API development, AI development for this project, they will assign the task to employee 2. Okay, and for backend development for this project, they will assign the tasks to the employee 3. Okay, that means all of the project will have these are the things are common, right? And it's not like that there would be a single guy. Okay, single guy, he can, let's say, handle each and everything. I can't say he cannot handle, he can handle definitely. Let's say if I'm hiring a full stack developer, so definitely he will be able to handle this kinds of scenario. He will be able to, let's say, implement the entire project. But what would be the problem? Okay, because if you see most of the full stack engineer, so they will have actually limited knowledge on this actually, let's say, individual topic. So for the end-to-end development, whatever things they need to know, they definitely will do that for you. But when it comes to the deep research, let's say I want to create some AI features for this project, and I need a deep research. Okay, I need a very very good, let's say good sources. Then after getting the good sources, I have to refer that sources and I have to build the AI features. Okay, so if we are only depending on the single, let's say, employee, so he won't be able to do that because he doesn't have actually that much of depth knowledge on this AI development. Okay, he can only, let's say, use some of the framework library and he can implement that project for you. But when it comes to deep let's say research, let's say deep experiment, you won't be able to do that. That means with the help of single guy, I can't perform actually multiple tasks. Task can be performed, but the output, the quality of output will be expecting, this should not be good. Okay, this should not be good. This should be kinds of average output. But whenever we are having this kinds of project, definitely will expect like very good quality output from my team, right? And if we are let's say assigning this kinds of tasks to the single employee, so definitely single employee won't be able to give the quality output to me. So that's why every company having a team, and in that particular team they are hiring, okay, different individual, those who are let's say expert in different field. Let's say someone is expert in front end, someone expert in AI development, someone is expert in backend development. Okay, and whatever project they are getting, they're dividing their tasks to them. So let's say employee 1 has completed front end, employee 2 has completed AI development, employee 3 has completed the backend development. Now they will combine everything and they will prepare the project for you. Now when it comes for research, let's say having a deep research on individual, let's say, topic, so easily these kinds of employee can perform because he's only expert in front end, he knows about the front end. And if you give time, okay, if you tell this let's say employee, just try to research and add some more front end feature with latest like framework, he will be able to do that. Okay, because he don't need to worry about the AI development and backend development, he will only focus on the front end development. So that's how for AI developer guy also I can tell, just try to explore more and add some other AI features as well. So definitely he will be able to do that because he doesn't need to worry about the front end and backend. Okay, then employee 3 I'll tell, just try to research more about the backend. Let's say I don't want to use Flask, you just need to use Fast API, just try to explore Fast API, he will be able to do that. Okay, so that's how individual person is working on individual task, and the output we are getting from here, this is like very good quality output. Okay, good quality output we'll be getting. Okay, that's how whenever we are creating kinds of agent application, instead of creating a single agent, okay, instead of creating these kinds of single agent, because in single agents, if I want to perform all of these tasks, okay, if I want to perform all of these tasks, so definitely the output should be very poor. And if I'm using multiple agent, okay, the architecture I showed you, I think, so this is the architecture. If I'm using multiple agent, so here I'm assigning a different task. Let's say first agent I have assigned, your task is to only fetch the real-time data from the internet and give the collect the URL. Okay, then you will try to save the state memory. Then second agent, I have given another task, your task is to take those URL and extract the content from that. Okay, so after extracting content, again save to the state memory. Then third agent I told let's say this agent, just try to take those content and write a report on this particular research. Okay, your task is your only task is to generate the report, so it will try to generate the report. Then the fourth agent, I told this agent, you just need to take this draft and try to review that whether it is good or bad, or it still it needs some feedback, just try to read this. Okay, so this particular agent only is responsible for rating this, okay, or critique this particular task. So once everything is done, then we are getting the final output, and this final output would be very good quality. But if I am performing the same task with a single agent, so definitely the output would be very bad quality. Okay, so that's why this multi-agent things are required. Okay, that's why we'll be developing multi-agent system most of the time. And all of the application you can see, okay, whatever application like Claude desktop, or you are using VS Code, anti-gravity, anything, you will see that they're using multiple agents in the backend. They're running multiple agents. Okay, they're adding, let's say, 100 like agents in their backend, and they're performing one kinds of task. Okay, so yes, that's how guys we will be following this multiple agent development. And one more thing, whenever you are creating multiple agents, so make sure all of the agents will have kinds of tool access. Okay, if it is required, definitely we'll give the tool access. and all of the agents will have a large language model for the reasoning operation. Okay, I think everything is clear. Now we'll move on the development part, guys. So first of all, I'm going to create a GitHub repo for this multi-agent. So let's try to create a GitHub repo. So here I'm going to give a name. Let's say I'll give a name here, LangChain multi-agent research okay, research system. I will make it as public repo, and I will add the readme file. I'll also add the git ignore. So here we'll be coding with Python, so I'll select the Python. After that you can select a license. So let's take this maybe Apache license. Okay, you can take any of the license, it's up to you. Once it is done, now just try to create the repo. Okay, so repo is created. Now we have to clone this repo inside our local folder. I'll click on this code, copy this link address. I'll open up my local folder, and here I will just try to open my terminal. Now let's clone it. So git clone, paste this link. Okay, so this directories already exist because previously I already created. So what I can do, maybe I can rename it. Okay, I can rename it. Okay, now just try to open your terminal in this directory and just write git clone and paste that URL. Okay, you have copied. Now if I hit enter, so you will see my repo has been cloned. I will go inside that, and I will also redirect my terminal inside this directory. So for this, let's write cd command, cd LangChain multi-agent research. Okay, research system. Now I'm inside this particular folder. Now here I'm going to open up my Visual Code Studio. Visual Code Studio. Fine. Okay. Now the first thing, guys, I told you. So let me show you the steps we'll be following. Yeah. So this is my actually note file. So in this particular file, you will be getting all the nodes and architecture steps, everything. So this is the Excalibur like extension file. If you want to open it up, so you have to install one extension from extension market called Excalibur. So if you can search here, Excalibur. Okay, so this particular extension you have to install. If you install that, you will be able to open this, okay, in your VS Code itself. Fine. So now if I show you my step, so the first step, what I have to do, I have to do the environment setup. Okay, let's try to do the environment setup. So for environment setup, here I'm going to write all of these steps. Here, let's say the first step, you have to create the environment. So to create the environment, you can use the same command I think you used for the previous project, conda create -n. You can give the name, let's say lang agent. Then you can specify the Python is equal to, you can take 3.11 and y. Okay, you are giving this permission. After that, you have to activate that, then you have to install the requirements. Okay, so just try to create the environment. So for me, I think I already have the environment. So I'm going to just activate the copy and activate the environment. So see, this language is already installed for me. Okay, but if you don't have, just try to create the environment, then try to activate. Then after that, let's install the requirement. So here I'm going to add the requirement.txt, and inside that I'm going to mention all of the requirement package I need. Yeah, so these are my requirement, guys. Okay, so these are my requirement I need for this particular project. So you can see we are installing LangChain. So I think you remember in previous project we installed actually LangChain old version. So let me show you. It was 0.1 point something, I think. So this is the first agent repository. That means our single AI agent repository. So if I go to the requirement.txt, as you can see, we have installed LangChain 0.1 here. Okay, but here we're installing LangChain 0.2. That means this is the modern LangChain, the latest one. So here actually LCL, that means LangChain expression language, is supported, but here this was not supported. Okay, so both I have showed you, but try to use the latest one if you want. Okay, latest one is always good because older one people are not using anymore, so they are trying to moving to the new one. It doesn't mean older one cannot be used, still you can use old one. Okay, there are some good functionality you can use, but yeah, whenever we have the latest one, so why not we can utilize this one. Okay, then we are installing this LangChain core community OpenAI, LangChain OpenAI. So you can use any other LLM provider as well, it's completely fine. Simply you just need to go to the ChatGPT and tell that you want to use Open Router or Gemini. So you will be able to see that they will suggest you the code. Okay, you can replace that code here. Okay, then Streamlit I need for creating the user interface, then Tably for the search tool, and I told you we'll be creating another tool which is a beautiful soup extracting. So here we'll install this beautiful tool soup, and for beautiful soup we need these are the dependency packages as well. Okay, then python .env for the environment management. So these are the packages we have to install. So how to install? Let's copy the command. So here's the command. I will copy this and run in my terminal. So for me it is already satisfied, but for you it may take some time. Okay, once it is done, now we can create the folder structure right now. So here what I'm going to do, I'm going to first of all create a folder here. I'm going to name it as src. Inside that I'm going to create a constructor file underscore init underscore .py, and inside that I'm going to create another folder. I'm going to name it as tools. I'm going to create another folder called agents. Okay, then I need another folder called pipeline. Okay, yeah, so once it is done, then here I'm going to create an endpoint which should be my app.py. Okay, and I need a .env file for environment management. So yeah, so this is my folder structure. But right now I'm going to create some of the file inside. These are the folder. Like first of all, I have to create a constructor file. So this is called modular coding, where creating as a module, each and every separate module. Inside that we'll be creating a file called agent.py. Then pipeline also I'm going to create a constructor underscore init underscore .py, and we'll be creating a file called pipeline.py. So for tools also we'll be doing the same thing. Okay, everything is done. Now let me check, let me verify everything is fine or not. Yeah, I think everything is fine. So now if I show you my step again, we have prepared all of the folders. Okay, like for tools we have created a separate tools folder inside src. So inside that we'll be writing all of the tools in the tools.py, For agent also, we have done the same thing, agent, and inside agents, we'll be writing all of the agents. For pipeline, we have done the same thing. For pipelines, we'll be writing the pipelines. Okay. And run and test, we'll be using this endpoint, which is app.py. Okay. So everything is fine. Okay. One more thing I can do for running and testing the agent. First of all, let's say we'll try to test in the main.py. Then once everything is working fine, we can add the user interface to the app.py. Okay. Yeah. So now it's ready. Now let me commit the changes to my GitHub. So simply what I will do, I'll try to commit the changes. So git add space dot git commit -m agent setup and folder structure created, and git push origin main. Done. Now if I go to my GitHub, refresh, see my folder structure is ready. Okay. Now first thing, let's try to work on this. I'll open up my step. Yeah, so environment setup and folder creation is done. Now here what I can do, maybe I can write another things, folder structure. Okay, folder structure. Yeah. Now first of all, we'll be creating the tools. Okay, let's try to create the tools. So here I'll close all of this file. But before creating the tools, first of all, I have to collect this uh, secret credential. I need my OpenAI API key and I need Tably API key. Okay, I already showed you in my previous implementation how to collect them. So I already collected. Let me show you. So this is my OpenAI API key and this is my Tably API key. So for OpenAI, what you have to do, you have to visit OpenAI API platform. So there, simply just try to log in with the API platform. Once you have logged in, just try to see the API keys option. And create the new access secret key. Okay. So for me, I have already created. Now for Tably, you can visit Tably API key, tably.com. And see here, if you don't want to use OpenAI, you can use Google Gemini API or OpenRouter or Grok API key, anything you can use. Okay, only you just need to change that model initialization. Simply you can go to the chat GPT and you can replace that. Okay, very easy. But I have my OpenAI account with me. That's why I'm going to use OpenAI, because I am expecting good output from my agent. Okay, that's why. Because in free API, there is some limitation. So after certain time, actually, this limit would be over. So that's why we are using OpenAI here. Now Tably also, you have to do the same thing. Here is a API creation option. You can click here, you can create a new key. Okay, for me, I already created the key. So this is available. Okay, now environment is ready. Now simply let's try to create the agent. What I'm going to do, I'm going to open this, sorry, not agent, I'm going to create a tool. So I'm going to open this tools. Okay, tool folder, tools.py. Okay, I'm going to open it. So the very first tools, guys, I have to create, I think you remember, which is this web search tool, which is this web search tool. If I show you my diagram, web search tool, which is Tably API. Okay, and we'll try to connect with our fast agent. So let's try to create this Tably search tool. So for this, let's import some library first of all. I'm going to select my environment. So I'm going to import, let's say, LangChain dot tools import tool. Okay, then I'm going to import request. I'm going to import this .env. So from .env, import load env. Then I need operating system. Okay, it should be import. And one more thing, I need to import the tably. So from tably import tably client. Yeah, you can also import tably from LangChain because LangChain inside tools, this tably tools is available. You can import. Either you can import from tably framework itself and you can create it as your custom tool. So in my previous example, tably I initialized from LangChain. uh, I didn't create it as a custom tool, but in this implementation I'm going to show you how you can create tably as your custom tool. Okay, this is also possible. Both you see, and whatever you like you can prefer that, because in my requirement I already installed this tably Python. Okay, that's why we'll be able to do that. So simply, first of all, load your environment variable, and after that let's create a tably object. So tably is equal to, so tably client. Here you have to pass the API key of the tably. So I'm going to get from my environment variable, so s.getEnv tably API key, and inside this .env I've already mentioned my tably API key. Okay, it will try to load from here. So once I got it, now I'll create a function here. So this function will try to perform the web search operation with the help of tably. So maybe I can name this function as web search. Okay, web search. Web search. So this will take a query, or I have already created. Let me show you. Yeah. So this is the function, guys, as you can see. So web search, this is the function. This takes the query, and what it does, it use tably, and it searches that particular query over the internet, and max result is equal to 5. That means it will give you 5 sources. Okay, 5 relevant sources URL from the internet. And what we are doing, let me show you what we are doing here. Let's say once we are getting all of the 5 responses, so let me just print them one by one. Print result, all of the results. Now let's call this function, or we can also test inside our endpoint, which is main.py. Let's import from src dot tools dot tool import web search, then web search. Let's say what is the capital of French. Okay, I have given this one, or let's say latest news on AI research. Now if I execute Python main.py, now see it is giving you 5 response. Okay, 5 response, but this print statement is not clear enough. So if you want to make it clear enough, so what you can do, guys, you can install one tool which is Rich. Let me add inside my environment Rich. Okay, so Rich helps us to actually see the good print statement, and you can also use it for the logging debugging. So let me install the Rich as well. Clear. I'll install my requirements. Once it is done, now let's try to import the Rich. In the tools, I'm going to import from Rich. Okay, import print. Now instead of this print, I'm going to use my Rich print. Okay, now if I execute, this will give you beautiful output. Now see, this is clean, right? This is understandable. Yeah, so you can see we are getting this response from tably API. So tably API, what is doing, it is going to internet and it is searching over different website. Okay, so this is the first website, reddit.com. So if I open it up, So here it has already discussed about this uh, latest AI research news. Then again, you can see there is another website called artificialintelligencenews.com. Okay, so this is another news. So that's how you have see. That's how you can see 1, 2, 3, 4, 5. Okay, total 5's response we are getting here. Okay, 5 URL we are getting here from different website. Okay, now what I can do, see, I don't need all of the informations because here I only need this result. Okay, in the result I have the URL, I have the title of that particular, let's say, information, and I have a content. So in that content actually some like 1 to 2 lines headlines are there about the content. Okay, so if I'm able to get these are the 3 things, I think this is more than enough for my agent. Because if I show you my agent, here, so let's say first agent, what it will do, it will use Tably API for real-time data fetching operation from different website, and we have to take there, these are the information, URL, title, and content. So this URL, title, and content will try to save in the state result, and my second result will try to take that, and from the URL itself, okay, from this URL itself, it will try to extract the content, because this is a web. Okay, this is HTML web. So now what it can do, it can actually extract the content. And how it extract, I think you know, if I perform the inspect operation. So there is an option, let's say if I want to extract any text, easily I can do that. Let's say I can show you, let's say I want to extract this particular part. If I click here, so this is the content of that. Okay, I can easily extract the content, and this operation we perform with the help of Beautiful Soup. Okay, so I'll try to do that as well. So here, let me show you. I'll open it up. Now instead of taking all of the content, so what I will do, I'll just try to take, these are the information. Okay, these are the information, like I need title, I need URL, and I need content. Okay, content I need, and content I'm only taking 300 word, just to make my let's say agent understand. Okay, so this is the content related that, and it is available inside this URL, you have to extract that. Okay, now if I see, after doing it, I'm just running a for loop, because this result will have a result keyword. Okay, we are going inside that because this is a JSON response. We are taking this key, and inside that we have title, URL, title, and content. So inside that we are extracting title, URL, and content, and we are appending to this particular empty list one by one. That means the five output should be there. Five links response should be there inside that. Okay, because I'm getting 5 response. Now let me show you. So if I print this, if I, first of all, I'll return it. I'll return it. So basically I'm performing the joining operation. So what the joiner will do, it will try to join as a string. Okay, so every time it will give a new line and it will join all of the content. Now let me show you how this thing will look like. So maybe now I'll try to receive it here. Let's say output, and print the output. Now if I execute my file, see, I'm getting 5 output, the title, and this is the URL of that content, and this is a like a short paragraph of that particular news. So if I go to the reddit.com, you'll see that an AWS user started. Okay, so this thing is available. Yeah, sorry, from here, Anthropic drops a new research paper today. Okay, so Anthropic drops a new research paper today. So that's how it is taking 300 word from the entire content. Okay, entire content. Now this is the second one, this is the third one, this is the fourth one, this is the fifth one. That means we are getting 5th response from our Tably tool. Okay, which is amazing. Now what I will do, guys, my first tool is ready. That means this particular tools is ready. Okay, now I have to work on this tool, which is Beautiful Soup Scrapper tool. Now let's try to also work on that. So for this, I again need to import some other library, like I need to import uh, beautiful soup. So from BS4, I import beautiful soup. Then I have to import from readability, import documents. Then I have to import Trafila. Okay, Trafila Tura. Okay, this is this thing I need with beautiful soup. Um, that's why this is a dependency package, and I also need regular expression. Import RE. So if you have ever performed web scraping, I think you know these are the libraries useful. So what I've done, guys, I have already generated a function with ChatGPT. Let me show you the function. Yeah, so this is the function I have generated from ChatGPT. So basically, if it takes a URL, okay, it takes a URL, and what it does, it scrap actually all of the content from the URL. Okay, it performs the scrapping. So here you can see we are using request package. We are hitting the URL. After that, we are getting the JSON HTML response, and we are extracting the content. Okay, so everything is performing with the help of beautiful soup. And once we got the content, we are returning the cleanup, and if exception is occurring, we're raising the exception. Okay, that's why exception handle is also important. If you're using any third-party services, definitely you can use try except block. Okay, this is required. So yes, guys, this is the scrapper function we have created. You can also test it whether it's working or not. So maybe let's say here, what I will do, I'll try to import it as well from tools, scrap URL. So this returns, right? This is returns. This returns, okay? Return. So what I can do, I can show you, let's say result web search. So this takes a URL. Okay, so maybe I can provide a URL. Let's say I'll copy this URL. Copy this URL and I'll give inside that. Okay, then I will print the result. Now see what happens here. Python main.py. Still we are getting this title URL. Why? Oh, okay, we are using web search. I have to use scrapper URL. Okay, scrap URL, this function. Sorry, my mistake. Now let's again execute. Okay, now see, from that HTML, I'm getting the content. Okay, I'm getting the important content. Okay, so this function is doing that. So this function is going to that particular URL. Okay, this function is going to that particular URL and extracting all of the content. Okay, you can see extracting all of the content, relevant content. Okay, and it is giving me here. Now this content I'll try to pass to my next agent here. Next agent. So let's say my second agent will try to extract these informations and it will save in the state memory. Now I can use my writer agents to use this particular content and prepare a draft for me. Okay, and my critic agent will try to review that. This is the work I think you are getting. So this is called actually team. Okay, this is called actually team, and we are using list of agents to performing actually task. Okay, multiple tasks we are performing with the help of multiple agents one by one. Okay, so this is the beauty of multi agents instead of using the single agent. Now one more thing I want to show you. See, as of now I have created these are the tool as a function. Okay, and now if I want to use it as a tool, so what I have to do, I think you remember we have to give a decorator. Yesterday also we did the same thing. So we have already imported this tool from LangChain. So now I can give a decorator. So here just simply give the tool decorator. Whenever you're giving the tool decorator, now you can invoke. Okay, you can invoke this tool. Let me show you. Tool decorator. Now let's say right now what I'm doing here right now, I just need to call this function and give the input like that. But now we have converted as a tool. Now I can perform the invoke operation. So how to perform the invoke operation? Let me show you. So let's say this is my tool, web search tool. Simply I'll do the invoke operation. Okay, invoke operation. Now here is the question. Let's say I'll give what is the latest research on using AI for climate change migration. Now whatever response I will get, I'll try to save inside a variable. Let's say result, and I'm going to print it. Now let me show you. This will work as a tool. See, now this is working as a tool. Okay, you can perform the invoke operation. All right, so similar wise, you can also perform the invoke on the scrap URL. Okay, both it will work with the help of invoke. So now guys, our tool is ready. We have created all the tool like Tably tool as well as the beautiful soap scrapper tool, and it is already working. Now the next part we can work on the agents implementation. Okay, now I'm going to show you how we can implement the agents. But before that, let me commit the changes. So I can also commit from my VS Code. So here I can tell tools created for agent. Oh, let's say tools created. Okay, I'll commit and see the changes. Done. Now if I go back, I'll close these are the tab. Refresh. Now see, tools added already. Okay, fine. Now let's try to work on the next part, which is agent implementation. Okay, we'll try to implement the agent. So guys, to implement the agent, I'm going to open this agent folder. Inside that I have agent.py. Let me open it up. I can close these are the file as of now. So first of all, here what I have to do guys, I have to create my first agent, which is a search agent. Okay, search agent. So basically this will have the connection with Tably API. So let's try to create that. I'm going to import some necessary library. So these are the library I need. These are the library I need. So one more thing I think you can observe. Right now I'm importing LangChain.agent import create agent. Okay, but previously I imported create react agent. Okay, there are some difference between them. See, because previously I showed you I installed actually old version of the LangChain. So in old version LangChain, they implemented create react agent, that means reasoning and action agent. Okay, but in the latest version, in the updated version modern LangChain, they have replaced with create agent. Okay, this particular function. So for this I did a Google search. Let me show you the result. See, I told is create agent and create react agent same in LangChain? It's telling no, they are not same. Though they both serve similar purpose. In recent LangChain updates, create agent has become the standard streamlined function, while create react agent is older implementation. Okay, so what they have done, they have updated their LangChain package, and what they did, they actually also worked on this create react agent. They updated with this react agent. Create agent right now, because create agent is nothing but it's the updated version of create react agent, and this is more stable, more standard. Okay, that's why they're recommending don't use create react agent, instead of use create agent only, because this is more standard and streamlined function. It is not it's not like that you can't use create react agent. You can use create react agent, but I think it's good to go with the updated one always. Okay, now here are some like difference between them. So you can see create react agent, this is the modern A recommended method in core LangChain package, it creates an agent that execute a built-in loops of tools calling using highly flexible modern middleware system. And apart from that, this React agent is an older implementation based on strictly on foundation React reasoning acting, okay, prompting paper. It was previously available one older version of LangChain, but has been deprecated in create agent. Okay, that means the latest one. Okay, so basically, I think remember whenever we use this create react agent function, we have to use another additional function which is agent executor, and that has to perform three things. One is the thoughts, then action, then observation. I think I showed you the detailed discussion in my previous agent implementation. If you have missed out, just try to check it out. So there we used to run three things: thought, action, and observation. And for running this three step, we used to use agent executor with this create react agent. But right now in create agent, you don't need to use that separately. So they have integrated everything. That means that thought, action, and observation, all of the execution process in the loop, they have inbuilt with this create react agent. So they will take care each and everything. You don't need to do. These are the part. Okay. So that's why this is like more standard and optimized version of create react agent. Okay. So that's why we'll be using this create agent right now. Okay, I hope it's clear, guys. So that's why in my code, you can see instead of importing this create react agent, where's the code? Yeah, create react agent, I'm importing create agent only. Okay, and all the code are same, like OpenAI, chat OpenAI. Then we are also importing the prompt template. If I want to give my custom prompt, I can set my prompt with the chat prompt template. Then output parser I need because I'm going to use the LCL LangChain expression language, the modern LangChain let's say syntax. So that's why output parser is required. And to understand this one, definitely you have to go through my LangChain lecture, guys. There I've discussed each and everything, what is LCL, why output parser is required, each and everything I've already explained. Then from tools, we are importing, this is not tools anymore. So this thing I can import like that. So in my main.py, I have already imported, I will copy and I'll replace it here. Okay, so from src tools, we have created web search tool and scrapper tool. Okay, both we have created, and we're importing .env and we're initializing the .env. Now the first thing, we have to set up the model. So LLM is equal to chat OpenAI. So I'm going to use this model. So here I can comment model initialization. Okay, model initialization. So we are using this GPT-4o mini model. You can use any model, GPT-5, whatever you can use. And this is the creativity parameter I have given 0. So this will give you the LLM object. So right now I'm going to create my first agent, which is this agent called search agent. Let's try to create it. Now see, if you're using modern LangChain, that means create agent function. It's like super easy. Only you just need to create a function. I'm going to name it as, let's say, build search agent. And simply you just need to return that. Okay, return what? Return your create agent. Okay, create agent, and this will take actually some parameter. The first parameter takes the model. So model is equal to, I'll pass my LLM. Second parameter, it takes the tools. Okay, the tools you want to connect with this agent. So I want to connect this tool, actually web search tool, because my first agent will try to connect with my web search tool, which is Stably API. Okay, so what I'm going to do, I'm going to call this web search and pass it here. Okay, and there is another thing you can perform, I think, which is system prompt. Okay, system prompt you can pass. You can tell your agent what to do, but system prompt, I think it is already given in default. The same system prompt I think I showed you, right, yesterday. I downloaded from LangChain Hub. So basically it explains about the agent behavior, okay, how to work. So I don't need to give it here because this is my search agent. So basically it will take a prompt, take a topic, and it will perform the live search operation over the internet, and this will return you the URL content, okay, with respect to that. So for this, the manual prompting is not required. I think the default prompt is fine completely, but if you want, you can also change the system prompt. Okay, it's completely up to you. So you can generate a system prompt from ChatGPT and you can pass it here. So this is my first agent. So this is my first agent, okay, which is search agent. Now I'm going to work on my second agent, which is scrapping agent. Okay, that means this one, reader agent. Okay, we can name it as reader agent. Reader agent. So let's create it. So similar wise, I will create this agent as well. I'll copy this code, and here this is my reader agent. Okay, and this will take this scrap URL tool, because this will connect it with my beautiful soup. That's why we're passing this scrap URL tool in this particular agent. And if you want, you can also change the system prompt here, but I think default for prompt is fine with me. I'm not going to change the prompt. Okay, so my first agent and second agent is done. Now I'll be working with my third agent and fourth agent. And see, this third agent and fourth agent I'm not going to create in that way. Instead of that, I can utilize the modern LangChain chain functionality. Okay, this is called LCL chain. So I think this is enough, because in LangChain we can use this LCL chain for these kinds of operation. Okay, this is also possible. Now let me show you how it can be initialized. See, if you haven't watched that my LCL in my LangChain, so try to watch that. Otherwise, it would be little bit confusion for you. But if you watch that session, I think it would be clear. So I have already created. Let me show you. This is my writer chain. That means my writer agent. See. So first of all, here you have to prepare a prompt. Okay, custom prompt. So I'm using the chat prompt template. And what I'm doing, I'm giving a system prompt. You are an expert research writer. Write a clean structure and insightful reports. A human, write a detailed research on report on the topic below. Okay. So first of all, I will give the topic, and this topic will come from the human input, and this will take the research. Okay. And where it will get the research? It will get the research from this reader agent. Okay. Because reader agent will try to, first of all, first agent, what it will do, it will give the URL. Okay, URL of the relevant actually sources, and the second agent will try to extract the content, and it will save in the state memory. And writer agent will try to take this content and write this draft for you. So that's why this research we are taking it from my reader agent. Okay, so this will automatically go to the writer agent. Okay, now here you can see structure report as I need, these are the informations in that report: introduction, key findings, minimum 3 well explained points, conclusion. Okay, and sources. That means whatever URL you refer, just try to also refer the URL in the research topic. You can change these kinds of prompt with respect to your requirement. You can generate a detailed report, you can generate a short report, you can generate more sub point here, you can customize it. Okay, now be detailed and factual and professional. Okay, this is the entire prompt. Now we are creating the chain. So writer chain is equal to writer prompt. First of all, you have to give the prompt, then you have to give the LLM, then you have to give the str output. So what will happen? This prompt will go to this LLM. LLM will try to work on that, because LLM is expecting the topic and research. We are already getting from the topic from the user, and research from my second agent, which is reader agent. Reader agents will return the content, research content, and with the help of this research content, it will refer and write that particular report. Okay, just try to think about, if I give you the recent, let's say I'm searching for, tell me the latest AI tools. So if I give you the let's say source content means, let's say from the internet I have collected some URL, and from URL I have extracted some let's say I've extracted the content of that particular latest information and I've given to you. So this is the content, and now just try to prepare a report on that. So what you will do, you will just try to refer that and prepare the report for me. Okay, the same thing we are doing here. So that's why we don't need to create an individual agent like that. Okay, it can be done with the help of this LCL chain. Okay, very easy. Now same, we'll try to do it for my critic chain as well. That means this one. So this one is done. Now we'll performing for this one. Let's do it. So this is my critic chain. So here also we are doing the same thing. We are creating the prompt template first of all. So you are a sharp and constructive research critic. Be honest and specific. Human, review the research on below and evaluate it strictly. So we are giving the report. Report means this writer agent, whatever it will return you, will try to pass here. Now it will respond like that. First of all, it will give you the score, strength, areas to improve, one line, verdict. Okay. Then we are preparing the chain. So critic chain is equal to critic prompt. That means my critic prompt, LLM, and str output. So this will become your critic chain. That means this part is also ready. Okay. Now we have to combine them all together to make all of the agent work together. Okay. So these kinds of things will be performing in the pipeline. Now we'll try to create the pipeline. We'll try to combine these agents all together. That means first of all, first agent will come, whatever output will be getting, we'll try to save in the state memory. Then second agent will try to receive that. Then we'll try to connect this stability tool with first agent. Then this tool with the second agent. Already this is done. Okay, I have already connected this tool. As you can see, this tool is already connected. Then once it is done, we'll try to connect the writer agent as well as the critic chain. Okay, critic agent or chain, whatever you can say. Now let's try to see how we can create this pipeline. So my agent is ready and my tools is ready. Now I'll be working on the pipeline. So guys, our agent and tools, everything are ready. Now we can work on the pipeline. So in the pipeline, I told you, we'll try to connect all of the agents together. And we'll also try to connect the state memory there. So for this, let's open up this pipeline.py file. It's available inside pipelines. I'll open it up. Now let me show you how it can be done. Okay, so for this, first of all, we have to import this agent. Okay, the agent we have created. That means my search agent, then reader agent, then my writer chain, as well as the critic chain. Okay, so all these things we have to import one by one. This is the critic chain. So let's import in the pipeline. So I'm going to write from src dot agents dot agent. So I'm going to import first of all build reader, build a search agent, then build reader agent, then writer chain, then my critic chain. Okay, critic chain. Now what I'm going to do, guys, I'm going to write a function. Already I prepared this function. Let me show you what it will do. Yeah. So first of all, I'll try to add this. So this is the function, guys. Let me explain. Yeah. So you can see the function name I have kept run research pipeline. So this will take the topic, whatever topic user will pass. So first of all, what I'm doing, guys, I'm taking a state dictionary here. Okay. So why I'm taking a dictionary? Because I told you we'll be creating a state memory. Okay. State memory. This is a temporary memory. Once agent has executed successfully, then this particular memory would be cleared. So that's why I told you later on, if you want, you can also add the permanent memory by adding some memory database. That thing I'm going to definitely discuss in future. But as of now, just try to consider this is our state memory we are taking as a dictionary. So every state, it will try to save some data inside that particular dictionary. So first of all, I'm just doing a print statement just to see a beautiful logs in my terminal. Okay, so we are first of all telling searching agent is working, then we're giving like 50 this equal sign. Okay, now what we're calling, guys, we're calling our build search agent. So we are creating an object of that particular agent, then we are invoking it. Okay, what we are invoking without prompt. So user is giving a prompt, find the recent, reliable and detailed information about this topic, and from where we are getting the topic it will be given by the user. Okay, from the user interface we'll try to pass the topic. So this topic will come here. So this search agent, what it will do, it will use stably search API. It will search over the internet of that particular topic, and this will return you the result. Okay, this will return the search result. What would be the search result? I think you remember, this will return you, these are the search result. That means the title, URL and snippet, that means the content. Okay, so this is the work of the fast agent, you can see. And this particular state, the first agent, whatever it is returning, I'm going to save inside state memory. So this is what we are doing. You can see we are calling this state, and I'm adding a new key, which is search result, and we're storing this particular result in that particular memory. Okay, you can see search result. We are getting the message and we're getting the content of that. Okay, content of that, and we're storing in the state memory. And once this is done, we are also printing that particular memory, what is we have inside that particular state. Okay, so this is for my fast agent. So we have completed till here. Now we will be creating this particular option, my second agent. So this will connect it with my previous state. It will take the data and it will run my second state, and whatever output we'll be getting, we'll try to save in the state memory again. So let's try to work on that. So my second step, my reader agent. So this is my reader agent. Yeah, reader agent. Again, I'm doing some print statement. Now you can see I'm initializing my reader agent. Again, we are doing the invoking operation of the reader agent. Then we are giving the prompt user based on the following search topic. So topic we are getting from here. Okay. Pick the most relevant URL and scrap it for deeper content. That means it will scrap that particular URL, and whatever, let's say, URL we are having, we are also passing from my state. You can see we're calling the state, and I think you remember we created a key called search result. Search result, we are giving that particular content. That means whatever URL my fast agent has extracted, my fast agent got from my tably, we have stored here, and my second agent is reading from that particular state. You can see it is reading from that particular state. That means all of the URL title it will get, then it will perform the scrapping operation, and whatever scrap result will be getting, again we are saving in the state memory. Again, I'm creating another key called scrap content inside this state, and we are saving the content inside that. Very simple. Okay, then we are printing that particular content. So this part is also done. Second agent and second agent response we are saving in the state memory. Now we have to work on the writer and critic chain. Now let's do it. So first of all, I'm going to write my writer. So this is the writer. You can see again I'm doing the print statement for beautiful logs. Now we can see we created a variable here. So this variable having two information. One is the search result. Okay, search result, and one is the detail scrap content. Okay, the search result we are getting from where? We're getting from this search result. Okay, then what we are doing, we are also getting the scrap content. Scrap content means nothing but my previous agent, whatever scrap content we got, we have in the state memory, we are also getting that. Okay, we are getting the scrap content. Now we are writing our chain. You can see chain.invoke, we are giving the topic as well as the research combined. That means both of the example we are giving. Why we are giving the search result? Because I told you, I think you remember here, if I show you my writer agent, okay, so here I told you have to also mention the sources. Okay, sources, list of the URL found in the research. Okay, and if I want to list down all the URL, so definitely I have to pass the URL as a reference. So this is what we are passing here. All the URL we are passing, and whatever content we got from the URL, we are also passing that. So it will prepare a draft for me, and this particular draft report we are again saving in the state memory. Okay, we are saving in the state memory so that my critic chain can refer, and it can review that. You can give the feedback, then we can get the final output. Okay, so you can see we're storing in the state memory and we are printing that. Now the last things, we have to write the critic report. So this is the critic report. Again, we're doing the print statement. After that, we are calling the critic chain invoke, and we're giving this report. The last state was the report. We are passing the report. Okay, so this will basically take the feedback, and again I'm storing in the state memory as a feedback, and we are printing it here. Okay, and we're returning the state. So yeah, this is the pipeline, guys. That means this connection we have done perfectly. Now let's test it whether it's working or not. So what I will do, so in the main.py, I'm going to test it. So simply here, let's try to import first of all this this function. This is the main function, run resource pipeline. So here I'm going to import it. So from src dot pipelines dot pipeline import run resource pipeline. Okay, Now simply here I'm going to take a topic is equal to, let's say, the impact of AI job market in 2026. Let's say this is my topic. Now I'm going to pass inside my run research pipeline. Okay, run research pipeline. So basically what it will do, it will give you the final result. Okay, final result. And although we are printing, so that's why we don't need to store it here. So it will print in the terminal. Now let me show you. I'll clear. I'll run my main.py. Now see, first of all, the research search agent is working. Now we got the search result, okay, with URL. Now my second reader agent is working. It is scraping all of the informations from the URL on that topic. Now see, we got the content. Now my writer agent is drafting the report. Now it will prepare the report by utilizing this content as well as the URL. Now see, my final report is ready, and it has also given you the sources, whatever sources it has referred. Now critic agent is also working, and it has given you the report. It told, okay, you got 6 out of 10, and there is some strain point. Here is the areas of improvement, and here is the one line verdict. Okay, amazing. That means all of my agents are working perfectly, guys. Okay, all of my agents are working perfectly. There is no error, and it is working together. Okay, it is working together, and we're getting a very detailed report on my given topic. Okay, but this thing I have to execute from my terminal, and it's not like readable properly. And if I give it to like non-coder guy, so definitely he won't be able to execute that agent. So what I can do, maybe I can add a user interface here. To add the user interface, you can use any kinds of framework. If you know front-end development, you can use React, Next.js. Okay, you can do it for you. But if you don't know about HTML, CSS, React, Next.js, okay, completely fine. There is a library inside Python called Streamlit. With the help of Streamlit, you can create a user interface. And again, you don't need to write the code from scratch. You can use ChatGPT. Just simply give this pipeline code to the ChatGPT and just try to add a Streamlit UI interface with that. So I have done the same thing. So what I did, guys, with my ChatGPT, I have generated a user interface with the help of my Streamlit. Okay, so ChatGPT is given me a code. Let me show you how this code looks like. So this is the code. This is the code. Okay, so you can see this is a Streamlit development. Okay, I have to import this one only. Instead of importing like that in the app.py, I have to import like that. Yeah, SRC agent, build agent, reader agent, writer agent, and critic chain. Fine. So first of all, you can see it is utilizing Streamlit, and we have already installed Streamlit inside our requirement, as you can see. Then it is setting the page configuration. It is adding some custom CSS for the designing of my UI. Okay, some color, background, and images it has added. Some other like markdown it has added. Okay, some HTML content it has added. See, in Streamlit also you can add HTML and CSS. But again, I told you, if you don't, it's completely fine. Just open up your any kinds of assistant, Gemini or ChatGPT or Cloud, and try to give this pipeline.py and tell like, okay, I just need to add Streamlit UI. It will add you whatever user interface you are getting. Just try to run. Okay, nobody's actually remember HTML, CSS nowadays. Okay, because we have these kinds of flexibility. Now this is a simple actually interface we have created with the help of Streamlit. Again, you don't need to understand this code. This is like AI generated user interface. It's completely fine. But there would be definitely other guy in the company. They will be working on the front end development as per the company requirement. Okay, but as a agentic AI engineer, we don't need to worry about the user interface. But to run our agent, I need a user interface so that I can show to my manager, I can show to my, let's say, customer, so that they can test my agent, okay, in a user interface background, okay, instead of giving the terminal access. So now if I want to execute my app.py, what I have to do, guys, I have to run this app.py. So simply I'm going to write Streamlit run app.py. Now if I execute, this will run my app here. And all of the code I'm going to share, guys, in my description. From there you can execute. See guys, this is the user interface. I think this is amazing, right? My ChatGPT has created this user interface for me, and it has named it as research agent because in the prompt I told this should be the research agent. So that's why it has named like researcher agent. Okay, multi-agent AI system. Four specialized AI agents collaborate, searching, scraping, writing, and creating to deliver a polished research report on a given topic. Amazing, right? Now here you can see, here I have the input option. That means I can pass any kinds of research topic. Even it has also given some suggestion like you can try with these are the example. Okay, this is amazing. Now there is a button. If I click on the button, my agent will be executing. And these are the pipeline I'm having inside my agent. That means the first pipeline, the search agent, second pipeline, reader agent, third is the writer chain, fourth is the critic chain. And right now the starter is waiting. Okay. Now let me try whether it's working or not. So maybe what I can do, maybe I can copy the same example, or you can also write some other thing if you want. Now simply run the research pipeline. Now see, first of all, my first agent is working, search agent is working. It is searching with the help of Tably API. Let's see. Done. Now my research agent is scraping, sorry, reader agent is scraping the top resources from the URL. Now my writer agent is drafting the entire report. Okay, so step by step it is working. Amazing, right? The same things you can also perform in your anti-gravity VS Code or Google Cloud or ChatGPT. You will see that it will also work step by step. You're using the agent mode, right? So the same thing we have developed here. Now see, my critic agent is reviewing the report, and that's how multi-agent system works. Now see, it's done. Now here you can see the status is already done. All the pipeline is completed successfully. There is no error. That means amazing, beautiful user interface it has created. Now just below you can see this is the result. Even you can see the individual actually execution. Let's say my search result, my search agent has searched, right? What it has searched, you will see that it has got the URL, and this is the URL. It has got the content from Medium, the snippet, that means the introduction part. Then this is the title. Okay, title, URL, and introduction part. Then this is the title, URL, introduction part. Okay, that's how it is having 5 information. Okay, 5 information. Now second agent that scrap the content from the URL. Now you can see this is the extracted content from all the 5 URL. This is how it has extracted. Okay, and refined. And this is the final research report we got. Okay, on this AGI development in next 5 year, introduction, key findings. So it has written all of this thing. Then conclusion. Now if you want to make it more detailed, you can change in the prompt itself. I think you remember. So here is the prompt. Here is the prompt in the agent.py. So here you can increase that particular section. Okay, if you increase, it will try to add that. Then sources, whatever sources it has referred, it will also give you the URL. You can see one by one all of the URL it has given you. Okay, amazing. Now you can also download it as a MD file. Okay, my ChatGPT also added another button here. I can also download it as a MD file if I want, and I can open it up. Then this is the critic feedback. So you can see score got 6 out of 10. This is the strength. That means still sorry, this is the strength that means of this particular report. Like the report provides a clear timeline for AGI development, blah blah blah. It addresses both technological and ethical consideration. Still areas to improvement are there. You can improve. These are the section. Maybe in the next prompt itself you can add these are the point here. Okay, these are the point here to improve that particular response. And this is the one verdict line it has written. Okay, amazing. Now let me try with another prompt. So what I will do, so maybe I can ask like all latest AI agent in 2026. This example, run the research pipeline. Again, my agent is working. Now reader agent is scrapping. Now my writer agent is drafting the report. critic is reviewing the report, and my agent has executed. Now this is my search result. This is the scrap content result. Okay, you can see here. And this is the final, okay, final research report on latest AI agent 2026. This is the report. This is the sources you can download. Even this is the critic feedback. Okay, amazing. It's working perfectly. Now if you want, you can also change the title. Then you can also change this. You can also change this. Okay, this content from this Streamlit UI itself. You can go to the code and maybe you can find out that section where it has added. So I think there is a, so the best part is that like you can search. Okay, so I'll copy this, and here I can search. Control F, Control V. So here itself you can change it here. Okay, now you can also change this title. Change this title if you want. Let's say here I think researcher agent. So I can make it as, let's say, research agent. I'll save it. Now if I come here, refresh, now it will become research agent. Okay, that's how you can change the title whatever you want. Okay, everything is possible, but I'll keep my researcher agent only. So you just need to figure out where to change this UI interface, and you can also change the color. Even if you want, you can also design this UI interface with respect to your requirement. It's completely fine. That means my agent is working fine. We have already tested. Now we'll commit the changes. Agents working and tested. Now we'll try to deploy this agent. So simply what I can do, I can go to my GitHub, refresh. Okay, my agent is ready. Now if you want, you can also update the readme file. So nowadays updating readme file is super easy. Just open the agent inside your VS Code and try to mention update the readme file for this project like a open source repo. Mention how to install and technologies used here. If architectures. So now I'll send this prompt. So automatically it will try to understand my entire code base, all the code, all of the agents, tool, everything, and it will prepare the readme file for me. Okay, so you don't need to write manually. After generating, you can customize. Okay, so let me do it quickly so that I can update in my repo. Then I will show you the deployment. Now see, it is evaluating. See, it is also working step by step, right? First of all, it is editing the file, evaluating the file. That's how it is running multiple agents in the backend. Okay, things are working like that. Now see, once it needs any kinds of human permission, it will tell me. I'll give the permission, again it will work. You can also give this kinds of human in loop permission. I will also show you in future this kinds of thing. Now in the readme file, see, it has updated my readme. Now you can see here, you can simply open the preview, and this is the update. Okay, this is the update you can see. Amazing, right? Now what I can do, maybe I can commit the changes. Readme updated. Always try to update the readme, because with the help of readme file, user will be able, some other people will be able to use your repo. And definitely whenever you are adding project in your resume, you have to update the readme in a proper GitHub repository. Now see, this is updated. Now see, this looks cool, right? This looks like a professional project. Okay, professional open source project. You can see it has added all of the features, architectures. Okay, their agent responsible, technology used, prerequisite, installation process. Okay, then get your own API keys, how to get the API keys, uses Streamlit UI, then project folder structure, workflow, example output, contributing, license, acknowledgement, and supports. Amazing, right? Now let's try to deploy this project. So to deploy this project, either you can use paid paid actually cloud services like AWS, GCP, Azure, or you can use any other platform there. You can freely deploy this project. See, there is a platform called Render Cloud. I think previous project also I showed you this render.com. So render.com also you can deploy any kinds of AI application. You can see first aid path to production for the workflow. You can deploy it here. But the best part is that here you will be getting a free instance. Okay, there you can deploy the project. But although this instance is like very low, but still I think for learning it is fine. But if you want to professionally deploy, that time you have to take the subscription. But in AWS, GCP, I don't freely actually deploy. We can't freely deploy there, right? So that's why we're using Render. So first of all, you have to create an account in Render. I already have the account, so I'll click on my dashboard. Okay. So previously I already hosted another application, as you can see. Now let me create a new web service. Okay. Now I'll click on public Git repository and I'll just try to give my repository link here. Then you have to connect it. Okay, once it is done, you can change the name. By default, it has taken my repository name. Everything would be same. No need to change anything. Only you have to give a start command here. So to run a Streamlit app, you have to give this command. Okay, Streamlit run app.py server port server address 000, and it will automatically install my requirement.txt, whatever I'm having here. Okay, once it is done, now I'll take the free plan. So initially it will get 512 MB RAM and 0.1 CPU. This is enough for I think learning, but whenever you want to professionally deploy it, you can take the subscription plan. Now you have to set the environment variable, because environment variable it's not available in my GitHub. So I have my OpenAI and this stable API. Both I'll add it here. So OpenAI, give the value. Okay. Now I'll add my another environment variable, which is tably. Tably. Okay. Once it is done, now simply click on deploy web service. Now it will set up everything in that particular instance. Maybe it will take some time because we are using free instance. We'll wait. Once this installation everything is complete, I will come back. Now see, it is installing requirement.txt. Let's wait it. Once this starter is live, I'll come back. So guys, as you can see, my build is successful and application is live. Now I can copy this URL, open up my browser, paste it and hit enter. Now this will load your application. So initially it may take some time. You have to wait. Once this has loaded, then you will be able to use that. So guys, as you can see, this is our application is live. Now you can share this URL with anyone. They can use it. Now let's try. Maybe I can copy this prompt and I will test it. See, it's working. My search agent is working right now. Now reader agent is working. Now writer agent is drafting the report and critic agent is reviewing the report. Okay, all of the execution is complete. Now here is the final result. You can expand and see. This is the search result. This is the scrap content, and this is our final result we got. Okay. Yeah, so this is the sources you can download also, critic feedback, everything is visible. So yes guys, I think it's working fine perfectly. There is no error. We have successfully deployed as well. Congratulations. Now let me show you if I want to, let's say, delete this instance, so how it can be done. So for this you have to go to the settings, and just below there is an option called delete web service. Now you have to give this command. Now delete the web service. Okay, once you do that, you will see that your web service will be deleted. Okay. So guys, I think you have seen the entire deployment, entire implementation of this AI agent. We have created the complete multi-agent pipeline with the help of LangChain. Uh, Definitely, I think this is going to be actually interesting project to you if you are creating the agent for the first time. So this was the fast orchestration framework we have explored so far. Don't worry, we'll be exploring all of the orchestration framework one by one. Now in the next video, I'm going to tell you, let's say, why we have to use the actual agentic AI orchestration framework like LangGraph, Crew AI, okay, or AutoGen. Why we can't use LangChain, okay, what are the limitation LangChains are having, each and everything I'm going to clarify. So guys, I think we have already implemented some AI agents with the help of LangChain. This was our fast orchestrator framework for building GenAI powered application, but I told you we can also use LangChain for building these kinds of AI agents. So there I have shown you single agents implementation as well as the multi agents implementation. So if you haven't checked that, the link is given in the description. From there you can check it out. So from this video itself guys, I'm going to start our actual agentic AI orchestrator framework. The first framework we'll be starting with which is LangGraph. So I think you have heard of about LangGraph. It's a very famous and mostly used framework in industry, and developer are using this framework, okay, day by day in their life. So before starting actually LangGraph, first of all, I want to give you the idea behind this LangGraph, why LangGraph came in the market. And if you don't know, LangGraph is a product of LangChain. Okay, so LangChain developer team has implemented this LangGraph framework for building agentic AI application. So first of all, let's try to understand why they have created this framework for building these kinds of agentic AI application. Although they are having LangChain, okay, I think we saw we can use LangChain for building some of the agents, okay, some of the basic level agents. But why we have to use the LangChain? Okay, what was the purpose behind to use this particular, let's say, LangGraph? Okay, first of all, we'll try to understand each and everything. Then I'm going to start with our LangGraph concept. Okay, so this video will cover the detailed discussion behind actually LangChain versus LangGraph. I will I will show you why we can't use actually LangChain when it comes to complex actually workflow, complex agentic AI, let's say, application. We can't use LangChain. Instead of that, actually, we have to use LangGraph for that. Okay, so I'm going to show you each and every example so that your understanding would be more clear. So make sure you watch this video till the end. Guys, now let's see what are the things we're gonna cover from this video. I'm going to give you the agenda first of all, then I will start with the discussion. So guys, as you can see, these are the things we'll be discussing in this particular video. First of all, I'm going to discuss about the brief overview of LangChain. So again, the prerequisite for this video is you have to know LangChain. Okay, LangChain understanding is required, and I already told you in my YouTube channel I have created LangChain video. Again, I'm going to add the link in the description. From there you can check it out. So first of all, we'll understand what is LangChain, how LangChain works, what are the application actually we can implement with the help of LangChain. Then we'll be discussing about the LangGraph. We'll understand why LangGraph is required and what is LangGraph exactly. Then we'll try to understand like the difference between LangChain versus LangGraph. What are the benefit we'll be getting from the LangGraph, okay, and what are the disadvantages we'll be getting from LangChain, and when to use what kinds of framework. Definitely we'll try to understand each and everything. So guys, here you can see guys, here is the LangChain definition. So if you see the LangChain definition, here LangChain is an open source library designed to simplify the process of building LLM based applications. It provides modular building blocks that let you create sophisticated LLM based workflows, okay, with S. So I think you have already used LangChain, I mean, inside Generative AI, and there we work with large language model, and mostly we implement some LLM based application like chatbots. Then we create RAG system, text generation system, okay, uh, retriever system. We try to create, these are the things, right? So guys, as you can see, LangChain consists of multiple component. The first component is the model component. So basically this model component gives us a unified actually interface to interact with any kinds of large language model provider. Let's say if you want to connect with OpenAI LLM, so it is having the model component for that. If you want to connect with Anthropic model, so it has the model component for that, okay. If you want to connect with any open source LLM like Llama, okay, Mistral, okay, everything is possible. So all kinds of provider basically it supports, and it will give you some kinds of functionality so that you can connect with, okay. Then it is having something called prompt component. So what is prompt component exactly? So this prompt component helps you to engineer the prompt. So let's say whenever we want to give our custom prompt, okay, custom prompt, then if I want to write actually different prompt template, so everything is possible here, and all kinds of prompting strategy, prompting engineer we can perform inside this prompt component, okay. So LangChain is having a prompt functionality. With the help of that we can play with the prompting, and I think you know, especially in GenAI application, prompting is super important. Without prompt actually we can't create a robust system, because if you're using very poor prompt, definitely whatever output you are getting from the application, it would be definitely poor. But if you're using a good prompt with a detailed instruction, that time you can get best output from the application itself, okay. So LangChain provides all of them. Then there is another important things we're having inside LangChain, which is this retriever component. So this basically helps you to fetch relevant documents from a vector store. So I think you know we use this for the RAG application, RAG application. So whenever we create the RAG application, that time this retriever component is super important. So there we use something called vector databases, and inside vector databases we store all of the documents as a chunk of vectors, and whenever we require them, so we use retriever component for that to fetch the information, relevant informations, okay. So yeah, I think these are some major components, multiple components we're having inside LangChain. But the biggest offering of LangChain is the chain, okay. This particular things, chain. So without chain actually it was very difficult creating these kinds of actually production grade GenAI application, because chain is kinds of actually workflow. It's actually sequential workflow. So what is this chain exactly? Chain is nothing but it's a I mean workflow. Basically here we create this chain in a sequential order. So if you have already used LangChain, I think you know that, let's say you have to create first of all multiple block, okay. Let's say I have created a prompt block. Then what I will do, I will take another block called model. Okay, then I will take another block called, let's say, output parser. Then we'll try to connect this chain together. Okay, this chain together. So basically what will happen, first of all, this prompt will go to the model, and model will generate some kinds of output, and this output will try to see with the help of output parser. So basically it's actually sequential workflow, and we call it as a chain. So every block will give some kinds of output, and this output will become the input for the next block. Okay, then again this block will generate some kinds of output. Again, this will be going as an input to another block. Okay, that's how you can create actually as many chain as you can. Let's say you can create thousands blockchain, you can create hundred of blockchain here. Okay, so everything is possible inside LangChain. So this is the biggest benefit we'll be getting from the LangChain. So here you don't have any kinds of restriction. That means you have to only create a 3 blockchain or 4 blockchain. You can create as much and as any so here you can create as much as block you can. Okay, as much as this chain you can. Okay, you have the flexibility here. So that's why this LangChain got like very popularity, and it was very easy for the developer for creating this kinds of Gen AI powered application. So as you can see, what you can build with LangChain. So I already told you we can implement like conversational workflow like chatbots, text summarization app. Okay, and then apart from that, we can also create translation system. Okay, all kinds of NLP related problem statement we can solve with the help of this LangChain. Okay, we can implement with the help of LangChain. Then multi-step workflow it supports. So let's say whenever I want to create any kinds of multi-step workflows, that time it is also possible. Multi-step workflow means, let's say I can give you one example. Let's say here you given a topic. Okay, you given a topic. Then what you have done, let's say you generated a detail report on that topic. Okay, once this detailed report topic generated, then again you took that and you perform something called summarization summary. Okay, so basically you are running multi-step workflow here. Okay, so if I break down as a let's say chain here, so what you are doing, let's say first of all you are taking a prompt related the topic, so you are passing it to the LLM. Okay, let's say you are telling I have or let's say tell me about actually large language model. Okay, um, you just generate a detailed report on that, on the large language model in 2026. So your this particular component will try to give you the output, that means the detailed report. Then what you are taking, again you are creating another prompt. Okay, you are creating another prompt. Then you are telling now I need the summary of this particular detailed report. Then again you are passing to another LLM. Okay, another LLM, and this LLM is giving you some kinds of output summary. Okay, output summary. So basically you are running here multi-step workflow. So here we are not only using one large language model or one prompting, you can use multiple large language model, multiple prompting, multiple output parser. Okay, so that's why I told you this chain can be created as many as you can. Okay, and this is the best things we got inside LangChain. Then the next thing we have, which is this RAG application, that means RAG application. So inside RAG application, what we can do, we can create an external knowledge base. Okay, knowledge base for the LLM, and we can connect our LLM there. So basically if you are asking any kinds of question, if the question answer is not available in the LLM itself, so what it will do, it will refer kinds of database. Okay, we call it as a vector database, and this is the knowledge base. Actually we try to connect the LLM there. So LLM will fetch the informations from here, and this process actually we perform with the help of this retriever component. Okay, then we give the answer to the user. Okay, so this is another things we can develop. Then the last thing we can do on this basic level agents creation. So we have already seen how we can implement AI agents application with the help of LangChain. So there I showed you we can create a single agents as well as the multi agents. But here the problem is that you can only create like very simple I mean workflow kinds of agents, but whenever it is having complex architecture, complex workflow, that time it would be difficult for you. I will show you okay how what is the difficult, and if I want to implement with the help of LangChain, so what would be the biggest challenge for you, each and everything I'm going to clarify. So basically in the basic level agents, what we can do, maybe we can take a large language model, and here we can take some kinds of tool, okay, tool access. So whenever user is giving any kinds of things, any kinds of input, so this particular LLM will have the connection with the tool, and it can use the tool to um, get the answer. Whether you can use any kinds of search tool or any kinds of tool you can use here with respect to your task, it will fetch the informations from the tool and it will show the user. So basically here what we have some kinds of system there, that system connected with some tools, okay, and that tool will provide some real-time informations to the agents so that it can perform mm, it can perform some automated workflow. Okay, so this is the thing. And in multi-agents we created multiple agents, and we combined them together so that whenever I was assigning any task, it was working together, okay, in a sequential manner. So yeah guys, these are the things we can actually implement from this LangChain actually framework. So guys, now we'll take an example, and we'll try to understand why LangChain cannot be used whenever we are building any kinds of agentic AI application. So what would be the biggest difficulties and challenges if we are using LangChain for building these kinds of agent application? We'll try to understand in detail, okay? And why we have to use LangGraph, we'll also try to understand in detail, okay? So for this, I'm going to take the same example, the example I given you in my introduction session, where I discussed about the agentic AI. I think probably this was the second session you have to watch on my playlist. So there I told you about a recruitment process agent. So basically, let's say um, if I'm having a job position, and if I want to let's say hire someone, so how I can utilize a agent, okay, how I can utilize an agent and how this agent was working, okay. I think I given you a detailed introduction on that. So what I have done, that particular example I have converted in a flowchart. You can see this is a detailed flowchart. So this flowchart actually explains each and everything about that particular application. So basically we call it as a workflow. So this thing we call it as a workflow, okay, workflow. So don't try to relate this workflow with the AI agents, because there are some difference between this workflow and AI agents. So if you want to understand this thing, so what you can do, uh, you can um, you can visit our website, anthropic.com. So they have written a blog about the building effective AI agents. So if you just go below, so there they have discussed about the workflow and agents, okay. So as you can see, workflow are system where LLM and tools are orchestrated through a predefined code path, okay. So as you can see, this workflow I showed you, so this is kinds of predefined path, and every time whenever I will run my let's say this particular block, it has to follow the same things, okay. But if I'm talking about the agents, okay, agents, as you can see, agents on the other hand are the system where LLM dynamically directs their own process and tool uses, okay, maintaining control over how they accomplish a task. So I think you have seen my first example I have given you of the same recruitment process let's say a system. There my agent was like kinds of automated, so I just need to give a prompt. Let's say I want to hire a backend engineer, so all the step actually it was performing automatically, okay. Sometimes it was giving you some kinds of let's say human in loop, that means human confirmation, but everything it was automatically working. So it was deciding what to do. It was automatically selecting the tools, okay, and each and everything. But to make you understand about this LangChain, LangChain actually agents implementation, or let's say if I want to implement the same that requirement application with the help of LangChain, so what would be the difficulties? Okay, for that I created this particular workflow so that I can make you understand, okay, how it can be done. um, so here you can see this is a workflow. So workflow means this is a predefined path. So you can see some kinds of condition looping, okay, it is available, okay, as you can see. But on the other hand, agents are actually dynamically changes everything, dynamically take the decisions, and it actually basically dynamically controls each and everything. Okay, so I think you have understood what is workflow and agents. Okay, so for example guys, we'll try to consider this particular workflow. Now see, let's try to understand this workflow again. So first of all, what we were doing here, so first of all we're starting this workflow, and starting actually we are giving our first prompt, which was, let's say I want to hire a backend engineer. So what will happen that time, this particular request will go to this hiring request. So this is kinds of a Python function. You can consider this is a Python function. So this request will go to the hiring request. So once it will go to the hiring request, so what will happen? It will create a job description of that actually job you are asking for. Let's say you have given backend engineer. So what will happen? For backend engineer, one job description would be created. Okay, one job description will be created. So let's say you are using some kinds of tool here. That tool will help you to write that particular job description. Then what it will do, it will try to send to the next actually block you can see called JD approved. So this is another function. So this function, let's say, has connection with another LLM. Okay, so this LLM, what it will do, it will try to, let's say, verify this job description. It will check whether this is fine or not for this job role. If not fine, so it will send no. Okay, if it is sending no, that means again you have to create the job description. Okay, and if actually this particular job JD let's say block approved, so what will happen, it will go to the next block. Okay, it will go to the next block and it will post the job description. So in this case, let's say you are using some other tools like LinkedIn API, Naukri API, and with the help of this API you are posting the job on that particular platform. Okay, now it will go to the next block. Let's say here it will wait for 7 days. Okay, so this particular block will wait for 7 days. So after waiting for 7 days, it will continuously monitor like how many application you are receiving. Okay, so now again it is going through another condition. So let's say if you got enough application, then it will perform the other step like shortlisting, scheduling, conduct interview and all. But let's say if you're not getting enough application, let's say you are getting only 2 to 3 application, what will happen? It will send you no, and again it has to modify the job description. Then again, let's say it will wait for 48 hours. Okay, then again this loop will be jump to back. Okay, that means the previous block. Again monitoring will start, and again it will check whether you got enough application or not. If you got enough application, now let's say you got 20 application, this is enough. That time shortlisting will be happening. Shortlisting means, let's say it has some kinds of resume parser tool, so it will use that and it will actually match the resume with our actual job description, and it will shortlist actually some of the candidates. Let's say from 20 candidate, it's like 4 to 5 candidate. Then we'll try to schedule the interview. Okay, then we'll take this interview. Okay, manually take this interview. Then again there is another condition block will come. So if let's say we selected the candidate, so what we'll do, we'll try to send the offer letter and all. But if we let's say don't select the candidate, so what will happen? One regret email will be sent to the candidate. Let's say, I'm extremely sorry for that. Actually, we are not not actually hiring you because let's say you haven't performed good in the interview. Okay, this kinds of regret email we can send. Otherwise, we can send the offer letter. Okay. So in offer letter also there are some condition. Let's say if this offer letter is accepted, that means definitely will perform the onboarding and other tasks. But if this offer letter is not accepted, Then again, what you will do, you'll try to perform some renegotiate. Okay, let's say maybe I can increase the package more. Let's say initially I let's say initially I offered 25 LPA, but let's say this person has rejected that. So again, I will renegotiate that. Let's say I will give you 30 LPA. So that time actually this person may prefer this particular package. So he will accept that. Then I'll perform the onboarding process and all. Then we'll, end this particular workflow. Okay, so that's how guys the entire workflow is working, and this was the first example we have taken to understand the AI agents. And right now we have seen as a workflow how things are working. Okay, now let's say you want to implement this system with the help of LangChain. So how you can implement this with the help of LangChain? Okay, because LangChain doesn't have any kinds of conditional let's say workflow or conditional related functionality or looping functionality. Okay, so LangChain doesn't have that. So first of all, let me tell you the challenges you will be facing here if you're using LangChain for this one. Let me show you. Yeah, so the first challenge you will be getting here, which is conditional branch. Okay, so as you can see, this particular workflow is having so many conditional branch. Okay, so this is the first challenges we'll be facing if you're using LangChain, because LangChain doesn't have any kinds of conditional branch, because it works with respect to the chaining concept. Okay, it kinds of sequential chaining concept it will be working. It doesn't have any kinds of conditional branch. Then the second challenge you'll be getting the loops. Okay, loops. So as you can see, sometimes it is performing the looping. So that means this particular things will continuously happening. Okay, if let's say you haven't received enough job application, so this process will again repeat. Okay, so that means you are looping the operation. Okay, unless and until this is not satisfied. So again, this looping concept is not available inside LangChain. Okay, you can't create this looping concept inside LangChain. This is not possible. Now the third challenges you will be getting called jump. Okay, jump. Now what is jump exactly? Now you can see whenever let's say I didn't get any enough application, so this is telling no. That time we are modifying the job description, waiting for 48 hours. Then again we are jumping back to my previous block. Okay, you can see monitor application. Okay, so from here we are jumping again here. So this is called jump, and this kinds of jump we can't do inside LangChain. This is not possible. Okay, so these are some biggest challenges guys we will be facing whenever we will be using LangChain for developing this kinds of agentic AI system. Okay, now let me show you as a code actually how it can be developed. Let's say somehow you want to develop these agents with the help of this LangChain. So now what would be the coding strategy? Okay, what would be the problem in the coding? Let's try to understand. So here I have actually taken some code example, and this is the LangChain implementation as you can see. So maybe I can open up my diagram. Let me open the diagram guys. So this is the diagram. This is that workflow. Okay, now we'll try to understand now with this code. Now, as you can see, first of all, here we are preparing our prompt. We need to hire a software engineer for the backend team. That means we are starting this recruitment process. We are sending the hiring request. So as you can see, before starting with, first of all, I need some let's say I need some important object. Like first of all, I need the LLM object. So we are taking an LLM, as you can see, chat OpenAI. We are taking, let's say, GPT-4. Then we are creating the prompt template. Okay, so create a job description based on the hiring request. Okay, so whatever request we are getting, so let's say this particular request we are getting, we are preparing a job description for that. Okay, this is a job description prompt. Okay, so to create this job description we need a prompt, so we are preparing here. Then we are creating the chain here. As you can see, JD chain is equal to job prompt. That means first of all job prompt will come, it will go to the LLM will prepare a job description. Okay, job description. Then it will be go to the output parser, and output parser will give you the job description. Okay, now what we have to do, guys, we have to write this particular things as a function, JD approved. Okay, this is going to be a simple Python function, as you can see. So we have written def approve underscore JD. So here we'll try to pass the JD, whatever JD we have prepared. Okay, I'll try to pass in this function, and this function will return. See, inside that I haven't written the whole code. I just given you the high level idea. Let's say if this job description is approved based on some parameter, then we'll try to return approved, otherwise we'll reject it. Okay, as you can see, we'll try to approved, otherwise we'll try to send no. Okay, so here you can see once this particular job description is approved, then we have to pass to the post job description. See, as of now we are considering till here. Okay, so this is the entire workflow, but I am not creating for the entire workflow. So let's try to consider this part. Okay, this part we are implementing as of now with the help of LangChain. Okay, I'm only considering this part. So you can see, let me show you. Yeah, so you can see the next function I have written for post job description. That means this particular function. So it will take the job description, and let's say it has some connection with some job portal. You have the API key, like let's say LinkedIn, Naukri, and it will use that and it will post that particular job description. Okay, so we have prepared all of the helper and utility related functionality. Now we have to work on the actual logic building. So you can see, sometimes we have to run the loop, sometimes we have to go through the condition. So these are the things we have to do. But in LangChain, this kinds of functionality is not available. In LangChain, I think I told you, this kinds of conditional, branching, looping, jumping is not available. So for this, what we have to do, we have to write some manual code. So let's say here we have written the manual code. So first of all, we have taken two variable, approved and job description output. Okay, by default I've created it as a false, and this one is none. Okay, now here you can see in step 5 we are running a loop until job description is approved. That means this particular things. Okay, this particular loop will be writing. So for writing this loop, I have taken a while loop. Okay, while loop, and I told while not approved. Okay, that means unless and until this particular approved parameter is true, this loop will be running. Then continuously what we are doing, we're creating the job description. Okay, job description with the help of this particular prompt user is giving, and we're sending to approved job description. That means this particular function. And unless and until we are not getting approved from this function, this particular loop will be continuously running. Okay, you can see if not approved, job not approved, regenerating. Again it will come here, again it will generate another one, again it will send to the this particular function. This loop will be continuously running. Okay, let's say this particular job description is fine, we got approved. Then what we'll do in the final step, if it is approved, then we'll try to post this job description with the help of this post JD function. Okay, so that's how we can implement this system. Okay, we can implement this system, and yeah, we are able to do that. Okay, somehow we are able to do that. But to implement this system, I think one more thing you have observed, which is this extra code. Okay, which is this manual coding. So let's say this manual function we have created. Again, this manual code we have created. Okay, this manual code we have created. So this is called actually glue code. Okay, glue code. So to implement this project, we have to write, okay, so many line of glue code. Now let's say you are creating the entire workflow right now. Let's say you are creating the entire workflow right now. Just try to think about, to complete the entire recruitment process, how much glue code you have to write here. Okay, and it's recommended whenever you are creating any kinds of production grade application, so you have to avoid writing this kinds of glue code. Okay, you have to avoid to write this kinds of glue code, this kinds of manual coding. Okay, so that's why in the market they published different framework for different kinds of tasks. Okay, for agents also we can't use LangChain, because in LangChain we can implement this kinds of system. It's completely fine, but for this we have to write so many manual coding, so many glue code, and this glue code is not good for our application. Okay, and again just try to think about, as a developer, definitely it would be very hectic task for you to write that much of glue code, okay, inside your code base. And just try to think about how much your code base would be. It would be huge code base, right? To manage this code base, like you have to, I mean, you have to, take care everything, and we won't be do that, right? So that's why, guys, we won't be using this LangChain for building these kinds of agentic workflow, because if you see, this agentic workflow is not a linear one, it's a complex workflow, right? It's a complex workflow. When it comes linear workflow, that time it's completely fine. Let's say there is no condition, there is no looping, that time easily we can use the chaining concept and we can implement these things with the help of LangChain, okay? But when it comes this kinds of conditional branch, looping, jump, that time this LangChain is not recommended for that, okay? So for this we have to use some kinds of agentic framework, okay? Agentic framework, it is only for design for building these kinds of complex workflow, complex block, okay? And it has support with these kinds of conditional, branching, looping, jumping, all the functionalities it is having, okay? That's why LangChain team has implemented another amazing framework called LangGraph. Okay, so they have created one amazing framework called LangGraph. So LangGraph is a agentic AI framework. Okay, with the help of that, you can create agents application. Okay, so how much complex, it doesn't matter. You can implement all kinds of agents application. And why this kinds of framework is really good for building agentic application? Because it works with respect to the nodes. Okay, I think you know graph is all about nodes. Okay, you can create as much as nodes you can, then you can connect those nodes all together. Then you can also add the conditional statement, you can add the looping in the nodes. Okay, that means graph data structure is a complex data structure, it's not a linear data structure. If you have already studied about this DSA concept, I think you know that. So graph data structure is a complex data structure, it's a non-linear data structure, so here we can do anything. Okay, so that's why this LangGraph is this is like very powerful and popular framework when it comes for building any kinds of agentic AI application. And that's why LangChain team has developed this kinds of system, and internally they are using LangChain only. Okay, internally they are using LangChain only. They have written some robust code for that, and with the help of that, actually they have built this LangGraph for us, so that we can use this LangGraph for building AI agents application. Okay, I hope you understood. So as I told you, this LangGraph works with the help of nodes, because it has to create a graph, and to create a graph we have to create a nodes. So if I now open the workflow, you can see I can clear. Yeah, so if I open the workflow, as you can see here, each and every block is kinds of nodes. Okay, LangGraph will consider each and every blocks as a node. So let's say this hiding request, it would be a node. So I can write here. So let's say this hiding request, it's a node, hiding request. Okay, now next we have this create job description, JD. So this is going to be another node. This is going to be another node. And then we have um, job approved. Okay, that means this checking function. So I can make it as job approved. Now there is another node called this post job description. Okay, post. I can make it as a post. Okay, so that's how it will create the nodes. Just a minute, guys. Let me fix it. Yeah, nodes. Okay. Now, after creating the nodes, guys, what it will do, it will draw the edges. Okay, edges means the flow. Let's say this hiring request will go to the job description. That means from here to here. Okay, this is called edges. Okay, in LangGraph we call it as a edges. Okay, you can see in the code also. I'll explain this code as well. But I know that you haven't written any kinds of code in LangGraph, but it's completely fine. I'm going to teach you how to write the code, but as a high level, I'm going to make you understand, okay, how things are working. Now, this job description will go to the job approved. Okay, this block, that means this node. So again, we'll create another edge. Okay, now this job approved will go to the next edge, next actually nodes, which is post job description. Post job description. Okay, so we have drawn the edges. Okay, now we'll be working on the conditional and looping. Okay, now we have to work on the conditional and looping. Now, I mean, for better understanding, maybe we can see the code, guys, here. So this is the code implementation of LangGraph. Let's say the same workflow we can implement with help of LangGraph. So you can see the LangGraph implementation. So first of all, we are adding the nodes. Okay, all of the nodes one by one. First of all, we are adding hiring request. This nodes, we are creating these nodes. Okay, and you can see we are giving the name as well as we are giving a hiring request object. Now you can ask, what is this hiring request object? This is nothing but this is a simple Python function, as you can see, hiring request. Okay, so we are creating a simple Python function. We are using LLM or we are using some kinds of API here in that, and we are preparing a function. And once this function is ready, we are giving the object of that particular function inside the nodes. That means this particular function will be created as a node. Okay, node inside LangGraph. Then the next node we are adding is create job description. Job description. Again, create job description is another function. Okay, we are giving the object here. Okay, then we are creating next node, which is check approval. That means this function. Okay, so this is the function check approval. Then next we are doing this post job description. That means this node. This node again, this is the post approval. Where is post job description? Okay, this one, this particular Python function. Okay, so with the help of that, we are preparing all of this node one by one. Now, once node is created, now I have to draw the edges. Okay, now we'll be drawing the edges. So as you can see, we are drawing the edges. So now see the workflow. First of all, hiring request will go to the create job description. So you can see graph.add edge hiring request will be connected with create job description. That means here to here. Okay, so the first one, then the second one. Okay, you want to connect this particular edge. Now next edge would be create job description to check approval. Create job description to check approval. Okay, so here we have to draw the edges. Okay, but in between you can see create job description to job approval. Here we have a condition. Okay, if job is not approved, then it will again create a job description. If it is approved, then it will post the job description. Okay, so now we have to create this conditional statement. And it would be very easy for me to create a conditional statement because we are using this graph structure. Okay, in LangGraph. Now you can see in graph itself, there is a function called add conditional edges. Okay, now what would be the condition? Condition would be depend on this check approval function. That means this check approval we have created. That means this one. Okay, so if this check approval returns no, okay, if it is returns no, okay, not accepted, again it will create the job description. You can see if it is not approved, then it create the job description. It's a loop back, right? But if it is approved, then it will go to the directly post ID. Now you can see in next graph we are again adding another edges post ID. That means from here to here, from here to here. Okay, so that's how, guys, we can easily implement this kinds of system with the help of LangGraph. Okay, I hope you got it. And see, like, very easy it is, right? But in my previous implementation, it was very hard for me, and we have to write so many line of glue code here, but here it is not required. Okay, so I hope, guys, you have understood. So this is the easiest example I can give, regarding this LangChain versus LangGraph. and why people are using LangGraph, why it is recommended to use LangGraph instead of using LangChain for building this kinds of agentic workflow. Now I think everything is clear in your mind. So that's why in this LangGraph implementation, you can either use looping, okay, looping concept, either use branching concept, this conditional statement concept, okay, without writing any kinds of glue code. That's why it is super powerful and recommended. And easily you can implement any kinds of complex application, complex agentic AI application with the help of this LangGraph. Okay, because internally it is using this noding concept, graphing concept. I hope it is clear, guys. So guys, now I'll be discussing about the second challenges you will be getting whenever you are using LangChain for this agentic AI application. So the challenge name is handling state. So let's try to understand what is state exactly. So see, state are kinds of metadata we use whenever we execute the entire workflow. So if I open the workflow, I think you have seen these are some important blocks we are having. So every blocks will generate some kinds of output, and based on this output, actually we are deciding for the next block. Let's say hiring request will go to the job description will generate job description, okay. Then job approved will try to check whether this job description is fine or not. If it is fine, if this job description sends yes, then job post will be happening. Otherwise if it sends no, that means again it will create a job description. So in every step, guys, you can see we are generating some kinds of state data, okay, state data. So if you just go through this block, I think you will understand why this block are important and why the generated datas are important, because based on the data we are making the decision for the next block. So as you can see, if I show you this state, so let's say if this is our goal, hire a backend software engineer. So first of all, what will happen, these are the information will be stored in the state memory. That means the job description text would be available, then job approved or not, this particular status would be true or false, job posted or not, this would be true or false, how many applications you got, number of applications you have, okay, shortlisted candidate's name, is offer letter sent or not, interview question is prepared or not, okay. So these kinds of data you need to run the entire workflow, because these your agents will try to refer the state, okay, state data, and it will decide, okay, what to do next. Let's say you have run till here, let's say you have run till here, you have executed till here, till monitoring. So now right now your agent is having this kinds of state data. Let's say it know actually how many application you have currently, okay, it received currently, and how it will understand, because this information is available inside state, right? So it will, so let's say 5 application came so far. So what it will do again, it will tell this is not enough, just try to modify the job description and again try to monitor everything, okay. Based on that particular data it is deciding, right? So this is super important. So this is called actually state. And LangChain is stateless, okay. LangChain doesn't have any kinds of state related functionality, because you can see this particular state would be stored as a key value pair like a dictionary, okay. But LangChain doesn't give you any kinds of dictionary or key value pair storing concept, okay. That means LangChain is completely stateless here, okay. You can't do it with the help of LangChain. You can do it. For this, maybe what you have to do, you have to, let's say whenever you are starting the code at the very first time, you have to take a dictionary about name, let's say state, okay. You are taking a dictionary, and you have to manually like define these are the key here, manually define these are the key, and after every execution you have to manually update these are the value here, okay. So that means you are again writing the glue code here, and this is very hectic task for you to manage all of this state, right? So if I show you all of this state, because it's not a like a very short state we are handling. If we're creating the entire workflow, just try to think about how many state, that means how many metadata will come, and every time you have to update that inside LangChain, okay. So this would be hectic for you. But inside this LangGraph, okay, if I'm using LangGraph, so inside LangGraph, guys, this concept is available. So LangGraph is like stateful, okay, stateful. If you're using LangGraph, it is stateful, because in LangGraph we create a nodes, right? we created nodes, and nodes will be having this kinds of actually state connection. State connection means, see, state connection means we can create a state object. Okay, we can create a state object inside LangGraph. So state object. So this state object can be created with the help of Pydantic. So I think I already taught you Pydantic in my playlist, this same playlist, you can check that. Either you can create with the help of type dict. There is another concept, you can use it, type dict. Okay, so basically what you will do, you will just try to define this kinds of structure at the very beginning of your application, and in every nodes you will try to provide this state access. Okay, so what the node will do, so after every node execution, automatically these kinds of data would be updated. Okay, these kinds of data would be updated inside the state. Okay, so let me show you, maybe you'll be clear enough. So I think I showed you an example, right? I showed you one example related this, yeah, node concept. Yeah, you can see we are creating the node. Okay, we are creating a node. So whenever you are creating a node, it will have the access to the state object. Okay, so let's say whenever it is doing any kinds of execution, let's say it is generating the job description, that time in the state there would be a section called job description in a key, right? It will try to update the job description. Again, it will run to the next node, job approved. So whether job is approved or not, whether it is true or false, again it will try to update that particular parameter, because we are defining this particular state with the help of this Pydantic or this state dict. Okay, we are doing that, this kinds of structure. So that's why in the code itself, if you see the LangGraph implementation, so every time in the function itself, we are giving this kinds of state. Okay, you can see we are giving this kinds of state. Okay, and output, it will also return you some kinds of state. Okay, because it is updating in that particular state object. Okay, so that's how this LangGraph handles this kinds of scenario, this kinds of stating scenario. Okay, but now you can ask me, in LangChain, we have the memory concept, definitely, right? In LangChain we have the memory, we can use the memory, but memory you can use for what? For the conversational workflow, conversation. Okay, you can store the conversation you are doing with your chatbot or whatever. You can state the you can store the conversation. Okay, conversation story, but it doesn't support any kinds of key value pair storing. This kind of stating concept, it doesn't support. You can store the conversation, you can use conversation buffer memory for that, but this kinds of thing is not possible. Okay, I hope it is clear, guys. Now guys, let's talk about the third challenges we'll be facing, which is event driven execution. Okay, so what is this event driven execution? See, let's try to understand this one. So the workflow we have seen here. So this workflow can be executed in two ways. One is, let's say this is the workflow. Okay, so this can be executed through sequential manner. Okay, and event driven. Okay, so let's try to understand the sequential. So let's say sequential means, let's say you are implementing through the LangChain, and I think you know LangChain works in a chain order, that means in a sequential order. So what I can do, maybe just a minute. Or let's clear. So see, in LangChain, you have created in a sequential order. So let's say first of all you have given a prompt, then you are passing this prompt to LLM. LLM is giving a kinds of output. Again you are preparing another prompt. Again this output and prompt you are giving to another LLM. Okay, LLM. Then you are getting some kinds of response here. Right? So this is called actually sequential, left to right. You can see left to right it is happening. So this is a sequential order. Sequential order it is following. Okay, so sequential order means this will start and this will complete the execution, then it will be completed. Okay, in between it is not pausing anywhere. Okay, in between it is not pausing anywhere. But if you see the workflow, inside workflow sometimes we have to pause the execution. Okay, so let's say if I give you an example, let's say if I come here, you can see, so whenever this workflow is running, right, it is running the workflow, it's completely fine. But here you can see it is waiting for some manual trigger, right? Let's say it will wait for 7 days. After waiting for 7 days, then what it will do, after posting the job description, it will wait for 7 days, then your monitoring application will be started. Okay, so here it is waiting for some kinds of trigger. Okay, so this triggering concept is not available inside that sequential execution. Okay, it is not available inside LangChain. LangChain doesn't have any kinds of this pausing option, triggering option. Okay, you can't do that. Okay, but you can implement inside LangChain. So for this, what you have to do, let's say maybe you will be creating this part separately, then you will wait for 7 days. Okay, let's say in some in Python code, you will be writing a function that function will try to wait for 7 days. Then again, you will run this particular let's say workflow. Okay, so that means you have to do it manually. Again, you have to write the glue code for that. But inside LangGraph, okay, inside LangGraph, this kinds of concept is available. This event-driven concept is available. So LangChain, what it will do, so automatically, because it has this state connection, right? It has this state connection, and the state itself, this metadata would be available. You have to wait for 3 days. So in LangGraph, automatically this particular event-driven option should be available. So it will wait for the trigger. So once this trigger is complete, then it will run the remaining workflow for you. Okay, so this is another challenges you will be getting if you're using LangChain for building this kinds of agentic workflow. Okay, I hope you clear, guys. So guys, next challenges you will be getting called fault tolerance. So what is this fault tolerance? Fault tolerance means, let's say whenever we are running these kinds of big workflow, so definitely there would be some kinds of fault in your application. Okay, fault in your application. Fault means, let's say sometimes what happens, let's say you are executing the workflow. Let's say here you are executing the workflow. This particular workflow is getting executed. This particular block is executed. That time, let's say you are posting the job description to the LinkedIn. Let's say that time LinkedIn API is not working. So definitely your application will stop that time. Okay, so this is called fault. There is another fault. Let's say you have deployed this workflow in a server, let's say AWS, and AWS got down. So this is another fault. So that means this fault can be two types. One is small type, and one is big type. Okay, in small type, what is happening? You are getting the fault in between. Let's say in between the block, let's say you are not able to post the job in the LinkedIn because LinkedIn API is down. Okay, our big fault means, let's say you have hosted this workflow in AWS and AWS got down. That time your application will crash. So what happens inside this LangChain doesn't have any kinds of fault tolerance functionality integrated with it. That means if you're creating a chain, let's say you have created this kinds of chain. Okay, this kinds of chain. Okay, so how chain executed? It executed in a sequential order. Let's say here you break the chain. Okay, so let's say for a region, let's say this is the post job description. Let's say API is not working. So that time it will break here and all of the application will be break. Okay, break. Then whenever you will be re-executing, again it will re-execute from the beginning. Okay, from here it will execute. Okay, but already you have done so many stuff before posting the job description. Let's say your JD is prepared, everything is ready. But if you're running from beginning, again it will do everything, then again it will post the job description over the LinkedIn. That means it is not able to resume from here. Okay, it is not able to resume from here. It is executing the entire workflow again. Okay, inside LangChain, this is the problem. Okay, and let's say if your server is getting down, AWS is getting down also, again you have to execute from the beginning. But inside LangGraph, this fault tolerance functionality is available. So basically what happens, let's say whenever you are creating this kinds of workflow, let's say this is your workflow. Okay, this is your workflow. So let's say you are coming here and you got you got some kinds of error. Let's say your LinkedIn API is not working. That time it will give you one option called retry. Okay, retry. So if you do the retry operation, that means from after some times, from here only your execution will start. That means it will go to this node and this node. Okay, it doesn't has to come here from beginning and run the entire workflow. Okay, and let's say you have hosted over the AWS got shut down, and let's say you run till here. There is some other workflow also available. Let's say you run till here. Okay, so whenever you again, let's say your AWS server fixed, okay, and it is running again, so again it will continue from here. Again it will continue from here. Again it doesn't need to run from the beginning. So this kinds of fault tolerance option is available, and again this fault tolerance how it is handling with the help of the state concept, because we are having the state informations. Okay, all of the state information. So every time LangGraph will take the snapshot of the state and it will store in a memory. Okay, you can also use a physical memory here if you want. Some memory database you can use, and this state you can save inside a memory. So every time it will take a snapshot of the state. Let's say what is the current execution. Let's say post job description. Let's say here your let's say you got the fault. Okay, so this kinds of state already saved. Let's say before this post job description everything is ready, but during post job description this is failed. So what it will do, again retry from here. It will not run from the beginning. Okay, I hope you got it. So that's why fault tolerance is another challenges inside LangChain. So guys, the next challenges and the very important challenges you will be facing if you're using LangChain, called human in the loop or HITL. I think you know what is human in loop and why it is required, because I have given you the same example, and let's try to understand from this workflow itself. So human in the loop, actually it depends upon the human input. So basically you are not giving the full access to the agent. Instead of that, some of the restriction you are setting, let's say whenever it will create the job description, before posting the job description, it will ask for the approve to the human. Let's say it is asking for the approve to you. If you approve that, then it will post this job description. Okay, or let's say here, before sending this conducting the interview, it will ask you whether you are free or not. Can I schedule the interview? So if you give the access, then it will schedule the interview for you. Okay, so this is called human in the loop. And this human in the loop functionality is not available default inside LangChain. You can't take the human human input in between the chain. So let's say if you create a chain here, let's say this is your chain, right? And in between, let's say you have to take an input from the human. Okay, you have to take the input from the human. That time you can't actually use any kinds of default functionality for that. So maybe what you can do in between, maybe you can take an input function and you can take the input from the human, but again this will stop the chain here. Okay, unless and until you are not giving the input, this chain won't be executed, or it will take unnecessary computation. And whenever it is long term, right, long term means this kinds of agentic system is a long term, so user can give the input after 2 days as well, right? So that time I don't want to necessarily compute, I don't want to necessarily use my computation, right? So this is another problem. So maybe you can create this chain separately, in between you can ask the input, and whenever user will give the input, then you can re-continue this chain from here. Okay, but again you have to take all of this state data manually, and you have to copy here again. So again you have to write some glue code there for that, right? But inside this LangGraph, this human is loop already implemented. Okay, this is already the first class citizen. Okay, first class citizen inside this LangGraph. It is already available. Okay, already available. Even if you go to the documentation of LangGraph, there is a separate section for that. Let me show you. So this is the LangGraph documentation. So you can see human in the loop is available. So the human in the loop HITL middleware lets you and human oversight to agents tool call when model responds an action that might require a review. For example, writing to a file or execution SQL, middleware can pause execution and wait decision. Okay, so you can see this particular option is available and they have already integrated in their functionality. Okay, human in the loop. Okay, this is already available. We'll definitely learn this in detail whenever we'll learn the LangChain component. LangGraph component. I will try to learn each and everything. Okay, I hope this part is clear. That means this is another challenges you will be getting if you're using LangChain. Okay, and this is super important, guys. If you're creating this kinds of workflow, so this human in loop is required there. Okay, I hope you clear. Now let's talk about the next one, which is nested workflow. Nested workflow means, see, inside LangGraph you can run the nested workflow. So whenever I'm talking about LangGraph, I think you know we can create actually complex nodes here, right? It works as a node. Okay, you can create these kinds of node. Okay, now let's say a nested workflow means the nodes you are creating, inside these nodes you can create another graph. Let's say this node represents this kinds of graph. Okay, that means this node itself, it's a graph object. This is called nested workflow. Okay, I think you get it. We call it as a sub node. So there is a concept inside the documentation. Let me show you. This is the documentation. You can see, if you see, there is a concept called sub node. So let's say this is your node. This node itself should be another graph, and you can use this particular graph. Okay, so this is called actually sub node concept, and we call it as a nested workflow. And this nested workflow is very much required whenever you are creating this kinds of system. So let's say if I'm talking about use case, so let's say if I'm talking about this conduct interview. Okay, so inside conduct interview, this thing is not like very easy to implement, because just try to think about, if I want to conduct the interview, first of all I have to prepare set of questions for each and every candidate. Then I have to also take the interview, let's say round 1, round 2, round 3. Okay, I have to track those informations. So instead of creating a single nodes here, maybe I can create it as a sub node. So this will be connected with another nodes, and that this will connected with another workflow, another graph, and this graph will try to let's say prepare the interview questions for the candidate, or taken care by the round 1, round 2, round 3. Okay, and so on. So these kinds of complex nodes, whenever it is coming, you can simply handle with the help of this nested workflow. And this is very much important whenever you are building any kinds of multi-agent system. Okay, in multi-agent system, this nested workflow is required that time. But this nested workflow functionality is not available inside LangChain. Inside LangChain, actually, we can't create these kinds of sub nodes and all. This is not possible. Okay, so that's why you can call it this is as a feature inside LangGraph as well. Now guys, the last challenges will be understanding, which is observability. So basically what is observability? Actually, let's try to understand. Observability refers to how easily you can monitor, debugs, and understand what your workflow is doing at the runtime. So whenever we are running these kinds of runtime, so definitely we have to continuously do the observation. Otherwise what will happen, sometimes it will do some let's say unexpected task, right? Let's say you have run your agents for the LinkedIn ads. Okay, so let's say it is running the LinkedIn ads continuously, and you will end up with lots of cost that time, right? Let's say it's not necessary to run that much of LinkedIn ads, or that much of budget, right? So that time if you're not doing observation, so definitely you will end up with lots of cost. So that's why observability is required. But it's not like that we'll sit there manually observe all of the execution. It's not like that. So definitely we have to use some automated things that will continuously do the observation, continuously do the monitoring, and it will give me the report. Okay, so fortunately in LangChain, if I'm talking about LangChain has observability tool, which is LangSmith. Okay, I think you heard about LangSmith. So LangSmith is a like observation tool. With the help of LangSmith, we can continuously track the LangChain actually pipeline, LangChain chain. So whatever LangChain chain will be executed, all of the actually, let's say, parameter we can actually monitor here in the LangSmith. LangSmith will automatically monitor. So by default, LangSmith can support this LangChain monitoring. Okay. And don't worry, we'll try to understanding LangSmith as well continuously. Going forward. But what is the problem with the LangChain if you're using LangSmith with that? See, if you're implementing this workflow with the help of LangChain, so definitely you have to write lots of glue code. I already told you, right? You have to write lots of glue code. But glue code cannot be monitored with the help of LangSmith. LangSmith only can monitor your LangChain chain, okay, chain code or whatever you are writing inside that. But if you're writing extra glue code, you can't actually track with the LangSmith. This is not possible. But if I'm talking about LangGraph, okay, LangGraph is having very strong connection. Okay, it is having very strong connection with LangSmith. Okay, so that means whatever node execution you are doing one by one, all of the node would be tracked in the LangSmith. Okay, LangSmith, and you can see each and everything. Okay, so that's why this LangSmith as a observability tool will be learning in this playlist as well. In detail, I'll tell you how to use the LangSmith and all, and how we can perform the monitoring operation of our agent. Each and everything we'll also try to understand here. Okay, this is super important. And yeah, I think this is a good practice to add the observability whenever you are creating the application, because there you will get the enough understanding about your workflow execution, okay, at runtime. This is super important. So yes guys, we are done with all of the challenges. We have understood each and everything in detail. Now we'll try to conclude this video. So before concluding, let me tell you few things. So guys, so far we have understood about the LangGraph and difference between LangChain and LangGraph. And I also showed you the challenges actually we will be facing. Okay, if you are using only LangChain, okay, if you are not using LangGraph, what would be the challenges? Now you have pretty much good understanding about the LangGraph, what exactly the LangGraph is. But again, I have given you a definition. You can see LangGraph is an orchestration framework that enables you to build stateful, multi-step and event-driven workflow using large language model. It's ideal for designing both single agents and multi-agentic AI applications. Think of a LangGraph as a flowchart engine for LLM. You define the steps nodes. Okay, we call it as a nodes. How they are connected edges, and the logic that governs the transitions. LangGraph takes care of state management, conditional branching, looping, pausing, resuming, fault recovery, feature essential for building robust production grade AI system. Okay, so I think you have seen I have introduced so many actually strong terms here, like this edges, branching, looping, pausing, okay, fault recovery. So now I think these are the terms are clear, because I have already clarified these are the terms. Then I've given you the introduction. So at the very beginning, I could have given you the introduction to this LangGraph. Okay, this kinds of definition I can show you. This actually page I can show you, but you won't be able to understand, okay, what the LangGraph is, and you that time actually you are not familiar with these are the concept. So what I have done, actually I have clarified all the concept. Now I have given you the introduction. Okay, I have given you I have told you what is LangGraph exactly. Okay, now I think you are pretty much clear with. Now let's try to understand when to use what kinds of framework. So use LangChain when you are building simple linear workflow like prompt chaining, summarization, or basic retriever system chatbots. Okay, these are the things. And use LangGraph when you use case involves complex non-linear workflow that needs conditional paths, loops, okay, human in the loops concept, and multi-agent coordination, and asynchronous or event-driven execution. Okay, so now I think guys you have the understanding about this concept, like when to use what kinds of framework. So based on the problem statement, you can decide whether you will be using the LangChain, whether you will be using the LangGraph for that. Okay, so now I think you have the enough understanding on that. Now one more very important things will be understanding at the last. So see, people will tell you like don't use LangChain, LangChain is like deprecated and all. Okay, so should we still use LangChain or not? Because this kinds of question will definitely come. And through the entire video, actually, I have given the appreciation to the LangGraph instead of giving to the LangChain. Okay, but things is not like that. See, still we have to use this LangChain. Okay, LangChain is required. Why? Because LangGraph is built on top of LangChain. Okay, internally they're using LangChain only. Okay, then they have created this LangGraph framework. So it is basically handling the complex workflow. Okay, the complex workflow by adding the noding concept, but internally it is using LangChain. Because if you see, still you need LangChain components. Like if you want to load any kinds of LLM, you have to use chat OpenAI or any other open let's say LLM provider functionality. If you want to create a prompt, so you have to use the prompt template. If you want to create a retriever system, you have to use the retriever, documents loader, tools, etc. Okay, these are the things you will be only loading from the LangChain, not from the LangGraph. Okay, I think you get it. And LangGraph handles workflow orchestration, while LangChain provides the building block for each steps in the workflow. That means LangChain is very important. Okay, but we can't use LangChain to build the entire complex workflow orchestration. Okay, we create this orchestration, we create this workflow orchestration with LangGraph, but internally LangGraph uses some LangChain building blocks. Like these are the building blocks to work on that. Okay, I hope this part is clear, guys. Okay, so guys, I think you have now clear and I mean enough amount understanding on this LangGraph, LangChain. You have got the detailed introduction to the LangGraph. And don't worry, I'm going to teach you all of the component of the LangGraph. We'll be also building the agents with that. Okay, each and everything will be covering in this course itself. Okay, now in this video I'm going to discuss some important core component of LangGraph. Because what I feel like before starting the actual LangGraph concept, first of all, let's try to understand the LangGraph core component. So once we have understood the LangGraph core component, it would be easy for us to learn all of these components one by one. Then we can combine all of them together and we can build any kinds of agentic AI application. So guys, as you can see, what is LangGraph? LangGraph is an orchestration framework for building intelligence, stateful and multi-step LLM workflows. It enables advanced features like parallelism, loops, branching, memory, and resumability, making it ideal for agentic and production-grade AI applications. And LangChain models your logic as a graph of nodes. Basically, we call it as a task and edges. Okay, I think you saw there are some edges we are drawing in my previous class, right? So we call it as a edges. We also call it as a routing instead of a linear chain. Okay, so in LangChain we used to create a linear chain, but here we don't create the linear chain. Instead of that, we try to make everything as a graph, and to make this graph we use nodes and edges. Okay, inside LangGraph. So let's say you are having a LLM workflow. So let's say this is our LLM workflow. Okay, this is our LLM workflow and this is called actually edges. Okay, this is called actually edges. So let's say this is our LLM workflow. Okay, I'll tell you more about this LLM workflow. What is LLM workflow is? LLM workflow is nothing but I told you about the workflow, right? Workflow is nothing but it's a process of executing an entire let's say application, entire problem statement. So basically we try to represent as a workflow, and inside that we use LLM, right? So that's why we call it as a LLM workflows. So you can see this is the LLM workflows. So here we pass any kinds of input. Okay, and all of these you can see node. Okay, this is called actually node. This is called actually node. This node can be called as a task. Okay, task. Basically, let's say you are having an entire goal. Okay, entire goal. So to achieve this goal, what you have to do, we have to break down this goal as a task. Okay, different subtasks, and each of these subtasks can be represented as a node. Okay, in LangGraph, so we try to represent as a node. So this node will perform all of the tasks. Let's say let's say the first node is responsible for taking the input. Second node is responsible, let's say, preparing the prompt. Okay, then third node is responsible for calling the LLM. Okay, that's how another node will be responsible for calling a tool. That's how it is defining a separate task as a node. Okay, I hope you get it. Now we also call it as a flow chart. We also call it as a flow chart. If you see this particular graph, this is kinds of flow chart. Okay, now you can see inside LangGraph, we can perform this parallelism, looping, branching, memory, reusability, each and everything. So if I'm talking about the parallelism, so LangGraph can be also executed in a parallel. Okay, let's say here you are having a node, here also you are having a node. So both node can be executed parallelly. Okay, both node can be executed parallelly. Let's say you are preparing a prompt template and here you are calling the LLM. Okay, so it's not like that after preparing the prompt template you will call the LLM. Both you can execute in parallel, right? That's how there are so many problem statement you can, consider here. Okay, now it can also supports this looping concept. Looping concept means, let's say sometimes, let's say you are here in this particular node. Let's say after completing this node, again you have to go back. Okay, again you have to go back, and again you will re-execute, and again you will try to send to the another nodes. I think you remembered our previous actually example I have given you, that interview agentic AI. I think so interview system. Okay, that interview system, what happens? Let's say whenever sorry, not interview, that was actually recruitment agent. So there actually what happened, let's say if let's say your job description is not generated properly, so what it will do, again it will go back and again it will regenerate. So this is called actually looping, right? This is called actually looping. You're performing the looping here. Then you can also perform the branching operation. Branching means the condition. Let's say if this condition is not true, okay, that means if it is not yes, then it will go here. Okay, that's how you are creating branch here. So this is called branching. Let's say if you didn't get 20 applications, again what you will do, again you will try to change the job description and wait for the application submission. So this is called actually branching. So this branching also can be supported. Then memory. Memory means, let's say each and every nodes, whatever it is generating the output, it would be stored inside a memory. Okay, it will remember that particular output and input as well. This is called memory. Okay, then reusability. Reusability means, let's say I told you about the actually problem. Okay, problem means, let's say somehow your one of the application got let's say got trouble. That means it got stopped. Let's say it got stopped here only in this particular node. Okay, in this particular node it has stopped. So whenever you will reinitialize the instance, so instead of running from the beginning, it can resume from here only. It can continue from here only. This is called resumability. Okay, so that's why we call it as a very powerful framework, this particular LangGraph, because the way it is handling all of the, let's say, task, all of the system, this is completely amazing, right? And that's why we can't use the simple LangChain here, the linear chain here, to solve these kinds of complex workflow. That's why LangGraph is required, and this is what actually your LangGraph is. Okay, so basically here we will be working with the nodes and edges, okay, to make a graph, okay, instead of a linear chain. I hope you understood, guys. Okay, now let's try to understand about the LLM workflow in more detail. So you can see what is LLM workflow. First of all, let's try to understand. So LLM workflows are step-by-step process using which we can build a complex LLM applications. Each steps in a workflow performs a distinct task such as prompting, reasoning, tool calling, memory access, or decision making. Workflows can be linear, parallel, branched, or looped, allowing for a complex behavior like retries, multi-agents communication, or tool-augmented reasoning. And we'll be discussing about some common workflows as well. So the first workflow, as you can see, this is the linear sequential workflow. We can also call it as a prompt chaining. So here what happens, let's say whenever we are giving any kinds of input, it will first of all go to LLM, okay, LLM call, because I'm calling it as a LLM workflow, and definitely inside the workflow, definitely LLM call should be there. Okay, LLM should be there. That time we can call it as a LLM workflows. Okay, if it doesn't have any kinds of LLM, that time you can't call it as a LLM workflow. And now inside a workflow, there can be one or multiple LLM call. Okay, one or multiple LLM call. It's not like that you have to only use one LLM call, or let's say 5 LLM call or 100 LLM call. You can use as many as LLM you can inside a workflow, but make sure LLM call should be there. Otherwise, we can't call it as a LLM workflow. Okay, so let's say this is our workflow. So first of all, this input will get this particular LLM. Then here we are, let's say, doing a kinds of verification. Whatever output we are getting, whether it is good or not. Okay, if it is good, then we are passing it to the LLM, another LLM. Okay, for another task. Then it will send again to another LLM for another task. Then it will give you some kinds of output. Okay. Otherwise, if this particular response is not good, then it will exit the application. Okay, so this is called actually linear workflow. You can understand, okay, from this particular. So here you can understand this particular concept from this workflow itself. Okay, I hope you clear. Now let's take an example to understand this prompt chaining workflow. So let's say you are building an agent. That agent will take a topic, okay, topic name as an input. Okay, so this input should be a topic name, and what it does, it generates a complete report on that particular topics. Okay, so I think previously you saw I created these kinds of agents with the help of LangChain. So there I passed a topic and it was preparing a detail actually scientific report on top of that. Okay, so first of all, what you are doing, you are giving this particular topic name to the first LLM call, and that means the first LLM, and this LLM will try to we will try to generate something. Okay, we'll try to generate something. Let's say this particular LLM has generated a draft from this particular topic. Okay, so let's say it has generated a draft. Okay, draft. Now here you are doing a verification. Let's say you are writing a condition. If this particular draft is more than 5,000 word, okay, it is more than 5,000 word, that time you are not going to take, you simply exit the application. Okay, you only take less than 5,000 word. So if it is less than 5,000 word, then again what you will do, again you will pass to the LLM. Let's say this LLM does the review operation. Okay, review operation. That means it will perform the review operation, the draft you have prepared. If review is completely fine, if it pass, okay, then it will go to the next LLM. This LLM will try to write this particular draft in a file. Okay, write this particular draft in a file, then you will get the output. Okay, so this is the example you can consider about the prompt chaining. Okay, so inside prompt chaining, what you are doing, you are trying to break down a task. Okay, and you are trying to solve it, okay, step by step. This is called prompt chaining. Now let's try to understand about the another LLM workflow, which is routing. Okay, so this is another kinds of LLM workflow. This is called routing. Routing means here you are getting an input and you are using a LLM, definitely LLM call, but this LLM call we are considering as a router. Router means it will basically route the task. Okay, route the task to different LLM. Okay, as you can see, let's say this is LLM1, this is LLM2, this is LLM3. Okay, and here we are getting the output. So let's say you are building a customer support application, let's say for the tech company. So there you are getting different let's say customer questions. Let's say you are getting related, let's say you are running an edtech company. You are, let's say, getting the question related about your service. Okay, the service you usually provide. Let's say whatever course you provide. Okay, whatever, let's say, content you are providing. These kinds of service people are asking about. So let's say the first LM, we just let's say defined this service task to the first LLM. That means the prompt we have written here. So this particular LM will try to only handle about our service. Okay, service related query. So let's say this is the service service LLM. Okay, now the next, let's say task which is about our let's say, what I can say, or let's try to consider about a technical query. Technical query. Okay, technical query means, let's say people are having a doubt related Python or machine learning, deep learning, whatever. So this particular LLM will try to handle that. Let's say this is the tech LLM. Okay. Now there is another LLM. This LLM will try to give you the interview related help. Okay, interview preparation related help. Let's say you want to prepare for the interview. So this particular LLM will try to handle the interview related task. Now, whenever any kind of student is giving the input, let's say student asking about the services, okay, the service we usually provide in the DSwithBappy, okay, DSwithBappy, whatever service we provide, he's asking for. Now, what this LLM router, okay, LLM call router will do, it will automatically understand about your questions and it will decide when to send this, why to send your question, whether it has to send to the LLM call, service LLM, whether it has to send to the tech LLM or whether it has to send to the interview LLM. So definitely this is a kinds of service related query. It will send to the service LLM here. Okay, and service LLM will try to give you the response and you will see the output. Now let's say someone is asking about the technical query. Let's say he is getting Python function error. So that time LLM router will understand, okay, now I have to send to the tech LLM. Tech LLM will give you the output and you will be able to see the output. Now there is another, let's say, question you are getting related interview. Your LLM router will send to the interview LLM and you will be getting the output. Okay, so this is called actually routing workflow, routing LLM workflow. This kinds of workflow we can easily create inside the LangGraph. Okay, so definitely we'll try to also discuss about that. Now let's try to understand about the next workflow, which is parallelization. Inside parallelization, actually, what we can do, we can execute the task in parallel. So let's try to understand this particular concept as well. As you can see, let's say here we are getting the input and some multiple LLM call is happening. Okay, let's say LLM2, LLM1, LLM2 and LLM3. Then we are performing the aggregator operation, then we are getting the output. Okay, so if I'm giving you a real-time example, let's say I'm a YouTuber, definitely I just try to upload my content to the YouTube, and by default YouTube also use internally this AI related functionality. Okay, so with the help of AI, actually what it do, it try to, let's say, do the verification check of your content. Let's say the content we're uploading to the YouTube. Okay, let's say I have recorded a video. Okay, I have recorded a video. So first of all, you will upload that video, and it's not like that YouTube will directly take that video and it will allow you to publish. First of all, it will do some verification. Okay, verification means, let's say, it can be multiple layer verification. The first is, let's say, whether it is any inappropriate content or not. Then it will check whether it is sexual content or not. Then it will check whether this content is having any kinds of let's say abusive or not. Okay, so this kinds of, let's say, multiple layer verification it will do. Now here what we can do, for each of the verification, maybe we can use different task, different let's say LLM call for that. Let's say the first one is responsible for checking inappropriate verification. Second one, let's say, it is responsible for sexual verification, and third one is responsible for, let's say, abusive verification. Now it's not like that after checking this inappropriate verification you have to do the sexual verification, or after checking the sexual verification you have to check for abusive verification. It's not like that. All of the checks are independent here. Okay, so instead of running sequentially, you can run in parallel. So parallelly all of the check will done. Okay, once you will get all of the let's say let's say ratings and answer, then we'll try to aggregate them together. Okay, let's say it will give you some kinds of rating. Let's see if it has given you 9.5 out of 10. Okay, that means this video is good. It has also given you, let's say, 9.6 around 10. Okay, it has also given you 9.5 around 10. Then you are combining all of them together, you are making the average, and let's say there is a condition, there is a average threshold. Let's say if this threshold is matching, that time you will try to accept this video, otherwise you will try to reject the video, then you are getting the output here. Okay, so that's how this parallelization will be working, and this kinds of workflow also we can easily create inside our LangGraph as well. Okay, now the next workflow let's try to understand, which is this orchestrator workflow. Okay, so this is this is the same kinds of parallelization actually workflow. As you can see, we are also taking all of the result and we are also doing the aggregator operation and we're getting the output. But the only difference is let's try to discuss about. So in this workflow, as you can see, before this before this particular section, there is another section we have, which is orchestrator. Okay, orchestrator is another, you can say, LLM call. So basically this is the main, okay, lead actually lead nodes. This particular nodes will decide a particular task it is getting. So what to assign, whether it will assign to the LLM1, LLM2 and LLM3, okay, it will basically decide. But if you see the previous one, the parallelization one, so basically here we are setting the task. Let's say here we are assigning the task. Let's say LLM1 will get the task related unappropriate content, LLM will get the task related let's say sexual content, and LLM3 will try to get the task related abusive content. We are defining the task, but here there is no task nature. Okay, so basically your orchestrator will decide what to you set this particular task. Okay, so based on the orchestrator, it will define, let's say it can define to LLM1, LLM2 and LLM3. Okay, it doesn't matter, but it will decide, okay, which one would be appropriate for this particular task. Then once we are getting this, we are again doing the synthesizer, that means aggregating, and we're getting the output. Okay, so your orchestrator can also define this particular task to only LLM1. Okay, or let's say it can define the task to LLM1 and LLM3. It doesn't matter. Okay, based on the task it will decide. It can either give to the let's say multiple LLM, either it can give it to the one LLM. Okay, so this is called actually orchestrator workflow. I hope you get it. Okay, so this is the similar kinds of your parallelization. Now the next workflow, you are having this evaluator optimizer. Okay, so what this evaluator optimizer? So I think by the workflow itself, you can understand the actual example, okay, how this will work. So basically it has one LLM call generator, okay, LLM call generator, this particular section, and it is having another one called LLM call evaluator. Okay, so basically whatever input you are giving, first of all LLM this LLM call is generating this particular output, then you are sending to the LLM call evaluator, and it is checking, okay, it is checking whether it is good or not. Okay, whether it is good or not, and if it is not good, it will reject, and with the reject it will also give some kinds of feedback like what to update next. Okay, so this will get again this particular LLM call generator, the rejection parameter as well as the feedback. Based on the feedback, again it will try to based on the feedback, again it will try to generate. Okay, again it will try to send to the LLM call evaluator. Okay, then if it is good, then it will accept and we'll see the output. Okay, and this particular loop will be continuously happening unless and until this LLM call evaluator will accept your content. Okay, so I think you know that in our recruitment agent, I told you about the job description, right? So let's say one of the LLM will generate the job description here. Let's say this is generating the job description, and another LLM you're using for verifying the job description whether it is perfect or not. If not perfect, it will give you some kinds of rejection and the feedback. Again it will try to generate the job description, again it will send, and if job description is fine, then it will accept it, that particular job description. Okay, I hope you get it, guys. So guys, I have shown you, I think 5 workflows here. 1, 2, 3, 4 and 5. Okay, so 5 different LLM workflows I have explained here, and don't worry, I'm going to cover, these are the workflow in this particular playlist itself. Okay, we'll try to see all of the workflow one by one. Now the very important concept we'll try to understand about the LangGraph components. Okay, we'll try to understand LangGraph core components, which is graph, nodes and edges. Okay, although I've given you the high level overview in my previous video what is graph, nodes and edges, but still we'll try to understand this particular concept in detail. So for this, here what I'm going to do, I'm going to take an example, I'm going to take a problem statement, and this problem statement will try to define as a graph. Okay, define as a workflow, then we'll try to understand these are the concept. So guys, as you can see here, I have taken an example. So let's say here we want to create a system that generate SE topic. Okay, I think you know about SE. So whenever you are let's say going for any big universities. So basically you have to submit a essay there, okay, based on the topic. So let's say what it does, it collects the student essay submissions and it evaluates in parallel on depth of analysis, language quality, and clarity of thoughts. Based on the combined score, it either gives the feedback for the improvement or approves the essay. Okay, so to build this particular system, first of all we have to break down the task. Okay, let's say this is the entire goal. Okay, this is the entire goal of our system. Now to achieve this goal, we have to define a set of tasks. Okay, the let's say first task what it would be. So let's say this particular system will first of all generate a SE, right? First of all we have to generate a SE topic. So system generate a relevant UPSC style SE topic and present it to us to the student. Let's say you are giving UPSC exam that time. Let's say this particular SE topic you have to prepare. Okay, then you have to collect the SE from the student. So student write and submits the SE based on the generated topics. Okay, you will try to collect that. After collecting, your system will evaluate the SE. Okay, parallel evaluation block, because here we will be evaluating based on the analysis, language quality, clarity of thought. So all of the checks we are doing, all of the evaluation checks we are doing based on the language, based on the language quality, then analysis, okay, clarity of thought, we are checking each and everything. Okay, so after getting the evaluation report, we are aggregating the results. Let's say combine the 3 scores and generate the total scores. Let's say we got the 3 scores all together, then we combine them and we got one average score and we match with the threshold. Now here there is another task, you can see conditional routing. So based on the total score, either it will accept that particular SE, otherwise you will give the feedback. Let's say again you have to update this particular SE. Okay, so then you can see we are our next task is the give feedback based on the conditional routing. That means aggregating results, we are giving the feedback. And there is another option we have kept. Let's say if user wants to give the revision version of that particular SE, they will be able to do that. Then at the last we'll try to show the success message to the student. Okay, if their essay is good, then we'll try to congratulate them. Okay, so this is the entire, let's say, problem. Now if I want to represent with the help of LangGraph, so first of all we have to make it as a graph. Okay, I think you know LangGraph make every, let's say, problem statement as a graph, as a workflow. Okay, so basically it will represent as a graph. After representing as a graph, then what it will do, it will try to take all of this task as a node. Okay, all of the task as a node, then it will connect the edges. Let's say after which node another node would be executed. Okay, this particular connection will be doing with the help of edges. So for this I have already prepared graph. Let me show you. Let's say this is our LangGraph graph we have prepared. Okay, so you can see whatever problem statement I have showed you here. So I have just represent as a graph. First of all, it will generate a topic. So this is the first, you can see this is the first task, right? Let me just write here. This is the first task. Okay, because we broken down our entire goal as a task, and generate topic was one of the tasks, and this task we represented as a node. Okay, this is called actually node. Each and every block is a node here. Okay, now this is another task. As you can see, write SE. Write SE means you can also, let's say, take the SE from the student. Okay, user will upload that, student will upload that. Then after uploading, you are doing the evaluation here. Okay, so this evaluation is also another task, another node. So this is also node, this is also node, this is another node, this another node, this another node. So here we are, let's say, evaluating with respect to the clarity of thought, depth of analysis, language. Then we are getting some kinds of score here. Okay, let's say we are getting some kinds of score. Let's say this one is given you 9.5, this one is given you 9.8, this one is given you 8.5. Okay, based on that we are doing the final evaluation. We are aggregating the results. Let's say our threshold is 9.5, and after combining all of these we are getting 9.5 or greater than 9.5. Then that time what I will do, I'll just try to simply give the success message to the students. Okay, let's say I will congratulate them, otherwise I will give the feedback. Let's say this is another node. In this particular node I'll give the feedback. So in the feedback itself, I'll tell what to update. Otherwise, they can also resubmit that particular HITL to me. Okay, so this is the entire representation, and in the representation itself, you can see this is the entire graph. Okay, this is the entire LangGraph graph, and each of the task is a node. Okay, each of the task is a node, and the connection, you can see this particular connection, this is called edge. Okay, this edge is represents after generate topics, write as will execute. After write as this evaluation, let's say nodes will execute. After evaluation, this final evaluator node will execute. Okay, then either it will go to the success nodes, either it will go to the feedback nodes. Okay, this is called edges, this is called connection. Okay, so if you understand this thing, guys, it would be very easy for you to create any kinds of LangGraph graph for you. Okay, and you can represent any kinds of problem statement in the graph. Okay, I hope you clear, guys. So guys, now we'll be discussing about the next LangGraph component, which is state. So I think you know already about this state. I have given you the state overview in my previous video, but let's try to understand. So as you can see in LangGraph state, it is the shared memory that follows through your workflows. It holds all the data being passed between nodes as you graph runs. Okay, as your graph runs. So as you can see, this is how your state looks like. So this is a kinds of a Python object. Okay, Python are kinds of dictionary object. It is having the key and value pair. Either you can create this with the help of Pydantic. Okay, Pydantic library with inside Python. Either you can also create it as a typedict. Okay, typedict. Both you can use to define this particular state memory. So I think you know that to run our LLM workflow, let's say this is our complete LLM workflow, we need this kinds of state. That means some metadata informations, because each of the nodes will generate some kinds of output, and that particular output will taken by another nodes. Okay, let's say this generate topic will generate some kinds of topic. Okay, topic name. So this topic name will go to the next node, which is this write ASY, because on top of that your ASY will be written, right? So that means whatever topic this particular node is generating, this should be stored in the state memory, and the next node, let's say this write ASY, will take that particular topic and it will write that content as well. So after writing this content would be also saved in the state memory. So you can see there is another section called ASY text topic. Okay, then we are evaluating the scores, and all of these scores would be saved in this state memory. You can see depth score, language score, clarity score. So after this score, you will perform the final evaluation. Okay, so total score would be also saved. Then you will be giving the feedback. This feedback would be also saved. Then evaluation round, it will also save. Okay, so that means to execute the entire nodes, to execute the entire workflow, you need this particular state. And this state is a shared, okay, it's a shared memory. As you can see, it's a shared memory. Shared memory means each of the nodes will take this particular state as an input. Okay, each of the node will take this particular state as an input. All of the node, okay, all of the node will take this particular state, and after taking it, once it will generate some output, this output will be instantly updated in that particular state. Okay, that's why this state is mutable as well. Okay, mutable means you can change it anytime, and after every execution, this state would be saved. Okay, because this is completely dynamic, and this is required, guys. Okay, without that, actually you can't create any kinds of Agentic AI application inside LangGraph. Okay, this state is required. So yes, I think you have understood, and whenever we'll try to create these kinds of application, definitely will define this state at the very beginning. Either we can use Pydantic, either we can use typedict for that. Okay, and we'll try to define this state. And for your problem statement, you have to define the state, like what are the variable you will be keeping here, whatever data you feel like, okay, this should be updated to run your entire agents. Okay, this thing we'll try to define at the very beginning. Now let's try to understand the next component of LangGraph, which is reducer. So what is reducer exactly? So reducer in the LangGraph defines how updates from nodes are applied to the shared state. Each key in the state can have its own reducer, which determines whether new data replaces, merges, or adds to the existing value. So if you see, this reducer is very close to your state. Okay, this is very close to the state. That means whenever you are defining the state, that time reducer will come to the picture. Okay, so let me give you one example. See, as of now what we are doing, let's say whatever we are getting the data from each and every nodes, we are directly updating in the state memory. Okay, I think you know that. And the state is a shared actually memory, and it is accessible to all of the nodes here. Let's say these nodes will also take the state, these nodes will also take the states. Okay, all of the nodes will take the state and it will update in real time. That means every time the value you are changing here, it is replacing. Okay, let's say previously you generated a topic, let's say topic A. So again, whenever you will second time execute that, this topic will replace. That means the previous topic will be removed. Okay, that means we are replacing the value. That's how depth score, language score, clarity score, as it takes. Okay, so all of the parameter you are changing every time, and your previous information you are losing. But let's say sometimes, let me give you first of all one example. Let's say you are creating an application. Okay, you are building an application. That application, let's say, takes two number. So let me just give you the workflow. Let's say takes two number A and B. After that, it performs the sum operation. Okay, then whatever sum you get, okay, it perform the multiply operation with 3. Okay, then it shows the result. Let's say this is your application. Now in this application, what would be the state? If you consider state, so state would be first of all the first number. Okay, first number should be state, then second number, then the result. Okay, so this is your state. So what will happen? Let's say you are giving two number, first number is 5, second number is 6, and if you do the sum operation, what would be the result? It would be 11. Okay, 11. But if you see, you are multiplying by 3. Okay, if you multiply by 3, so what will happen? This result will be replaced. That means previously it was 11. Now I'll wrap this 11. Initially, after summing, the result is 11. Now you have to multiply by 3. So if you multiply by 3, that means this 11 will be replaced by 33. Okay, that means this 11 is not there anymore. Okay, this is changed completely. But in some application, let's say, let me give you another example. I will wrap this. Now let's say you are creating a chatbot. In the chatbot, what you are doing the conversation to the AI, your conversation to the application. Let's say this is your app. Okay, this is your app and you are doing the conversation. So in this application, what would be the state? State, it would be the, let's say, message, the message we are sending or message we are getting from the application. So initially, let's say you have given hi, I am Bappy. Okay, let's say this is your message. So this message would be saved here. Let's say hi, I am Bappy. Okay, now let's say second time you have given I like football. Okay, now this message will be replaced. Okay, let's say this will removed and it will replaced by I like football. Okay, football. Now if you ask what is my name, so that time let's say your nodes won't be able to get your name, because this name is already removed, okay, from the state memory. Now you only have I like football. Okay, this is the problem. So in this case, if you are using only state without reducer, that time it will replace that. But if you are using reducer, okay, inside reducer you can define whether you have to, okay, you have to replace the data or merge the data or add the data. So in this case, maybe we can add the data. So that means my previous message would be also there. Let's say I am Bappy. Okay, after giving a comma, maybe I can add the second message. That's how continuously all of the messages would be saved here. Either you can merge, either you can replace. Everything can be defined with the help of this reducer. Okay, so that means the reducer in LangGraph defines how updates from nodes are applied to the shared state. Okay, that means whenever you are creating the state, that time you can define all of the state data you are preparing, right? Whether it should be addable, it should be mergeable, or it should be replaceable. Okay, so in this case, let's say we have defined this particular state. So in the feedback section, you can see we have given add. Add means instead of let's say replacing the feedback, it will continuously add. Let's say this is our example I showed you. So in this example, let's say the feedback we are getting. So this feedback should be definitely saved in the state memory. So next time, whenever it is executing, okay, it will see that particular feedback, the previous feedback, then it will give the new feedback. Otherwise, what will happen? The same feedback continuously it might give, right? So that's why it should be addable. Okay, it should be addable inside the state memory. So this is the work of reducer, and definitely we'll also learn by a project. Okay. In this particular playlist there, I'll try to use this reducer concept as well with the state. So there, this part would be more clear. So I think guys, now you got it. What is the reducer? So reducer only can be used whenever you are using the state concept inside the LangGraph. Okay, now I think it is clear. So guys, now we'll be understanding the last concept of this LangGraph, which is LangGraph execution model. So what is this LangGraph execution model means? That means the way it is executing the graph, because I think you know LangGraph internally defines your problem statement as a graph. It creates the nodes, then it creates the edges. Okay, that's how basically it executes everything. So what is the execution process of this particular graph? Okay, this is called actually execution model. So LangGraph internally follows one amazing execution model strategy, which is let me show you, which is actually Google Praggle. Okay, Praggle. So what is Google Praggle? Google Praggle is a system for large scale graph processing. So basically they have published this particular research long ago. That time actually they showed if you are having a large scale graph, okay, that time how it can be processed. Okay, so internally LangGraph uses the same technique for executing these kinds of graph. Because if you see the LangGraph actually graph, whenever you are creating very big workflow, that time this graph would be also big, and to process this, to execute this, you have to follow that Praggle strategy. Okay, now this is the strategy guys. As you can see here, I have already defined all of the execution process. So first of all, what happens if you see here, first of all it defines the graph. Okay, so whenever you are giving any problem statement, it will define the graph. So whenever it will define the graph, first of all it will define the state schema. That I showed you about the schema, right? State schema. Either you can do it with the help of Pydantic, either with the help of typedict. Okay, you just need to define the state schema. After that, you have to prepare the node and edges. Okay, so this node and this edge connection. Okay, so and what is node actually? This node is nothing but it's a simple Python function. Okay, it's a Python function only. If you can write a Python function, if you can write a Python code, you can just define any kinds of node. Okay, because each of the nodes is responsible for a specific task, and this task you are solving inside this Python function only. Okay, that's it. And what is edges? Which node connects to which? Okay, that means this particular edges will be connecting to another nodes. Okay, like the execution flow, like after this node, which node would be executed. So once you have defined this particular graph, then next step you will do the compilation. So here we'll do the compile operation. Compile means, let's say you have created a graph. Let's say this is your graph. Okay, this is your graph and this is the edge connection. And let's say you created another node, but this node doesn't have any kinds of connection. Okay, so after doing the compilation, you will be able to understand, okay, this node doesn't have any kinds of connection. That means there's some problem with the graph. Okay, otherwise what will happen? Our entire agentic system will be, okay, terminated. So that's why after defining the graph, we have to do the compilation to check the graph structure and prepares for the execution. Okay, then the third thing we'll be doing the invocation operation. So invocation operation, that means whatever first node we have prepared, we'll try to do the invoke operation with our initial state. The state we are preparing will try to pass to this initial actually nodes, and this initial nodes, what it will do, it will take this state and it will execute, and it will generate some kinds of output, and this output would be also updated in the state. Okay, so once it has updated to the state, then this state will go to the another function. Okay, another nodes, and this node would be also initialized, that means activated. Okay, so after giving this initial state, this node would be activated, and once you get some kinds of output from this node, then it will pass to the next one. The next one will be activated. Okay, so this is called actually invocation. Okay, you can see LangGraph sends the initial state as a message to the entity of nodes. Okay, then once it gets this particular let's say output, and whenever it activates, okay, we call it as a super step begins, okay, execution process in rounds. That means it's not like that manually you have to initiate and invoke all of the nodes one by one. So once you invoke the first one, okay, the remaining one will be automatically executed because it is getting the output, and after getting the output this will go to the input to the next node, and next node would be uh, activated. Okay, this is called actually super begins, super step begins. Okay, LangGraph call it as a super step begins. That means all of the nodes would be activated that time. That means you can see message passing and node activation. The messages are passed to the downstream nodes via edges. So that means whatever output you are getting from the first node, it will go via these edges to the second node. Then it will be activating one by one. Okay, so this is called super step begins. Okay, and with the help of that, it perform the message parsing and node activation. And the last step, which is nothing but the halting conditions. So execution stop when all no nodes are activated and no messages are in transit. That means if all of the node has been activated and no messages are let's say in transit, that time this particular condition would be stop and your graph would be also stop. Yeah, so this is called actually the Sprague, a system for large scale graph execution process, and LangGraph follow the same strategy whenever they execute their graph. Okay, so yes guys, I think you have understood all of the concept about the LangGraph, all of the component about the LangGraph. Now it would be easy for you to code in LangGraph whenever we'll try to write the code, whenever we'll create the agents. That time you won't be having any kinds of confusion, you won't be having any kinds of problem related each of the components we have discussed. So guys, so far we have discussed about the theoretical aspect of agentic AI, as well as I have already given you the in-depth understanding about the LangGraph components and all. Now it's time to start the practical exploration. So from this video onward guys, we'll be working on the practical part of the LangGraph. So first of all, we'll be starting with the very basic workflow inside LangGraph, which is sequential workflow. I think I have already told you about that. First actually workflow, the workflow name is sequential workflow. Okay, sequential means this will run um, in a step-by-step let's say manner. Okay, this is called sequential workflow. So it doesn't have any kinds of looping, it doesn't have any kinds of conditional branching. Okay, it doesn't have anything, only it will be working as a sequence manner. So we call it as a sequential workflow. Okay, so for these guys, first of all, we'll be installing the LangGraph, okay, inside our system. So to install the LangGraph guys, you can visit this LangGraph documentation. So there you will be getting all kinds of actually tutorial, how to install, okay, how to create your fast agent. So each and everything they have already given. So see, if you want to install this LangGraph, you can use the pip command, either you can use UV, okay. So let's use pip as of now. Maybe in future I will also show you how to use the UV package manager as well. So you just need to run pip install LangGraph. So this LangGraph would be installed inside your system. So for this, let's open up our local folder, and here I'm going to just open up my Visual Code Studio. And I will also open up my terminal here. Okay, so the first thing guys, here I'm going to create a file called readme.md. Inside that I'm going to mention all of the command you need to execute to install this LangGraph, to create your virtual environment and everything. So if you want to create the virtual environment, you have to execute this command called conda create -n. Okay, then you can give the name of the environment. I will give, let's say, LangGraph test. Okay, Python. You can specify the Python version. Python is equal to 3.11 and -y. Okay, so this is the command. First of all, you have to execute this command to create a virtual environment. Then you'll be installing this LangGraph. Okay, now you have to activate this environment. After that, you will be installing the requirements. Pip install -r requirement.txt. Okay, so these are the command guys you have to follow first of all. So let's create this requirement.txt here. So inside that, let's mention our LangGraph. package. Okay, LangGraph. So apart from LangGraph, you need to install some other library as well. Like you need this LangChain OpenAI. Okay, so we are using this LangChain OpenAI because I'll be using my OpenAI large language model. But if you want, you can also use any other model from any other provider. Let's say you can use OpenRouter, you can use Grok API. Okay, you can use Gemini API. Anything you can use. It's completely up to you. It's a very easy things. You just need to change this model provider at that time. Okay, so with me, I am having my OpenAI API key. That's why I'll be using this one. Okay, and if you want to use OpenAI API, so that time you have to install this LangChain OpenAI, because I told you LangGraph doesn't work actually independently. Internally, it is uses LangChain. Okay, and for all the model, let's say loading, creating the prompt template, we need the LangChain. Okay, still LangChain is required. Then I also need python.env for the environment management. Okay. Now guys, you have to install this requirement.txt file, but before that I told you you have to create the environment. So try to copy the first command and execute from your terminal. So this will create the environment, okay, for you. But for me, this environment is already available. I will activate the environment. So conda activate LangGraph test. Yeah, so you can see this is already available. But if you don't have, just try to create it first of all, then just execute this requirement command. It will install everything. So for me, it is already satisfied because I installed previously. Okay, now once it is done, now what I'm going to do guys, let me just tell you about the sequential workflow. Okay, what is the workflow it will be creating here? See here, I'm going to create a very simple workflow without using any kinds of LLM. uh, I'll also show you how to use LLM, how to create the LLM workflow as well. Don't worry. But this is our first workflow we are creating inside LangGraph, and we don't know how to code inside LangGraph, right? So to understand the workflow, first of all, we'll be creating a very simple workflow without using any kinds of LLM. Then I'm also going to show you how to use the LLM as well. Okay. So guys, now let's see what workflow we'll be creating first of all. So here you can see we'll be creating a sequential workflow, and the workflow is temperature conversion workflow. Okay, so here it doesn't have any kinds of LLM. As you can see, this is a simple workflow we have created without using any kinds of LLM. So basically this workflow, what it will do, it will convert actually Celsius temperature to Fahrenheit. Okay, this is the only work this workflow will do. And if we convert this workflow in a graph, so this will look like that. So as you can see, we have taken the start node, then convert temperature node, and the end node. So start and end would be common for all the workflow you'll be creating with the help of this LangGraph. This is a dummy nodes, you can say, because LangGraph understands, okay, workflow starts from here and it ends actually here. Okay, and basically it takes the input to the like other nodes as well. And this will also have a state, right? State is a shared memory, and this is a mutable let's say object. You can create this state with the help of Pydantic. Either you can use typedict. Okay, anything you can use it. So basically this state I have to share to all of the node so that it can take the data and it can update the data as well in real time. So you can see in this particular workflow, the only function I have to write this conversion function, temperature conversion function. So user will give Celsius temperature and I'll try to convert it to the Fahrenheit. Then this Fahrenheit output would be shows as an output. Okay, so you can see for this we have taken a node convert temperature, and this node would be a simple Python function. In that particular Python function, what I will do, I'll just try to write the code related conversion, temperature conversion, and whatever output we'll try to get, we'll try to update in this particular state. So here in this particular variable, we'll try to update that. Let's say whatever temperature user will give, this is in Celsius, so this will save inside this particular state let's say object. And whatever I'll try to convert, right, in the Fahrenheit, this one I'll try to save it here. Okay, then whenever I'll try to show the output, so from here I'll try to read and I'll show the output here. So this is a simple workflow guys we have to create, and this state is a shared memory, so this will go to the all of the nodes, okay, one by one. And the complete, you can see this diagram, this workflow, this is called actually graph. Okay, I hope you cleared. Now let's try to code inside LangGraph. So what I'm going to do, I'm going to open up my, so let's create a file here. I'm going to create a file. I'm going to name it as one temperature conversion workflow dot ipynb. Okay. So here I have taken the Jupyter notebook file, guys, because here I'm not creating any kinds of end-to-end project. I'm just explaining the concept. That's why I think this notebook format would be great fit for that, because I will also show you the uh, workflow in a diagram. Okay, and this diagram I can't actually show you inside .py file. That's why I have taken this .ipynb file, notebook file. So let's select our environment, LangGraph test. Yeah. So first of all, what you have to do, guys, you have to import some library. So here, let me comment. First of all, you have to import some library. Okay. So you have to import this LangGraph. So from LangGraph dot graph, okay, you have to import state graph. Okay, you have to import a state graph. If you check the documentation as well, so here also they are doing the same thing. From LangGraph, they're importing state graph, then start and end. Okay, this is a dummy nodes, I already told you. This will be common for all the workflow you'll be creating with the help of this LangGraph. Okay, so let's try to import them. So state graph, then I need start, then I need end. So here state graph is the function. With the help of that we create the graph. Okay, entire graph it would be creating. Basically this helps to create the graph as well as to add the state inside our graph. Okay, now let me import them. Yeah, so import is successful. That means we have already installed this LangGraph and we are able to import everything. Okay, then I also need to import this type dict from typing. So from typing, so first of all, I'm going to show you how you can create the state with the help of this type dict actually module from Python. Then later on, I'm also going to show you how we can create this state with the help of Pydantic. Okay, Pydantic is another Python framework. With the help of that, you can also create the state. So let's import typedict, this one. Now let me import all of them. Now the first thing, guys, I have to initialize the state object. Okay, state is important. Without state, actually we can't create the graph. Then after creating the state, we'll be creating the entire graph. First of all, we'll be creating the nodes, all the nodes. Then after that, we'll be creating the edges as well. Okay, so this is called edges. Edges means this is the connection. Let's say after which node would be executed. Okay, this is the connection. So these edges should be also created. Okay, and if we create all of them, this will become a graph. Okay, so now let's try to define the state here. So here maybe I can comment define state. So for this problem, I told you state would be two state. Okay, one is temperature Celsius and temperature Fahrenheit. So let's try to define that. So for this, I'll write a class. Okay, I'll write a class. I'm going to name this class as a temperature state. Okay, and I'm going to inherit this class with this typedict function we have imported. Okay, now basically you are telling this class like this class right now can store any kinds of data as a key value pair. Okay, now the first key should be the temperature, temp Celsius. Okay, and you can mention the data type as well. What should be the data type for this particular variable? So basically Celsius should be in a float data type. I think you know that it can't be integer, it should be float. That's why I told it is a float. Okay, float data type. Then you have to write another variable called temperature Fahrenheit. So this should be also a float type data. Okay, so this will become our state. Okay, this will become our state, and this state will be using inside our nodes. Okay, all of the nodes will be creating. Yeah, now this state is also ready. Now let's work on this graph. So here what I'm going to do, here let's say I'm going to comment define. Okay, define and compile graph. I think you know, after defining the graph, you have to compile. I told you the graph execution process, right? In my previous video as well. So to define the graph, I told you, first of all, you have to use this state graph function. You have to create an object of that. So let's create an object called graph. Then I'm going to initialize state graph, and inside that you have to pass the state. The state you have created, this is the state, temperature state. Okay, so basically this will take the state. Now see what is happening. If you're using the state graph object, right, state graph functionality, and if you're passing the state inside that, so basically this particular function will try to provide the state to all of the nodes, okay, automatically one by one. You don't need to manually provide that. Okay, so this is the main benefit here. So that's why we're using this state graph. State graph basically takes this state object and it provides to all of the nodes, okay, one by one. Now we have defined our graph here. So this is called definition of the graph. Define your graph. Define your graph. Now next I have to add the nodes. Nodes to your graph, to the graph. So to add the nodes, guys, you just need to write graph dot add nodes. Okay, add nodes. Then you have to provide the nodes name. Okay, nodes name. At the very first time you have to give the nodes name. Let's say if you see my nodes here, okay, if you see my nodes here, so I have only one nodes, which is this convert temperature, right? I have only one nodes, which is convert temperature. Now you can ask me start and ends is also a node, right? But this is a dummy node. This thing you don't need to create it separately. Okay, so whenever you are defining the edges, okay, that time you will mention that, let's say after start, this convert temperature node would be connected. Okay, this is called actually connection. That's why we call it as a dummy nodes. We don't need to create separately here. Okay, we don't need to add separately here. So by default your LangGraph adds that, and we just need to connect this particular nodes to our actual nodes. Okay, this is the funda here. Now let me first of all create. Now I'm going to explain, okay, how it works. So first of all, here I have to add our nodes. So here I only have one nodes, which is convert temperature. So maybe I can just give a name. I'll give, let's say, convert. Okay, convert temp. You can give any name, it's up to you, but make sure the name you are giving here, the same name you use for creating that particular function. Okay, now this will take that convert temperature function object. Okay, this will take this convert temperature function object, and I told you every node takes a function, and this function is nothing but it's a Python simple function. Okay, now let's try to create this convert temperature function individually here. So what I'm going to do, I'm going to simply come here. So basically this is our first node. So now let's write the function. So def convert temperature. So this will take a state. Okay, this will take a state. What is this state? This temperature state. And this will return also the state. I told you every time this state would be the input, and each and every nodes will return some kinds of output. This output should be also state. Okay, the updated state. So that's why I have to give this blueprint that this function takes state as an input, and it also returns the state. Okay, this temperature state only. So that's how you can give the blueprint of a function. Okay, now inside that, first of all, I'll take the Celsius data, whatever data user will provide. So here I'll just write Celsius, okay, is equal to this Celsius would be available inside state. Okay, so we are calling state and we are extracting the Celsius only, because this is a dictionary right now, and you know how to work with the dictionary, right? So we are working in a same. Then after that, we'll try to convert this to the Fahrenheit. So I've already written the code. Let me show you. So here we are converting to the Fahrenheit. Okay, you can see Celsius to Fahrenheit. And if you want to see how to convert Celsius to Fahrenheit, you can go to Google. You can search here. So you will see the formula. Okay, so this is the formula. So we are replicating the same formula here. You can see we are replicating the same formula. We are first of all multiplying the Celsius with 9 out of 5. Then we are adding 32 with that. So once we get this Fahrenheit, we have to also update the state memory, right? We have to also update the state memory because we have taken a variable called temperature Fahrenheit. Now whatever Fahrenheit we got, we have to update inside this particular state, right? So for this, that's how we can update, because this is a dictionary, right? This is a dictionary. So I'm just adding this particular new value to this variable, to this key, right? So here we're using round function because if it is a float type data, so after point there would be too many number, but I'm not taking too many number. I'm only taking last two digit, okay, after the point. Now once it is done, I'm going to simply return this state. So return this state. Okay, that's it. So this is our simple Python function we have created. Okay, now this function can convert any kinds of Celsius data to Fahrenheit, and we are updating the state here. Okay, that's it. Now this particular function will object will come here. So that's how, guys, we have created our first node. We have added our first node. Now see, this node has added. Okay, now you have to create these edges. Okay, you have to create these edges. That means the connection, the flow of execution. So for this, let's do that. So here I'm going to comment add edges to the graph. So first of all, you have to add the first edges. Now see, this start node will come here. Okay, now see. So here I'll just write start and convert 10. Just try to see this graph. See, now I'm telling this start node would be connected to the convert temp. Okay, that means this is the connection we are making right now, because from here it will start and it will go to the convert temperature. See, here we're doing start to convert temperature. Okay, now I will add the second graph. Sorry, second edge, add edge. Now convert temp to end. Now you can see. So basically, let me just show you. See, first of all, we connected here, right? That means this connection we have built. Start to convert temperature. Now convert temperature to end. Okay, and that means this particular edge we are getting right now. This edge is already created. Start to convert temp. Now convert temp to end. Okay, particular this edge we are getting. This edge is already created. Now we are doing it here. So you can see convert temp to end. Okay, I hope you clear, guys. Now once this is done, then you will be compiling the graph. So compile the graph. So you just need to write graph dot compile. Okay, and this returns you the workflow. So maybe I can store inside a variable workflow. Okay, now let's compile. So compilation is also done. Now we'll simply execute the graph. Execute the graph. Now guys, we'll try to execute the graph. So to execute the graph, first of all, you have to take the initial state. That means the input, which is the Celsius. Okay, Celsius temperature. So here what I can do, I can create a variable. I'm going to name it as, you can also call it as input state or initial state. Okay, it's up to you. but I've named it as initial state because this will become my initial state. Okay, the first state, which is nothing but the temperature Celsius, right? So initial state. So temperature Celsius, I'm giving, let's say 28.5. Now this thing will try to provide to the workflow. So I have created my workflow dot invoke. Now you can perform the invoke operation because this is a LangGraph object. And inside that, I'm going to pass my initial state, and this will return you the final state. Okay, final state, that means the output, final state. And this final state, I'm going to simply print it here. Okay, done. Now let's see whether it is working or not. Now see if I execute. Now see, initially we have given 28.5. This is the Celsius temperature. Now the final state is temperature Fahrenheit 83.3. Okay, you can also try with Google. Let's say if I'm giving Celsius. Now see, Celsius is 28.5 and you are getting 83.3. You can see 83.3. That means it's working fine, right? So we are able to execute our first graph, guys. Okay, we are able to create our first graph and this is completely working fine. See, there is no problem. Now, if you want to see this graph as a image, you can also do that. That means you can visualize this particular graph. This is very interesting things I found in LangGraph. So let me just comment here. Okay, visualize graph. So I found this code inside this LangGraph documentation. Yeah. So here we are using this IPython display and we are importing this image function. Inside that we are just giving workflow.getGraph. Okay, basically this will get the graph and we are drawing this particular graph as a mermaid PNG. Okay, so mermaid is a kinds of you can talk about, it's a flowchart. Okay, flowchart style. You can search on Google mermaid flowchart or simply search for mermaid. You will see that okay, mermaid flowchart. Yeah, see, so this will give you this kinds of flowchart. Okay, now let me show you. If I execute, see guys, you are getting the flowchart. Now see, this flowchart and this flowchart, just try to tell me whether you are able to see this is same or not. Okay, this is same, right? So you can see start, then it is going to the convert temperature, then it is giving you the final output. That means the end nodes. Okay, amazing. So guys, congratulations, we have created our first workflow, first LangGraph graph, and this is completely working fine. So guys, now what we'll do, we'll just try to update the workflow we have created. Let's say this is our workflow. So here we are only converting the temperature to the Fahrenheit. Now what I have done, I created another workflow. So this is the similar workflow, only I have added a new node here, you can see. So the node name is label weather. So what this label weather will do, let's say the Fahrenheit temperature we are getting, we'll just try to label that. Label means, let's say if this Fahrenheit temperature is less than 50, that time weather status is cold. Okay, if let's say Fahrenheit temperature is less than equal 50 and less than equal 77, that time it is mild. Okay, if it is less than 95, then that time it is hot, and if it is not all of them, that means it is extreme heat. Okay, so this kinds of labeling I want to do. So for this I have created another node here. I'll be writing another node here. This particular node will try to figure out the weather status. Okay, it will try to figure out the weather status, whether the weather is hot, cold, mild, okay, or extreme hot, etc. Right? And to create this particular graph, guys, I need another state called weather status, because these nodes will return the label, right? Whether it is hot, cold, mild, or anything. So this particular data I have to also save in the state. That's why I have taken another variable called weather status here. But previously this was missing here. Okay, now let's try to update this. So what I'm going to do, I'm going to open up my code again. So see here, I'll add another nodes. Okay, I'll add another nodes here. Yeah. Let's say the node name is label weather. Okay, and it will take a function, Python function called label weather. So now let's write this function. So after this function, maybe I can write it here. So def label weather. So this will take this state as an input. Okay. And it will also return this state as an output. State as an output. Okay. So already I got the suggestion code from my Copilot, but let me show you the code I have written. So this is the code. Okay. Now let me also comment here. Let's say this is for label weather condition. This is our second node. Okay. So now what we are doing, the Fahrenheit temperature we are getting, we're taking it from the state. Okay. We are pulling the Fahrenheit from the state instead of Celsius because I want to check with respect to the Fahrenheit. Okay. I want to check with respect to the Fahrenheit. You can also do it with the help of Celsius as well. Celsius temperature as well. You can also label that, but I want to do it with the help of Fahrenheit. I want to only show you the output we are getting, whether we can use it inside this particular node or not. Okay, that's why I'm using this temperature Fahrenheit. Then after that, I'm checking if Fahrenheit is less than 50. That time weather status should be cold. We are updating this state. Okay, there should be another variable called weather status. And right now this status should be hot, cold, mild. So I can consider this should be a string type data. Okay. Now let me execute this node. Yeah. Now you can see this weather status should be cold. If it is less than and equal 50 or less than 77, that time the weather status should be mild. If it is less than 77 and less than 95, this should be hot. Otherwise it should be extreme heat. Okay. So this is our logic we have written inside this label weather function, and we are returning the state. Okay, now let me execute. Now what I'm going to do, just execute from the beginning one more time, just to show you the output. So the node add is done. Now we'll try to add the edges. Okay, now we'll add the edges. That means after convert temperature, this will go to the label weather. Okay, so here I'm going to write start convert temperature. Okay, that means this part is done. Now I have to work on this part, convert temperature to label weather. So here I have to write convert temperature to label weather. Okay, now label weather to end. Now here I just need to write label weather to end. Okay, now I think you have understood this particular edge connection. Okay, this is like very amazing, right? And if you understand this edge connection, just trust me, you can create any kinds of workflow inside LangGraph. Okay, that's why I'm showing you this easy workflow at the very beginning. Now once it is done, now let's try to compile the graph again. Then I will execute the graph. This only takes the temperature Celsius input. So you can see temperature Celsius, this 28.5, we are getting the Fahrenheit, and based on the Fahrenheit result, we are seeing that weather status is hot right now. You can check if it is 83, right? 83, that means here this condition is matching here. Okay, that means this particular condition is hot right now. Okay, now if I visualize this graph, now see another node is added, which is level weather. Now this graph and this graph, I think you can match. Okay, great guys. So yes, this was the first sequential actually workflow we have created without using any kinds of large language model. So now I'm going to show you how we can create sequential workflow with the help of large language model as well. So guys, now we'll be creating a LLM workflow. Previously the workflow I showed you, this workflow I have created, this is a non-LLM based workflow. Here I'm not using any kinds of LLM. Okay, with the help of simple Python function, simple Python logic, I was handling everything. Now let's say you want to use LLM. Okay, LLM inside the workflow. So how to create the LLM workflow? For that, let's try to understand. And see here, our main goal is to learn the LangGraph workflow creation. The problem statement I'm taking, it might be very simple. You can think about, okay, this thing I can create with the help of simple Python function only, but why we are writing that much line of code? Okay, So our intention is to learn the LangGraph workflow. Okay, how we can use the LangGraph, how we can create the workflow, how we can create the node edges. Okay, each and everything. This idea I'm giving you. Okay, so problem statement doesn't matter. You can use any kinds of problem statement. So after learning this simple concept, so later on, whenever we'll be creating the actual agents or big project, so this concept will help us a lot, right? So that's why we are explaining this concept with the help of simple workflow. Now here I'm going to take another very simple workflow, guys, for the LLM workflow. So here what I'm going to do, here this is the workflow, this is the graph you can see. So basically this will have the start and end nodes, definitely, because this is common. So the only one nodes I will be creating here, the LLM QA nodes. Okay, so LLM QA means what it will perform. So basically user will give some of the question, and this LLM will answer that particular question, and this will return you the answer. Only this simple operation will be doing, okay, in this particular workflow. So for this, what should be the state? The state should be definitely the question, whatever question user is giving, and whatever answer we are getting from the LLM, this should be another state. Okay, so this state should be passed to all of the nodes, and it will real-time update that, and our workflow would be ended. So this is the simple graph, guys. Now let's try to implement this graph with the help of LangGraph. So for this, I have already prepared a notebook, as you can see, simple QA LLM workflow. So let me open it up. And to run this code, guys, you need this .env file, because in the .env, I have mentioned my OpenAI API key, because here we are using large language model, and I'm using OpenAI large language model. But if you want to use any other large language model, you can use it completely fine. For this, you can change the API key here. So this is the code, guys. This is the notebook I have prepared. Now this looks same as per your previous notebook. Only the things I have added the LLM functionality here. Now first of all, you have to import some necessary library. So see, you can see we are importing the same state graph start ends from the LangGraph graph. Then one additional package we are importing, LangChain underscore OpenAI chat OpenAI. I told you, if I want to use any kinds of let's say a large language model or whatever, I have to still use LangChain, because LangGraph doesn't have direct functionality, so that functionality can load any kinds of LLM. Okay, so it has to use this LangChain to load the large language model. So here one more thing you are also learning, how we can use LangChain along with the LangGraph. Okay, so this is the concept. So we are importing chat OpenAI. Let's see if you're using any other provider, if you're using Grok or OpenRouter, inside LangChain it is available. You can open it up. Then we are also importing typedict just to create the state, and the load env just to load our environment variable. Now the first step, we are loading the environment variable, this .env. For this, we are calling this load env. So if it is returns 2, okay, first of all I have to import this. Now I'll execute. Now if it returns 2, that means this env file is present, and inside that we have the key, right? It has loaded successfully. Now we'll try to define the large language model. Okay, so here we are creating a model object, and we are calling the chat OpenAI. So by default, I think it loads some model. Okay, I think GPT 3.5 turbo model it will load. You can also change the model parameter. If you want to use any other model like GPT 5 or 4, you can easily do that. But I will take the default model. It's completely fine for me. Okay, so I got my model object. Now here you can change with any model object. Either you are using Grok, either you can using OpenRouter, Gemini, anything you can use. Now we have to create this state. Okay, this state we have to create, and I told you to create this workflow, I need this two state, question and answer. So this thing I'll be creating right now. You can see I have written a class. I named it as LLM state, and again I'm inheriting with the help of typedict. Now we can store the data as a key value pair. Now the first state, you can see this is the question, and the data type should be string, because usually whatever question we are writing, this is kinds of string type data, and answer also this is string type data. Okay, we are preferring the state. Now once state preparation is done, now we'll be creating the nodes. But before showing you the nodes logic, I will show you the graph definition. So you can see, guys, we are creating the state graph, and we are passing the state we have created, this state. Then after that we are adding the nodes. Okay, the first node we have added the LLM QA. Okay, now this LLM QA we have to write. Okay, this LLM QA we have to write. So this should be a simple Python function. Inside that we'll perform the LLM call. So see, LLM QA, this is the function we are writing. This will take this state as an input and return the state as an output. Now whatever question user is giving, I am taking it from the state, then I'm preparing a prompt, answer the following questions, we're giving the questions. Then this particular prompt I'm just giving to the model, we're just doing model.info, giving the prompt, and whatever content it is giving me, I'm just extracting in the answer, and this answer I'm updating in the state memory again. Okay, so you can see it is having the answer key, I'm updating the value there, and we're returning the state. Okay, now let's execute. Now once our node is added, now we'll be working on the edges. We'll try to connect the edges. Now if you see the graph, so see, first of all, start node will connect to the LLM QA. So we are connecting that start to LLM QA. Then LLM QA will be connected to the end. You can see, then add edges LLM QA to end. Okay. And I told you start and end is a default node inside LangGraph. You don't need to manually add that. This is a dummy node. Okay. So only we'll be calling whenever we'll be adding the edges. So once it is done, we'll try to compile the graph. Let's compile. Okay, now everything is ready. Now we can execute the graph. So we are preparing the initial state, which is nothing but the question. Let's say here I'm giving a question, who is the creator of Python? And for the workflow we have created, we are just doing the invoking operation. We are giving the initial state and we are getting the final state output. Then we are just returning the answer. So I'm asking a question, who is the creator of Python? Now let's see. So see, the Python was created by Guido van Rossum in the late 90s, 80s. Okay, 1980s. So it's working fine. Okay, you can give any other question as well. It will work. Now let's try to visualize the graph. So here I will execute this code. This code is common. Now see, this is the graph. You can see start, LLM QA and ends. Okay, amazing. So this is the actually LLM workflow we have created. So previously we created without non-LLM workflow. Now we have created LLM based workflow. Okay, I hope you get it. So that's how, guys, if you want to use any kinds of large language model inside the workflow, you can define it like that. Okay, now we'll be learning another amazing concept. I think I told you in my previous video as well, called prompt chaining. Prompt chaining means you can use multiple LLM calls. See here I'm using only one LLM call, right? One LLM call. But if you want to use multiple LLM call, that is also possible. So we'll be learning in the we'll be learning this concept in the prompt chaining. Okay, so I'm going to create another notebook. There I'm going to show you how we can perform the prompt chaining operation. That means one LLM answer you are getting, you can pass this answer to another LLM to get another response. Okay, this is also possible here. Let me show you that part as well. So guys, now I'll explain about this prompt chaining. This is another sequential workflow. So in our previous workflow, we did the single LLM call. That means user was giving any kinds of question and it was generating the answer. But let's say you want to do multiple LLM call. That means after one LLM call, that output you want to use for another LLM, okay, as an input. This is called prompt chaining. So for an example, let me just tell you, see here what I'm going to do. I'm going to, let's say, create a blog generator, okay, blog generator from a topic. So here, let's say user will give a topic name, okay. So this will generate a blog, okay, blog for that. But this blog I'm not going to generate directly. Instead of that, what I'm going to do, first of all, I'm going to take this topic name, then I'm going to pass to a LLM. Okay, I'm going to pass to LLM, and this LLM will try to generate the outline, okay, outline for the blog. So let's say this will generate the outline, okay, outline of the blog from this LLM. And whatever outline I will get from this LLM, I will pass to another LLM, okay, and this LLM will try to take this topic as well as this outline and it will generate the blog, okay, and we'll be getting the final blog as an output, okay, at the last. So this is the workflow and this is called actually prompt chaining concept, okay, prompt chaining concept. Basically, whatever output we are getting from a fast large language model, we are passing it to the second LLM as an input and we are getting a final output. That means we are calling multiple LLM call here. This is called prompt chaining concept, okay. So this workflow we'll try to create right now. Now see guys, I have already created this graph, okay. I've already created this workflow. As you can see, so start and end would be common. So here I have to create two nodes. One is the create outline. That means whatever input I'll be getting, that means the topic. So first of all, I'll generate outline, and this outline as well as the topic I'll send to another nodes, which is create block. This will generate the block and I'll be getting the final block as an output, okay. And what should be the state for this particular workflow? first of all the title, that means the blog title. Okay, then whatever outline it will generate this outline as well, and whatever content, that means the blog will be getting, this should be another state. Okay, so that means 3 state will be available for this particular workflow, for this particular graph. Okay, now let's try to represent in the LangGraph code. So for this I have created another notebook, as you can see, prompt chaining workflow. So let's open it up. So this is the notebook. So again, this is the same as per your previous notebook I created. First of all, we have to import all the necessary libraries. So you can see we are importing state graph, start, ends, chat, OpenAI. Okay, then type dict, load env. Then we'll be loading the .env file to load the OpenAI API key. Then we'll be defining the large language model. Then we'll be creating the state. And this state name I have named it as blog state. And again, I'm doing the inheritance operation with the help of this type dict. Now we are preparing the state. The state means the title, outline, and the content. Okay, 3 state we are taking. Now, before creating the nodes, first of all, let me show you the graph. Okay, see, here we are creating the graph, state graph, and we are passing the state. And first of all, we are adding the nodes. Okay, so the first nodes we are adding for the create outline. Now let me show you this create outline function. So this is the create outline function. So this will take this state as an input and return you the state as an output. Okay, so whatever title user is giving, first of all, I'm taking the title, and here I'm preparing a prompt, generate a detailed outline for the blog, for a blog on the topic. So then we are passing it to the LLM. LLM is giving the outline. This outline we are saving inside the state. Okay, inside outline variable. Then we are returning the state. Then after that, if you show, if you see, I'm adding another nodes. Okay, called generate blog. Now whatever outline I got and title I got, I will pass to this particular function. You can see it will take from the state the title as well as the outline. Then I'm preparing another prompt. This prompt is telling write a detailed blog on the title. Okay, using the following outline. The outline we are getting as well as the title we are using here. Then we are passing it to the LLM. Okay, again we are doing the LLM call. Whatever LLM is generating, I'm just storing in the content. That means this is the final blog. Okay, I'm storing inside this content state. Okay, so it is done. Now you can see we are adding both of the nodes one by one. So this nodes is added, create outline and create blocks. Now I have to create the edges. Now to create the edges, guys, here you can see I'm creating the edges. First of all, edge would be created start to create outline. You can see start to create outline. Then create outline to create block. Create outline to create block. Okay. Then create block to end. Create block to end. Okay. Then we are doing the compile operation. Done. Now we'll execute the graph. So here as initial state, we are giving the title. Okay. We are giving title, let's say Rise of AI in India. Let's say this is our title and I want to generate our outline and then blog. Now we are giving into the workflow. We are doing the invoking operation and we are getting the final state as an output. See, it is doing multiple LLM call. That's why it's taking some time. First of all, it will invoke first LLM, then the second LLM, right? Now see, here we are getting the output. So this is the title. Based on the title, we are getting the outline. And also we have a content, final content. I think somewhere content is also there. We can see here. So final state, first of all, I want to see the outline. So this is the outline. Okay, it has prepared. Now, if I want to show you the content, that means the blog. So this is the blog, guys. Okay, I'm getting. So this is called prompt chaining concept. Now, if I want to show you the graph, so this is the graph. You start, create outline, then you will go to the generate blog, create blog, then ends. Okay, I hope you got it, guys. Okay, so that's how, guys, we can create any kinds of sequential workflow. Either you can create a non-LLM based, either you can create LLM based, either you can create prompt chaining based, anything you can create. Only you just need to know how to define these nodes and this particular connection. Okay, edge connection. If you can understand this concept, you can just trust me, you can create any kinds of workflow. Okay, inside LangGraph. Now I think by end of this video, it is very much clear how we can create any kinds of sequential workflow inside LangGraph. Okay, don't worry, I'm also going to show you like complex workflow as well, like parallel workflow. Okay, there are lots of workflow we saw, right? We'll be learning each of them. Don't need to worry. But before starting that complex workflow, first of all, I've given you the sequential workflow. I think now you have enough understanding how to code inside LangGraph at least, right? Now I think these are the syntax, won't be confusion to you, right? Like what is a node, what is edges, okay? So far we have learned so many theoretical concepts. Now we have seen the practical implementation. And all of this code and everything would be available in the description. From there you can download and you can try in your system. And one more exercise you can perform, let's say this prompt chaining we have done. Maybe you can add another node for the evaluation for this block. Let's say the block you are generating, whether this is good or bad, you can take another LLM, you can take another nodes and you can evaluate that. And you can also print the evaluation result. Let's say it needs the feedback or not, or it is completely fine. This kinds of result you can also print. Okay, that means you have to take another state here, and whatever result you are getting, you can also show the result here. Okay, after you can see content, maybe you can print another result which is evaluator result. Okay, now the best part is of this state is you can access all of the output. Okay, all of the output input anytime. Let's say we have generated these three things, right? Title, outline and content, and it is accessible anytime. Okay, this is the final state. From the final state you can access any kinds of state. Let's say you can access title, outline, content, or if you're adding the evaluator, you can access it anytime. Okay, so yes, that's it guys. So yes, this is all about from this video. I hope you got it. Now in the next video guys, we'll be learning some other workflow as well. Okay, like parallel workflow. We'll be also learning conditional workflow, iterative workflow. Okay, all the workflow we'll try to cover one by one. So guys, we are continuing with our complete Agentic AI course, and as you know, we started learning our fast orchestration framework, which is LangGraph. And in our previous video, I have already showed you how we can build sequential workflow inside LangGraph. So if I open up my previous materials, so there I already showed you about the sequential workflow, and I think you know how sequential workflow works. Basically it will work as a step-by-step manner. Okay, first of all, let's say this node, then this node, then this node. Okay, that's how it will execute. Okay, as a sequence. So if I show you, see, I created a non-LLM based workflow and LLM workflow, then prompt chaining workflow. So as you can see, after executing this node would be executed. Okay, then you will be getting the output. So this is a sequential order. Now we'll try to understand this parallel workflow, like how parallel workflow works, and we'll also try to write the code inside LangGraph. And here is the example guys. The first example I'm going to show you, the employee analytics workflow. Okay, so this is the example I have taken. I already told you, just don't focus on the problem statement. I have taken some of the problem statement, easy problem statement, so that I can make you understand these are the workflow. So later on we'll be building some amazing Agentic AI application completely end to end. So you can see guys, here this is the parallel workflow graph, as you can see. So you can see the difference between the sequential and the parallel. Sequential means after executing this node will be executing. That means the output you are getting from this particular node, you are passing this particular output to the next node, and this node is taking that output as an input, then it is executing. Okay, that means you have to wait. Okay, you have to wait till this node just complete the execution, then this node will start. But in parallel workflow, it's not like that. Each of the nodes are independent. That means you can execute them independently. Okay, simultaneously you can execute all of the node and you can get the output. So for this, I have taken one amazing example called employee analytics workflow. So basically what we'll do here, we'll just try to take some employee data. So here I already created the state. As you can see, I have already defined the state for this particular demo. So as you can see, let's say this is our employee state, and you know what is state, right? State is a shared memory inside our graph, right? And it will pass to all of the nodes. So you can see these are the data we'll be taking from the user. Okay, let's say employee name, monthly salary, working days, and completed projects. Okay, based on that, what we'll do, we'll just try to calculate the bonus of the employee, yearly salary of the employee, and the project evaluation. Evaluation means the project is excellent, let's say project work is excellent or average. Okay, we'll try to mark that. Now you can see to do that, I don't need to wait for any of the node here. Let's say I don't need to wait for this bonus to calculate the yearly salary. Then I don't need to wait for project evaluation for this calculate yearly salary. Okay, I don't need to wait for each and every nodes here, because each and every nodes are independent. The task I have taken, you can see this is completely independent task. So instead of running this in a sequential manner, so I can follow this parallel workflow. Okay, so that I can execute them in parallel and I can quickly complete my task. Okay, otherwise if you are running in sequential order, you have to wait for the previous node to be executed. Okay, but here it's not like that. This is completely independent. Then after getting all of this information, what we'll do, guys, we'll just try to give a summary. Summary means, let's say the employee name, their salary, yearly salary, project evaluation, calculated bonus. We'll just try to return a string, complete detailed summary string, and we'll just try to end the graph. Okay, so this is a simple problem statement I have taken. Again, I told you guys, don't just focus on the problem statement. Just to make you understand, I have taken this problem statement. The main intention, you have to learn this workflow, okay, how we can build this workflow. So first of all, we'll try to learn this non-LLM based workflow. So here I'm not going to use any kinds of LLM. Then after learning this non-LLM based workflow, the next one I'm going to take the LLM workflow. Okay, so both will be learning, no need to worry. Now let's start the coding inside LangGraph. So what I'm going to do, guys, I'm going to simply create a file here. I'm going to name it as for employee data analytics. Okay, employee analytics workflow. I'm going to create a notebook file. Perfect. So here I'll take the code cell and I will select the kernel. So previously I created this environment, I think you remember. We'll try to select that as well. Fine. Now guys, the first thing what you have to do, I think you remember, the first thing you have to import all of the necessary library. So maybe what I can do, I can refer my previous notebook and I can just import all of the necessary library I need. I need this one, right? This LangGraph, state graph and start and end. So I'll try to import this, as well as I need this typing to create this state. Okay, I need this particular type dict. Now let's import it. Now the second thing, guys, you have to define the state. Okay, if you see that, let's say the previous example also. So this is a LLM workflow, but if I open my previous example, let's say this one I created, right? This is the non-LLM based workflow. Then second thing, you have to define the state. And for this example, guys, what should be the state? So this is the state I already prepared. First of all, these are the state we'll be taking from the user, and these are the state will be just calculating. Okay, we'll be updating. Basically, let's say this calculate yearly salary. We'll try to calculate the yearly salary and we'll try to update inside this particular state. Then bonus, okay, we'll update inside this state. Then project evaluation, we update inside this project status. And summary, whatever summary we are getting, we'll also update here. Okay, and all of the data type I have also mentioned. You can see employee name should be string data type, monthly salary should be integer, working days it should be also integer, completed project it should be integer, that is the number of project employee has completed, yearly salary this is also integer, bonus amount also integer, project status. Okay, this status I will, let's say, tell excellent, average. Okay, so this should be a string and summary also should be a string. Okay, so this is the data type. Now let's try to just write same state inside our notebook. I'm going to just close this at the file. So this is the state, guys. Okay, you can see the same state we have prepared here, and I just named it as employee state, and I inherited with type dict because I can store my data as a key value pair. Okay, I think I have already discussed previously, okay, this thing, so I'm not going to repeat again. Now my state is done. Now I'll just need to create the graph. Now let's try to create the graph. So we'll try create the graph. You can see we are using state graph, and inside that we are passing our state, okay, employee state. Now we have to add the nodes. Okay, now how many nodes we are having? 1 2 3. Okay, and last we have another nodes called summary. And start and end, you don't need to take it because this is a default node inside LangGraph. This is a dummy node. So first of all, let's try to create this this one, this calculate bonus, or you can create any of them because this is completely independent, right? You are not I mean you don't need to worry about the like order because this is not a sequential one. You can create any of them. Okay, so first of all, let's create this calculate yearly salary. So here I'm going to add a node. So this is the node, guys. Graph.add nodes. I named it as calculate yearly salary, and the same name I used for this particular function. Okay, and this is going to be a Python function. We'll just try to write the function. Okay, just give me some time. So like that, I'll also define for all of these nodes one by one. The next one I'm going to create for calculate bonus and project evaluation. Yeah, so calculate bonus, this one, and the project evaluation. Okay, so all of the nodes I have created. Only the last node I have to create this summary. Now let's also create the summary. Summary. Okay, my node creation is done. Now I'll write these are the function one by one. So I'll come here. So here I will comment. This is our node one, and the function name is calculate yearly salary. Okay, now let's define a function def calculate yearly salary, and this will take this employee state as an input because every node takes this state. I think you remember. Okay, every node takes this state. Okay, and also it also return a state, right? So we are giving this type hint here. So let's try to write the logic here. So first of all, we'll try to calculate the yearly salary. So how to calculate the yearly salary? I think you know that we have the monthly salary. So what I can do, I can just multiply by 12. So this will give me the yearly salary, and monthly salary I have inside the state. You can see the monthly salary I have inside the state. So once it is done, I'm going to update the yearly salary where in my state again. You can see we are updating this yearly salary in the state. Then we are returning the state. You know that every nodes return the state. Okay, we are returning the state. It's completely fine, right? We have written the first nodes. Now like that, we'll also write the second nodes. State nodes dot define. We have to execute this cell. Now let's execute. Okay, now it's working fine. Now the second node, guys, we have to write for the calculate bonus for this one. Let's write this function. Def calculate bonus. This will also take employee state, that means the state, and also return the state. Okay, and here we'll try to calculate the bonus. So you can see whatever so what I can do, I can calculate the bonus based on the monthly salary. So I'll just try to multiply by 2. Okay, see here I'm not calculating the exact bonus here. Just try to think about just I'm adding some bonus based on the monthly salary of that particular employee. Okay, and after that we are adding this bonus amount inside the state, then we are returning the state. Okay, it's done. Now we'll try to create the next one, which is project evaluation. Node 3 project evaluation def project evaluation. This will also take the state as an input and return the state as an output. So here I can just write a logic. So let's say this is the logic I can write. Simple logic. If let's say the completed project amount is more than 5, so that time I can just give the stat as excellent. Otherwise I'll just try to tell it's average one. Okay, now I'll update this project status, then I will return the status. Okay, so yeah, this is our notes we have prepared. Now once it is done, the last I will add this summary notes as well. Now let's add the summary note. So inside summary, I'm just going to return all of the summary. That's it. So def summary. So here I will just initialize the summary. Let's say this is the entire summary text. I've taken the f string and I'm just joining the string all together. Employee name, then has a yearly salary, a bonus of bonus amount, project status is the project status. Okay, that means this is a complete string I'm just writing and updating and returning it. Okay, that's it. Now let me execute. Yeah, my all of the nodes are prepared. Now what I have to do, guys, we have already created all of the nodes. That means nodes is created. Now we have to add the edges. Okay, this is called edges. Now we have to do the edge connection. Now let's try to do the edge connection. So for this, I think you know that we use this add edge function inside LangGraph. So here I can comment. So first of all, try to see how we are going to connect the edges. You can see from start, it is connecting to calculate bonus. It is connecting to calculate yearly salary. It is connected to project evaluation. Okay, that means simultaneously you can see it is having three connection. Okay, with calculate bonus, calculate yearly salary, and project evaluation. So what I'm going to do, I'm going to do the same thing. First of all, I'm going to add this start with calculate yearly salary. Then I'm going to add with my calculate bonus. Then I'm going to add with project evaluation. Okay, I'm going to add with project evaluation. Now just try to relate. You can see start is connected with yearly salary, calculate bonus, and project evaluation. Okay, so these are the connection I have already made. You can see these are the connection I have already made. Now this connection is complete. Now I have to build this connection. Okay, that means now calculate bonus is connected to the summary, yearly salary also connected to the summary, project evaluation is also connected to the summary. Okay, that means I have to build this connection. Now let's do that. So here what I'm going to do, I'm going to write calculate yearly salary, it is connected to summary. Calculate yearly salary, it is connected to summary. Okay, then calculate bonus, it is also connected to the summary, and project evaluation, this is also connected to the summary. Okay, project evaluation, this is also connected to the summary, and summary is connected to the end. Now let's add another edge. Summary is connected to the end. Now just try to relate. Okay, just trust me, if you can understand this one, just the edge connection and the node creation, you can build any kinds of workflow inside LangGraph. Okay, any kinds of workflow you can create. So I hope guys you got it. Okay, I hope guys you got it, how we have made this connection. Okay, and this is an independent connection. This is an independent connection. Nobody, I mean, none of the nodes is dependent on another nodes. Okay, so that's why we call it as a parallel workflow. Now let me show you. For this, first of all, we have to compile the workflow. Let's compile. Okay, now I'll compile the workflow. Now you can just see the workflow graph. See, if you're using this Jupyter notebook, you don't need to write this extra code for that. I think in the recent update, they have automatically done this one in the cell itself. So previously I used this code to draw this graph, but right now you don't need to do that. If you just print this workflow, you'll automatically see this particular graph. Okay, now see guys, this is the graph and this is our parallel workflow we have created. Now just try to relate this graph. Okay, now you can see start and it is connected with all of the nodes, independently connected. Then whatever result we are getting, we are just returning the summary and we're ending the graph. Okay, so this is the parallel workflow. Now let's try to execute. So what I'm going to do, I'm going to initialize my initial state. And what should be the initial state? These are the state should be the initial one, because we'll be taking, these are the data from the user. So let's define that. So this is our initial state. You can see I'm taking the employee name, then monthly salary. So I'm going to take my name. Let's say I'm the employee. This is the monthly salary. This is the working days, and this is the completed project. Okay. Now we'll just try to run this workflow. Run the workflow. So we're just running this workflow dot invoke. We are giving the initial state and we're getting the result. Now execute. Okay. Now see guys, here we are getting one output. The output is add key employee name can receive only one value per step. Use an annotated key to handle multiple value. Now you can ask me why we are getting the error. Okay, why we are getting this error? Because everything is fine so far, right? Everything is fine so far, but why we are getting the error? See, the reason I showed you this error, actually I could have fixed it previously, but I showed you this error so that you can relate the difference between the sequential workflow and this parallel workflow. Okay, if you can understand this, I think you won't be having any kinds of problem. See what is happening if I show you my workflow again. So this is my workflow. See, here we created the state, right? We created this state and we are passing this state to the all of these nodes. But if you just observe, if you just deeply observe what is happening, whenever we are passing this state to all of the nodes, what is happening to calculate the bonus, what I'm using, okay, to calculate the bonus, what I'm using this initial state. That means whatever data user is passing, I'm using that. So to calculate this, I think I was using this monthly salary only, right? I was using the monthly salary. And I was updating this value where in this particular section. That means this bonus amount variable would be changed. Okay, after running this state, this particular variable would be changed. I'm not changing these at the variable, right? That means the monthly salary is remain same. I'm not changing it anywhere. That means the employee name I'm also not changing. Working days also I'm not changing. Completed project also I'm not changing, right? I'm only changing these are the variable here, but these are the variable remains same, common, right? So wherever you are passing this state, everywhere it is updating here only, not here. Okay, so that's why in parallel workflow, whenever you are giving this simultaneously to all of the nodes, okay, so these nodes actually conflicts each other. Conflicts each other means there is no update, so it conflicts, like whether the value we are getting here, this is correct for these nodes or not, whether the value we are getting here, this is correct for these nodes or not. Okay, that means it conflicts inside, because we are returning the entire state here. You can see we are returning the entire state, although we are not updating these at the state, but still we are returning the entire state. That means the entire state will go to the another node. Okay, that means the entire state will go to the another node, although we are not doing any kinds of update, but we are returning the state. Okay, it's not recommended. So whenever you are creating the parallel workflow, you have to make sure only the update you are doing inside the variable, that particular variable or that particular state, you have to return only. Okay, let's say in this case, let me just give you one example. Let's say in this case, we are only calculating what? We are only calculating the yearly salary. So instead of returning all the state together, what I'm going to do, only I'm going to return the yearly salary. Okay, because this is a parallel one. I don't need to like wait for my employee name, monthly salary. These are the things, right? Whatever update I'm just doing, I'll just only try to return that. So instead of this update, what I'm going to do, guys, I'm going to only return yearly salary. See, I'm going to only return the yearly salary we have calculated. We are only returning that, because at the end, this is a dictionary. Okay, this nodes returns a dictionary. Okay, we have to return a dictionary somehow. Now I don't need to give this type int. Okay, this is not required because we are not returning the entire employee state. Okay, now I'm going to just remove it. So only it will take the state, and whatever update it will do inside the state, and that state will only return, not any other state. Okay, not any other state, only the updated one it will return. So for this, I'll update for all the nodes I have done. So let's say here I was updating the bonus amount, so I'll only return the bonus amount, and this thing is not required. Okay, now for this project evaluation also, I'll do the same thing. Return the project status. This thing is not required. Now for summary also, we'll do the same thing. This is not required. Okay, so let me check everything is fine or not. Yeah, everything is fine. Now let me execute from the beginning. Now our workflow is created. Now we'll just try to invoke this workflow. Now see, it's working. Now if I print the result, See, we are getting the final result. So this is the employee name, monthly salary, working days, completed project, yearly salary. So see, we got the calculated yearly salary. Then bonus amount, project status excellent because the completed project is 7 and our logic was if it is more than 5, right? More than and equal 5, that means it is excellent. You are getting the excellent here. And here's the summary, but summary is giving a function. So let me check. Okay. So this should be summary text. I'm just returning the function on the right, the nodes only. So this should be a this variable. Now I think this should work. Now we are getting the summary. Employee Bappy has yearly salary of that amount. Bonus is that amount, and project status is excellent. Okay. So this is our uh, parallel workflow, guys. We have created, and I hope you understood. Okay. I hope you understood, and this particular concept also you understood why we don't need to return the entire state inside parallel workflow. If you're creating the sequential workflow, it's completely fine. You can return the entire state that time. Okay, you can return the entire state that time. But whenever you are creating the parallel workflow, make sure only the state you are changing, just try to return those state only. Okay, not the entire state. Okay, you don't need to do like that because internally it will do the conflict operation because we can't pass simultaneously to all of the nodes the same state. Okay, this is not possible. So in every state that should be updated. Okay, state should be updated, but here you can see it is not getting updated. Okay, after going to the every state, every nodes, it is not going to be updated. Okay, that's why this is going to be conflicted. So we have to update it somehow. So that's why we only are returning these are the state which is getting updated. Get it? Yeah. So this is the concept, guys. And this is our first non LLM based workflow we have created. And this is the parallel workflow. It is executing as parallel. Okay. Now we'll try to create another workflow. We'll use the LLM and we'll call as a LLM parallel workflow. Now let's try to see how we can create this LLM based parallel workflow, guys. So guys, so far we have created this non-LLM based parallel workflow. We have already seen the example how it can be done. Now I'm going to show you how we can create LLM based parallel workflow. And now we'll try to integrate LLM with that. And for this example, I'm going to take this particular demo called assay workflow. I think you remember in my introductory session, whenever I was giving you the introduction about the LangGraph, I used one example called assay. Okay, assay writing example. So there I created a system. I created a workflow. That workflow takes an assay as an input and it does the evaluation based on some parameter like it checks the depth analysis, then language evaluation, then research of thought evaluation. Okay, based on that it returns you some kinds of feedback as well as the score, and we get the final evaluation, then we conclude that, right? So these kinds of things I think I already discussed about my this session. Okay, this is the number 7 video I have already discussed. You can go through that if you want to understand about that particular workflow. But again, I'm going to show you the workflow. Here I already created the workflow. I'm going to discuss it here. And you can also see what is assay. Assay is it's a short non-frictional piece of writing that presents a specific argument analysis or personal point of view on a particular subject. Okay, so basically whenever you attend any kinds of let's say exams, or you if you are studying in a university, any kinds of university that so these are the essay writing you will be getting there. Okay, so this is a kinds of research topic you can talk about. So what I'm going to do, I'm going to take this same example here to make you understand this LLM based workflow, because here we'll be utilizing the LLM to analyze the essay, right? And we'll also do the marking and all. So this is the workflow. This is the graph, guys. I have created. As you can see, start and end nodes would be common, and these are the nodes we'll be creating. Evaluate analysis nodes, and that means whatever assay topic we'll be giving, right? Assay will be giving, it will try to evaluate the analysis, whether the analysis section is good or not. It will evaluate, and it will give you two things. Okay, this will give you two things. Just let me write down what I can do. I can take a screenshot. I can take a screenshot and I will open up my board. So now let me tell you. Yeah. So let's say you are giving a assay here. You are giving a assay here. Okay. That means the entire assay text you are giving. So basically, first of all, we'll be running this evaluate analysis. So this evaluate analysis will try to analyze the entire assay, and it will give you two things. The first one is the feedback. Okay, feedback of the assay, and second one is the score. This will give you a score. Let's out of 10, it will give you some kinds of score. Then next nodes we have writing for the evaluate language. Let's say you are using English language, right? So how is your grammatical, let's say, grammatical arrangement, or if you are following the right grammatical structure or not, and what is the words you are using. So these kinds of language related evaluation will perform. Then again, this will give you a feedback. Okay, and this will also give you a score out of 10, right? Then we'll just perform another analysis. This is the thought analysis. Thought analysis means the thought of on top of this assay. Okay, so here this will also give you a feedback and the score. Okay, that means every nodes we are getting two things: feedback, score, feedback, score, feedback, score. Okay, then we'll pass this feedback score, feedback and score, all of the feedback and score from all of the nodes. Let's say this is node 1, this is node 2, this is node 3, to another nodes called final evaluator. So that means this will evaluate based on all of the feedback. Let's say this is feedback 1, this is feedback 2, this is feedback 3. So it will take all of the feedback, then it will give you the final feedback. Okay, or evaluation. Then it will take all of this code. Okay, all of this code, and this will return you the average score of that. Okay, average final score of that. Okay, so this is how actually we'll be implementing this particular assay. Then once it is done, we'll try to end this particular graph. Okay, now if I get back to my workflow, I think now you are getting right. And to make this workflow, I need desired state. Okay, I already prepared the state. As you can see, I need desired state. I named it as assay state, and I inherited with type dict. And first of all, I need to take the assay, and assay should be string, right? This is a variable. Then language feedback. That means here. So evaluate language. This will basically do the language evaluation, and whatever feedback we'll be getting, we'll try to save inside language feedback. Then it will also give you. This will also give you another score, right? That means the language score. So instead of storing inside a single variable, so what I am doing, so here you can see I have taken another variable called individual score. Okay, and here I use this annotated list integer operator dot add. So I think you can call this concept, right? So this is called actually reducer. I already talked about the reducer here in my demo. Whenever I was explaining about the LangGraph core component, there I talked about the reducer. So if you haven't watched that video, guys, please try to watch, because this is important. Without that, actually you won't be able to understand what is a reducer exactly. So reducer will help us to replace, add, and merge the like data inside the state. So by default, it will replace everything. I think so far, whatever state we have created, it was replacing every time, right? But as you can see, from each and every nodes, we are getting some score. Okay, let's say if I'm only taking one, let's say score variable. So what will happen? So whenever I'll get the score from here, let's say I got 12. I got, let's say, 8. Then from this particular nodes, I get another score. From this particular node, I get another score. Let's say this is 8.5. So what I will do, this 8.5 would be replaced by 8.5. So that means I will lose my previous score of that evaluate analysis, right? Then let's say this node has generated another one. Okay, let's say 9.5. So again, it will replace by 9.5. So I lose my previous score, right? But I need all of this code to make the average. So I need this score as well. I need this score as well. I need this score as well. That means I need to keep inside a dictionary. Let's say the first score I'm getting 8. Second score I'm getting 8.5. The third score I'm getting 9.5. I'll store all of the score from all of the nodes, okay, inside a list. Then I'm going to create an average of that particular score, and this is going to be my final evaluation. Okay, and for this we are using this operator.add here. Okay, you can see we are using operator.add here, and we are using annotated. Okay, I think you know what is annotated. Whenever I want to use reducer, right, I have to use this annotated, and here we are mentioning that should be a list of integer. Okay, there should be a list of integer. That means I want to let's say store list of integer here. So here I have taken a float value, but you can consider I want to you can also like give it as float value here. Let's say sometimes score should be also float value 8.5, 7.5, but I told I need only an integer type like feedback. Okay, integer type score. So that's why I given list of integer and operator dot add. That means I want to perform reducer what operation? Add operation. That means instead of replacing, it will every time add all of this score. So whatever score I'm going to get from my evaluator analysis, I'll store it here. Okay, apart from the feedback. Then from evaluator language also, I'm going to add the score. From evaluate thoughts, whatever feedback score I'm getting, I will also try to add there. Okay, so that's how you can see for all of the nodes, I have individual variable. So you can see language feedback, I have one variable. Then evaluate of thought, that means this one clarity feedback. Okay, this is clarity of thought, you can consider, and the full name is clarity of thought. We have taken a variable called clarity feedback. So basically this feedback will store here. Then we have evaluator analysis, that means the analysis feedback, it will store here. Okay, that means language analysis, then evaluate thoughts. Okay, clarity of thoughts. Then the overall feedback, that means from final evaluation also we are getting a feedback. From final evaluation also we are getting a feedback. So this feedback will store inside overall feedback. Okay, and final evaluation will give you another score, which is average score, and for average score we have kept another separate variable called average score, and this should be a float value. Okay, and for individual score we are getting, we are storing inside this particular list. Okay, individual score, this should be a list, and we are performing the reducer add operation. Okay, now I think you got it, how we created this particular state. Okay, how we created this particular state. Now I think this is pretty much clear, guys. And to understand this reducer concept, I will suggest you go through this recording. Okay, LangGraph core component, you will try to understand, okay, how reducer works. So yeah, I think our state is ready, everything is ready. Now we can start working on that. But one more issue we'll be having, which is this output format. Okay, that means I need a structure output from my LLM. That means every nodes will return feedback and score, feedback and score, feedback and score, and we are using LLM, and you know LLM is an unstructured data generator. Okay, we won't be getting this kinds of feedback score every time. Let's say if you're adding by the prompt, I need a feedback and score only. Let's say it will run 5 times, maybe in 6 times it will give you some other parameter as well. That time your code will crash, right? So to make our output structured, so I taught you about I already taught you about this Pydantic, right? So you can see Pydantic for AI agents. I've already taken a class on that. So you just need to go through this Pydantic, because we'll be using Pydantic concept to get the structured output from my LLM. Okay, now let's try to show you how it can be done. So what I'm going to do here, I'm going to create another file. So I'm going to name it as pipe as a workflow. I'm going to select my environment. So first of all, I will import all of the necessary library. So I need this state graph start end, okay, from LangGraph. Then I also need OpenAI model, because here I'm going to use LLM, and for LLM I'm going to use OpenAI model. You can use any model, okay, it's up to you. You can use Gemini, Grok provider, and any kinds of model you can use, but I already have the OpenAI API key. Yesterday I already collected, I think you remember. Okay, that's why I'm using that. Then okay, I'm going to close this. Then I need this load env to load my environment variable, because inside environment variable I have my API key. Then I need these are the These are the import as well. From typing, I'm importing this type dict and annotated. Why annotated? Because you know that to make this reducer, okay, I need this annotated. Okay, annotated is required, and it is available inside this typing. We are importing annotated, and we are using Pydantic. So from Pydantic, we are importing base model and field, and you have to install Pydantic for this. Let me install Pydantic. Pydantic. Okay. I'll install this specific version of the Pydantic. Now let me activate my environment. Then let's install the requirements again. Okay, done. Now I'll come here. Now you can use this Pydantic. So from Pydantic, I'm importing base model and field. And what this base model field does, guys, I already discussed in this session. Please go through that. Okay, I'm not going to repeat again. So this session will give you the entire idea about Pydantic. Okay, why it is required. And operator for this add operation. That means for the reducer. Okay, operation dot add operator dot add. We have to write it here. So once it is done, now let me import all of the package. Yeah, so it's working fine. Now, first of all, we'll try to load the environment variable. Yeah, then we'll prepare the model. So here I will take GPT-4o mini. Okay, this model. This is our LLM. Now you can perform the invoke operation if you want directly, but if you perform the invoke operation right now, so what will happen? This will give you unstructured output, but I need what? I need only this feedback and score. Okay, I need feedback score from this model. Okay, whatever assay I'll give you, I'll give to this model. It will give me feedback and score. So I have to make the structure. So how to make the structure for this? We'll be using the Pydantic. So here I have created one Pydantic class. So this is the Pydantic class. So the name of the Pydantic class is evaluation schema. And we are inheriting with the base model. Okay, the base model we have imported here, we have inherited, and here is the Pydantic syntax. Okay, this syntax I already taught you in that session. So this should be string and this should be integer, and here I have given the field. So in the field I'm telling detailed feedback for the assay, and for score I've given a description score out of 10. So this is the greater than and this is the lesser than. Okay, greater than 0 and lesser than 10. So this should be the score. So that's how you can make the structured output from any kinds of given LLM. Okay, now to make the structured model, what I'm going to do, simply I'm going to just add this schema to the model. So for this you have to call the model dot with structure output. There is a function called with structured output, I think. With structured output. Inside that you have to pass this class. Okay, this Pydantic class. Now this will set into the model. That means whenever you will generate any kinds of output, this will have two things. One is the feedback, one is the score. Okay, now I'll store inside another variable called structured model. Now this is going to be my structured model object. Okay, now every time I'm going to call this model. Okay, not this model. This model will give you unstructured output, but this model will give you the structured output. Okay, now let me execute and see whether everything is fine or not. Now if you want to test, guys, so maybe I can show you. So I'll give an assay here. So this is one assay I generated from ChatGPT. You can see this is assay I generated from ChatGPT. Europe in the age of AI, the regulatory superpower. So what I'm going to do, I'm going to pass this assay to the structured model with a prompt. So this is the prompt I have written. Evaluate the language quality of the following assay and provide a feedback and assign a score out of 10. Okay, I'm giving the assay text here. And right now I'm calling the structured model, not the model only. Okay, structured model dot invoke, and I'm passing the prompt. Now this will give you the result. Okay, result stored inside the result variable. Now let's execute. Now if I print this result, you'll see that it will have two parameter. One is the feedback, okay, feedback of the assay, and another one is the score. Okay, see, I got the score. You can also extract it if you want. So you just simply need to write result dot feedback. Okay, we'll get the feedback, and if you want the score, you can call result dot score. Okay, this is the score you got. I hope you got it, guys. Okay, that's how with the help of Pydantic you can get the structured output from any large language model. Okay, this is very much important. Now we'll try to start writing our this workflow. Now first of all, let's prepare this state. So already state is given. I'm going to just replicate the same state here. So this is our state, assay state. So we are giving the assay, language feedback, test analysis feedback, clarity feedback, overall feedback, individual scores, and this is reducer concept you are using. Basically, this should be a list of score, okay, and it will add every time and the average score. Now let's initialize that. Now we'll write our graph. Let's prepare the graph. Yeah, so we have given this state to this graph. Okay, now we'll try to add the nodes. So first of all, I will add this node, this node, this node. Okay, and the final evaluation node. Total 4 nodes I have to add. Let's add it. I have already prepared all of the node. Add node. So yeah, you can see we're adding the nodes. First of all, we're adding the evaluate language. Okay, evaluate language, this node. Then we are adding evaluate analysis, this node. Then we are giving evaluate thoughts, this node. Okay, then last final evaluation. Okay, my node is done. Now we have to create these are the Python function one by one. Let's create quickly. So here I'm going to just create it quickly. First of all, I'm going to create this function evaluate language. So I already created. Let me show you. Yeah, so evaluate language, this will take this state as an input, and here you can see I'm using LLM, and for this I prepared a prompt. So here I'm telling evaluate the language quality of the following assay and provide a feedback and assign a score out of 10, and we're giving the state assay from the state. Okay, and we are calling this structured model. That means the structured model we have prepared here, this model, okay, instead of this model. So structured model. So this model will give you two things. One is the feedback, one is the score. So the feedback we're storing inside language feedback. That means this particular variable, because we are evaluating the language here. That's why feedback will go to the language feedback. And the score we are getting, we're storing inside individual score. And this is like a reducer type. That means we are adding inside a list. So that's why you can see individual score, output score. Okay, that means the first score will save here. That means let's say what I'm going to do. See, that means from here, evaluate language, right? I think it is evaluate language. Evaluate language. So that means we are executing this node. So this node will give you two things. One is the feedback. One is the score. Okay. So feedback I already stored inside my feedback feedback state. That means here language feedback. Now score. Okay. Score what I'm doing, because I created an individual feedback variable. Okay. So here let me show you. Maybe I can take a screenshot. So here you remember I created this individual score variable. So basically this is a list. Okay, this should be a list. This should be a list. Okay, and we added our first score, which is this evaluate language. Let's say it has given you 8. Okay, then there would be a comma. Done. Okay, now I will write for the next nodes, which is evaluate analysis. Okay, because I already executed, I already created this node, evaluate language. This will give you feedback and score. I already got it. And instead of returning all the state, we are returning the updated one only, because in my previous example, I showed you, if you're creating parallel workflow, you don't need to return the entire state. Instead of that, only you just need to return the updated state. Okay. Otherwise there would be a conflict problem. Okay. Yeah. So now let me define this node. Now, once it is done, I'll define the next node, which is the depth of analysis, evaluate analysis. This will take the state, and here we are giving the prompt again, evaluate the depth of analysis of the following assay and provide a feedback and assign a score out of 10, and we are giving the assay. And this will pass to the structured model. This will give you two things. One is the feedback. So this feedback I'm storing inside analysis feedback. That means here in this particular variable, and it is giving you the individual score, and we're storing this score in the individual score. That means here. Okay, this is a list. So like, let's say this has given you again 8. Okay, this will store here. Okay, that's how we are storing. Now this is also done. Now we'll write for the next one, which is clarity of thought analysis, evaluate clarity of thought. Again, this will take the state as an input. We are defining the prompt, evaluate the clarity of thought of the following assay and provide a feedback analysis and assign a score out of 10. Okay, we are giving the assay, and we are passing it to the structured model. And this will give you two things. One is the feedback. So feedback I'm storing inside clarity feedback in this variable, and the score we are getting, we're storing inside individual score. Okay, that means here. Then again it will get give you another score. Let's say you got 9 here. Okay, so that's how your individual score will form, right? And now we have all of the score from all of the nodes. Now we'll try to make the average one, okay, later on. Now it's done. You can see we are also returning these two things, clarity feedback and individual scores. Then this will become my next node. Now we have to work on the final node, which is final evaluation. Now let's also write that. This is our final evaluation nodes. Again, this will take the state as an input, and again we are preparing a prompt based on the following feedbacks. Create a summarized feedback. Okay, now here we are passing all of the feedback one by one. That means this feedback, this feedback, this feedback. Okay, this feedback, this feedback, this feedback. 3 feedback we are giving: language feedback, then depth of analysis feedback, clarity of thought feedback, and I'm just telling the model, give me a overall feedback. And right now I only need a feedback. I know I don't need any kinds of score. Okay, so that's why I'm using the original model instead of working on the structured model. I'm now invoking the original model because I only need the feedback. That's why I'm invoking on the original model. I'm giving this prompt, and whatever content it is generating, I'm just storing inside overall feedback. Okay, now I have to calculate the average score. Okay, and how to calculate the average score? Because I already have the all of this score, right? All of this score as a list. Now you can see from this state I'm extracting the individual score. Okay, individual score, because this is a list. Okay, now we are calculating the length of this like list, and how many like let's say variable, how many value we are having. We are just doing the dividing operation. Okay, first of all we are doing the sum operation. You can see. So how to calculate average? First of all, you will do the sum operation. You will do the sum operation, 8 plus 8 plus 9. Okay, then you will just try to divide with the number of item you have. Let's say we have 3 here. Now whatever output you will be getting, this is your average. Okay, so we are calculating the average like that. First of all, we are summing all the value, then we are dividing with length of the item we are having inside the list. Then this is going to be your average score, and we are returning the overall feedback and average score. So overall feedback we're storing inside this variable, overall feedback, and the average score we are storing this average. Okay, average score here, and that's it. Okay, now all of the function we have created, now we have to add the nodes. Now let's try to refer this graph and add the nodes. Now see, whenever you are adding the nodes, first of all, you can see start would be connected to the evaluate analysis, evaluate language, evaluate of thoughts. Let's add that. Add edges. Yeah. So you can see start is connected with evaluate language, evaluate analysis, evaluate thoughts, evaluate analysis, evaluate language, evaluate thoughts. Okay. That means these are the connection we have built. Now evaluate analysis is connected with final evaluation. Evaluate language is connected with final evaluation, and evaluate thought is connected to final evaluation. Now I have to make this connection. Now let me do that. See, evaluate language is connected to the final evaluation. Evaluate analysis is connected to the final evaluation. Evaluate thought is connected to the final evaluation. That means this connection is also done. Now final evaluation is connected to the end. Now final evaluation is connected to the end. Okay. Now we have to compile the graph. Done. Now if you print the workflow, so that's how your workflow looks like. And now you can verify this workflow and this workflow. Okay, these are same. Now I need to invoke this workflow. So for this, let's prepare another assay. So I generated another assay from my ChatGPT. So this is another assay. I named it as assay 2. Okay, so this is the innovative state in the age of AI, the infrastructure and capital superpower. So I'm going to invoke it right now with my workflow. So let's do that. So first of all, here I have prepared the initial state and I have given my assay. Okay, then we are invoking the workflow and this will return you the result. Done. Now we'll print this result. See, here you have all of the data. So this is the assay, this is the language feedback you got, this is the analysis feedback you got, this is the clarity feedback you got, this is the overall feedback you got, this is the individual scores from all of the nodes. Okay, and this is the average score. I hope you get it, guys. See, amazing, right? So that's how we can create any kinds of LLM based parallel workflow. Now I think it is pretty much clear, and the only things is that you have to understand the connection, you have to understand this graph and the state. Okay, the state you will be using here, and when to use this reducer, when to use the Pydantic, you have to understand by seeing the problem statement. So here two things you have learned. I just used in this particular practical demo. One is the Pydantic, how to use Pydantic to get the structured output. Okay, then another one, this reducer. So reducer we already saw, right, in the concept understanding. Now we practically applied this reducer as well, okay, in the LangGraph. So yes guys, this is all about that's how we can create any kinds of parallel workflow. Now in the next video I'm going to teach you some other workflow like conditional, iterative. Okay, each and everything we'll try to discuss. Then we'll also implement some amazing practical project. Okay, Agentic AI project. Okay, in our previous video I have already discussed about parallel workflows, like how parallel workflow works, and we already did the coding as well with the help of LangGraph. Now let's try to understand these conditional workflows. And this conditional workflows would be more interesting because if you have already let's say learned programming language, you know that inside programming language we have something called if-else condition, right? So based on this if-else condition, we handle any kinds of conditional based scenario. So the same thing you can do inside LangGraph as well. Whenever you are having a workflow, this is having some kinds of condition, you can handle this kinds of scenario with the help of this conditional workflows. Okay, so make sure you watch this video till the end, don't miss anything. And if you found this content useful guys, please try to subscribe to my channel and hit the like. Just hit the like guys, because like is required if you like the session. So it will be reaching to all the people out there so that they can also find these kinds of content. And please try to share this video with your friends and family. So first of all, let me give you the idea about conditional workflows. Then I will also show you how we can code with the help of LangGraph, how we can implement this conditional workflow with the help of LangGraph. So here also I'm going to take two kinds of example. I'm going to take the first example, non-LLM based conditional workflows. First of all, I'm going to show you the non-LLM based workflows. Then after that, I'm also going to show you the LLM based workflows. Okay, both we're going to cover here. So if you see here, this is the conditional workflows, guys. So this is similar to the parallel workflows. I think you already studied about parallel workflows. Okay, so let me show you. So previously I already discussed about this parallel workflows, right? So in parallel workflows, what happens if you give a task? So basically here we are having multiple nodes, and all of the nodes would be executed independently. That means it will execute, it will be executed in parallel. Okay, all together it will be executing. Then whatever result I was getting, I was just aggregating and showing the results. Okay, but inside this conditional workflow, this is a little bit different. Let me show you. So inside conditional workflow, what will happen? See, here also we are having multiple nodes, okay, in parallel, but these are actually condition. Okay, these are actually condition. That means let's say whatever content we are sending. So first of all, it will analyze that. After doing the analyze, it will perform a conditional statement. That means if this content is good, let's say it will approve that particular post. If it is, let's say, needs any human review, that time it will send it to the human review. Okay, and if it is having any kinds of problem, that time it will directly reject the post. That means here you are checking the condition. Based on the condition, you are executing one of the node. Okay, you are not executing all of the node, you are only executing one of the node. Okay, let's say this node can be executed based on the condition, or this node can be executed based on the condition, or this node can be executed based on the condition. Okay, based on that you are ending the entire graph. But here it's not like that. Here you are executing all the node together. Okay, in parallel you are executing, then you are aggregating the results and you are showing that. But here it's not like that. This is working as a if-else condition. Okay, so let me show you. See, here basically we'll just write a condition. Okay, let's say here the problem statement. First of all, I'm going to show you. This is actually content moderation system. This is the non-LLM based workflow. First of all, I'm going to create. Then after that, I'm also going to show you how to create the LLM based workflow. So here basically we'll be creating a content moderation system for a social media platform. It processes a user text post and evaluate it for spam, and conditionally route it to be published. Okay, published, either flagged for the human review. If it is need any kinds of human review, it will try to send to the human review, or it will automatically reject that particular post. That means here we'll be basically deciding this kinds of statement based on the condition. Okay, condition will first of all check the content. Whatever content user will post, whatever text user will post, we'll try to check that. Okay, before checking that, we'll try to first of all format the post. Format the post means I will show a message. Okay, I will show a message like let's say this is the user, he has posted this this particular content. After that, we'll analyze that, right? Analyze that. So this analyze function will try to analyze whether this particular post I can directly post or not, if it doesn't have any kinds of violation or not, or either if user is completely new to my platform. Okay, first of all, I have to send this post for the review. Okay, either if it is having any kinds of violation related post, I'll just try to reject that particular post. Okay, so this is the condition. So basically here you are sending you are handling these kinds of condition. If else condition, if else condition. Okay, if else condition. If this post is fine, you are approving that. Okay, if it is if it or if user is completely new user, okay, new user, you are sending for the human review, or else you are rejecting the post. That means there is a violation problem. Okay, so this is a conditional based workflow. Now I think you got it. What is the difference between these conditional workflows and the parallel workflows? Okay, and to implement these workflows, guys, I need a state. So I already prepared this state. As you can see, I named it as moderation state, and I inherited with the type dict, and here I have taken some of the variable. So the first one I have taken for the post content. That means whatever text user will pass, I'll try to save it here, post content, and this should be a string type data. Then user reputation. This is also user will pass. User reputation means either user is a registered user, or he's the new user. Okay, let's say if user reputation is equal to um, let's say the user is let's say trusted user. Okay, trusted user means this user is already registered user. Okay, so that time I'll not send this post for the review. Okay, this post won't be going for the review, because the review I will only learn I will only execute whenever the user is completely new to my platform. Okay, so this statement will store here, and this is going to be also string type data. Then formatted post. So whatever content user will give us, first of all we'll try to format that particular post. Format means I will give a message. Let's say user says this is the post. Okay, that kinds of like I'm going to just give a message. Then content flag means here is the content flag, basically all of the condition, whether this should be approved or whether this should be rejected or whether this should be flagged for the human review. Okay, so these kinds of condition I'll try to save inside content flag, and this is also going to be a string, because here I'm going to store either approved, either review, either reject post. Okay, that's why it's going to be string. Then result, the final result. Okay, final result means whether the post has been approved. It will give a message, right? Let's say post automatically approved, or post flagged for the human review, or post or already rejected. Okay, this kinds of message I want to show at the last. That's why I have taken another variable called result, and this is also going to be a string. Okay, I hope you got it, guys. Now let's try to code inside LangGraph how we can create this graph, how we can create this workflow. So I think you already get it. First of all, I have to create some of the nodes. Okay, this node, this node, this node, this node, this node. Okay, then I'll try to do the edge connection, and I will show you how we can handle this kinds of conditional workflow as well with the help of this LangGraph. Okay, this can be also discussed in this particular video. Now let me create a file first of all here. So I'm going to create a file. I'm going to create a new file. I'm going to name it as 6 content moderation workflow.ipynb. Okay, this is a notebook file. So I'll take a code cell, and here also I'll take the kernel. So the first thing, guys, I have to import the necessary library, and I think you know that what are the library we need, right? So let's import. So I need this state graph start end from LangGraph graph and type dict. Let's import them. Then after that we have to create this state, right? So the same state I'm going to create here. So this is the state. I have taken the post content user reputation, then formatted post, content flag, and result. So first of all, now I'm going to create the graph. Okay, then after creating the graph, we'll try to add all of the nodes. Now let's create the graph. So graph is equal to state graph. Then I have given my state, moderation state. Then after that, we'll just try to add the nodes. Add the nodes. Okay, first of all, I'm going to add my first nodes, which is this one, format post. Let's add that. Format post, and this function I have to write. Okay, this format post Python function I have to write separately. Then the next nodes I have to write this analyze content. Analyze content. Okay, I have given the same name. Then the next node I have to create approve post. Then next node I have to create flag for review. Then next node I have to create this reject post. Okay, now let me check whether I have any node or not. No, it's completely fine. I have created all the nodes. Now we have to create all of this node one by one. So first of all, let's create the format post. See, inside formatted post, I'm not going to do anything. This is the non-LLM based workflow. So I'm going to just write a simple Python code here. So basically whatever, let's say user is passing, input user is passing, let's say user is passing post content and user reputation. So I just created a formatted f string here. So here I told user reputation. Okay, that means let's say user is trusted user. So here trusted user will come. That means user, trusted user says post content. That means whatever post he is giving, this particular post, it will show here. Let's say user has given one post, check out this amazing new product and buy now. Okay, so this will show here inside a this f string. Okay, then after that we are just returning this particular formatted post. Okay, formatted because we created this formatted post, and whatever formatted output we are generating, right, we'll just try to store it in the formatted post string. Okay, we are storing here and we're returning it. And why we are not returning the entire state, guys? Because in my previous video I already told you about, right? I whenever I created the parallel workflow, that time I told you if you are having this kinds of scenario, that time don't use the entire state returning concept. Instead of that, whatever state you are changing, only just try to return those state. Okay, this is a good practice. Okay, instead of returning the whole one, because here you are not changing inside that. Okay, after the execution, node execution, you are not changing inside this particular variable, you are only changing inside that, right? That's why don't return the entire state. Instead of whatever state you are changing, only just try to return that. Okay, I hope you got it. So this is our first node we have created. Now let's create the next one called this analyze content. Okay, now analyze content would be very simple. See here I just written a simple condition. So see here I'm giving my state, and whatever post content we are having, first of all we're doing the lower operation. Okay, lower operation. Then after that we are checking the condition. So as you can see, if spam in the content or buy now in the content, see here we are only considering this particular post would be rejected based on some like parameter, whether it should be a spam, whether it should be buy now. If user is giving this kinds of word in the text itself, I'm going to directly reject that particular content. Okay, because this is a condition, I mean non LLM based one, so that's why I just taken like manual verification. But whenever it would be LLM based, that time it would be more robust. Okay, but just for your understanding, I kept this particular easy example. So that's why I only consider two word, one is spam, one is buy now. Okay, if it is present in the content, I'm going to directly reject that particular content, so flag would be rejected. Elif the state reputation if is equal to new user, that means I told you if user reputation is equal to new user, that means he is the completely new user on my platform. First of all I will review this particular post. Okay, I will send it for the review, or else I'm going to approve the post. Let's say if it doesn't have any kinds of spam content, or it doesn't need any kinds of review, that means this content is fine, I'm going to approve that. Okay, that's why in the else block the flag is equal to approved. Then whatever flag we are getting based on the condition, we are just storing inside content flag. Okay, here we are storing that and we are returning this particular state. Okay, I hope you got it. Now the next one I have to create for this approve post. Okay, approve post. So this will basically return this approve message. Result is equal to post published successfully to the timeline, and result is equal to result. So we are storing inside result. Okay, now we'll do it for the same for the flag review and reject post as well. Now here also I'm going to just return the message for flag for review, post sent to the human moderation queue. Okay, for the review, and we are updating the result. Okay, and here you can see we don't need to store all of the like result here, because this is not required, because this is a conditional workflow. So either one of the node would be executed. It should not be executed all of the node, right? Like that. Okay, so previously it was executing all of the node, and I was collecting all of the ratings. Okay, and I was storing inside a list. That's why I used actually reducer concept here. But here reducer concept is not required, because here either one of the node would be executed, and I only need to save one particular result. Okay, that's why this is completely string type. Okay, I haven't taken any kinds of reducer type here. Okay, every time it will replace that. Then the next one I have for the reject post. Reject post. So as you can see, post automatically deleted due to the policy violation, and we are updating the result. That's it. So let's execute this one. Execute this one. And I'll execute this one. Also execute this one. Okay. Once it is done, Now I have to do the edge connection. Okay, so first of all, let's do the edge connection, then I will show you how we can handle the conditional scenario. So here let's try to do the edge connection, add the edges. So first of all, you can see the edge connection would be start to formatted post. Okay, let's try to do that. Start to formatted post. Okay, then the next one, formatted post to analyze content. Formatted post to analyze content. Okay, then after that, what we have, we have this connection. Okay, but this connection will build up based on the condition. Either analyze content will return this particular output to the approved post, or flag review post, or rejected post. Okay, now this conditional statement will come into picture. Okay, now this conditional statement will come into picture. So let's say if I'm not adding the condition, if I'm directly just, let's say these nodes are not there, I'm directly just adding this analyze content to the end, analyze content to the end. Analyze content to the end. Okay, now if I compile the graph and if I show you the workflow, okay, node, okay, there should not be any quotation, that's why it's coming the error. Now if I execute, this workflow is created. Now if I show you the workflow, now see the workflow look like that. So this is the workflow right now. Okay, but I created the nodes already, right? So if I, let's say, comment is at the node. Now if I execute, see, this will look like that. So start, formatted post, then analyze content, and end. Okay, so let's say these are the nodes are not there. Okay, but now I have to create this node because I have to handle the conditional statement. Now let's uncomment that. Now here I'll just try to add the condition. Now I'll remove this one. Okay, now here only you have to add the condition. Now see, if you want to add a condition, okay, if you want to add a condition, so you have to use this function, add conditional edge. Okay, there is a function inside graph called add conditional edge. Inside that you have to give a function object. Okay, condition function object. Okay, condition function object, and you have to provide from where to it will go to the conditional function. Let's say you can see condition will start after this analyze content. Okay, so here I'll just write analyze content. Okay, analyze content. Yeah, now from analyze content it will either go to the approved post, flag for review, or rejected post. Okay, now I have to write this conditional function. Now separately I have to create another function. Now let me show you the function. So this is the function, guys. Okay, this is the function. Now we have to import this literals. Okay, literal from this typing. Okay, now see, whenever you are writing any kinds of condition, this code would be common. See, I have named this function as check condition, and it will also take this state. Okay, and it will return the nodes. Okay, you can see we are giving the nodes name, analyze content, approved. Okay, sorry, approved post, flag for review, and reject post. That means these are the node, approved post, flag for review, reject post. Okay, because these are my node name, right? So this function, basically what happens, see, this function takes this state and it returns either one of this particular node. Okay, based on the condition. Now let's try to see the condition. See, if my state flag, I already calculated the state flag, guys, here, right? If it is let's say approved, that means my approved post node would be returned. That means this node would be returned. That means that time only this node would be executed, not these are the nodes. Okay, then if my content flag is equal to review, that means only flag for review will be executed. That means if my flag post is equal to let's say review, that means this particular node would be executed, not these two nodes. Then if either none of them, then rejected post would be written. That means if it is not approved post and flag for review, then reject node would be executed. Okay, reject node would be written. So this is the logic we have written here. That's why we are using this literal. Literal means you can return the node object here. Okay, you can return the node object. That's why we have to give this particular syntax, and this syntax basically recommended by LangGraph. If you check the LangGraph documentation, you will see that they have also given the same thing. Okay, so this is the condition function you have to write whenever you want to use these kinds of conditional edges. Okay, if you want to handle this kinds of conditional scenario, that time you have to write this kinds of function. Now this function object you have to just provide here. Okay, after this analyze content, you have to provide this kinds this function object, check condition. That's it. Okay, now what will happen after analyze content? This particular connection would be either with this particular node, or with this particular node, or with this particular node. Okay, but you don't know which one, because it will check the condition. Based on the condition, which condition will match, it will go to that particular node. Okay, that's why we have written the condition. Okay, I hope you got it. Now this connection is also done. This connection is also done. Now it will do the connection either one of them. Okay, now I have to make this kinds of connection. That means approved post will be connected to the end, flag for review will connect to the end, and reject post will also connect to the end. Okay, now let's do this connection. So here I will just do the connection. So this is the connection. You can see approved post is connected to the end, then flag for review, it is also connected to the end. Okay, then reject post will be also connected to the end. Then we are compiling the graph. Now if I execute the graph, okay, check condition is not defined because I have to execute this function. Literal is not defined. Okay, sorry, I have to also import it first of all. Then I will execute. Then I'll compile the graph. After that, now let me show you the workflow. Now see guys, this workflow and this workflow is same. Okay, I hope you got it guys, how we are handling this kinds of conditional scenario. Okay, I hope you already got it, right? Only the change is that you have to use this use this function add conditional edges, and this add conditional edges takes the previous connection. Okay, previous connection, and it takes the condition function, because condition function will decide after that which node should be connected. Okay, either approved post, either flag post, either rejected post. Okay, but it should not be executed all together. It would be only executed either one of them based on the condition. This is what we have done guys. Now let me check this workflow. So I'll invoke this workflow. First of all, let's define initial state. So this is our initial state. So first of all, I've given the post content, check out this amazing new product and buy now. And then I've given the user reputation. Let's say this is the trusted user, already registered user. Then we're invoking the workflow, and this workflow will give me a result. Okay. Now if I print this result, now see guys, this is the post user has given, user reputation is trusted user, and we are formatting that particular post. So you can see user, trusted user says, check this amazing product, buy now. Content flag is rejected. Okay, why it is rejected? Because it is having buy now, and we already did the condition check here. Buy now here. So if buy now is present in the content, it would be rejected. Okay, so that's why you can see content flag is rejected, and result is also post automatically deleted due to the policy violation. Okay, now let's say here I'm not giving this buy now. Buy now I will remove it. Now if I execute the workflow again, now see right now it is approved because it doesn't have any kinds of violation. Again, user is a trusted user, so it doesn't need any kinds of approval. Okay, it doesn't need any kinds of review. That's why directly approved and post published successfully. Okay, now let's say user is new user. Okay, now see, although this I mean, content is fine, but still it will, okay, I have to execute, then result. Huh. So although this content is fine, but still it is waiting for the review, because I have to first of all check the user, because this is he is not registered in my platform. That's why it is going for the review. And you can see post sent to the human moderation fee. Okay, I hope you got it, guys. That's how this conditional workflow is working. Okay, that's how this conditional workflow is working. So whatever message you are giving, based on that, it is first of all checking the condition. Okay, after checking the condition, it is executing either one of this particular node. Okay, not all the nodes altogether. I hope you got it, guys. So this is what our non-LLM based workflow. Now let's try to discuss the LLM based workflow as well. So guys, so far we have seen the non-LLM based workflow, conditional workflows, and I showed you how it works, right? How we can handle the conditional scenario. Now let's try to learn the LLM based conditional workflows. Okay, now we'll be using large language model, but previously I didn't use any kinds of large language model here. Okay, everything I handled manually. So see, if I first of all explain the problem statement we're gonna create here. So this is going to be a review reply system. Review reply system means, let's say here user will give a review. Okay, user will give a review, and what we have to do, we have to give a reply to that particular review. Now review can be anything, whether it should be a positive review, it should be a negative review. Let's say we are working in a tech company, right? We are selling a product. Let's say we have created a software, right? So in that software, let's say I have made a subscription plan, and some of the user have taken their subscription. Okay, now definitely they will be using your product, and based on the product, actually they will give some kinds of I mean review, right, on your product. And as a, let's say, company owner, what you have to do, definitely you have to take care about the user review. Okay, whatever user is giving the review, you have to take care. If they are giving the positive review, that means it's completely fine, your product is amazing. Okay, you don't need to change inside your product. But if they're getting some, if they're giving some negative review, that means if they're having some of the issue, definitely you have to handle their issue, right? So you just think in that way. So basically user will give a review. First of all, what we'll do, we'll just try to check the sentiment of that review, whether this is a positive review or whether this is a negative review. And whenever I want to do this sentiment check, right, so definitely I have to use a large language model here. So here I'll be using a large language model, and this large language model either will return the positive, either it will return the negative. That means this is also a structured output. And if I want to get the structured output, guys, what I have to do, I have to use the Pydantic. I already showed you in my previous lecture as well. Whenever I created that parallel workflow, that time I also told you with the help of Pydantic, you can get the structured output. Okay, you have to just create a schema, and you have to provide the schema to the model, and model will work in that way. And for this, you have to learn the Pydantic. And Pydantic video I already have in my playlist. Please try to check that. Okay, so this particular node will return either positive or negative based on the review. I will be using a large language model. Large language model will analyze that, analyze the sentiment, and based on that it will give me positive, either negative. Okay, if it is positive, so see here your condition statement is working. If let's say this particular sentiment is positive, that means I'll generate a positive response. Okay, positive reply to the customer. Okay, but if it is negative, if this review is negative, sentiment is negative, so again I'm running another node called run diagnosis. Okay, so what this run diagnosis will do, basically I want to analyze this particular review in little more depth, because I want to understand what is the issue they are having. Okay, what is their main concern, I have to analyze that. That's why I will be running another node called run diagnosis. So this run diagnosis will return three things. One is the issue type. First of all, it will return the issue type. What is the issue related, whether the issue is coming from UI UX, okay, or whether it is coming from performance, or whether it is kinds of bugs, or whether they need any kinds of support or any other things. Okay, I have to understand the issue type. Then I have to understand the tone, whether they're angry, frustrated, disappointed, or calm. Okay, I have to understand the user. Then I have to understand their urgency, whether this urgency is low, medium, or high. Okay, based on that, definitely I have to take the actions. Okay, otherwise I can't sell my product anymore, right? Then once I got these at the, let's say, issue type, based on that, okay, I will be generating a reply, negative like reply to that particular user. Let's say I'll tell, okay, you are getting this kinds of UI related problem, you are very angry, okay, and your urgency is high, so definitely our team will look into that immediately. Or if it is low, so you just wait for 3 to 2 days, I will look into that. Okay, so this kinds of reply will try to generate. Okay, I hope you got it, this workflow. Now you can see here, this is the workflow, this is a conditional workflow, but we'll be solving with the help of LLM. Okay, so we will be we'll be using the LLM two times here. So in this particular nodes, and here also we'll be using the LLM to run this diagnosis. I need another LLM. Okay, with the help of LLM, we'll try to generate these at the structure, and again this would be a structured output. Okay, so every time whenever I run this nodes, run diagnosis node, LLM will return three things: issue type, tone, and urgency. Again I have to use Pydantic for that. Okay, Pydantic for that, we'll be creating a schema and we'll generate this structure output. Okay, so this is what we'll be implementing, guys, right now. And for this, whatever state I need, I already created the state. As you can see, I named it as review state, inherited with type dict. So first of all, whatever the review user will give me, I will store in the review, and this should be a string. And this node will try to find the sentiment, okay, sentiment of the review. So either it would be a positive or negative. You can either create it as a string, either you can create it as a literal type. In literal type, you can mention, because this is a category, right? Either it would be positive or negative. It kinds of category. So that's why we have taken this literal type. You can also take a string type, it will also work. Okay, I have taken literal type. So positive and negative. Okay, sentiment should be positive or negative. And diagnosis. So diagnosis will return three things. That means tone, type, tone, and angry. Okay, so this structure should be a dictionary type. You can see this is the key, this is the value, this is the key, this is the value, right? So that's why I have taken this should be a dictionary type. And the response, whatever response I'll try to generate, whether I'll generate a positive response or negative response, it will come here. And this again, this would be a string type. Okay, I hope you got it. Now we can start coding inside LangGraph, guys. Okay, so what I'll do, guys, I'll create another file here. Let's create another file. I'm going to name it as 7 review workflow. Review workflow dot ipynb. I'll take the code cell, select the kernel. Fine. So the first thing, guys, what I have to do, I have to import all the necessary libraries. So let's import, and here we'll be using LLM. So again, I'm going to use my OpenAI model. I already have the API key inside my .env. So you just also need to generate API key. Okay, you can either use any other model as well. It's completely fine. Yeah. Then after that, I need this typing, type dict and literal from typing. Then I also need to load this .env. For this, I need this .env load env function. And I also need to import the Pydantic, okay, because I have to generate a structured output. So Pydantic, I need base model and field. So please try to see in my playlist, guys. This tutorial is already there. So here is the playlist, guys, complete Agentic AI course, and here is the Pydantic video. Please try to go ahead with this Pydantic. You will try to understand. Okay, and earlier I also discussed about this sequential workflow and parallel workflow. Okay, this concept you have to also understand. Okay, if you're understanding this conditional workflow, because each of the workflow is something is like connected with each other. That means if you can understand our workflow, then you can relate with another workflow. Okay, so that's why this is required, and the way I have structured this course, right, step by step, this is interconnected between. So if you missed out the previous sessions, I think it would be a little bit confusing, okay, for the current session. So that's why I'm telling you, just try to go ahead with the previous session. Yeah. So yeah, so after that, I'll first of all load the environment variable. Okay, now let's initialize the model, LLM model. So here I have taken GPT-4o mini. Yeah. Now I told you I have to generate this, I have to create this structure. So yeah, so I told you this find sentiment nodes will give you two things, either positive or negative. Okay, for this I'll create a structured output, and for run diagnosis node I'll create a structured output. That means it will generate three things. One is issue type, tone, and urgency, right? So for this, let's try to write this Pydantic class. So this is the first class I have written for the sentiment. Okay, so basically this will return two things, positive or negative, based on the review. Okay, so this is going to be my first actually structured output from my LLM. Okay, so maybe I can show you. So let's create an object of a model. Yeah, so let's say structured model is equal to model dot with structured output. I have given the sentiment schema. Now see, if I show you the output, let's say I've generated this structured model. Now if I give any kinds of let's say prompt here, let's say this is the prompt. What is the sentiment of the following review? This software is too good. Okay, now I'll give it to my model. Now see, here I'm not using the direct model, I'm giving my structured model. Okay, now I'm doing the invoke operation and I'm only getting the sentiment. Now see positive. It will either return positive or negative. Now let's say here I've give too bad. Now this will return me negative. Okay, so this is the structured output, and if you want to get this kinds of output, you have to use the Pydantic schema for that. So the same thing I'll also write for my diagnosis node. So this is for my diagnosis node. Okay, so again I'm inheriting with the base model of the Pydantic, and here I have written the issue type, tone, and urgency. So this node will return these three things: issue type. Now here I have given some of the hint, like I need issue type should be UI, UX, performance, bug, support, and others. Here I've given the field description, the category of the issue mentioned in the review, then tone, angry, frustrated, disappointed, calm, the emotion tone expressed by the user, urgency, low, medium, high, how urgent to or critical the issue appears to be. Okay, so this thing I have discussed in my Pydantic class. Okay, so I already talked about what is this literal, what is this field, what is the description, each and everything I have already discussed. Okay, so this is another structured output we have created. Okay, now you can also test. For this you can create another model. So let's say I have named this model as structured model 2 model with structured output, and we are giving the diagnosis schema here, and this is going to be my another object. Okay, I'm getting an output. Okay, I have to execute this one. Now I'll execute. Now see, this is working. Now you can also give a prompt, and you can basically do the analysis. Let's say now I'll call this model. Okay, structured model 2. Now I'm giving the same prompt. Now I want to see the output. Now see, issue type is other, tone is disappointed, urgency is medium. Okay, so this is returning three things. Okay, I hope you got it. Now what I'm going to do, I'm going to simply create the state. Okay, now I have to prepare the state. So let's define the state, the same state. So this is the state, review state, review, sentiment, diagnosis, and response. It's done. Now I'll define the nodes. Okay, I have given my state here. Now add the nodes. So now see the node connection, see the nodes, how many nodes you are having. Find sentiment, then you have positive response, you have run diagnosis, you have negative response. Okay, these are the nodes. Let's add one by one. So these are the node: find sentiment, positive response, run diagnosis, and negative response. Okay, now I have to create these are the function one by one. Okay, so let's create first of all I'll create find sentiment. So this is the function, this is the node, find sentiment. It will take the state, and here I've given a prompt for the following review. Please find out the sentiment, and here we're giving the review. Review is present inside our state. Okay, and here we are getting the sentiment from the model, and we are calling the structured model. That is the first model. And first model, I think, returns only the sentiment, whether positive or negative. Okay, we're getting the sentiment and we're updating the sentiment and we're returning this particular sentiment only. Okay, instead of returning the whole state. Then I'm going to write the next nodes, which is positive response. Positive response. Okay, so again, it is taking the state and we are preparing the prompt. Write a warm thank you message in response to this review. So we are giving the review. Also, kindly ask user to leave feedback on our website. Let's see. That means if the review is completely positive, at that time I want to just give a thank you message to the user. Okay, and I will tell also just please leave a feedback to the website. Then once it is done, we are giving to the model, and see, we are not using any structured model here. We are giving the main model. Because why? Here I don't need any kinds of structured output, because it will only generate some kinds of thank you messages. Okay, and I don't need any kinds of structured output. That's why I'm giving the original model, and whatever content it is returning, I'm just saving inside my response. Okay, done. Now next thing, I have to create my diagnosis. Run diagnosis. So this is the run diagnosis. Again, it is taking the state, and here I am preparing the prompt. Diagnosis this negative review. We are giving the review. Return issue type, tone, and urgency. So we are executing this structure 2 model. Okay, and basically this will return these 3 things. And whenever we are getting, we are updating my diagnosis. You can see we are updating the diagnosis because diagnosis type is dictionary, and this will also a dictionary type output. Okay, we are doing that. Now once it is done, I'll do it for my next one, negative response. Negative response. So we are passing the state, then we are taking the diagnosis. Okay, then we are preparing the prompt. You are a supportive assistant. You the user had a issue type, then tone, then urgency. Based on that, just write a empathetic, helpful resolution message, and we are involving the actual model, and whatever response we are getting, we are updating the response. Okay, so that's how we are creating all of the node one by one. Now my node is ready. Now what I have to do, guys, I have to make the edge connection. Now let's do the edge connection. So add edges with condition. So first of all, the edge connection should be start to find sentiment. Start to find sentiment. Okay, start to find sentiment. Then you have to take the conditional edge right now, because either it will go to the positive response, either it will go to the run diagnosis. Okay, so here we'll just write the condition right now. Yeah, so this is the conditional edges. So see, it will start from find sentiment, and either it will connect to the positive, either it will connect to the negative. So that's why we have taken the find sentiment. Now we have to write the check sentiment function. I think previous also we have created a conditional function, right? And this conditional function is returning your nodes based on the condition. Either it will return this node, or this node. Okay, we'll write the same thing here. So let's write this function. Very simple function. That's why I told you this code would be common everywhere whenever you are using conditional based workflow. So see, this is the function I have written. Check statement sentiment. It will take the state and it will return the nodes, either positive response node. Okay, either positive response node, either run diagnosis node. That means this run diagnosis node. Okay, based on the condition. Now where I will check the condition? In the sentiment. If the sentiment is positive, I will return the positive node, positive response node. Okay, that means this node will be returned. Or if it is negative, I'll return this run diagnosis node. That means this node would be returned. Okay, I hope you got it, guys. So that's why we have to give this particular function here. Now this function will decide which node should be called. Okay, so once it is done, now let's say this connection is done. Okay, now this connection is done. Now I have to make the other connection. Now what will happen? This positive will connect to the end, then run diagnosis will connect to the negative response, and negative response will connect to the end. Okay, we'll try to make this connection right now. So this is the connection. Yeah, so you can see positive response is connected to the end, then run diagnosis will connect to the negative response. Okay, if let's say diagnosis runs successfully, we got the issue type, tone, and urgency. We'll connect to the negative. We'll generate the negative response, and negative response will connect it to the end. It is connected to the end. Okay, I hope you got the connection. Now let's define the workflow, compile the workflow, Now let's execute. Done. Now if I show you the workflow, so this is the workflow, guys. Now this workflow and this workflow is same. You can check. Find sentiment positive, run diagnosis negative, and okay, completely fine. Now let's invoke this workflow. So what I can do, I can give a positive review first of all. So I will generate from ChatGPT. I'll just tell generate a or write a positive review for a tech software. In short. Okay, now I'll copy this, and what I'm going to do, I'm going to add inside my initial state. So let me define my initial state. So in the review itself, I'll try to write my review. Now let's invoke the workflow. And this will give me the result. Now I'll print the result. Now see, this is the review, and the sentiment is positive, and response is also positive. Their username, thank you for your wonderful field. Here to that our software made such a positive. Okay, your kinds of word means a lot, blah blah blah, and also please give a review inside our website. Okay, now let's give a negative response as well. Now I'll generate another one. Now negative review. Now what I can do, I can copy the same code. Only I'll just change this review. So I will invoke the result workflow and print the result. Okay, now we are getting the negative. You can see this sentiment is negative, and diagnosis we got, issue type is performance, tone is frustrated, urgency is high, and this is the negative response we are writing. We are here to help you with the performance issue, high user, blah blah blah. Okay, so amazing. That means it's working fine. Okay, and I think you got how we have created the entire workflow with the help of this conditional workflow. Get it? So now I think you can create any kinds of conditional workflow, either it is non-LLM based or LLM based, it doesn't matter. You can create it. Only you just need to understand this conditional connection. Okay, if you understand this conditional connection, then you will be able to create any kinds of conditional workflow. So guys, in this video, I'll be discussing about the last workflows inside LangGraph, which is iterative workflows. So far, I have discussed about sequential workflows, parallel workflows, conditional workflows. Okay, each and everything I have already covered. If you haven't checked those videos, it is already available inside my playlist. I have given the link in the description. From there, you can check it out. So this is going to be very important and interesting workflows, guys, inside LangGraph. because with the help of iterative workflows, you can perform the looping operation. So let's say whenever you are performing any task, and if you feel like this task needs some more improvement, you can continuously actually perform the looping operation with the help of these iterative workflows. So we'll try to understand this one. So if you found my content useful, guys, and if you are really learning, okay, from this particular playlist, I would like to request you, please try to subscribe to my channel and hit the like, and please try to share this with your friends and family. So if you are supporting me, guys, if you are supporting my channel, I'll be getting more motivation to bring these kinds of content. So if you see, guys, here is the iterative workflows we'll be discussing about. So previously I already discussed about all the workflows I told you about inside LangGraph, like sequential workflows. You have understood the LLM, non-LLM based. Okay. Then I have discussed about the parallel workflows. Then I discussed about the conditional workflows. Okay. Now we'll try to understand this iterative workflows. So you can see this is the iterative workflows graph. I already created this particular graph. So guys, to make you understand these iterative workflows, I'm going to take one amazing example. I'm going to take Facebook post generation example. So what happens, let's say I want to post anything on my Facebook. Let's say I want to post any kinds of tech related content on my Facebook. So nowadays actually what will happen, I'll be definitely using ChatGPT or any other large language model, let's say provider, and I'll try to generate that content. Okay. And what I will do, I will copy that and I will post on my Facebook. Okay. But it's not like that. At the very first time, you will be getting the perfect post, right? Let's say you have given a prompt and it has generated something for the first time, right? It's not like that. That should be 100% perfect and optimized for you, for your needs. So maybe you just need to do some little bit, let's say change, or you need some improvement, you need some optimization. So again, what you will do, you will send it to the LLM and you will try to tell, okay, try to optimize it more. Okay. So once you have, let's say, optimized another one, again, you will try to review that, evaluate that. If it is perfect for you, then you will try to approve and you will post it over the Facebook. Okay. Otherwise you will again do the optimization. Okay. So that's how, let's say, we usually generate any kinds of content from the LLM, right? So why not we can create a automatic workflow. So this workflow will automatically generate, let's say, Facebook content based on the topic you have provided. Then after that, it will automatically evaluate that whether this content is perfect or not. Okay. Let's say after doing the evaluation, it found, okay, this is useful, this is fine. Then it will approve. Then you can post over the Facebook. Otherwise, it will send it to the another, let's say, nodes, and that nodes will try to do the optimization. Okay. Optimization, it will optimize it will do some improvement. Then after that, again it will try to send it to the evaluator. Okay. Evaluate will again evaluate that. If found, let's say, this content is fine, then it will approve. Otherwise, again it will try to send it to the optimizer. Then optimizer, again it will optimize the content and it will again send it for the evaluation. Okay. So that's how this particular loop will continuously run unless and until this content is approved. Okay. So this is called actually iterative workflows. So to make iterative workflows, guys, we are using conditional workflows as well, as you can see, because here is the condition. If this content is completely fine, after doing the evaluation, it will approve. Okay. Otherwise, it will send it to the optimizer, and optimizer will like do the improvement and it will again send it to evaluator. Okay. So here is the looping concept, and this looping concept, we call it as a iterative workflows inside LangGraph. Now we'll try to implement this particular workflows, okay, inside LangGraph. And for this, whatever state I need, guys, I already prepared the state. As you can see, this is the state. I named it as post state and I inherited with the type dict. So first of all, I have taken a variable called topic. So user will pass a topic, okay, for post generation. Let's say I have given a topic related, let's say Agentic AI. So it will generate some kinds of post related Agentic AI. Okay. So let's say I'll send it to the generate LLM, right? Here we'll be using a LLM. Then LLM, or let's say this node will generate the post. Okay, let's say this post I'm going to save inside this post variable, and this is also going to be string type data. Then after that, we'll try to send it to the evaluator. Evaluator will also use a LLM, right? Large language model, and it will evaluate that particular result. And it will send two things. One is the approved, another is the needs improvement. Okay, if it is sending returning approved, that means this post is completely fine. We can directly approve that. And if it is sending needs improvement, okay, that time we'll try to send it to the optimizer. Okay, and it will also give you some kinds of feedback. Okay, let's say what should be the improvement. It will also send it to the optimizer. This feedback will try to save inside this particular variable. Then we'll also try to see the iteration. Iteration means, let's say it has given this content to the evaluator. Evaluator tells, okay, this needs the improvement. Again, it will send it to the optimizer. Optimizer will try to again generate a new or let's say optimize that particular post, and it will again send it to the evaluator. That means one iteration is done. Then again, evaluator will try to check that. Again, let's say it will tell it needs the improvement. Again, it will try to send it to the optimizer. Optimizer, again, it will improve that. Again, it will send to the evaluator. That means iteration goes to. That means how many loop it is performing. We'll try to log that particular informations in this iteration variable. Okay. And here we'll also set a maximum iteration. Let's say if you don't set this maximum iteration, what is the possibility? Let's say if you are using any very poor large language model, that time, let's say every time whatever content it will generate, maybe your evaluator will not evaluate that, or let's say approve that. That time this particular loop will continuously running. Okay, will not get any final result. That's why we'll set a maximum iteration, let's say 4 to 5. So after 4 or 5 let's say iteration, this particular loop will break, and whatever content we got after 4 or 5 iteration, that I will try to make it as final post. Okay, that's why this maximum iteration will also set. Then whatever, let's say post we are generating, whatever feedback we are getting, okay, from this evaluator, we'll also try to save inside this particular variable as a history. That's why we made it as post history and feedback history. That means it will continuously add. Okay, it will not replace, it will continuously add. So that's why we'll be using reducer concept. I think you know what is reducer inside LangGraph. You can see we are using annotated. We have taken a list type data structure, and we're using operation.add. That means every time it will add the post history and feedback history instead of replacing. But here we haven't taken any kinds of reducer. It will continuously replace here. Okay, I hope you got it. Then let's say once this improvement is done, evaluator will let's say found this is useful or this is completely fine. That time this would be approved and this loop would be break. Okay, so this is what actually iterative workflows. Now we'll try to code inside LangGraph. Then we'll try to understand the whole concept. Okay, now for this, what I'm going to do, guys, I'm going to simply open up this iterative workflows.ipynb file, and let's select our kernel. So first of all, we have to import the necessary library. So let's import. So I'll import all of the necessary library. So you can see I'm importing the state graph, start, end. Then from typing, I'm importing type dict, literal, and annotated. Then I'm using chat OpenAI. That means I'll be using OpenAI large language model. You can use any kinds of large language model. For this, I have one .env file, and I set my OpenAI key here already. Then I'm importing the system message and human message. Okay, where we're importing the system message and human message, because I want to give the prompt for each and every LLM. So you can see here we'll be using the LLM. Here also we'll be using the LLM. For optimization also we'll be using the LLM. Okay, and every LLM I'll try to set a different prompt. Let's say for generation 1 I will set a generation related prompt. For evaluator I'll set evaluation related prompt. For optimization I'll set optimization related prompt. Okay, so you can directly give the prompt as well, but it is recommended to use this system message and human message function whenever you are giving the prompt. Okay, this should be more optimized one. Then operator I need, because I want to perform the reducer, I have to do the adding operation. Then .env. So let's import all of them. So as you can see, execution is complete. Now we'll load our environment variable. Now we'll define all the large language model. So here you can see, yeah. So I need 3 large language model. One is for generation, one is for evaluator, one is for optimization. Okay. So what I'm going to do, I'm going to make 3 object for 3 large language model. See, I'm going to use the same model only, but I'm going to create 3 object, okay? Because here I told you we'll be using 3 nodes, okay, differently. So whenever you are creating this kinds of project, let's say in real time, actual real project, that time you have to select this large language model in a such a way. So let's say whatever model is very good for generation, that time you can use that particular model. Let's say some model is very much good for evaluation, that time you can take that particular model. Let's say some model is very much good for optimization, you can take that particular model, okay? So that's how we have to select in real time, but right now we are only understanding the example. That's why I've taken the same model, but I created 3 object, okay? One is for generator, evaluator, and optimizer. Generator, evaluator, and optimizer. Done. Now next, I'm going to define the state, but before defining the state, I already told you here. See, this evaluator nodes will return you 2 things, okay? One is the evaluation, okay? Evaluation, that means it should be approved or needs improvement, okay? These 2 things. And another one is the feedback, okay? What should be the feedback for the optimization, right? So it will generate 2 things. I don't need anything else apart from these two things. One is the evaluation and another one is the feedback. So if I want to get this kind of structured output, what I have to do, I have to use the Pydantic. I already told you previously. I have also taken the same example. So what I'm going to do, guys, I'm going to just create a Pydantic class. As you can see, I have created a Pydantic class. So here I have named it as post evaluation. I'm inheriting with the Pydantic base model, and 2 things I have taken, evaluation and feedback. So in evaluation, you can see this is the literal type. It should be approved or needs approved, okay? Needs improvement. And another one is the feedback. That means it will generate some kinds of feedback for Facebook post. That means if I now pass this thing to the model, that means if I add this line, evaluator LLM with structured output, and if I pass this class, this model will try to generate the structured output now. So it will only give you evaluation and feedback, not anything else, okay? Now let me show you. So let's say I have defined this one. Now here I'm going to just generate a Facebook post from my ChatGPT. Facebook post about Agentic AI. Okay, I'll copy this, and let's say here I can take a variable post. Now inside that, I'm going to paste this post. Okay, now I'm going to send it to the structured evaluation LLM. Done. Now if I show the result, see, this is giving you 2 things. One is the evaluation. You can also extract evaluation, approved, and the feedback. See, this is the feedback for this particular post, okay? So that's how every time we'll be getting this structured output from this large language model, okay? The evaluated large language model, because we have used Pydantic data evaluation for that. Now, what I'm going to do, guys, next, I'm going to define the state. I'm going to define the same state I have taken here. This is my state. As you can see, topic, post, evaluation, feedback, iteration, max iteration, post history, and feedback history. So here I have added the reducer concept. So every time I'll try to add this to information, okay, instead of replacing. And these are the things I think you already got it, right? Yeah. And why I've taken literal here, because evaluation will only return two things, approved or needs improvement. Okay, these two category, that's why I've taken literal type instead of string. So now I will add my nodes. Let's define the graph and add the nodes. Yeah, so I have already defined the graph. You can see state graph. I have given this post state here. Now I'll add the node. Add node. So how many nodes we are having? 1, 2, 3. Okay, 3 nodes we are having. We'll add this 3 node all together. Yeah, so these are 3 nodes: generate post, evaluate post, and optimize post. Okay, generate, evaluate, and optimize. Now we'll write this function one by one. So first of all, we'll just try to write this generate post function node. So this is the function, guys, I've already written. As you can see, generate post, it will take the state, and here is the prompt I have prepared. It's a detailed prompt I created with the help of ChatGPT, and here we are using the system message and human message function, whatever I have imported from here. Okay, so as you can see, this is the prompt. So system message I'm giving, you are a funny and clever Facebook influencer. And human message, write a short, original, and hilarious Facebook post on the topic, whatever topic user will give. And here I have assigned some rule: do not use a question answer format, maximum 500 characters. Okay, and blah blah blah. These are the things I have added. Now after that, I am just invoking my generator LLM, and whatever content I'm getting, I'm just updating the response inside the post. And post history I am also updating, because simultaneously update two things. One is the post and it is the post history. Both I will update, right? So here it will replace every time, here it will add every time, because here we are using reducer concept and we are returning this particular state. Okay, instead of returning whole state, we are only returning the state we are changing. So this is our generate post nodes we have created. That means this node is complete. Now let's try to add the evaluator one. Generate is done. Now we'll try to create the evaluator one. So this is the evaluator one, guys. Again, I named it as evaluate post and sending the state. And here is the prompt, guys, I have prepared. Again, I've given a system prompt. So this is the system prompt I have given. Okay. Now this is the human prompt. Evaluate the following Facebook post. We have given the post from the state. And here are some criteria I have given. Based on that, it will try to evaluate, and it will return two things. One is the evaluation, approved or need improvements. Other one is the feedback. Then we are invoking our structured evaluator LLM. That means this one. Okay, this one we are invoking, this one instead of this one, because here we have added the Pydantic class for the structured output. See, and whatever evaluation result we are getting, we are sending saving to the evaluator state, evaluation state, and feedback also. I'm saving inside feedback, and I'm also saving the feedback history, because feedback history should be also updated. Okay, yeah. So once it is done, we are also returning the state. Now let's execute. Done. Now we'll try to create the last one, which is optimize post. So this is for the optimize post. Again, we are passing the state, and here is the prompt. You are a punch up Facebook post or virality and humor based on the given feedback. Then here's the human prompt I have given: improve the Facebook post based on this feedback. We are giving the feedback, we are giving the topic, as well as the original post my model has generated. Okay, so based on the original post, based on the feedback, based on the topic, it will optimize that post. Okay, and it will rewrite that particular post and it will give it to you. For this, I'm hitting this optimizer LLM and getting the response, and we are updating the iteration here. See, here we are updating the iteration, like how many iteration it has to perform to give the final, or let's say optimized version of the post. Okay, every time this loop will execute, and once let's say it found, okay, now this post is completely fine, that time it will approve. Otherwise this loop would be continuously running. And how many times it will run, for this we are just logging this iteration, we are just adding one. Okay, so this iteration value I'll give initially one. Okay, whenever I'll create the initial state, and every time it will add the one, how many time it will execute. Okay, after that we are just returning the response. Okay, that means the final post, then the iteration. Okay, then we are also saving this inside the post history, and we are returning the state. Done, guys. Okay, now all of the nodes we have created successfully. Now we have to define the edge connection. Now let's do that. So here I'll just try to comment add edges. So first of all, here we have to add the edges for this start to generate. Let's define start to generate. Then we have to define generate to evaluate. Generate to evaluate. Okay, now here conditional edges will come, because evaluate, either it will send it to the approved. Okay, it will directly to the approved, otherwise it will send it to the optimizer, right? Optimization. So here we'll be using the conditional edges. So let's use the conditional edges here. So here we're using conditional edges. So it will start from evaluate, and evaluate will decide what to send, whether it will approved or send it to the optimize. For this we have to write a conditional function. I think you remember, for conditional statement we write a conditional function separately. So this is the conditional function. So it will take the state, and here we are checking the condition. If my evaluation, okay, that means I already saved this evaluation inside my state, right? You remember, right? Evaluation, and what is the evaluation? Approved or needs improvement. Okay, so here we are checking if the state is equal to state evaluation is equal to approved, or state iteration is greater than or equal state max iteration. That means if, let's say, it has performed maximum iteration, let's say we have given maximum iteration is equal to 4. Let's say 4th time it has done the iteration, and whenever it is running for the 5th time, that time I think our condition is matching, right? Because my highest iteration is, maximum iteration is 4, but whenever it is going for 5, that means this particular loop will break, right? So that's how we are checking another condition. If this iteration is equal to it is greater than or equal to maximum iteration, that time just return approve. Okay, otherwise return needs improvement. So this will basically redirect this particular route, whether it will send it to the optimizer or for the approver. Now we'll try to define this method here. Route evaluation. We'll write it here, route evaluation. Okay. Now here we'll be adding the iteration. Okay, that means the iterative workflows right now. Now what will happen? See, let's say this evaluator returns approved. That means this particular workflow will exit here, because I got my final post. But if it doesn't got the approve, let's say it sends needs improvement, that time what will happen? It will send it to the optimizer. Okay, it will send it to the optimizer node, and optimizer will optimize, then again it will send it to the evaluation. So these kinds of things, if you want to write, you have to give this statement inside conditional workflow only. You have to write this, additional line. See, okay, double comma I have given. Yeah, now I think you can get, see, once this route evaluation returns approved, okay, that means it will end that particular workflow. But if it return needs improvement, that time it will execute the optimized node. This optimized node. Okay, optimized node. See, it is redirecting from here. If it needs improvement, it will hit the optimized node. Otherwise, it will hit the end node. See, that is what we are doing. And this is called actually your iterative workflows. So here we are adding the iteration. Okay, this is called actually iteration. I hope you got it, guys. You don't need to take any kinds of separate function for this. Inside conditional edges only, you have to only write this statement. Okay, that means this route evaluation, if it is returned the approved, it will go to the end. Otherwise, if it returns needs improvement, it will execute my optimized node. And how many time it will perform? Unless and until you are not getting approved. Okay, approved from my evaluator, or this maximum iteration ends. Okay, I hope you got it. Now our edge connection is also done. Now simply what I'm going to do, I'm going to see, this connection is done, this connection, and this connection is done. Optimize to evaluate. So this connection is done. Now we'll try to make this connection, optimize to evaluate. So let's say once it is in the optimize, so optimize will try to connect to the evaluator. That means optimize will send this optimization result to the evaluator. So this connection will try to add. So this is the connection. This is the connection, okay? Optimize to evaluator. Now we'll try to compile. Okay, now we'll show you the workflow. So see, this is the workflow. Now this workflow and this workflow is exactly same. You can check it here. Okay, now we'll try to execute this workflow. For this, let's define a state. Let's say I have given the topic Agentic AI. Let's say this is our topic, and iteration initially I have set it to the 1, because after that it will every time update. It will every time update 1. Okay, so whenever it needs any kinds of improvement, optimization, it will add 1. Okay, that means the iteration update. And this is our maximum iteration. I want to perform this iteration maximum 5 times. Okay, if it is not found in 5 times, that means this loop will execute. Then we are giving this initial state to my workflow, and we are getting the result. Now let me execute. Done. Now if I show you my result, so see, this is the result we are getting. As you can see, this is the topic and this is the post it has generated. Evaluation is okay, evaluation return approved. See, at the first iteration it got approved. Okay, then feedback, this is the feedback, and you can see iteration is 1. That means it didn't updated any iteration. That means at the first time only it has approved. This is our maximum iteration, and this is the post history, and this is the feedback history. Okay, now maybe you can change to another topic. Let's say I'll give LLM. See, here we are using OpenAI LLM, right? That's why this LLM is very powerful. At the very first time it is generating good post. Okay, that's why it is getting approved. Okay, in the first iteration only. Let me give any other topic or a random topic and see the output. So maybe, okay, I'll give any random topic and let's see. Still at the first time only it is approving. Okay, it's completely fine. You can maybe try with different topic. Okay, and you will able to see that whenever it needs any kinds of improvement, okay, it will run this iteration and it will update. Okay, and again it will send it to the optimizer. The reason it is giving you one shot approval, because we are using this OpenAI GPT-4o mini, and this is like good model. Maybe you can use any weaker model. Okay, like more weaker model, more poor model. That time I think this loop will run. Okay, iteration will run, because we are using a good model. That's why we are getting the result at the very first time. Okay, I hope you got it. Now if you want to see the post history separately, you can also just write a loop, and from the result you can extract the post history, and you can see all of the post history you are getting. Okay, you can also see the feedback history. This is also possible. Okay, anything you can extract, because you are getting all the object here. Okay, so yes guys, that's how we can write this iterative workflows inside LangGraph, and this is super useful. Trust me, whenever you will be implementing actual AI agents, so this concept you need. Okay, without that you can't perform this continuous looping operation, and you need to create a workflow. I need this kinds of looping, I need this kinds of conditional statement, parallel statement. Okay, each and everything is required. Now we have understood the last workflows inside LangGraph. Now in the next video onward guys, we'll try to start working on the project.